The Complete Aristotle. Aristotle, Part 2, Universal Physics. Physics, 8 books, translated by R. P. Hardy and R.K. Gay. On the Heavens, 4 books, translated by J. L. Stokes. On Generation and Corruption, 2 books, translated by H. H. Joachim. Meteorology, 4 books, translated by E. W. Webster. Part 2, Universal Physics. Physics, Book I, translated by R. P. Hardy and R.K. Gay. When the objects of an inquiry, in any department, have principles, conditions, or elements, it is through acquaintance with these that knowledge, that is to say scientific knowledge, is attained. For we do not think that we know a thing until we are acquainted with its primary conditions or first principles, and have carried our analysis as far as its simplest elements. Plainly therefore in the science of nature, as in other branches of study, our first task will be to try to determine what relates to its principles. The natural way of doing this is to start from the things which are more knowable and obvious to us and proceed towards those which are clearer and more knowable by nature, for the same things are not knowable relatively to us and knowable without qualification. So in the present inquiry we must follow this method and advance from what is more obscure by nature, but clearer to us, towards what is more clear and more knowable by nature. Now what is to us plain and obvious at first is rather confused masses, the elements and principles of which become known to us later by analysis. Thus we must advance from generalities to particulars, for it is a whole that is best known to sense perception, and a generality is a kind of whole, comprehending many things within it, like parts. Much the same thing happens in the relation of the name to the formula. An name, for example round, means vaguely a sort of whole. Its definition analyzes this into its particular senses. Similarly a child begins by calling all men father, and all women mother, but later on distinguishes each of them. The principles in question must be either A, one or B, more than one. If A, one, it must be either I, motionless, as Parmenides and Melissus assert, or 2, in motion, as the physicists hold, some declaring air to be the first principle, others water. If B, more than one, then either I, a finite, or 2, an infinite plurality. If I, finite, but more than one, then either 2 or 3 or 4 or some other number. If 2, infinite, then either as Democritus believed one in kind, but differing in shape or form, or different in kind and even contrary. A similar inquiry is made by those who inquire into the number of existence, for they inquire whether the ultimate constituents of existing things are one or many, and if many, whether a finite or an infinite plurality. So they too are inquiring whether the principle or element is one or many. Now to investigate whether being is one and motionless is not a contribution to the science of nature. For just as the geometer has nothing more to say to one who denies the principles of his science, this being a question for a different science or for all comment to all, so a man investigating principles cannot argue with one who denies their existence. For if being is just one, and one in the way mentioned, there is a principle no longer, since a principle must be the principle of something or things. To inquire therefore whether being is one in this sense would be like arguing against any other position maintained for the sake of argument, such as the Heraclitean thesis, or such a thesis as that being is one man, or like refuting a merely contentious argument, a description which applies to the arguments both of Melissus and of Parmenides. Their premises are false and their conclusions do not follow. Or rather the argument of Melissus is gross and palpable and offers no difficulty at all, except one ridiculous proposition, and the rest follows a simple enough proceeding. We physicists, on the other hand, must take for granted that the things that exist by nature are, either all or some of them, in motion, which is indeed made plain by induction. Moreover, no man of science is bound to solve every kind of difficulty that may be raised, but only as are drawn falsely from the principles of the science. It is not our business to refute those that do not arise in this way, just as it is the duty of the geometer to refute the squaring of the circle by means of segments, but it is not his duty to refute Antiphon's proof. At the same time the holders of the theory of which we are speaking do incidentally raise physical questions, though nature is not their subject, so it will perhaps be as well to spend a few words on them, especially as the inquiry is not without scientific interest. The most pertinent question with which to begin will be this: in what sense is it asserted that all things are one? For is used in many senses. Do they mean that all things are substance or quantities or qualities? And, further, are all things one substance, one man, one horse, or one soul or quality, and that one and the same white or hot or something of the kind? These are all very different doctrines and all impossible to maintain. For if both substance and quantity and quality are, then, whether these exist independently of each other or not, being will be many. If on the other hand it is asserted that all things are quality or quantity, then, whether substance exists or not, an absurdity results, if the impossible can properly be called absurd. For none of the others can exist independently, substance alone is independent, for everything is predicated of substance as subject. Now Melissus says that being is infinite. It is then a quantity. For the infinite is in the category of quantity, whereas substance or quality or affection cannot be infinite except through a concomitant attribute, that is, if at the same time they are also quantities. For to define the infinite you must choose quantity in your formula, but not substance or quality. If then being is both substance and quantity, it is two, not one. If only substance, it is not infinite and has no magnitude, for to have that it will have to be a quantity. Again, one itself, no less than being, is used in many senses, so we must consider in what sense the word is used when it is said that the all is one. Now we say that, a, the continuous is one, or that, b, the indivisible is one, or, c, things are said to be one, when their essence is one and the same, as liquor and drink. If, a, their one is one in the sense of continuous, it is many, for the continuous is divisible ad infinitum. There is, indeed, a difficulty about part and whole, perhaps not relevant to the present argument, yet deserving consideration on its own account, namely, whether the part and the whole are one or more than one, and how they can be one or many, and, if they are more than one, in what sense they are more than one. Similarly with the parts of wholes which are not continuous. Further, if each of the two parts is indivisibly one with the whole, the difficulty arises that they will be indivisibly one with each other also. But to proceed, if, b, their one is one as indivisible, nothing will have quantity or quality, and so the one will not be infinite, as Melissus says, nor, indeed, limited, as Parmenides says, for though the limit is indivisible, the limited is not. But if, c, all things are one in the sense of having the same definition, like raiment and dress, then it turns out that they are maintaining the Heraclitean doctrine, for it will be the same thing to be good and to be bad, and to be good and to be not good, and so the same thing will be good and not good, and man and horse. In fact, their view will be, not that all things are one, but that they are nothing, and that to be of such and such a quality is the same as to be of such and such a size. Even the more recent of the ancient thinkers were in a pother lest the same thing should turn out in their hands both one and many. So some, like Lycophron, were led to omit is, others to change the mode of expression and say the man has been whitened instead of his white, and walks instead of his walking, for fear that if they added the word as they should be making the one to be many, as if one and being were always used in one and the same sense. What is may be many either in definition, for example to be white is one thing, to be musical another, yet the same thing be both, so the one is many, or by division, as the whole and its parts. On this point, indeed, they were already getting into difficulties and admitted that the one was many, as if there was any difficulty about the same thing being both one and many, provided that these are not opposites, for one may mean either potentially one or actually one. If, then, we approach the thesis in this way, it seems impossible for all things to be one. Further, the arguments they use to prove their position are not difficult to expose. For both of them reason contentiously, I mean both Melissus and Parmenides. Their premises are false and their conclusions do not follow. Or rather the argument of Melissus is gross and palpable and offers no difficulty at all. Admit one ridiculous proposition and the rest follows a simple enough proceeding. The fallacy of Melissus is obvious. For he supposes that the assumption what has come into being always has a beginning justifies the assumption what has not come into being has no beginning. Then this also is absurd, that in every case there should be a beginning of the thing, not of the time, and not only in the case of coming to be in the full sense but also in the case of coming to have a quality, as if change never took place suddenly. Again, does it follow that being, if one, is motionless, why should it not move, the whole of it within itself, as parts of it do which are unities, for example this water? Again, why is qualitative change impossible? But, further, being cannot be one in form, though it may be in what it is made of. Even some of the physicists hold it to be one in the latter way, though not in the former. Man obviously differs from horse in form, and contraries from each other. The same kind of argument holds good against Parmenides also, besides any that may apply specially to his view, the answer to him being that this is not true and that does not follow. His assumption that one is used in a single sense only is false, because it is used in several. His conclusion does not follow, because if we take only white things, and if white has a single meaning, nonetheless what is white will be many and not one. For what is white will not be one either in the sense that it is continuous or in the sense that it must be defined in only one way. Whiteness will be different from what is whiteness. Nor does this mean that there is anything that can exist separately, over and above what is white. For whiteness and that which is white differ in definition, not in the sense that they are things which can exist apart from each other. But Parmenides had not come in sight of this distinction. It is necessary for him, then, to assume not only that being has the same meaning, of whatever it is predicated, but further that it means, 1. What just is, and 2. What is just 1. It must be so, for 1. An attribute is predicated of some subject, so that the subject to which being is attributed will not be, as it is something different from being. Something, therefore, which is not will be. Hence substance will not be a predicate of anything else. For the subject cannot be a being, unless being means several things, in such a way that each is something. But ex hypothesi being means only one thing. If, then, substance is not attributed to anything, but other things are attributed to it, how does substance mean what is rather than what is not? For suppose that substance is also white. Since the definition of the latter is different, for being cannot even be attributed to white, as nothing is which is not substance, it follows that white is not being, and that not in the sense of a particular not being, but in the sense that it is not at all. Hence substance is not, for it is true to say that it is white, which we found to mean not being. If to avoid this we say that even white means substance, it follows that being has more than one meaning. In particular, then, being will not have magnitude, if it is substance. For each of the two parts must be in a different sense. 2. Substance is plainly divisible into other substances, if we consider the mere nature of a definition. For instance, if man is a substance, animal and biped must also be substances. For if not substances, they must be attributes, and if attributes, attributes either of A, man, or of B, some other subject. But neither is possible. A. An attribute is either that which may or may not belong to the subject, or that in whose definition the subject of which it is an attribute is involved. Thus sitting is an example of a separable attribute, while snugness contains the definition of nose, to which we attribute snugness. Further, the definition of the whole is not contained in the definitions of the contents or elements of the definitory formula, that of man for instance in biped, or that of white man in white. If then this is so, and if biped is supposed to be an attribute of man, it must be either separable, so that man might possibly not be biped, or the definition of man must come into the definition of biped, which is impossible, as the converse is the case. B. If, on the other hand, we suppose that biped and animal are attributes not of man but of something else, and are not each of them a substance, then man too will be an attribute of something else. But we must assume that substance is not the attribute of anything, that the subject of which both biped and animal and each separately are predicated is the subject also of the complex biped animal. Are we then to say that the all is composed of indivisible substances? Some thinkers did, in point of fact, give way to both arguments. To the argument that all things are one if being means one thing, they conceded that not being is. To that from bisection, they yielded by positing atomic magnitudes. But obviously it is not true that if being means one thing, and cannot at the same time mean the contradictory of this, there will be nothing which is not, for even if what is not cannot be without qualification, there is no reason why it should not be a particular not being. To say that all things will be one, if there is nothing besides being itself, is absurd. For who understands being itself to be anything but a particular substance? But if this is so, there is nothing to prevent the being many beings, as has been said. It is, then, clearly impossible for being to be one in this sense. The physicists on the other hand have two modes of explanation. The first set make the underlying body one, either one of the three or something else which is denser than fire and rarer than air, then generate everything else from this, and obtain multiplicity by condensation and rarefaction. Now these are contraries, which may be generalized into excess and defect. Compare Plato's great and small, except that he make these his matter, the one his form, while the others treat the one which underlies as matter and the contraries as differentiae, that is forms. The second set assert that the contrarieties are contained in the one and emerge from it by segregation, for example Anaximander, and also all those who assert that what is one and many, like Empedocles and Anaxagoras, for they too produce other things from their mixture by segregation. These differ, however, from each other in that the former imagines a cycle of such changes, the latter a single series. Anaxagoras again made both his homogeneous substances and his contraries infinite in multitude, whereas Empedocles posits only the so-called elements. The theory of Anaxagoras that the principles are infinite in multitude was probably due to his acceptance of the common opinion of the physicists that nothing comes into being from not being. For this is the reason why they use the phrase all things were together and the coming into being of such and such a kind of thing is reduced to change of quality, while some spoke of combination and separation. Moreover, the fact that the contraries proceed from each other led them to the conclusion. The one, they reasoned, must have already existed in the other, for since everything that comes into being must arise either from what is or from what is not, and it is impossible for it to arise from what is not, on this point all the physicists agree. They thought that the truth of the alternative necessarily followed, namely that things come into being out of existent things, that is out of things already present, but imperceptible to our senses because of the smallness of their bulk. So they assert that everything has been mixed in every thing, because they saw everything arising out of everything. But things, as they say, appear different from one another and receive different names according to the nature of the particles which are numerically predominant among the innumerable constituents of the mixture. For nothing, they say, is purely and entirely white or black or sweet, bone or flesh, but the nature of a thing is held to be that of which it contains the most. Now, 1. The infinite qua infinite is unknowable, so that what is infinite in multitude or size is unknowable in quantity, and what is infinite in variety of kind is unknowable in quality. But the principles in question are infinite both in multitude and in kind. Therefore it is impossible to know things which are composed of them, for it is when we know the nature and quantity of its components that we suppose we know a complex. Further, 2. If the parts of a whole may be of any size in the direction either of greatness or of smallness, by parts I mean components into which a whole can be divided and which are actually present in it, it is necessary that the whole thing itself may be of any size. Clearly, therefore, since it is impossible for an animal or plant to be indefinitely big or small, neither can its parts be such, or the whole will be the same. But flesh, bone, and the like are the parts of animals, and the fruits are the parts of plants. Hence it is obvious that neither flesh, bone, nor any such thing can be of indefinite size in the direction either of the greater or of the less. Again, 3. According to the theory all such things are already present in one another and do not come into being but are constituents which are separated out, and a thing receives its designation from its chief constituent. Further, anything may come out of anything water by segregation from flesh and flesh from water. Hence, since every finite body is exhausted by the repeated abstraction of a finite body, it seems obviously to follow that everything cannot subsist in everything else. For let flesh be extracted from water and again more flesh be produced from the remainder by repeating the process of separation, then, even though the quantity separated out will continually decrease, still it will not fall below a certain magnitude. If, therefore, the process comes to an end, everything will not be in everything else, for there will be no flesh in the remaining water. If on the other hand it does not, and further extraction is always possible, there will be an infinite multitude of finite equal particles in a finite quantity which is impossible. Another proof may be added, since every body must diminish in size when something is taken from it, and flesh is quantitatively definite in respect both of greatness and smallness, it is clear that from the minimum quantity of flesh no body can be separated out, for the flesh left would be less than the minimum of flesh. Lastly, 4. In each of his infinite bodies there would be already present infinite flesh and blood and brain having a distinct existence, however, from one another, and no less real than the infinite bodies, and each infinite, which is contrary to reason. The statement that complete separation never will take place is correct enough, though Anaxagoras is not fully aware of what it means. For affections are indeed inseparable. If then colors and states had entered into the mixture, and if separation took place, there would be a white or a healthy which was nothing but white or healthy, that is was not the predicate of a subject. So his mind is an absurd person aiming at the impossible, if he is supposed to wish to separate them, and it is impossible to do so, both in respect of quantity and of quality, because there is no minimum magnitude, and of quality, because affections are inseparable, nor is Anaxagoras right about the coming to be of homogeneous bodies. It is true there is a sense in which clay is divided into pieces of clay, but there is another in which it is not. Water and air are, and are generated from each other, but not in the way in which bricks come from a house and again a house from bricks, and it is better to assume a smaller and finite number of principles, as Empedocles does. All thinkers then agree in making the contraries principles, both those who describe the all as one and unmoved, for even Parmenides treats hot and cold as principles under the names of fire and earth, and those too who use the rare and the dense. The same is true of Democritus also, with his plenum and void, both of which exist. B says, the one as being, the other as not being. Again he speaks of differences in position, shape, and order, and these are genera of which the species are contraries, namely, of position, above and below, before and behind, of shape, angular and angle-less, straight and round. It is plain then that they all in one way or another identify the contraries with the principles. And with good reason. For first principles must not be derived from one another nor from anything else, while everything has to be derived from them. But these conditions are fulfilled by the primary contraries, which are not derived from anything else because they are primary, nor from each other because they are contraries. But we must see how this can be arrived at as a reasoned result, as well as in the way just indicated. Our first presupposition must be that in nature nothing acts on, or is acted on by, any other thing at random, nor may anything come from anything else, unless we mean that it does so in virtue of concomitant attribute. For how could white come from musical, unless musical happened to be an attribute of the not white or of the black? No, white comes from not white and not from any not white, but from black or some intermediate color. Similarly, musical comes to be from not musical, but not from anything other than musical, but from unmusical or any intermediate state there may be. Nor again do things pass into the first chance thing. White does not pass into musical, except, it may be, in virtue of concomitant attribute, but into not white and not into any chance thing which is not white, but into black or an intermediate color. Musical passes into not musical and not into any chance thing other than musical, but into unmusical or any intermediate state there may be. The same holds of other things also, even things which are not simple but complex follow the same principle, but the opposite state has not received a name, so we fail to notice the fact. What is in tune must come from what is not in tune, and vice versa. The tuned passes into untunedness and not into any untunedness, but into the corresponding opposite. It does not matter whether we take attunement, order, or composition for our illustration, the principle is obviously the same in all, and in fact applies equally to the production of a house, a statue, or any other complex. A house comes from certain things in a certain state of separation instead of conjunction, a statue, or any other thing that has been shaped, from shapelessness, each of these objects being partly order and partly composition. If then this is true, everything that comes to be or passes away from, or passes into, its contrary or an intermediate state. But the intermediates are derived from the contraries' colors, for instance, from black and white. Everything, therefore, that comes to be by a natural process is either a contrary or a product of contraries. Up to this point we have practically had most of the other writers on the subject with us, as I have said already, for all of them identify their elements, and what they call their principles, with the contraries, giving no reason indeed for the theory, but constrained as it were by the truth itself. They differ, however, from one another in that some assume contraries which are more primary, others contraries which are less so, some those more knowable in the order of explanation, others those more familiar to sense. For some make hot and cold, or again moist and dry, the conditions of becoming, while others make odd and even, or again love and strife, and these differ from each other in the way mentioned. Hence their principles are in one sense the same, in another different certainly, as indeed most people think, but the same inasmuch as they are analogous, for all are taken from the same table of columns, some of the pairs being wider, others narrower in extent. In this way then their theories are both the same and different, some better, some worse, some, as I have said, take as their contraries what is more knowable in the order of explanation, others what is more familiar to sense. The universal is more knowable in the order of explanation, the particular in the order of sense, for explanation has to do with the universal, sense with the particular, the great and the small, for example, belong to the former class, the dense and the rare to the latter. It is clear then that our principles must be contraries. The next question is whether the principles are 2 or 3 or more in number. 1 they cannot be, for there cannot be one contrary. Nor can they be innumerable, because, if so, being will not be knowable, and in any one genus there is only one contrariety, and substance is one genus. Also a finite number is sufficient, and a finite number, such as the principles of Empedocles, is better than an infinite multitude, for Empedocles professes to obtain from his principles all that Anaxagoras obtains from his innumerable principles. Lastly, some contraries are more primary than others, and some arise from others, for example sweet and bitter, white and black, whereas the principles must always remain principles. This will suffice to show that the principles are neither one nor innumerable. Granted, then, that they are a limited number, it is plausible to suppose them more than 2. For it is difficult to see how either density should be of such a nature as to act in any way on rarity or rarity on density. The same is true of any other pair of contraries, for love does not gather strife together and make things out of it, nor does strife make anything out of love, but both act on a third thing different from both. Some indeed assume more than one such thing from which they construct the world of nature. Other objections to the view that it is not necessary to assume a third principle as a substratum may be added. 1. We do not find that the contraries constitute the substance of anything. But what is a first principle ought not to be the predicate of any subject. If it were, there would be a principle of the supposed principle, for the subject is a principle, and prior presumably to what is predicated of it. Again, 2. We hold that a substance is not contrary to another substance. How then can substance be derived from what are not substances? Or how can non-substances be prior to substance? If then we accept both the former argument and this one, we must, to preserve both, assume a third somewhat as the substratum of the contraries, such as is spoken of by those who describe the all as one nature, water or fire, or what is intermediate between them. What is intermediate seems preferable, for fire, earth, air, and water are already involved with pairs of contraries. There is, therefore, much to be said for those who make the underlying substance different from these four. Of the rest, the next best choice is air, as presenting sensible differences in a less degree than the others, and after air, water. All, however, agree in this, that they differentiate their one by means of the contraries, such as density and rarity and more and less, which may of course be generalized, as has already been said, into excess and defect. Indeed, this doctrine too, that the one and excess and defect are the principles of things, would appear to be of old standing, though in different forms, for the early thinkers made the two the active and the one the passive principle, whereas some of the more recent maintain the reverse. To suppose then that the elements are three in number would seem, from these and similar considerations, a plausible view, as I said before. On the other hand, the view that they are more than three in number would seem to be untenable, for the one substratum is sufficient to be acted on, but if we have four contraries, there will be two contrarieties, and we shall have to suppose an intermediate nature for each pair separately. If, on the other hand, the contrarieties, being two, can generate from each other, the second contrariety will be superfluous. Moreover, it is impossible that there should be more than one primary contrariety. For substance is a single genus of being, so that the principles can differ only as prior and posterior, not in genus. In a single genus there is always a single contrariety, all the other contrarieties in it being held to be reducible to one. It is clear then that the number of elements is neither one nor more than two or three, but whether two or three is, as I said, a question of considerable difficulty. We will now give our own account, approaching the question first with reference to becoming in its widest sense, for we shall be following the natural order of inquiry if we speak first of common characteristics, and then investigate the characteristics of special cases. We say that one thing comes to be from another thing, and one sort of thing from another sort of thing, both in the case of simple and of complex things. I mean the following. We can say, 1. Man becomes musical, 2. What is not musical becomes musical, or, 3. The not musical man becomes a musical man. Now what becomes in 1 and 2 man and not musical I call simple, and what each becomes musical simple also. But when 3, we say the not musical man becomes a musical man, both what becomes and what it becomes are complex. As regards one of these simple things that become, we say not only this becomes so and so, but also from being this, comes to be so and so, as from being not musical comes to be musical. As regards the other we do not say this in all cases, as we do not say, 1, from being a man he came to be musical but only the man became musical. When a simple thing is said to become something, in one case, 1, it survives through the process, in the other, 2, it does not. For man remains a man and is such even when he becomes musical, whereas what is not musical or is unmusical does not continue to exist, either simply or combined with the subject. These distinctions drawn, one can gather from surveying the various cases of becoming in the way we are describing that, as we say, there must always be an underlying something, namely that which becomes, and that this, though always one numerically, in form at least is not one. By that I mean that it can be described in different ways, for to be man is not the same as to be unmusical. One part survives, the other does not. What is not an opposite survives, for man survives, but not musical or unmusical does not survive, nor does the compound of the two, namely unmusical man. We speak of becoming that from this instead of this becoming that more in the case of what does not survive the change becoming musical from unmusical, not from man, but there are exceptions. As we sometimes use the latter form of expression even of what survives, we speak of a statue coming to be from bronze, not of the bronze becoming a statue. The change, however, from an opposite which does not survive is described indifferently in both ways, becoming that from this or this becoming that. we say both that the unmusical becomes musical, and that from unmusical he becomes musical. And so both forms are used of the complex, becoming a musical man from an unmusical man, and unmusical man becoming a musical man. But there are different senses of coming to be. In some cases we do not use the expression come to be, but come to be so and so. Only substances are said to come to be in the unqualified sense. Now in all cases other than substance it is plain that there must be some subject, namely, that which becomes. For we know that when a thing comes to be of such a quantity or quality or in such a relation, time, or place, a subject is always presupposed, since substance alone is not predicated of another subject, but everything else of substance. But that substance is too, and anything else that can be said to be without qualification, come to be from some substratum, will appear on examination. For we find in every case something that underlies from which proceeds that which comes to be, for instance, animals and plants from seed. Generally things which come to be in different ways: 1. By change of shape, as a statue; 2. By addition, as things which grow; 3. By taking away, as the Hermes from the stone; 4. By putting together, as a house; 5. By alteration, as things which turn in respect of their material substance. It is plain that these are all cases of coming to be from a substratum. Thus, clearly, from what has been said, whatever comes to be is always complex. There is, on the one hand, a, something which comes into existence, and again, b, something which becomes the latter, b, in two senses, either the subject or the opposite. By the opposite I mean the unmusical, by the subject man, and similarly I call the absence of shape or form or order the opposite, and the bronze or stone or gold the subject. Plainly then, if there are conditions and principles which constitute natural objects and from which they primarily are or have come to be, I mean, what each is said to be in its essential nature, not what each is in respect of a concomitant attribute. Plainly, I say, everything comes to be from both subject and form. For musical man is composed, in a way, of man and musical. You can analyze it into the definitions of its elements. It is clear then that what comes to be will come to be from these elements. Now the subject is one numerically, though it is two in form. For it is the man, the gold, the matter generally that is counted, for it is more of the nature of a this, and what comes to be does not come from it in virtue of concomitant attribute. The privation, on the other hand, and the contrary are incidental in the process, and the positive form is one the order, the acquired art of music, or any similar predicate. There is a sense, therefore, in which we must declare the principles to be two, and a sense in which they are three, a sense in which the contraries of the principles, say for example the musical and the unmusical, the hot and the cold, the tuned and the untuned, and a sense in which they are not, since it is impossible for the contraries to be acted on by each other. But this difficulty also is solved by the fact that the substratum is different from the contraries, for it is itself not a contrary. The principles therefore are, in a way, not more in number than the contraries, but as it were two, nor yet precisely two, since there is a difference of essential nature, but three. For to be man is different from to be unmusical, and to be unformed from to be bronze. We have now stated the number of the principles of natural objects which are subject to generation, and how the number is reached, and it is clear that there must be a substratum for the contraries, and that the contraries must be two. Yet in another way of putting it this is not necessary, as one of the contraries will serve to effect the change by its successive absence and presence. The underlying nature is an object of scientific knowledge, by an analogy. For as the bronze is to the statue, the wood to the bed, or the matter and the formless before receiving form to anything which has form, so is the underlying nature to substance, that is the this or existent. This then is one principle, though not one or existent in the same sense as the this, and the definition was one as we agreed. Then further there is its contrary, the privation. In what sense these are two, and in what sense more, has been stated above. Briefly, we explained first that only the contraries were principles, and later that a substratum was indispensable, and that the principles were three. Our last statement has elucidated the difference between the contraries, the mutual relation of the principles, and the nature of the substratum. Whether the form or the substratum is the essential nature of a physical object is not yet clear. But that the principles are three, and in what sense, and the way in which each is a principle, is clear. So much then for the question of the number and the nature of the principles. We will now proceed to show that the difficulty of the early thinkers, as well as our own, is solved in this way alone. The first of those who studied science were misled in their search for truth and the nature of things by their inexperience, which as it were thrust them into another path. So they say that none of the things that are either comes to be or passes out of existence, because what comes to be must do so either from what is or from what is not, both of which are impossible. For what is cannot come to be, because it is already, and from what is not nothing could have come to be, because something must be present as a substratum. So too they exaggerated the consequence of this, and went so far as to deny even the existence of a plurality of things, maintaining that only being itself is. Such then was their opinion, and such the reason for its adoption. Our explanation on the other hand is that the phrases something comes to be from what is or from what is not or what is does something or has something done to it or becomes some particular thing, are to be taken, in the first way of putting our explanation, in the same sense as a doctor does something or has something done to him, is or becomes something from being a doctor. These expressions may be taken in two senses, and so too, clearly, may from being, and being acts or is acted on. A doctor builds a house, not qua doctor, but qua house builder, and turns grey, not qua doctor, but qua dark-haired. On the other hand he doctors or fails to doctor qua doctor. But we are using words most appropriately when we say that a doctor does something or undergoes something, or becomes something from being a doctor, if he does, undergoes, or becomes qua doctor. Clearly then also to come to be so and so from not being means qua not being. It was through failure to make this distinction that those thinkers gave the matter up, and through this error that they went so much farther astray as to suppose that nothing else comes to be or exists apart from being itself, thus doing away with all becoming. We ourselves are in agreement with them in holding that nothing can be said without qualification to come from what is not. But nevertheless we maintain that a thing may come to be from what is not, that is, in a qualified sense. For a thing comes to be from the privation, which in its own nature is not being, this not surviving as a constituent of the result. Yet this causes surprise, and it is thought impossible that something should come to be in the way described from what is not. In the same way we maintain that nothing comes to be from being, and that being does not come to be except in a qualified sense. In that way, however, it does, just as animal might come to be from animal, and an animal of a certain kind from an animal of a certain kind. Thus, suppose a dog to come to be from a horse. The dog would then, it is true, come to be from animal, as well as from an animal of a certain kind, but not as animal, for that is already there. But if anything is to become an animal, not in a qualified sense, it will not be from animal, and if being, not from being nor from not being either, for it has been explained that by from not being we mean from not being qua not being. Note further that we do not subvert the principle that everything either is or is not. This then is one way of solving the difficulty. Another consists in pointing out that the same things can be explained in terms of potentiality and actuality. But this has been done with greater precision elsewhere. So, as we said, the difficulties which constrain people to deny the existence or some of the things we mentioned are now solved. For it was this reason which also caused some of the earlier thinkers to turn so far aside from the road which leads to coming to be and passing away and change generally. If they had come in sight of this nature, all their ignorance would have been dispelled. Others, indeed, have apprehended the nature in question, but not adequately. In the first place they allow that a thing may come to be without qualification from not being, accepting on this point the statement of Parmenides. Secondly, they think that if the substratum is one numerically, it must have also only a single potentiality, which is a very different thing. Now we distinguish matter and privation, and hold that one of these, namely the matter, is not being only in virtue of an attribute which it has, while the privation in its own nature is not being, and that the matter is merely, in a sense is, substance, while the privation in no sense is. They, on the other hand, identify their great and small alike with not being, and that whether they are taken together as one or separately. Their triad is therefore of quite a different kind from ours. For they got so far as to see that there must be some underlying nature, but they make it one, for even if one philosopher makes a dyad of it, which he calls great and small, the effect is the same, for he overlooked the other nature. For the one which persists is a joint cause, with the form, of what comes to be a mother, as it were. But the negative part of the contrariety may often seem, if you concentrate your attention on it, as an evil agent, not to exist at all. For admitting with them that there is something divine, good, and desirable, we hold that there are two other principles, the one contrary to it, the other such as of its own nature to desire and yearn for it. But the consequence of their view is that the contrary desires its extinction. Yet the form cannot desire itself, for it is not defective, nor can the contrary desire it, for contraries are mutually destructive. The truth is that what desires the form is matter, as the female desires the male and the ugly the beautiful, only the ugly or the female not per se but per accidens. The matter comes to be and ceases to be in one sense, while in another it does not. As that which contains the privation, It ceases to be in its own nature, for what ceases to be the privation is contained within it. But as potentiality it does not cease to be in its own nature, but is necessarily outside the sphere of becoming and ceasing to be. For if it came to be, something must have existed as a primary substratum from which it should come and which should persist in it, but this is its own special nature, so that it will be before coming to be. For my definition of matter is just this: the primary substratum of each thing, from which it comes to be without qualification, and which persists in the result, and if it ceases to be it will pass into that at the last, so it will have ceased to be before ceasing to be. The accurate determination of the first principle in respect of form, whether it is one or many and what it is or what they are, is the province of the primary type of science, so these questions may stand over till then. But of the natural, that is perishable, forms we shall speak in the expositions which follow. The above, then, may be taken as sufficient to establish that there are principles and what they are and how many there are. Now let us make a fresh start and proceed. Physics, Book 2, translated by R.P. Hardy and Dark-Ag. Of things that exist, some exist by nature, some from other causes. By nature the animals and their parts exist, and the plants and the simple bodies, earth, fire, air, water, for we say that these and the like exist by nature. All the things mentioned present a feature in which they differ from things which are not constituted by nature. Each of them has within itself a principle of motion and of stationariness, in respect of place, or of growth and decrease, or by way of alteration. On the other hand, a bed and a coat and anything else of that sort, qua receiving these designations, that is, in so far as they are products of act, have no innate impulse to change. But in so far as they happen to be composed of stone or of earth or of a mixture of the two, they do have such an impulse, and just to that extent which seems to indicate that nature is a source or cause of being moved and of being at rest in that to which it belongs primarily, in virtue of itself and not in virtue of concomitant attribute. I say not in virtue of a concomitant attribute, because, for instance, a man who is a doctor might cure himself. Nevertheless, it is not in so far as he is a patient that he possesses the art of medicine. It merely has happened that the same man is doctor and patient, and that is why these attributes are not always found together. So it is with all other artificial products. None of them has in itself the source of its own production. But while in some cases, for instance houses and the other products of manual labor, that principle is in something else external to the thing, in others those which may cause a change in themselves in virtue of a concomitant attribute lies in the things themselves, but not in virtue of what they are. Nature then is what has been stated. Things have a nature which have a principle of this kind. Each of them is a substance, for it is a subject, and nature always implies a subject in which it inheres. The term according to nature is applied to all these things and also to the attributes which belong to them in virtue of what they are. For instance, the property of fire to be carried upwards, which is not a nature nor has a nature but is by nature or according to nature. What nature is, then, and the meaning of the terms by nature and according to nature, has been stated. That nature exists, it would be absurd to try to prove, for it is obvious that there are many things of this kind, and to prove what is obvious by what is not is the mark of a man who is unable to distinguish what is self-evident from what is not. This state of mind is clearly possible. A man blind from birth might reason about colors. Presumably therefore such persons must be talking about words without any thought to correspond. Some identify the nature or substance of a natural object with that immediate constituent of it which taken by itself is without arrangement. For example, the wood is the nature of the bed, and the bronze the nature of the statue. As an indication of this, Antiphon points out that if you planted a bed and the rotting wood acquired the power of sending up a shoot, it would not be a bed that would come up, but wood, which shows that the arrangement in accordance with the rules of the art is merely an incidental attribute, whereas the real nature is the other, which, further, persists continuously through the process of making. But if the material of each of these objects has itself the same relation to something else, say bronze, or gold, to water, bones, or wood, to earth and so on, that, they say, would be their nature and essence. Consequently some assert earth, others fire or air or water or some or all of these, to be the nature of the things that are. For whatever any one of them supposed to have this character, whether one thing or more than one thing, this or these he declared to be the whole of substance, all else being its affections, states, or dispositions. Every such thing they held to be eternal, for it could not pass into anything else, but other things to come into being and cease to be times without number. This then is one account of nature, namely that it is the immediate material substratum of things which have in themselves a principle of motion or change. Another account is that nature is the shape or form which is specified in the definition of the thing. for the word nature is applied to what is according to nature and the natural in the same way as art is applied to what is artistic or a work of art. We should not say in the latter case that there is anything artistic about a thing, if it is a bed only potentially, not yet having the form of a bed, nor should we call it a work of art. The same is true of natural compounds. What is potentially flesh or bone has not yet its own nature, and does not exist until it receives the form specified in the definition, which we name in defining what flesh or bone is. Thus in the second sense of nature it would be the shape or form, not separable except in statement, of things which have in themselves a source of motion. The combination of the two, for example man, is not nature but by nature or natural. The form indeed is nature rather than the matter, for a thing is more properly said to be what it is when it has attained to fulfillment than when it exists potentially. Again man is born from man, but not bed from bed. That is why people say that the figure is not the nature of a bed, but the wood is. If the bed sprouted not a bed but wood would come up. But even if the figure is art, then on the same principle the shape of man is his nature. For man is born from man. We also speak of a thing's nature as being exhibited in the process of growth by which its nature is attained. The nature in this sense is not like doctoring, which leads not to the art of doctoring but to health. Doctoring must start from the art, not lead to it. But it is not in this way that nature, in the one sense, is related to nature, in the other. What grows qua growing grows from something into something. Into what then does it grow? Not into that from which it arose but into that to which it tends. The shape then is nature. Shape and nature, it should be added, are in two senses. For the privation too is in a way form. But whether in unqualified coming to be there is privation, that is a contrary to what comes to be, we must consider later. We have distinguished, then, the different ways in which the term nature is used. The next point to consider is how the mathematician differs from the physicist. Obviously physical bodies contain surfaces and volumes, lines and points, and these are the subject matter of mathematics. Further, is astronomy different from physics or a department of it? It seems absurd that the physicist should be supposed to know the nature of sun or moon, but not to know any of their essential attributes, particularly as the writers on physics obviously do discuss their shape also and whether the earth and the world are spherical or not. Now the mathematician, though he too treats of these things, nevertheless does not treat of them as the limits of a physical body, nor does he consider the attributes indicated as the attributes or such bodies. That is why he separates them, for in thought they are separable from motion, and it makes no difference, nor does any falsity result, if they are separated. The holders of the theory of forms do the same, though they are not aware of it, for they separate the objects of physics, which are less separable than those of mathematics. This becomes plain if one tries to state in each of the two cases the definitions of the things and of their attributes. Odd and even, straight and curved, and likewise number, line, and figure, do not involve motion. Not so flesh and bone and man, these are defined like snub nose, not like curved. Similar evidence is supplied by the more physical of the branches of mathematics, such as optics, harmonics, and astronomy. These are in a way the converse of geometry. While geometry investigates physical lines but not qua physical, optics investigates mathematical lines, but qua physical, not qua mathematical. Since nature has two senses, the form and the matter, we must investigate its objects as we would the essence of snubness. That is, such things are neither independent of matter nor can be defined in terms of matter only. Here too indeed one might raise a difficulty. Since there are two natures, with which is the physicist concerned? Or should he investigate the combination of the two? But if the combination of the two, then also each severally. Does it belong then to the same or to different sciences to know each severally? If we look at the ancients, physics would to be concerned with the matter. It was only very slightly that Empedocles and Democritus touched on the forms and the essence. But if on the other hand art imitates nature, and it is the part of the same discipline to know the form and the matter up to a point, for example the doctor has a knowledge of health and also of bile and phlegm, in which health is realized, and the builder both of the form of the house and of the matter, namely that it is bricks and beams, and so forth. If this is so, it would be the part of physics also to know nature in both its senses. Again, that for the sake of which, or the end, belongs to the same department of knowledge as the means. But the nature is the end or that for the sake of which. For if a thing undergoes a continuous change and there is a stage which is last, this stage is the end or that for the sake of which. That is why the poet was carried away into making an absurd statement when he said he has the end for the sake of which he was born. For not every stage that is last claims to be an end, but only that which is best. For the arts make their material, some simply make it, others make it serviceable, and we use everything as if it was there for our sake. We also are in a sense an end. That for the sake of which has two senses, the distinction is made in our work on philosophy. The arts, therefore, which govern the matter and have knowledge are two, namely the art which uses the product and the art which directs the production of it. That is why the using art also is in a sense directive, but it differs in that it knows the form, whereas the art which is directive as being concerned with production knows the matter. For the helmsman knows and prescribes what sort of form a helm should have, the other from what wood it should be made and by means of what operations. In the products of art, however, we make the material with a view to the function, whereas in the products of nature the matter is there all along. Again, matter is a relative term, to each form there corresponds a special matter. How far then must the physicist know the form or essence? Up to a point, perhaps, as the doctor must know sinew or the smith bronze, that is until he understands the purpose of each, and the physicist is concerned only with things whose forms are separable indeed, but do not exist apart from matter. Man is begotten by man and by the sun as well. The mode of existence and essence of the separable it is the business of the primary type of philosophy to define. Now that we have established these distinctions, we must proceed to consider causes, their character and number. Knowledge is the object of our inquiry, and men do not think they know a thing till they have grasped the why of, which is to grasp its primary cause. So clearly we too must do this as regards both coming to be and passing away and every kind of physical change, in order that, knowing their principles, we may try to refer to these principles each of our problems. In one sense, then, one, that out of which a thing comes to be and which persists, is called cause, for example the bronze of the statue, the silver of the bowl, and the genera of which the bronze and the silver are species. In another sense, two, the form or the archetype, that is the statement of the essence, and its genera, are called causes, for example of the octave the relation of 2 to 1, and generally number, and the parts in the definition. Again, 3. The primary source of the change or coming to rest, for example the man who gave advice is a cause. The further is cause of the child, and generally what makes of what is made and what causes change of what is changed. Again, 4. In the sense of end or that for the sake of which a thing is done, for example health is the cause of walking about. Why is he walking about? We say, to be healthy, and, having said that, we think we have assigned the cause. The same is true also of all the intermediate steps which are brought about through the action of something else as means towards the end, for example reduction of flesh, purging, drugs, or surgical instruments are means towards health. All these things are for the sake of the end, though they differ from one another in that some are activities, others instruments. This then perhaps exhausts the number of ways in which the term cause is used. As the word had several senses, it follows that there are several causes of the same thing not merely in virtue of concomitant attribute, for example both the art of the sculptor and the bronze are causes of the statue. These are causes of the statue qua statue, not in virtue of anything else that it may be only not in the same way, the one being the material cause, the other the cause whence the motion comes. Some things cause each other reciprocally, for example hard work causes fitness and vice versa, but again not in the same way, but the one as end, the other as the origin of change. Further the same thing is the cause of contrary results. For that which by its presence brings about one result is sometimes blamed for bringing about the contrary by its absence. Thus we ascribe the wreck of a ship to the absence of the pilot whose presence was the cause of its safety. All the causes now mentioned fall into 4 familiar divisions. The letters are the causes of syllables, the material of artificial products, fire, and sea, of bodies, the parts of the whole, and the premises of the conclusion, in the sense of that from which. Of these pairs the one set are causes in the sense of substratum, for example the parts, the other set in the sense of essence the whole and the combination and the form. But the seed and the doctor and the advisor, and generally the maker, are all sources whence the change or stationariness originates, while the others are causes in the sense of the end or the good of the rest, for that for the sake of which means what is best and the end of the things that lead up to it. Whether we say the good itself or the apparent good makes no difference. Such then is the number and nature of the kinds of cause. Now the modes of causation are many, though when brought under heads they too can be reduced in number. For cause is used in many senses and even within the same kind one may be prior to another. For example the doctor and the expert are causes of health. The relation 2 to 1 and number of the octave, and always what is inclusive to what is particular. Another mode of causation is the incidental and its genera, for example in one way polyklitis, in another sculptor is the cause of a statue, because being polyklitis and sculptor are incidentally conjoined. Also the classes in which the incidental attribute is included, thus a man could be said to be the cause of a statue or, generally, a living creature. An incidental attribute too may be more or less remote. For example, suppose that a pale man or a musical man were said to be the cause of the statue. All causes, both proper and incidental, may be spoken of either as potential or as actual. For example, the cause of a house being built is either house builder or house builder building. Similar distinctions can be made in the things of which the causes are causes, for example of the statue or of image generally, of this bronze or of material generally. So too with the incidental attributes. Again, we may use a complex expression for either and say, for example, neither Polykleitos nor sculptor but Polykleitos, sculptor. All these various uses, however, come to 6 in number, under each of which again the usage is twofold. Cause means either what is particular or a genus, or an incidental attribute or a genus of that, and these either as a complex or each by itself, and all 6 either as actual or as potential. The difference is this much, that causes which are actually at work and particular exist and cease to exist simultaneously with their effect. For example, this healing person with this being healed person, and that house building man with that being built house. But this is not always true of potential causes. The house and the house builder do not pass away simultaneously. In investigating the cause of each thing, it is always necessary to seek what is most precise, as also in other things. Thus man builds because he is a builder, and a builder builds in virtue of his art of building. This last cause then is prior, and so generally. Further, generic effects should be assigned to generic causes, particular effects to particular causes. For example, statue to sculptor, this statue to this sculptor, and powers are relative to possible effects, actually operating causes to things which are actually being affected. This must suffice for our account of the number of causes and the modes of causation. But chance also and spontaneity are reckoned among causes. Many things are said both to be and to come to be as a result of chance and spontaneity. We must inquire therefore in what manner chance and spontaneity are present among the causes enumerated, and whether they are the same or different, and generally what chance and spontaneity are. Some people even question whether they are real or not. They say that nothing happens by chance, but that everything which we ascribe to chance or spontaneity has some definite cause. For example, coming by chance into the market and finding there a man whom one wanted but did not expect to meet is due to one's wish to go and buy in the market. Similarly, in other cases of chance it is always possible, they maintain, to find something which is the cause, but not chance, for if chance were real, it would seem strange indeed, and the question might be raised, why on earth none of the wise men of old in speaking of the causes of generation and decay took account of chance, whence it would seem that they too did not believe that anything is by chance. But there is a further circumstance that is surprising. Many things both come to be and are by chance and spontaneity, and although know that each of them can be ascribed to some cause, as the old argument said which denied chance, nevertheless they speak of some of these things as happening by chance and others not. For this reason also they ought to have at least referred to the matter in some way or other. Certainly the early physicists found no place for chance among the causes which they recognized: love, strife, mind, fire, or the like. This is strange, whether they supposed that there is no such thing as chance, or whether they thought there is but omitted to mention it, and that too when they sometimes used it, as Empedocles does when he says that the air is not always separated into the highest region, but as it may chance. At any rate he says in his cosmogony that it happened to run that way at that time, but it often ran otherwise. He tells us also that most of the parts of animals came to be by chance. There are some too who ascribe this heavenly sphere and all the worlds to spontaneity. They say that the vortex arose spontaneously, that is the motion that separated and arranged in its present order all that exists. This statement might well cause surprise, for they are asserting that chance is not responsible for the existence or generation of animals and plants, nature or mind or something of the kind being the cause of them, for it is not any chance thing that comes from a given seed but knowledge from one kind and a man from another, and yet at the same time they assert that the heavenly sphere and the divinest of visible things arose spontaneously, having no such cause as is assigned to animals and plants. Yet if this is so, it is a fact which deserves to be dwelt upon, and something might well have been said about it. For besides the other absurdities of the statement, it is the more absurd that people should make it when they see nothing coming to be spontaneously in the heavens, but much happening by chance among the things which as they say are not due to chance, whereas we should have expected exactly the opposite. Others there are who, indeed, believe that chance is a cause, but that it is inscrutable to human intelligence, as being a divine thing and full of mystery. Thus we must inquire what chance and spontaneity are, whether they are the same or different, and how they fit into our division of causes. First then we observe that some things always come to pass in the same way, and others for the most part. It is clearly of neither of these that chance is said to be the cause, nor can the effect of chance be identified with any of the things that come to pass by necessity and always, or for the most part. But as there is a third class of events besides these two events which all say are by chance, it is plain that there is such a thing as chance and spontaneity, for we know that things of this kind are due to chance and that things due to chance are of this kind. But, secondly, some events are for the sake of something, others not. Again, some of the former class are in accordance with deliberate intention, others not, but both are in the class of things which are for the sake of something. Hence it is clear that even among the things which are outside the necessary and the normal, there are some in connection with which the phrase for the sake of something is applicable. Events that are for the sake of something include whatever may be done as a result of thought or of nature, things of this kind. Then, when they come to pass incidental are said to be by chance. For just as a thing is something either in virtue of itself or incidentally, so may it be a cause. For instance, the house-building faculty is in virtue of itself the cause of a house, whereas the pale or the musical is the incidental cause. That which is per se cause of the effect is determinate, but the incidental cause is indeterminable, for the possible attributes of an individual are innumerable. To resume then, when a thing of this kind comes to pass among events which are for the sake of something, it is said to be spontaneous or by chance. The distinction between the two must be made later. For the present it is sufficient if it is plain that both are in the sphere of things done for the sake of something. Example, a man is engaged in collecting subscriptions for a feast. He would have gone to such and such a place for the purpose of getting the money, if he had known. He actually went there for another purpose, and it was only incidentally that he got his money by going there, and this was not due to the fact that he went there as a rule or necessarily, nor is the end effected, getting the money, a cause present in himself. It belongs to the class of things that are intentional and the result of intelligent deliberation. It is when these conditions are satisfied that the man is said to have gone by chance. If he had gone of deliberate purpose and for the sake of this, if he always or normally went there when he was collecting payments, he would not be said to have gone by chance. It is clear then that chance is an incidental cause in the sphere of those actions for the sake of something which involve purpose. Intelligent reflection, then, and chance are in the same sphere, for purpose implies intelligent reflection. It is necessary, no doubt, that the causes of what comes to pass by chance be indefinite, and that is why chance is supposed to belong to the class of the indefinite and to be inscrutable to man, and why it might be thought that, in a way, nothing occurs by chance. For all these statements are correct, because they are well grounded. Things do, in a way, occur by chance, for they occur incidentally, and chance is an incidental cause. But strictly it is not the cause without qualification of anything. For instance, a house builder is the cause of a house. Incidentally, a flute player may be so. And the causes of the man's coming and getting the money, when he did not come for the sake of that, are innumerable. He may have wished to see somebody, or been following somebody, or avoiding somebody, or may have gone to see a spectacle. Thus to say that chance is a thing contrary to rule is correct. For rule applies to what is always true or true for the most part, whereas chance belongs to a third type of event. Hence, to conclude, since causes of this kind are indefinite, chance too is indefinite. Yet in some cases one might raise the question whether any incidental fact might be the cause of the chance occurrence. For example, of health, the fresh air or the sun's heat may be the cause, but having had one's hair cut cannot, for some incidental causes are more relevant to the effect than others. Chance or fortune is called good when the result is good, evil when it is evil. The terms good fortune and ill fortune are used when either result is of considerable magnitude. Thus one who comes within an ace of some great evil or great good is said to be fortunate or unfortunate. The mind affirms the essence of the attribute, ignoring the hair's breadth of difference. Further, it is with reason that good fortune is regarded as unstable, for chance is unstable, as none of the things which result from it can be invariable or normal. Both are then, as I have said, incidental causes, both chance and spontaneity, in the sphere of things which are capable of coming to pass not necessarily, nor normally, and with reference to such of these as might come to pass for the sake of something. They differ in that spontaneity is the wider term. Every result of chance is from what is spontaneous, but not everything that is from what is spontaneous is from chance. Chance and what results from chance are appropriate to agents that are capable of good fortune and of moral action generally. Therefore necessarily chance is in the sphere of moral actions. This is indicated by the fact that good fortune is thought to be the same, or nearly the same, as happiness, and happiness to be a kind of moral action, since it is well-doing. Hence what is not capable of moral action cannot do anything by chance. Thus an inanimate thing or a lower animal or a child cannot do anything by chance, because it is incapable of deliberate intention, nor can good fortune or ill fortune be ascribed to them, except metaphorically, as Protagoras, for example, said that the stones of which altars are made are fortunate because they are held in honor, while their fellows are trodden underfoot. Even these things, however, can in a way be affected by chance, when one who is dealing with them does something to them by chance, but not otherwise. The spontaneous on the other hand is found both in the lower animals and in many inanimate objects. We say, for example, that the horse came spontaneously, because, though his coming saved him, he did not come for the sake of safety. Again, the tripod fell of itself, because, though when it fell it stood on its feet so as to serve for a seat, it did not fall for the sake of that. Hence it is clear that events which, 1. belong to the general class of things that may come to pass for the sake of something, 2. do not come to pass for the sake of what actually results, and, 3. have an external cause, may be described by the phrase from spontaneity. These spontaneous events are said to be from chance if they have the further characteristics of being the objects of deliberate intention and due to agents capable of that mode of action. This is indicated by the phrase in vain, which is used when A which is for the sake of B, does not result in B. For instance, taking a walk is for the sake of evacuation of the bowels. If this does not follow after walking, we say that we have walked in vain and that the walking was vain. This implies that what is naturally the means to an end is in vain, when it does not affect the end towards which it was the natural means, for it would be absurd for a man to say that he had bathed in vain because the sun was not eclipsed, since the one was not done with a view to the other. Thus the spontaneous is even according to its derivation the case in which the thing itself happens in vain. The stone that struck the man did not fall for the purpose of striking him, therefore it fell spontaneously, because it might have fallen by the action of an agent and for the purpose of striking. The difference between spontaneity and what results by chance is greatest in things that come to be by nature, for when anything comes to be contrary to nature, we do not say that it came to be by chance, but by spontaneity. Yet strictly this too is different from the spontaneous proper, for the cause of the latter is external, that of the former internal. We have now explained what chance is and what spontaneity is, and in what they differ from each other. Both belong to the mode of causation, source of change, for either some natural or some intelligent agent is always the cause, but in this sort of causation the number of possible causes is infinite. Spontaneity and chance are causes of effects which, though they might result from intelligence or nature, have in fact been caused by something incidentally. Now since nothing which is incidental is prior to what is per se, it is clear that no incidental cause can be prior to a cause per se. Spontaneity and chance, therefore, are posterior to intelligence and nature. Hence, however true it may be that the heavens are due to spontaneity, it will still be true that intelligence and nature will be prior causes of this all and of many things in it besides. It is clear then that there are causes, and that the number of them is what we have stated. The number is the same as that of the things comprehended under the question why. The why is referred ultimately either, 1. in things which do not involve motion, for example in mathematics, to the what, to the definition of straight line or commensurable, and c. or 2. to what initiated a motion, for example why did they go to war ? Because there had been a raid, or 3. we are inquiring for the sake of what ? that they may rule, or 4. in the case of things that come into being, we are looking for the matter. The causes, therefore, are these and so many in number. Now, the causes being 4, it is the business of the physicist to know about them all, and if he refers his problems back to all of them, he will assign the why in the way proper to his science, the matter, the form, the mover, that for the sake of which. The last 3 often coincide, for the what and that for the sake of which are one, while the primary source of motion is the same in species as these, for man generates man, and so too, in general, are all things which cause movement by being themselves moved, and such as are not of this kind are no longer inside the province of physics, for they cause motion not by possessing motion or a source of motion in themselves, but being themselves incapable of motion. Hence there are 3 branches of study, one of things which are incapable of motion, the second of things in motion, but indestructible, the third of destructible things. The question why, then, is answered by reference to the matter, to the form, and to the primary moving cause. For in respect of coming to be it is mostly in this last way that causes are investigated. What come to be after what? What was the primary agent or patient? And so at each step of the series. Now the principles which cause motion in a physical way are 2, of which one is not physical, as it has no principle of motion in itself. Of this kind is whatever causes movement, not being itself moved, such as 1. That which is completely unchangeable, the primary reality, and 2. The essence of that which is coming to be, that is the form, for this is the end or that for the sake of which. Hence, since nature is for the sake of something, we must know this cause also. We must explain the why in all the senses of the term, namely, 1. That from this that will necessarily result, from this either without qualification or in most cases. 2. That this must be so if that is to be so, as the conclusion presupposes the premises. 3. That this was the essence of the thing, and 4. Because it is better thus, not without qualification, but with reference to the essential nature in each case. We must explain then, 1. That nature belongs to the class of causes which act for the sake of something. 2. About the necessary and its place in physical problems, for all writers ascribe things to this cause, arguing that since the hot and the cold, and sea, are of such and such a kind, therefore certain things necessarily are and come to be, and if they mention any other cause, one his friendship and strife, another his mind, it is only to touch on it, and then goodbye to it. A difficulty presents itself. Why should not nature work, not for the sake of something, nor because it is better so, but just as the sky rains, not in order to make the corn grow, but of necessity. What is drawn up must cool, and what has been cooled must become water and descend, the result of this being that the corn grows. Similarly, if a man's crop is spoiled on the threshing floor, the rain did not fall for the sake of this in order that the crop might be spoiled, but that result just followed. Why then should it not be the same with the parts in nature, for example that our teeth should come up of necessity, the front teeth sharp, fitted for tearing, the molars broad and useful for grinding down the food, since they did not arise for this end, but it was merely a coincident result, and so with all other parts in which we suppose that there is purpose. Wherever then all the parts came about just what they would have been if they had come be for an end, such things survived, being organized spontaneously in a fitting way, whereas those which grew otherwise perished and continue to perish, as Empedocles says his man-faced ox progeny did. Such are the arguments, and others of the kind, which may cause difficulty on this point. Yet it is impossible that this should be the true view. For teeth and all other natural things either invariably or normally come about in a given way, but of not one of the results of chance or spontaneity is this true. We do not ascribe to chance or mere coincidence the frequency of rain in winter, but frequent rain in summer we do, nor heat in the dog days, but only if we have it in winter. If then, it is agreed that things are either the result of coincidence or for an end, and these cannot be the result of coincidence or spontaneity, it follows that they must be for an end, and that such things are all due to nature. Even the champions of the theory which is before us would agree. Therefore action for an end is present in things which come to be and are by nature. Further, where a series has a completion, all the preceding steps are for the sake of that. Now surely as in intelligent action, so in nature, and as in nature, so it is in each action, if nothing interferes. Now intelligent action is for the sake of an end, therefore the nature of things also is so. Thus if a house, for example, had been a thing made by nature, it would have been made in the same way as it is now by art, and if things made by nature were made also by art, they would come to be in the same way as by nature. Each step then in the series is for the sake of the next, and generally art partly completes what nature cannot bring to a finish, and partly imitates her. If, therefore, artificial products are for the sake of an end, so clearly also are natural products. The relation of the later to the earlier terms of the series is the same in both. This is most obvious in the animals other than man. They make things neither by art nor after inquiry or deliberation. Wherefore people discuss whether it is by intelligence or by some other faculty that these creatures work, spiders, ants, and the like. By gradual advance in this direction we come to see clearly that in plants too that is produced which is conducive to the end leaves, for example grow to provide shade for the fruit. If then it is both by nature and for an end that the swallow makes its nest and the spider its web, and plants grow leaves for the sake of the fruit and send their roots down, not up, for the sake of nourishment, it is plain that this kind of cause is operative and things which come to be and are by nature. And since nature means two things, the matter and the form, of which the latter is the end, and since all the rest is for the sake of the end, the form must be the cause in the sense of that for the sake of which. Now mistakes come to pass even in the operations of art. The grammarian makes a mistake in writing and the doctor pours out the wrong dose. Hence clearly mistakes are possible in the operations of nature also. If then in art there are cases in which what is rightly produced serves a purpose, and if where mistakes occur there was a purpose in what was attempted, only it was not attained, so must it be also in natural products, and monstrosities will be failures in the purposive effort. Thus in the original combinations the ox progeny, if they fail to reach a determinate end, must have arisen through the corruption of some principle corresponding to what is now the seed. Further, seed must have come into being first, and not straightway the animals. The words whole-natured first must have meant seed. Again, in plants too we find the relation of means to end, though the degree of organization is less. Were there then in plants also olive-headed vine progeny, like the man-headed ox progeny, or not? An absurd suggestion, yet there must have been, if there were such things among animals. Moreover, among the seeds anything must have come to be at random. But the person who asserts this entirely does away with nature and what exists by nature. For those things are natural which, by a continuous movement originated from an internal principle, arrive at some completion. The same completion is not reached from every principle, nor any chance completion, but always the tendency in each is towards the same end, if there is no impediment. The end and the means towards it may come about by chance. We say, for instance, that a stranger has come by chance, paid the ransom, and gone away, when he does so as if he had come for that purpose, though it was not for that he came. This is incidental, for chance is an incidental cause, as I remarked before. But when an event takes place always or for the most part, it is not incidental or by chance. In natural products the sequence is invariable, if there is no impediment. It is absurd to suppose that purpose is not present because we do not observe the agent deliberating. Art does not deliberate. If the shipbuilding art were in the wood, it would produce the same results by nature. If, therefore, purpose is present in art, it is present also in nature. The best illustration is a doctor doctoring himself. Nature is like that. It is plain then that nature is a cause that operates for a purpose. As regards what is of necessity, we must ask whether the necessity is hypothetical, or simple as well. The current view places what is of necessity in the process of production, just as if one were to suppose that the wall of a house necessarily comes to be because what is heavy is naturally carried downwards and what is light to the top, wherefore the stones and foundations take the lowest place, with earth above because it is lighter, and wood at the top of all as being the lightest. Whereas, though the wall does not come to be without these, it is not due to these, except as its material cause, it comes to be for the sake of sheltering and guarding certain things. Similarly in all other things which involve production for an end. The product cannot come to be without things which have a necessary nature, but it is not due to these, except as its material, it comes to be for an end. For instance, why is a saw such as it is? To effect so and for the sake of so and so. This end, however, cannot be realized unless the saw is made of iron. It is, therefore, necessary for it to be of iron, if we are to have a saw and perform the operation of sawing. What is necessary then, is necessary on a hypothesis. It is not a result necessarily determined by antecedents. Necessity is in the matter, while that for the sake of which is in the definition. Necessity in mathematics is in a way similar to necessity in things which come to be through the operation of nature. Since a straight line is what it is necessary that the angles of a triangle should equal 2 right angles. But not conversely, though if the angles are not equal to 2 right angles, then the straight line is not what it is either. But in things which come to be for an end, the reverse is true. If the end is to exist or does exist, that also which precedes it will exist or does exist, otherwise just as there, if the conclusion is not true, the premise will not be true, so here the end or that for the sake of which will not exist. For this too is itself a starting point, but of the reasoning, not of the action, while in mathematics the starting point is the starting point of the reasoning only, as there is no action. If then there is to be a house, such and such things must be made or be there already or exist, or generally the matter relative to the end, bricks and stones if it is a house. But the end is not due to these except as the matter, nor will it come to exist because of them. Yet if they do not exist at all, neither will the house, or the saw, the former in the absence of stones, the latter in the absence of iron, just as in the other case the premises will not be true, if the angles of the triangle are not equal to 2 right angles. The necessary in nature, then, is plainly what we call by the name of matter, and the changes in it. Both causes must be stated by the physicist, but especially the end, for that is the cause of the matter, not vice versa, and the end is that for the sake of which, and the beginning starts from the definition or essence, as in artificial products. Since a house is of such and such a kind, certain things must necessarily come to be or be there already, or since health is this, these things must necessarily come to be or be there already. Similarly, if man is this, then these, if these, then those. Perhaps the necessary is present also in the definition. For if one defines the operation of sawing as being a certain kind of dividing, then this cannot come about unless the saw has teeth of a certain kind, and these cannot be unless it is of iron. For in the definition too there are some parts that are, as it were, its matter. Physics, Book 3, translated by R.P. Hardy and R.K.G. Nature has been defined as a principle of motion and change, and it is the subject of our inquiry. We must therefore see that we understand the meaning of motion, for if it were unknown, the meaning of nature too would be unknown. When we have determined the nature of motion, our next task will be to attack in the same way the terms which are involved in it. Now motion is supposed to belong to the class of things which are continuous, and the infinite presents itself first in the continuous. That is how it comes about that infinite is often used in definitions of the continuous. What is infinitely divisible is continuous. Besides these, place, void, and time are thought to be necessary conditions of motion. Clearly, then, for these reasons and also because the attributes mentioned are common to, and coextensive with, all the objects of our science, we must first take each of them in hand and discuss it. For the investigation of special attributes comes after that of the common attributes. To begin then, as we said, with motion, we may start by distinguishing, 1. What exists in a state of fulfillment only, 2. What exists as potential, 3. What exists as potential and also in fulfillment, one being a this, another so much, a third such, and similarly in each of the other modes of the predication of being. Further, the word relative is used with reference to 1. Excess and defect, 2. Agent and patient, and generally what can move and what can be moved. For what can cause movement is relative to what can be moved, and vice versa. Again, there is no such thing as motion over and above the things. It is always with respect to substance or to quantity or to quality or to place that what changes changes. But it is impossible, as we assert, to find anything common to these which is neither this nor quantum nor quale nor any of the other predicates. Hence neither will motion and change have reference to something over and above the things mentioned, for there is nothing over and above them. Now each of these belongs to all its subjects in either of two ways, namely, 1. Substance. The one is positive form, the other privation, 2. In quality, white and black, 3. In quantity, complete and incomplete, 4. In respect of locomotion, upwards and downwards or light and heavy. Hence there are as many types of motion or change as there are meanings of the word is. We have now before us the distinctions in the various classes of being between what is full real and what is potential, def. The fulfillment of what exists potentially, insofar as it exists potentially, is motion, namely, of what is alterable qua-alterable, alteration, of what can be increased and its opposite what can be decreased. There is no common name, increase and decrease, of what can come to be and can pass away, coming to he and passing away, of what can be carried along, locomotion. Examples will elucidate this definition of motion. When the buildable, insofar as it is just that, is fully real, it is being built, and this is building. Similarly, learning, doctoring, rolling, leaping, ripening, aging, the same thing, if it is of a certain kind, can be both potential and fully real, not indeed at the same time or not in the same respect, but for example potentially hot and actually cold. Hence at once such things will act and be acted on by one another in many ways. Each of them will be capable at the same time of causing alteration and of being altered. Hence, 2. What affects motion as a physical agent can be moved. When a thing of this kind causes motion, it is itself also moved. This, indeed, has led some people to suppose that every mover is moved. But this question depends on another set of arguments, and the truth will be made clear later. Is possible for a thing to cause motion, though it is itself incapable of being moved? It is the fulfillment of what is potential when it is already fully real and operates not as itself but as movable, that is motion. What I mean by as is this: bronze is potentially a statue. But it is not the fulfillment of bronze as bronze which is motion. For to be bronze and to be a certain potentiality are not the same. If they were identical without qualification, that is in definition, the fulfillment of bronze as bronze would have been motion. But they are not the same, as has been said. This is obvious in contraries. To be capable of health and to be capable of illness are not the same, for if they were there would be no difference between being ill and being well. Yet the subject both of health and of sickness, whether it is humor or blood, is one and the same. We can distinguish, then, between the two just as, to give another example, color and visible are different, and clearly it is the fulfillment of what is potential as potential that is motion. So this, precisely, is motion. Further, it is evident that motion is an attribute of a thing just when it is fully real in this way, and neither before nor after. for each thing of this kind is capable of being at one time actual, at another not. Take for instance the buildable as buildable. The actuality of the buildable as buildable is the process of building. For the actuality of the buildable must be either this or the house. But when there is a house, the buildable is no longer buildable. On the other hand, it is the buildable which is being built. The process then of being built must be the kind of actuality required, but building is a kind of motion, and the same account will apply to the other kinds also. The soundness of this definition is evident both when we consider the accounts of motion that the others have given, and also from the difficulty of defining it otherwise. One could not easily put motion and change in another genus. This is plain if we consider where some people put it. They identify motion with or inequality or not being, but such things are not necessarily moved, whether they are different or unequal or non-existent, nor is change either to or from these rather than to or from their opposites. The reason why they put motion into these genera is that it is thought to be something indefinite, and the principles in the second column are indefinite because they are privative. None of them is either this or such or comes under any of the other modes of predication. The reason in turn why motion is thought to be indefinite is that it cannot be classed simply as a potentiality or as an actuality. A thing that is merely capable of having a certain size is not undergoing change, nor yet a thing that is actually of a certain size, and motion is thought to be a sort of actuality, but incomplete, the reason for this view being that the potential whose actuality it is incomplete. This is why it is hard to grasp what motion is. It is necessary to class it with privation or with potentiality or with sheer actuality, yet none of these seems possible. There remains then the suggested mode of definition, namely that it is a sort of actuality, or actuality of the kind described, hard to grasp, but not incapable of existing. The mover too is moved, as has been said. Every mover, that is, which is capable of motion, and whose immobility is rest. When a thing is subject to motion, its immobility is rest. For to act on the movable as such is just to move it. But this it does by contact, so that at the same time it is also acted on. Hence we can define motion as the fulfillment of the movable qua movable, the cause of the attribute being contact with what can move, so that the mover is also acted on. The mover or agent will always be the vehicle of a form, either of this or such, which, when it acts, will be the source and cause of the change. For example, the full-formed man begets man from what is potentially man. The solution of the difficulty that is raised about the motion, whether it is in the movable, is plain. It is the fulfillment of this potentiality, and by the action of that which has the power of causing motion, and the actuality of that which has the power of causing motion is not other than the actuality of the movable, for it must be the fulfillment of both. A thing is capable of causing motion because it can do this, it is a mover because it actually does it. But it is on the movable that it is capable of acting. Hence there is a single actuality of both alike, just as 1 to 2 and 2 to 1 are the same interval, and the steep ascent and the steep descent are one, for these are one and the same, although they can be described in different ways. So it is with the mover and the moved. This view has a dialectical difficulty. Perhaps it is necessary that the actuality of the agent and that of the patient should not be the same. The one is agency and the other patiency, and the outcome and completion of the one is an action, that of the other a passion. Since then they are both motions, we may ask, in what are they, if they are different? Either, A, both are in what is acted on and moved, or, B, the agency is in the agent and the patiency in the patient. If we ought to call the latter also agency, the word would be used in two senses. Now, in alternative, B, the motion will be in the mover, for the same statement will hold of mover and moved. Hence either every mover will be moved, or, though having motion, it will not be moved. If on the other hand, A, both are in what is moved and acted on, both the agency and the patiency, for example both teaching and learning, though they are two, in the learner, then, first, the actuality of each will not be present in each, and, a second absurdity, a thing will have two motions at the same time. How will there be two alterations of quality in one subject towards one definite quality? The thing is impossible, the actualization will be one. But, someone will say, it is contrary to reason to suppose that there should be one identical actualization of two things which are different in kind. Yet there will be, if teaching and learning are the same, and agency and patiency. To teach will be the same as to learn, and to act the same as to be acted on. The teacher will necessarily be learning everything that he teaches, and the agent will be acted on. One may reply. 1. It is not absurd that the actualization of one thing should be in another. Teaching is the activity of a person who can teach, yet the operation is performed on some patient. It is not cut adrift from a subject, but is of A on B. 2. There is nothing to prevent two things having one and the same actualization, provided the actualizations are not described in the same way, but are related as what can act to what is acting. 3. Nor is it necessary that the teacher should learn, even if to act and to be acted on are one and the same, provided they are not the same in definition, as raiment and dress, but are the same merely in the sense in which the road from Thebes to Athens and the road from Athens to Thebes are the same, as has been explained above. For it is not things which are in a way the same that have all their attributes the same, but only such as have the same definition. But indeed it by no means follows from the fact that teaching is the same as learning, that to learn is the same as to teach, any more than it follows from the fact that there is one distance between two things which are at a distance from each other, that the two vectors ab and ba are one and the same. To generalize, teaching is not the same as learning, or agency as patiency, in the full sense, though they belong to the same subject, the motion, for the actualization of x in y and the actualization of y through the action of x differ in definition. What then motion is, has been stated both generally and particularly. It is not difficult to see how each of its types will be defined. Alteration is the fulfillment of the alterable qua alterable, or, more scientifically, the fulfillment of what can act and what can be acted on, as such generally and again in each particular case, building, healing, and see. A similar definition will apply to each of the other kinds of motion. The science of nature is concerned with spatial magnitudes and motion and time, and each of these at least is necessarily infinite or finite, even if some things dealt with by the science are not. For example, a quality or a point. It is not necessary perhaps that such things should be put under either head. Hence it is incumbent on the person who specializes in physics to discuss the infinite and to inquire whether there is such a thing or not, and, if there is, what it is. The appropriateness to the science of this problem is clearly indicated. All who have touched on this kind of science in a way worth considering have formulated views about the infinite, and indeed, to a man, make it a principle of things. 1. Some, as the Pythagoreans and Plato, make the infinite a principle in the sense of a self-subsistent substance, and not as a mere attribute of some other thing. Only the Pythagoreans place the infinite among the objects or sense, they do not regard number as separable from these, and assert that what is outside the heaven is infinite. Plato, on the other hand, holds that there is no body outside, the forms are not outside because they are nowhere, yet that the infinite is present not only in the objects of sense but in the forms also. Further, the Pythagoreans identify the infinite with the even. For this, they say, when it is cut off and shut in by the odd, provides things with the element of infinity. An indication of this is what happens with numbers. If the gnomons are placed round the one, and without the one, in the one construction the figure that results is always different, in the other it is always the same. But Plato has two infinites, the great and the small. The physicists, on the other hand, all of them, always regard the infinite as an attribute of a substance which is different from it and belongs to the class of the so-called elements water or air or what is intermediate between them. Those who make them limited in number never make them infinite in amount. But those who make the elements infinite in number, as Anaxagoras and Democritus do, say that the infinite is continuous by contact compounded of the homogeneous parts according to the one, of the seed mass of the atomic shapes according to the other. Further, Anaxagoras held that any part is a mixture in the same way as the all, on the ground of the observed fact that anything comes out of anything. For it is probably for this reason that he maintains that once upon a time all things were together. This flesh and this bone were together, and so of anything, therefore all things, and at the same time too, for there is a beginning of separation, not only for each thing, but for all. Each thing that comes to be comes from a similar body, and there is a coming to be of all things, though not, it is true, at the same time. Hence there must also be an origin of coming to be. One such source there is which he calls mind, and mind begins its work of thinking from some starting point. So necessarily all things must have been together at a certain time, and must have begun to be moved at a certain time. Democritus, for his part, asserts the contrary, namely that no element arises from another element. Nevertheless for him the common body is a source of all things, differing from part to part in size and in shape. It is clear then from these considerations that the inquiry concerns the physicist. Nor is it without reason that they all make it a principle or source. We cannot say that the infinite has no effect, and the only effectiveness which we can ascribe to it is that of a principle. Everything is either a source or derived from a source. But there cannot be a source of the infinite or limitless, for that would be a limit of it. Further, as it is a beginning, it is both uncreatable and indestructible. For there must be a point at which what has come to be reaches completion, and also a termination of all passing away. That is why, as we say, There is no principle of this. But it is this which is held to be the principle of other things, and to encompass all and to steer all, as those assert who do not recognize, alongside the infinite, other causes, such as mind or friendship. Further they identify it with the divine, for it is deathless and imperishable as Anaximander says, with the majority of the physicists. Belief in the existence of the infinite comes mainly from 5 considerations. 1. From the nature of time, for it is infinite. 2. From the division of magnitudes, for the mathematicians also use the notion of the infinite. 3. If coming to be and passing away do not give out, it is only because that from which things come to be is infinite. 4. Because the limited always finds its limit in something, so that there must be no limit, if everything is always limited by something different from itself. 5. Most of all, a reason which is peculiarly appropriate and presents the difficulty that is felt by everybody, not only number but also mathematical magnitudes and what is outside the heaven are supposed to be infinite because they never give out in our thought. The last fact, that what is outside is infinite, leads people to suppose that body also is infinite, and that there is an infinite number of worlds. Why should there be body in one part of the void rather than in another? Grant only that mass is anywhere and it follows that it must be everywhere. Also, if void and place are infinite, there must be infinite body too, for in the case of eternal things what may be must be. But the problem of the infinite is difficult. Many contradictions result whether we suppose it to exist or not to exist. If it exists, we have still to ask how it exists, as a substance or as the essential attribute of some entity. Or in neither way, yet nonetheless is the something which is infinite or some things which are infinitely many? The problem, however, which specially belongs to the physicist is to investigate whether there is a sensible magnitude which is infinite. We must begin by distinguishing the various senses in which the term infinite is used. 1. What is incapable of being gone through, because it is not in its nature to be gone through, the sense in which the voice is invisible. 2. What admits of being gone through, the process however having no termination, or what scarcely admits of being gone through. 3. What naturally admits of being gone through, but is not actually gone through or does not actually reach an end. Further, everything that is infinite may be so in respect of addition or division or both. Now it is impossible that the infinite should be a thing which is itself infinite, separable from sensible objects. If the infinite is neither a magnitude nor an aggregate, but is itself a substance and not an attribute, it will be indivisible, for the divisible must be either a magnitude or an aggregate. But if indivisible, then not infinite, except in the sense, 1, in which the voice is invisible. But this is not the sense in which it is used by those who say that the infinite exists, nor that in which we are investigating it, namely as, 2, that which cannot be gone through. But if the infinite exists as an attribute, it would not be, qua infinite, an element in substances, any more than the invisible would be an element of speech, though the voice is invisible. Further, how can the infinite be itself anything, unless both number and magnitude, of which it is an essential attribute, exist in that way? If they are not substances, a 40 or I the infinite is not. It is plain, too, that the infinite cannot be an actual thing and a substance and principle. For any part of it that is taken will be infinite, if it has parts, for to be infinite and the infinite are the same, if it is a substance and not predicated of a subject. Hence it will be either indivisible or divisible into infinites. But the same thing cannot be many infinites. Yet just as part of air is air, so a part of the infinite would be infinite, if it is supposed to be a substance and principle, therefore the infinite must be without parts and indivisible. But this cannot be true of what is infinite in full completion, for it must be a definite quantity. Suppose then that infinity belongs to substance as an attribute. But, if so, it cannot, as we have said, be described as a principle, but rather that of which it is an attribute, the air or the even number. Thus the view of those who speak after the manner of the Pythagoreans is absurd. With the same breath they treat the infinite as substance, and divide it into parts. This discussion, however, involves the more general question whether the infinite can be present in mathematical objects and things which are intelligible and do not have extension, as well as among sensible objects. Our inquiry, as physicists, is limited to its special subject matter, the objects of sense, and we have to ask whether there is or is not among them a body which is infinite in the direction of increase. We may begin with a dialectical argument and show as follows that there is no such thing. If bounded by a surface is the definition of body, there cannot be an infinite body either intelligible or sensible. Nor can number taken in abstraction be infinite, for number or that which has number is numerable. If then the numerable can be numbered, it would also be possible to go through the infinite. If, on the other hand, we investigate the question more in accordance with principles appropriate to physics, we are led as follows to the same result. The infinite body must be either 1. Compound, or 2. Simple, yet neither alternative is possible. 1. Compound. The infinite body will not be, if the elements are finite in number. For they must be more than one, and the contraries must always balance, and no one of them can be infinite. If one of the bodies falls in any degree short of the other in potency, suppose fire is finite in amount while air is infinite, and a given quantity of fire exceeds in power the same amount of air in any ratio provided it is numerically definite, the infinite body will obviously prevail over and annihilate the finite body. On the other hand, it is impossible that each should be infinite. Body is what is extension in all directions, and the infinite is what is boundlessly extended, so that the infinite body would be extended in all directions ad infinitum. Nor, 2, can the infinite body be one and simple, whether it is, as some hold, a thing over and above the elements, from which they generate the elements, or is not thus qualified. We must consider the former alternative, for there are some people who make this the infinite, and not air or water, in order that the other elements may not be annihilated by the element which is infinite. They have contrariety with each other. Air is cold, water moist, fire hot. If one were infinite, the others by now would have ceased to be. As it is, they say, the infinite is different from them and is their source. It is impossible, however, that there should be such a body, not because it is infinite. On that point a general proof can be given which applies equally to all, air, water, or anything else, but simply because there is, as a matter of fact, no such sensible body, alongside the so-called elements. Everything can be resolved into the elements of which it is composed. Hence the body in question would have been present in our world here, alongside air and fire and earth and water, but nothing of the kind is observed. Nor can fire or any other of the elements be infinite. For generally, and apart from the question of how any of them could be infinite, the all, even if it were limited, cannot either be or become one of them, as Heraclitus says that at some time all things become fire. The same argument applies also to the one which the physicists suppose to exist alongside the elements, for everything changes from contrary to contrary, for example from hot to cold. The preceding consideration of the various cases serves to show us whether it is or is not possible that there should be an infinite sensible body. The following arguments give a general demonstration that it is not possible. It is the nature of every kind of sensible body to be somewhere, and there is a place appropriate to each, the same for the part and for the whole, for example for the whole earth and for a single clod, and for fire and for a spark. Suppose, that the infinite sensible body is homogeneous. Then each part will be either immovable or always being carried along. Yet neither is possible. For why downwards rather than upwards or in any other direction? I mean, e.g., if you take a clod, where will it be moved or where will it be at rest? For X hypothesis the place of the body akin to it is infinite. Will it occupy the whole place, then? And how? What then will be the nature of its rest and of its movement, or where will they be? It will either be at home everywhere, then it will not be moved, or it will be moved everywhere, then it will not come to rest. But if, the all has dissimilar parts, the proper places of the parts will be dissimilar also, and the body of the all will have no unity except that of contact. Then, further, the parts will be either finite or infinite in variety of kind. Finite they cannot be, for if the all is to be infinite, some of them would have to be infinite, while the others were not. For example, fire or water will be infinite. But, as we have seen before, such an element would destroy what is contrary to it. This indeed is the reason why none of the physicists made fire or earth the one infinite body, but either water or air or what is intermediate between them, because the abode of each of the two was plainly determinate, while the others have an ambiguous place between up and down. But, 2, if the parts are infinite in number and simple, their proper places too will be infinite in number, and the same will be true of the elements themselves. If that is impossible, and the places are finite, the whole too must be finite, for the place and the body cannot but fit each other. Neither is the whole place larger than what can be filled by the body, and then the body would no longer be infinite, nor is the body larger than the place, for either there would be an empty space or a body whose nature it is to be nowhere. Anaxagoras gives an absurd account of why the infinite is at rest. He says that the infinite itself is the cause of its being fixed. This because it is in itself, since nothing else contains it, on the assumption that wherever anything is, it is there by its own nature. But this is not true. A thing could be somewhere by compulsion, and not where it is its nature to be. Even if it is true as true can be that the whole is not moved, for what is fixed by itself and is in itself must be immovable, yet we must explain why it is not its nature to be moved. It is not enough just to make this statement and then decamp. Anything else might be in a state of rest, but there is no reason why it should not be its nature to be moved. The earth is not carried along, and would not be carried along if it were infinite, provided it is held together by the center. But it would not be because there was no other region in which it could be carried along that it would remain at the center, but because this is its nature. Yet in this case also we may say that it fixes itself. If then in the case of the earth, supposed to be infinite, it is at rest, not because it is infinite, but because it has weight, and what is heavy rests at the center and the earth is at the center, similarly the infinite also would rest in itself, not because it is infinite and fixes itself, but owing to some other cause. Another difficulty emerges at the same time. Any part of the infinite body ought to remain at rest. Just as the infinite remains at rest in itself because it fixes itself, so too any part of it you may take will remain in itself. The appropriate places of the whole and of the part are alike. For example, of the whole earth and of a clod the appropriate place is the lower region, of fire as a whole and of a spark, the upper region. If, therefore, to be in itself is the place of the infinite, that also will be appropriate to the part. Therefore it will remain in itself. In general, the view that there is an infinite body is plainly incompatible with the doctrine that there is necessarily a proper place for each kind of body, if every sensible body has either weight or lightness, and if a body has a natural locomotion towards the center if it is heavy, and upwards if it is light. This would need to be true of the infinite also. But neither character can belong to it. It cannot be either as a whole, nor can it be half the one and half the other. For how should you divide it? Or how can the infinite have the one part up and the other down, or an extremity and a center? Further, every sensible body is in place, and the kinds or differences of place are up down, before behind, right left, and these distinctions hold not only in relation to us and by arbitrary agreement, but also in the whole itself. But in the infinite body they cannot exist. In general, if it is impossible that there should be an infinite place, and if every body is in place, there cannot be an infinite body. Surely what is in a special place is in place, and what is in place is in a special place. Just, then, as the infinite cannot be quantity, that would imply that it has a particular quantity, e.g., 2 or 3 cubits. Quantity just means these, so a thing's being in place means that it is somewhere, and that is either up or down or in some other of the 6 differences of position, but each of these is a limit. It is plain from these arguments that there is no body which is actually infinite. But on the other hand, to suppose that the infinite does not exist in any way leads obviously to many impossible consequences. There will be a beginning and an end of time, a magnitude will not be divisible into magnitudes, number will not be infinite. If, then, in view of the above considerations, neither alternative seems possible, an arbiter must be called in, and clearly there is a sense in which the infinite exists and another in which it does not. We must keep in mind that the word is means either what potentially is or what fully is. Further, a thing is infinite either by addition or by division. Now, as we have seen, magnitude is not actually infinite, but by division it is infinite. There is no difficulty in refuting the theory of indivisible lines. The alternative then remains that the infinite has a potential existence. But the phrase potential existence is ambiguous. When we speak of the potential existence of a statue, we mean that there will be an actual statue. It is not so with the infinite. There will not be an actual infinite. The word is has many senses, and we say that the infinite is in the sense in which we say it is day or it is the games, because one thing after another is always coming into existence. For of these things too the distinction between potential and actual existence holds. We say that there are Olympic games, both in the sense that they may occur and that they are actually occurring. The infinite exhibits itself in different ways in time, in the generations of man, and in the division of magnitudes. For generally the infinite has this mode of existence: one thing is always being taken after another, and each thing that is taken is always finite, but always different. Again, being has more than one sense, so that we must not regard the infinite as a this, such as a man or a horse, but must suppose it to exist in the sense in which we speak of the day or the games as existing things whose being has not come to them like that of a substance, but consists in a process of coming to be or passing away, definite if you like at each stage, yet always different. But when this takes place in spatial magnitudes, what is taken perests, while in the succession of time and of men it takes place by the passing away of these in such a way that the source of supplely never gives out. In a way the infinite by addition is the same thing as the infinite by division. In a finite magnitude, the infinite by addition comes about in a way inverse to that of the other. For in proportion as we see division going on, in the same proportion we see addition being made to what is already marked off. For if we take a determinate part of a finite magnitude and add another part determined by the same ratio, not taking in the same amount of the original whole, and so on, we shall not traverse the given magnitude. But if we increase the ratio of the part, so as always to take in the same amount, we shall traverse the magnitude, for every finite magnitude is exhausted by means of any determinate quantity however small. The infinite, then, exists in no other way, but in this way it does exist, potentially and by reduction. It exists fully in the sense in which we say it is day or it is the games, and potentially as matter exists, not independently as what is finite does. By addition then, also, there is potentially an infinite, namely, what we have described as being in a sense the same as the infinite in respect of division. For it will always be possible to take something r extra. Yet the sum of the parts taken will not exceed every determinate magnitude, just as in the direction of division every determinate magnitude is surpassed in smallness and there will be a smaller part. But in respect of addition there cannot be an infinite which even potentially exceeds every assignable magnitude, unless it has the attribute of being actually infinite, as the physicists hold to be true of the body which is outside the world, whose essential nature is air or something of the kind. But if there cannot be in this way a sensible body which is infinite in the full sense, evidently there can no more be a body which is potentially infinite in respect of addition, except as the inverse of the infinite by division, as we have said. It is for this reason that Plato also made the infinites 2 in number, because it is supposed to be possible to exceed all limits and to proceed ad infinitum in the direction both of increase and of reduction. Yet though he makes the infinites 2, he does not use them. For in the numbers the infinite in the direction of reduction is not present, as the monad is the smallest, nor is the infinite in the direction of increase, for the parts number only up to the decad. The infinite turns out to be the contrary of what it is said to be. It is not what has nothing outside it that is infinite, but what always has something outside it. This is indicated by the fact that rings also that have no bezel are described as endless, because it is always possible to take a part which is outside a given part. The description depends on a certain similarity, but it is not true in the full sense of the word. This condition alone is not sufficient, it is necessary also that the next part which is taken should never be the same. In the circle, the latter condition is not satisfied, it is only the adjacent part from which the new part is different. Our definition then is as follows. A quantity is infinite if it is such that we can always take a part outside what has been already taken. On the other hand, what has nothing outside it is complete and whole. For thus we define the whole that from which nothing is wanting, as a whole man or a whole box. What is true of each particular is true of the whole as such the whole is that of which nothing is outside. On the other hand that from which something is absent and outside, however small that may be, is not all. Whole and complete are either quite identical or closely akin. Nothing is complete, teleon, which has no end, telos, and the end is a limit. Hence Parmenides must be thought to have spoken better than Melissus. The latter says that the whole is infinite, but the former describes it as limited, equally balanced from the middle. For to connect the infinite with the all and the whole is not like joining two pieces of string, for it is from this they get the dignity they ascribe to the infinite as containing all things and holding the all in itself from its having a certain similarity to the whole. It is in fact the matter of a completeness which belongs to size, and what is potentially a whole, though not in the full sense. It is divisible both in the direction of reduction and of the inverse addition. It is a whole and limited, not, however, in virtue of its own nature, but in virtue of what is other than it. It does not contain, but, in so far as it is infinite, is contained. Consequently, also, it is unknowable, qua infinite, for the matter has no form. Hence it is plain that the infinite stands in the relation of part rather than of whole. For the matter is part of the whole, as the bronze is of the bronze statue, if it contains in the case of sensible things, in the case of intelligible things the great and the small ought to contain them. But it is absurd and impossible to suppose that the unknowable and indeterminate should contain and determine. It is reasonable that there should not be held to be an infinite in respect of addition such as to surpass every magnitude, but that there should be thought to be such an infinite in the direction of division. For the matter and the infinite are contained inside what contains them, while it is the form which contains. It is natural too to suppose that in number there is a limit in the direction of the minimum, and that in the other direction every assigned number is surpassed. In magnitude, on the contrary, every assigned magnitude is surpassed in the direction of smallness, while in the other direction there is no infinite magnitude. The reason is that what is one is indivisible whatever it may be, for example a man is one man, not many. Number on the other hand is a plurality of ones and a certain quantity of them. Hence number must stop at the indivisible, for 2 and 3 are merely derivative terms, and so with each of the other numbers. But in the direction of largeness it is always possible to think of a larger number, for the number of times a magnitude can be bisected is infinite. Hence this infinite is potential, never actual. The number of parts that can be taken always surpasses any assigned number. But this number is not separable from the process of bisection, and its infinity is not a permanent actuality but consists in a process of coming to be, like time and the number of time. With magnitudes the contrary holds. What is continuous is divided ad infinitum, but there is no infinite in the direction of increase. For the size which it can potentially be, it can also actually be. Hence, since no sensible magnitude is infinite, it is impossible to exceed every assigned magnitude, for if it were possible there would be something bigger than the heavens. The infinite is not the same in magnitude and movement and time, in the sense of a single nature, but its secondary sense depends on its primary sense, that is movement is called infinite in virtue of the magnitude covered by the movement, or alteration or growth, and time because of the movement. I use these terms for the moment. Later I shall explain what each of them means, and also why every magnitude is divisible into magnitudes. Our account does not rob the mathematicians of their science, by disproving the actual existence of the infinite in the direction of increase, in the sense of the untraversable. In point of fact they do not need the infinite and do not use it. They postulate only that a finite straight line may be produced as far as they wish. It is possible to have divided in the same ratio as the largest quantity another magnitude of any size you like. Hence, for the purposes of proof, it will make no difference to them to have such an infinite instead, while its existence will be in the sphere of real magnitudes. In the fourfold scheme of causes, it is plain that the infinite is a cause in the sense of matter, and that its essence is privation, the subject as such being what is continuous and sensible. All the other thinkers, too, evidently treat the infinite as matter. That is why it is inconsistent in them to make it what contains, and not what is contained. It remains to dispose of the arguments which are supposed to support the view that the infinite exists not only potentially but as a separate thing. Some have no cogency, others can be met by fresh objections that are valid. 1. In order that coming to be should not fail, it is not necessary that there should be a sensible body which is actually infinite. The passing away of one thing may be the coming to be of another, the all being limited. 2. There is a difference between touching and being limited. The former is relative to something and is the touching of something, for everything that touches something, and further is an attribute of some one of the things which are limited. On the other hand, what is limited is not limited in relation to anything. Again, contact is not necessarily possible between any two things taken at random. 3. To rely on mere thinking is absurd, for then the excess or defect is not in the thing but in the thought. One might think that one of us is bigger than he is and magnify him ad infinitum. But it does not follow that he is bigger than the size we are, just because someone thinks he is, but only because he is the size he is. The thought is an accident. A. Time indeed and movement are infinite, and also thinking, in the sense that each part that is taken passes in succession out of existence. B. Magnitude is not infinite either in the way of reduction or of magnification in thought. This concludes my account of the way in which the infinite exists, and of the way in which it does not exist, and of what it is. Physics, Book 4, translated by R.P. Hardy and R.K.G. The physicist must have a knowledge of place, too, as well as of the infinite, namely, whether there is such a thing or not, and the manner of its existence and what it is both, because all suppose that things which exist are somewhere, the non-existent is nowhere, where is the goat, stag or the sphinx? And because motion in its most general and primary sense is change of place, which we call locomotion. The question, what is place, presents many difficulties. An examination of all the relevant facts seems to lead to divergent conclusions. Moreover, we have inherited nothing from previous thinkers, whether in the way of a statement of difficulties or of a solution. The existence of place is held to be obvious from the fact of mutual replacement. Where water now is, there in turn, when the water has gone out as from a vessel, air is present. When therefore another body occupies this same place, the place is thought to be different from all the bodies which come to be in it and replace one another. What now contains air formerly contained water, so that clearly the place or space into which and out of which they passed was something different from both. Further, the typical locomotions of the elementary natural bodies, namely, fire, earth, and the like, show not only that place is something, but also that it exerts a certain influence. Each is carried to its own place, if it is not hindered, the one up, the other down. Now these are regions or kinds of place up and down in the rest of the 6 directions. Nor do such distinctions, up and down and right and left, and sea, hold only in relation to us. To us they are not always the same but change with the direction in which we are turned. That is why the same thing may be both right and left, up and down, before and behind. But in nature each is distinct, taken apart by itself. It is not every chance direction which is up, but where fire and what is light are carried. Similarly, too, down is not any chance direction but where what has weight and what is made of earth are carried, the implication being that these places do not differ merely in relative position, but also as possessing distinct potencies. This is made plain also by the objects studied by mathematics. Though they have no real place, they nevertheless, in respect of their position relatively to us, have a right and left as attributes ascribed to them only in consequence of their relative position, not having by nature these various characteristics. Again, the theory that the void exists involves the existence of place, for one would define void as place bereft of body. These considerations then would lead us to suppose that place is something distinct from bodies, and that every sensible body is in place. Hesiod too might be held to have given a correct account of it when he made chaos first. At least he says, "First of all things came chaos to being, then broad-breasted earth," implying that things need to have space first, because he thought, with most people, that everything is somewhere and in place. If this is its nature, the potency of place must be a marvelous thing, and take precedence of all other things. For that without which nothing else can exist, while it can exist without the others, must needs be first, for place does not pass out of existence when the things in it are annihilated. True. But even if we suppose its existence settled, the question of its nature presents difficulty whether it is some sort of bulk of body or some entity other than that, for we must first determine its genus. 1. Now it has 3 dimensions, length, breadth, depth, the dimensions by which all body also is bounded. But the place cannot be body, for if it were there would be 2 bodies in the same place. 2. Further, if body has a place and space, clearly so too have surface and the other limits of body, for the same statement will apply to them, where the bounding planes of the water were, there in turn will be those of the air. But when he come to a point we cannot make a distinction between it and its place. Hence if the place of a point is not different from the point, no more will that of any of the others be different, and place will not be something different from each of them. 3. What in the world then are we to suppose place to be? If it has the sort of nature described, it cannot be an element or composed of elements, whether these be corporeal or incorporeal, for while it is size, it is not body. But the elements of sensible bodies are bodies, while nothing that has size results from a combination of intelligible elements. 4. Also we may ask, of what in things is space the cause? None of the 4 modes of causation can be ascribed to it. It is neither in the sense of the matter of existence, for nothing is composed of it, nor as the form and definition of things, nor as end, nor does it move existence. 5. Further, 2. If it is itself unexistent, where will it be? Zeno's difficulty demands an explanation, for if everything that exists has a place, place too will have a place, and so on ad infinitum. 6. Again, just as every body is in place, so, too, every place has a body in it. What then shall we say about growing things? It follows from these premises that their place must grow with them, if their place is neither less nor greater than they are. By asking these questions, then, we must raise the whole problem about place not only as to what it is, but even whether there is such a thing. We may distinguish generally between predicating B of A because it, A, is itself, and because it is something else, and particularly between place which is common and in which all bodies are, and the special place occupied primarily by each. I mean, for instance, that you are now in the heavens because you are in the air and it is in the heavens, and you are in the air because you are on the earth, and similarly on the earth because you are in this place which contains no more than you. Now if place is what primarily contains each body, it would be a limit, so that the place would be the form or shape of each body by which the magnitude or the matter of the magnitude is defined, for this is the limit of each body. If, then, we look at the question in this way, the place of a thing is its form. But, if we regard the place as the extension of the magnitude, it is the matter. For this is different from the magnitude, it is what is contained and defined by the form, as by a bounding plane. Matter or the indeterminates of this nature, when the boundary and attributes of a sphere are taken away, nothing but the matter is left. This is why Plato in the Timaeus says that matter and space are the same, for the participant and space are identical. It is true, indeed, that the account he gives there of the participant is different from what he says in his so-called unwritten teaching. Nevertheless, he did identify place and space. I mention Plato because, while all hold place to be something, he alone tried to say what it is. In view of these facts we should naturally expect to find difficulty in determining what place is, if indeed it is one of these 2 things, matter or form. They demand a very close scrutiny, especially as it is not easy to recognize them apart. But it is at any rate not difficult to see that place cannot be either of them. The form and the matter are not separate from the thing, whereas the place can be separated. As we pointed out, where air was, water in turn comes to be, the one replacing the other, and similarly with other bodies. Hence the place of a thing is neither a part nor a state of it, but is separable from it. For place is supposed to be something like a vessel, the vessel being a transportable place. But the vessel is no part of the thing. In so far then as it is separable from the thing, it is not the form, qua containing, it is different from the matter. Also it is held that what is anywhere is both itself something and that there is a different thing outside it. Plato, of course, if we may digress, ought to tell us why the form and the numbers are not in place, if what participates is place, whether what participates is the great and the small or the matter, as he called it in writing in the Timaeus. Further, how could a body be carried to its own place, if place was the matter or the form? It is impossible that what has no reference to motion or the distinction of up and down can be place. So place must be looked for among things which have these characteristics. If the place is in the thing, it must be if it is either shape or matter. Place will have a place, for both the form and the indeterminate undergo change and motion along with the thing, and are not always in the same place, but are where the thing is. Hence the place will have a place. Further, when water is produced from air, the place has been destroyed, for the resulting body is not in the same place. What sort of destruction then is that? This concludes my statement of the reasons why space must be something, and again of the difficulties that may be raised about its essential nature. The next step we must take is to see in how many senses one thing is said to be in another. 1. As the finger is in the hand and generally the part in the whole. 2. As the whole is in the parts, for there is no whole over and above the parts. 3. As man is in animal and generally species in genus. 4. As the genus is in the species and generally the part of the specific form in the definition of the specific form. 5. As health is in the hot and the cold and generally the form in the matter. 6. As the affairs of Greece center in the king, and generally events center in their primary motive agent. 7. As the existence of a thing centers in its good and generally in its end, that is in that for the sake of which it exists. 8. In the strictest sense of all, as a thing is in a vessel, and generally in place. One might raise the question whether a thing can be in itself, or whether nothing can be in itself, everything being either nowhere or in something else. The question is ambiguous. We may mean the thing qua itself or qua something else. When there are parts of a whole, the one that in which a thing is, the other the thing which is in it, the whole will be described as being in itself. For a thing is described in terms of its parts, as well as in terms of the thing as a whole. For example, a man is said to be white because the visible surface of him is white, or to be scientific because his thinking faculty has been trained. The jar then will not be in itself and the wine will not be in itself. But the jar of wine will, for the contents and the container are both parts of the same whole. In this sense then, but not primarily, a thing can be in itself, namely, as white is in body, for the visible surface is in body, and science is in the mind. It is from these, which are parts, in the sense at least of being in the man, that the man is called white, and see. But the jar and the wine in separation are not parts of a whole, though together they are. So when there are parts, a thing will be in itself, as white is in man because it is in body, and in body because it resides in the visible surface. We cannot go further and say that it is in surface in virtue of something other than itself. Yet it is not in itself, though these are in a way the same thing. They differ in essence, each having a special nature and capacity, surface and white. Thus if we look at the matter inductively, we do not find anything to be in itself in any of the senses that have been distinguished, and it can be seen by argument that it is impossible. For each of two things will have to be both. For example, the jar will have to be both vessel and wine, and the wine both wine and jar. If it is possible for a thing to be in itself, so that, however true it might be that they were in each other, the jar will receive the wine in virtue not of its being wine but of the wine's being wine, and the wine will be in the jar in virtue not of its being a jar but of the jar's being a jar. Now that they are different in respect of their essence is evident, for that in which something is and that which is in it will be differently defined. Nor is it possible for a thing to be in itself even incidentally, for two things would at the same time in the same thing. The jar would be in itself if a thing whose nature it is to receive can be in itself, and that which it receives, namely, if wine will be in it. Obviously then a thing cannot be in itself primarily. Zeno's problem that if place is something it must be in something is not difficult to solve. There is nothing to prevent the first place from being in something else, not indeed in that as in place, but as health is in the hot as a positive determination of it, or as the hot is in body as an affection. so we escape the infinite regress. Another thing is plain, since the vessel is no part of what is in it, what contains in a strict sense is different from what is contained. Place could not be either the matter or the form of the thing contained, but must different for the latter. Both the matter and the shape are parts of what is contained. This then may serve as a critical statement of the difficulties involved. What then after all is place? The answer to this question may be elucidated as follows. Let us take for granted about it the various characteristics which are supposed correctly to belong to it essentially. We assume then, 1. Place is what contains that of which it is the place. 2. Place is no part of the thing. 3. The immediate place of a thing is neither less nor greater than the thing. 4. Place can be left behind by the thing and is separable. In addition, 5. All place admits of the distinction of up and down, and each of the bodies is naturally carried to its appropriate place and rests there, and this makes the place either up or down. Having laid these foundations, we must complete the theory. We ought to try to make our investigation such as will render an account of place, and will not only solve the difficulties connected with it, but it will also show that the attributes supposed to belong to it do really belong to it, and further will make clear the cause of the trouble and of the difficulties about it. Such is the most satisfactory kind of exposition. First then we must understand that place would not have been thought of, if there had not been a special kind of motion, namely that with respect to place. It is chiefly for this reason that we suppose the heaven also to be in place, because it is in constant movement. Of this kind of change there are two species: locomotion on the one hand and, on the other, increase and diminution. For these two involve variation of place. What was then in this place has now in turn changed to what is larger or smaller. Again, when we say a thing is moved, the predicate either, 1, belongs to it actually, in virtue of its own nature, or, 2, in virtue of something conjoined with it. In the latter case it may be either, a, something which by its own nature is capable of being moved, for example the parts of the body or the nail in the ship, or, b, something which is not in itself capable of being moved, but is always moved through its conjunction with something else, as whiteness or science. These have changed their place only because the subjects to which they belong do so. We say that a thing is in the world, in the sense of in place, because it is in the air, and the air is in the world, and when we say it is in the air, we do not mean it is in every part of the air, but that it is in the air because of the outer surface of the air which surrounds it, for if all the air were its place, the place of a thing would not be equal to the thing which it is supposed to be, and which the primary place in which a thing is actually is. When what surrounds, then, is not separate from the thing, but is in continuity with it, the thing is said to be in what surrounds it, not in the sense of in place, but as a part in a whole. But when the thing is separate and in contact, it is immediately in the inner surface of the surrounding body, and this surface is neither a part of what is in it nor yet greater than its extension, but equal to it, for the extremities of things which touch are coincident. Further, if one body is in continuity with another, it is not moved in that but with that. On the other hand it is moved in that if it is separate. It makes no difference whether what contains is moved or not. Again, when it is not separate it is described as a part in a whole, as the pupil in the eye or the hand in the body. When it is separate, as the water in the cask or the wine in the jar. For the hand is moved with the body and the water in the cask. It will now be plain from these considerations what place is. There are just 4 things of which place must be 1. The shape, or the matter, or some sort of extension between the bounding surfaces of the containing body, or this boundary itself if it contains no extension over and above the bulk of the body which comes to be in it. 3 of these it obviously cannot be. 1. The shape is supposed to be place because it surrounds, for the extremities of what contains and of what is contained are coincident. Both the shape and the place, it is true, are boundaries, but not of the same thing. The form is the boundary of the thing, the place is the boundary of the body which contains it. 2. The extension between the extremities is thought to be something, because what is contained and separate may often be changed while the container remains the same, as water may be poured from a vessel, the assumption being that the extension is something over and above the body displaced. But there is no such extension. One of the bodies which change places and are naturally capable of being in contact with the container falls in whichever it may chance to be. If there were an extension which were such as to exist independently and be permanent, there would be an infinity of places in the same thing. For when the water and the air change places, all the portions of the two together will play the same part in the whole which was previously played by all the water in the vessel. At the same time the place too will be undergoing change, so that there will be another place which is the place of the place, and many places will be coincident. There is not a different place of the part, in which it is moved. When the whole vessel changes its place, it is always the same, for it is in their proximate place where they are that the air and the water, or the parts of the water, succeed each other, not in that place in which they come to be, which is part of the place which is the place of the whole world. 3. The matter, too, might seem to be place, at least if we consider it in what is at rest and is thus separate but in continuity. For just as in change of quality there is something which was formerly black and is now white, or formerly soft and now hard, this is just why we say that the matter exists so place, because it presents a similar phenomenon, is thought to exist only in the one case we say so because what was air is now water, in the other because where air formerly was there is now water. But the matter, as we said before, is neither separable from the thing nor contains it, whereas place has both characteristics. Well, then, if place is none of the three, neither the form nor the matter nor an extension which is always there, different from, and over and above, the extension of the thing which is displaced, place necessarily is the one of the four which is left, namely, the boundary of the containing body at which it is in contact with the contained body. By the contained body is meant what can be moved by way of locomotion. Place is thought to be something important and hard to grasp, both because the matter and the shape present themselves along with it, and because the displacement of the body that is moved takes place in a stationary container, for it seems possible that there should be an interval which is other than the bodies which are moved. The air, too, which is thought to be incorporeal, contributes something to the belief. It is not only the boundaries of the vessel which seem to be place, but also what is between them, regarded as empty. Just, in fact, as the vessel is transportable place, so place is a non-portable vessel. So when what is within a thing which is moved and changes its place, as a boat on a river, what contains plays the part of a vessel rather than that of place. Place on the other hand is rather what is motionless, so it is rather the whole river that is place, because as a whole it is motionless. Hence we conclude that the innermost motionless boundary of what contains is place. This explains why the middle of the heaven and the surface which faces us of the rotating system are held to be up and down in the strict and fullest sense for all men, for the one is always at rest, while the inner side of the rotating body remains always coincident with itself. Hence, since the light is what is naturally carried up, and the heavy what is carried down, the boundary which contains in the direction of the middle of the universe, and the middle itself, are down, and that which contains in the direction of the outermost part of the universe, and the outermost part itself, are up. For this reason, too, place is thought to be a kind of surface, and as it were a vessel, that is a container of the thing. Further, place is coincident with the thing, for boundaries are coincident with the bounded. If then a body has another body outside it and containing it, it is in place, and if not, not. That is why, even if there were to be water which had not a container, the parts of it, on the one hand, will be moved, for one part is contained in another, while, on the other hand, the whole will be moved in one sense, but not in another. For as a whole it does not simultaneously change its place, though it will be moved in a circle, for this place is the place of its parts. Some things are moved, not up and down, but in a circle, others up and down, such things namely as admit of condensation and rarefaction. As was explained, some things are potentially in place, others actually. So, when you have a homogeneous substance which is continuous, the parts are potentially in place. When the parts are separated, but in contact, like a heap, they are actually in place. Again, 1. Some things are per se in place, namely every body which is movable either by way of locomotion or by way of increase is per se somewhere, but the heaven, as has been said, is not anywhere as a whole, nor in any place, if at least, as we must suppose, no body contains it. On the line on which it is moved, its parts have place, for each is contiguous the next, but, 2. Other things are in place indirectly, through something conjoined with them, as the soul and the heaven. The latter is, in a way, in place, for all its parts are, for on the orb one part contains another. That is why the upper part is moved in a circle, while the all is not anywhere. For what is somewhere is itself something, and there must be alongside it some other thing wherein it is and which contains it. But alongside the all or the whole there is nothing outside the all, and for this reason all things are in the heaven, for the heaven, we may say, is the all. Yet their place is not the same as the heaven. It is part of it, the innermost part of it, which is in contact with the movable body, and for this reason the earth is in water, and this in the air, and the air in the ether, and the ether in heaven. But we cannot go on and say that the heaven is in anything else. It is clear, too, from these considerations that all the problems which were raised about place will be solved when it is explained in this way. 1. There is no necessity that a place should grow with the body in it. 2. Nor that a point should have a place. 3. Nor that two bodies should be in the same place. 4. nor that place should be a corporeal interval, for what is between the boundaries of the place is any body which may chance to be there, not an interval in body. Further, 5. Place is also somewhere, not in the sense of being in a place, but as the limit is in the limited, for not everything that is in place, but only movable body. Also, 6. It is reasonable that each kind of body should be carried to its own place. For a body which is next in the series and in contact, not by compulsion, is akin, and bodies which are united do not affect each other, while those which are in contact interact on each other. Nor, 7. Is it without reason that each should remain naturally in its proper place? For this part has the same relation to its place, as a separable part to its whole, as when one moves a part of water or air. So, too, air is related to water, for the one is like matter, the other form water is the matter of air, air as it were the actuality of water, for water is potentially air, while air is potentially water, though in another way. These distinctions will be drawn more carefully later. On the present occasion it was necessary to refer to them. What has now been stated obscurely will then be made more clear. If the matter and the fulfillment are the same thing, for water is both, the one potentially, the other completely, water will be related to air in a way as part to whole. That is why these have contact. It is organic union when both become actually one. This concludes my account of place, both of its existence and of its nature. The investigation of similar questions about the void, also, must be held to belong to the physicist, namely whether it exists or not, and how it exists or what it is, just as about place. The views taken of it involve arguments both for and against, in much the same sort of way. For those who hold that the void exists regard it as a sort of place or vessel which is supposed to be full when it holds the bulk which it is capable of containing, void when it is deprived of that, as if void and full and place denoted the same thing, though the essence of the three is different. We must begin the inquiry by putting down the account given by those who say that it exists, then the account of those who say that it does not exist, and third the current view on these questions. Those who try to show that the void does not exist do not disprove what people really mean by it, but only their erroneous way of speaking. This is true of Anaxagoras and of those who refute the existence of the void in this way. They merely give an ingenious demonstration that air is something by straining wineskins and showing the resistance of the air, and by cutting it off in clepsydras. But people really mean that there is an empty interval in which there is no sensible body. They hold that everything which is in body is body, and say that what has nothing in it at all is void, so what is full of air is void. It is not then the existence of air that needs to be proved, but the non-existence of an interval, different from the bodies, either separable or actual, an interval which divides the whole body so as to break its continuity, as Democritus and Leucippus hold, and many other physicists, or even perhaps as something which is outside the whole body, which remains continuous. These people, then, have not reached even the threshold of the problem, but rather those who say that the void exists. 1. They argue, for one thing, that change in place, that is locomotion and increase, would not be. For it is maintained that motion would seem not to exist, if there were no void, since what is full cannot contain anything more. If it could, and there were two bodies in the same place, it would also be true that any number of bodies could be together, for it is impossible to draw a line of division beyond which the statement would become untrue. If this were possible, it would follow also that the smallest body would contain the greatest, for many a little makes a mickle. Thus if many equal bodies can be together, so also can many unequal bodies. Melissus, indeed, infers from these considerations that the all is immovable, for if it were moved there must, he says, be void, but void is not among the things that exist. This argument, then, is one way in which they show that there is a void. 2. They reason from the fact that some things are observed to contract and be compressed, as people say that a cask will hold the wine which formerly filled it, along with the skins into which the wine has been decanted, which implies that the compressed body contracts into the voids present in it. Again, 3. Increase, 2, is thought to take always by means of void, for nutriment is body, and it is impossible for two bodies to be together. A proof of this they find also in what happens to ashes, which absorb as much water as the empty vessel. The Pythagoreans, 2, 4, held that void exists and that it enters the heaven itself, which as it were inhales it, from the infinite air. Further, it is the void which distinguishes the natures of things, as if it were like what separates and distinguishes the terms of a series. This holds primarily in the numbers, for the void distinguishes their nature. These, then, and so many, are the main grounds on which people have argued for and against the existence of the void. As a step towards settling which view is true, we must determine the meaning of the name. The void is thought to be place with nothing in it. The reason for this is that people take what exists to be body, and hold that while every body is in place, void is place in which there is no body, so that where there is no body, there must be void. Every body, again, they suppose to be tangible, and of this nature is whatever has weight or lightness. Hence, by a syllogism, what has nothing heavy or light in it, is void. This result, then, as I have said, is reached by syllogism. It would be absurd to suppose that the point is void, for the void must be place which has in it an interval intangible body. But at all events we observe then that in one way the void is described as what is not full of body perceptible to touch, and what has heaviness and lightness is perceptible to touch. So we would raise the question, what would they say of an interval that is color or sound, is it void or not? Clearly they would reply that if it could receive what is tangible it was void, and if not, not. In another way void is that in which there is no this or corporeal substance. So some say that the void is the matter of the body. They identify the place, too, with this, and in this they speak incorrectly, for the matter is not separable from the things, but they are inquiring about the void as about something separable. Since we have determined the nature of place, and void must, if it exists, be place deprived of body, and we have stated both in what sense place exists and in what sense it does not, it is plain that on this showing void does not exist, either unseparated or separated, the void is meant to be, not body but rather an interval in body. This is why the void is thought to be something, viz. Because place is, and for the same reasons. For the fact of motion in respect of place comes to the aid both of those who maintain that place is something over and above the bodies that come to occupy it, and of those who maintain that the void is something. They state that the void is the condition of movement in the sense of that in which movement takes place, and this would be the kind of thing that some say place is. But there is no necessity for the being a void if there is movement. It is not in the least needed as a condition of movement in general, for a reason which, incidentally, escaped Melissus, viz. That the full can suffer qualitative change. But not even movement in respect of place involves a void, for bodies may simultaneously make room for one another, though there is no interval separate and apart from the bodies that are in movement. And this is plain even in the rotation of continuous things, as in that of liquids, and things can also be compressed not into a void but because they squeeze out what is contained in them, as, for instance, when water is compressed the air within it is squeezed out, and things can increase in size not only by the entrance or something but also by qualitative change. For example, if water were to be transformed into air, in general, both the argument about increase of size and that about water poured onto the ashes get in their own way. For either not any and every part of the body is increased, or bodies may be increased otherwise than by the addition of body, or there may be two bodies in the same place, in which case they are claiming to solve a quite general difficulty, but are not proving the existence of void, or the whole body must be void, if it is increased in every part and is increased by means of void. The same argument applies to the ashes. It is evident, then, that it is easy to refute the arguments by which they prove the existence of the void. Let us explain again that there is no void existing separately, as some maintain. If each of the simple bodies has a natural locomotion, for example fire upward and earth downward and towards the middle of the universe, it is clear that it cannot be the void that is the condition of locomotion. What, then, will the void be the condition of? It is thought to be the condition of movement in respect of place, and it is not the condition of this. Again, if void is a sort of place deprived of body, when there is a void where will a body placed in it move to? It certainly cannot move into the whole of the void. The same argument applies as against those who think that place is something separate, into which things are carried, viz. How will what is placed in it move, or rest? Much the same argument will apply to the void as to the up and down in place, as is natural enough since those who maintain the existence of the void make it a place. And in what way will things be present either in place or in a void? For the expected result does not take place when a body is placed as a whole in a place conceived of as separate and permanent, for a part of it, unless it be placed apart, will not be in a place but in the whole. Further, if separate place does not exist, neither will void. If people say that the void must exist, as being necessary if there is to be movement, what rather turns out to be the case, if one the matter, is the opposite, that not a single thing can be moved if there is a void, for as with those who for a like reason say the earth is at rest, so, too, in the void things must be at rest, for there is no place to which things can move more or less than to another, since the void in so far as it is void admits no difference. The second reason is this: all movement is either compulsory or according to nature, and if there is compulsory movement there must also be natural, for compulsory movement is contrary to nature, and movement contrary to nature is posterior to that according to nature, so that if each of the natural bodies has not a natural movement, none of the other movements can exist. But how can there be natural movement if there is no difference throughout the void or the infinite? For insofar as it is infinite, there will be no up or down or middle, and insofar as it is a void, up differs no whit from down, for as there is no difference in what is nothing, there is none in the void, for the void seems to be a non-existent and a privation of being, but natural locomotion seems to be differentiated, so that the things that exist by nature must be differentiated. Either, then, nothing has a natural locomotion, or else there is no void. Further, in point of fact things that are thrown move though that which gave them their impulse is not touching them, either by reason of mutual replacement, as some maintain, or because the air that has been pushed pushes them with a movement quicker than the natural locomotion of the projectile wherewith it moves to its proper place. But in a void none of these things can take place, nor can anything be moved save as that which is carried is moved. Further, no one could say why a thing once set in motion should stop anywhere, for why should it stop here rather than here? So that a thing will either be at rest or must be moved ad infinitum, unless something more powerful get in its way. Further, things are now thought to move into the void because it yields, but in a void this quality is present equally everywhere, so that things should move in all directions. Further, the truth of what we assert is plain from the following considerations. We see the same weight or body moving faster than another for two reasons, either because there is a difference in what it moves through, as between water, air, and earth, or because, other things being equal, the moving body differs from the other owing to excess of weight or of lightness. Now the medium causes a difference because it impedes the moving thing, most of all if it is moving in the opposite direction, but in a secondary degree even if it is at rest, and especially a medium that is not easily divided, that is a medium that is somewhat dense. A, then, will move through B in time g, and through D, which is thinner, in time E, if the length of B is equal to D, in proportion to the density of the hindering body. For let B be water and D air, then by so much as air is thinner and more incorporeal than water, A will move through D faster than through B. Let the speed have the same ratio to the speed, then, that air has to water. Then if air is twice as thin, the body will traverse B in twice the time that it does D, and the time G will be twice the time E. And always, by so much as the medium is more incorporeal and less resistant and more easily divided, the faster will be the movement. Now there is no ratio in which the void is exceeded by body, as there is no ratio of 0 to a number. For if 4 exceeds 3 by 1, and 2 by more than 1, and 1 by still more than it exceeds 2, still there is no ratio by which it exceeds 0, for that which exceeds must be divisible into the excess plus that which is exceeded, so that will be what it exceeds 0 by plus 0. For this reason, too, a line does not exceed a point unless it is composed of points. Similarly the void can bear no ratio to the full, and therefore neither can movement through the one to movement through the other, but if a thing moves through the thickest medium such and such a distance in such and such a time, it moves through the void with a speed beyond any ratio. For let Z be void, equal in magnitude to B and to D. Then if A is to traverse and move through it in a certain time, h, a time less than E, however, the void will bear this ratio to the full. But in a time equal to h, A will traverse the part O of A. And it will surely also traverse in that time any substance Z which exceeds air in thickness in the ratio which the time E bears to the time h. For if the body Z be as much thinner than D as E exceeds h, A, if it moves through Z, will traverse it in a time inverse to the speed of the movement, that is in a time equal to h. If, then, there is no body in Z, A will traverse Z still more quickly. But we suppose that its traverse of Z when Z was void occupied the time h, so that it will traverse Z in an equal time whether Z be full or void. But this is impossible. It is plain, then, that if there is a time in which it will move through any part of the void, this impossible result will follow. It will be found to traverse a certain distance, whether this be full or void, in an equal time, for there will be some body which is in the same ratio to the other body as the time is to the time. To sum the matter up, the cause of this result is obvious, viz. that between any two movements there is ratio, for they occupy time. And there is a ratio between any two times, so long as both are finite, but there is no ratio of void to full. These are the consequences that result from a difference in the media. The following depend upon an excess of one moving body over another. We see that bodies which have a greater impulse either of weight or of lightness, if they are alike in other respects, move faster over an equal space, and in the ratio which their magnitudes bear to each other. Therefore they will also move through the void with this ratio of speed. But that is impossible, for why should one move faster? In moving through plano it must be so, for the greater divides them faster by its force. For a moving thing cleaves the medium either by its shape, or by the impulse which the body that is carried along or is projected possesses, therefore all will possess equal velocity. But this is impossible. It is evident from what has been said, then, that, if there is a void, a result follows which is the very opposite of the reason for which those who believe in a void set it up. They think that if movement in respect of place is to exist, the void cannot exist, separated all by itself. But this is the same as to say that place is a separate cavity, and this has already been stated to be impossible. But even if we consider it on its own merits, the so-called vacuum will be found to be really vacuous. For as, if one puts a cube in water, an amount of water equal to the cube will be displaced, so too in air, but the effect is imperceptible to sense. And indeed always in the case of any body that can be displaced, must, if it is not compressed, be displaced in the direction in which it is its nature to be displaced, always either down, if its locomotion is downwards as in the case of earth, or up, if it is fire, or in both directions whatever be the nature of the inserted body. Now in the void this is impossible, for it is not body. The void must have penetrated the cube to a distance equal to that which this portion of void formerly occupied in the void, just as if the water or air had not been displaced by the wooden cube, but had penetrated right through it. But the cube also has a magnitude equal to that occupied by the void, a magnitude which, if it is also hot or cold, or heavy or light, is nonetheless different in essence from all its attributes, even if it is not separable from them, I mean the volume of the wooden cube. So that even if it were separated from everything else and were neither heavy nor light, it will occupy an equal amount of void, and fill the same place, as the part of place or of the void equal to itself. How then will the body of the cube differ from the void or place that is equal to it? And if there can be two such things, why cannot there be any number coinciding? This, then, is one absurd and impossible implication of the theory. It is also evident that the cube will have this same volume even if it is displaced, which is an attribute possessed by all other bodies also. Therefore if this differs in no respect from its place, why need we assume a place for bodies over and above the volume of each, if their volume be conceived of as free from attributes? It contributes nothing to the situation if there is an equal interval attached to it as well. Further, it ought to be clear by the study of moving things what sort of thing void is. But in fact it is found nowhere in the world. For air is something, though it does not seem to be so, nor, for that matter, would water, if fishes were made of iron, for the discrimination of the tangible is by touch. It is clear, then, from these considerations that there is no separate void. There are some who think that the existence of rarity and density shows that there is a void. If rarity and density do not exist, they say, neither can things contract and be compressed. But if this were not to take place, either there would be no movement at all, or the universe would bulge, as Xuthus said, or air and water must always change into equal amounts. For example, if air has been made out of a cupful of water, at the same time out of an equal amount of air a cupful of water must have been made, or void must necessarily exist, for compression and expansion cannot take place otherwise. Now, if they mean by the rare that which has many voids existing separately, it is plain that if void cannot exist separate any more than a place can exist with an extension all to itself, neither can the rare exist in this sense. But if they mean that there is void, not separately existent, but still present in the rare, this is less impossible. Yet, first, the void turns out not to be a condition of all movement, but only of movement upwards, for the rare is light, which is the reason why they say fire is rare. Second, the void turns out to be a condition of movement not as that in which it takes place, but in that the void carries things up as skins by being carried up themselves carry up what is continuous with them. Yet how can void have a local movement or a place? For thus that into which void moves is till then void of a void. Again, how will they explain, in the case of what is heavy, its movement downwards? And it is plain that if the rarer and more void a thing is the quicker it will move upwards. If it were completely void it would move with a maximum speed. But perhaps even this is impossible, that it should move at all. The same reason which showed that in the void all things are incapable of moving shows that the void cannot move, viz. the fact that the speeds are incomparable. Since we deny that a void exists, but for the rest the problem has been truly stated, that either there will be no movement, if there is not to be condensation and rarefaction, or the universe will bulge, or a transformation of water into air will always be balanced by an equal transformation of air into water. For it is clear that the air produced from water is bulkier than the water. It is necessary therefore, if compression does not exist, either that the next portion will be pushed outwards and make the outermost part bulge, or that somewhere else there must be an equal amount of water produced out of air, so that the entire bulk of the whole may be equal, or that nothing moves. For when anything is displaced this will always happen, unless it comes round in a circle, but locomotion is not always circular, but sometimes in a straight line. These then are the reasons for which they might say that there is a void. Our statement is based on the assumption that there is a single matter for contraries, hot and cold and the other natural contrarieties, and that what exists actually is produced from a potential existent, and that matter is not separable from the contraries but its being is different, and that a single matter may serve for color and heat and cold. The same matter also serves for both a large and a small body. This is evident, for when air is produced from water, the same matter has become something different, not by acquiring an addition to it, but has become actually what it was potentially, and, again, water is produced from air in the same way, the change being sometimes from smallness to greatness, and sometimes from greatness to smallness. Similarly, therefore, if air which is large in extent comes to have a smaller volume, or becomes greater from being smaller, it is the matter which is potentially both that comes to be each of the two. For as the same matter becomes hot from being cold, and cold from being hot, because it was potentially both, so too from hot it can become more hot, though nothing in the matter has become hot that was not hot when the thing was less hot, just as, if the arc or curve of a greater circle becomes that of a smaller, whether it remains the same or becomes a different curve, convexity has not come to exist in anything that was not convex but straight. For differences of degree do not depend on an intermission of the quality, nor can we get any portion of a flame, in which both heat and whiteness are not present. So too, then, is the earlier heat related to the later. So that the greatness and smallness, also, of the sensible volume are extended, not by the matter's acquiring anything new, but because the matter is potentially matter for both states, so that the same thing is dense and rare, and the two qualities have one matter. The dense is heavy, and the rare is light. Again, as the arc of a circle when contracted into a smaller space does not acquire a new part which is convex, but what was there has been contracted, and as any part of fire that one takes will be hot, so, too, it is all a question of contraction and expansion of the same matter. There are two types in each case, both in the dense and in the rare, for both the heavy and the hard are thought to be dense, and contrariwise both the light and the soft are rare, and weight and hardness fail to coincide in the case of lead and iron. From what has been said it is evident, then, that void does not exist either separate, either absolutely separate or as a separate element in the rare, or potentially, unless one is willing to call the condition of movement void, whatever it may be. At that rate the matter of the heavy and the light, qua matter of them, would be the void, for the dense and the rare are productive of locomotion in virtue of this contrariety, and in virtue of their hardness and softness productive of passivity and impassivity, that is not of locomotion but rather of qualitative change. So much, then, for the discussion of the void, and of the sense in which it exists and the sense in which it does not exist. Next for discussion after the subjects mentioned is time. The best plan will be to begin by working out the difficulties connected with it, making use of the current arguments. First, does it belong to the class of things that exist or to that of things that do not exist? Then secondly, what is its nature? To start, then, the following considerations would make one suspect that it either does not exist at all or barely, and in an obscure way. One part of it has been and is not, while the other is going to be and is not yet. Yet time, both infinite time and any time you like to take, is made up of these. One would naturally suppose that what is made up of things which do not exist could have no share in reality. Further, if a divisible thing is to exist, it is necessary that, when it exists, all or some of its parts must exist. But of time some parts have been, while others have to be, and no part of it is through it is divisible. For what is now is not a part is a measure of the whole, which must be made up of parts. Time, on the other hand, is not held to be made up of nows. Again, the now which seems to bound the past and the future, does it always remain one and the same, or is it always other and other? It is hard to say. 1. If it is always different, and if none of the parts in time which are other and other are simultaneous, unless the one contains and the other is contained, as the shorter time is by the longer, and if the now which is not, that formerly was, must have ceased to be at some time, the nows too cannot be simultaneous with one another. But the prior now must always have ceased to be. But the prior now cannot have ceased to be in itself, since it then existed, yet it cannot have ceased to be in another now. For we may lay it down that one now cannot be next to another, any more than point to point. If then it did not cease to be in the next now but in another, it would exist simultaneously with the innumerable nows between the two, which is impossible. Yes, but, 2, neither is it possible for the now to remain always the same. No determinate divisible thing has a single termination, whether it is continuously extended in one or in more than one dimension, but the now is a termination, and it is possible to cut off a determinate time. Further, if coincidence in time, that is being neither prior nor posterior, means to be in one and the same now apostrophe, then, if both what is before and what is after are in this same now, things which happened 10,000 years ago would be simultaneous with what has happened today, and nothing would be before or after anything else. This may serve as a statement of the difficulties about the attributes of time, as to what time is or what is its nature. The traditional accounts give us as little light as the preliminary problems which we have worked through. Some assert that it is, 1. The movement of the whole, others that it is, 2. The sphere itself, 1. Yet part, 2, of the revolution is a time, but it certainly is not a revolution, for what is taken is part of a revolution, not a revolution. Besides, if there were more heavens than one, the movement of any of them equally would be time, so that there would be many times at the same time. 2. Those who said that time is the sphere of the whole thought so, no doubt, on the ground that all things are in time and all things are in the sphere of the whole. The view is too naive for it to be worthwhile to consider the impossibilities implied in it, but as time is most usually supposed to be, 3, motion and a kind of change, we must consider this view. Now, a. The change or movement of each thing is only in the thing which changes or where the thing itself which moves or changes may chance to be. But time is present equally everywhere and with all things. Again, b. Change is always faster or slower, whereas time is not, for fast and slow are defined by time. Fast is what moves much in a short time, slow what moves little in a long time, but time is not defined by time, by being either a certain amount or a certain kind of it. Clearly then it is not movement. We need not distinguish at present between movement and change, but neither does time exist without change, for when the state of our own minds does not change at all, or we have not noticed its changing, we do not realize that time has elapsed, any more than those who are fabled to sleep among the heroes in Sardinia do when they are awakened, for they connect the earlier now with the later and make them one, cutting out the interval because of their failure to notice it. So, just as, if the now were not different but one and the same, there would not have been time, so too when its difference escapes our notice the interval does not seem to be time. If, then, the non-realization of the existence of time happens to us when we do not distinguish any change, but the soul seems to stay in one indivisible state, and when we perceive and distinguish we say time has elapsed, evidently time is not independent of movement and change. It is evident, then, that time is neither movement nor independent of movement. We must take this as our starting point and try to discover, since we wish to know what time is, what exactly it has to do with movement. Now we perceive movement and time together, for even when it is dark and we are not being affected through the body, if any movement takes place in the mind we at once suppose that some time also has elapsed, and not only that but also, when some time is thought to have passed, some movement also along with it seems to have taken place. Hence time is either movement or something that belongs to movement. Since then it is not movement, it must be the other, but what is moved from something to something, and all magnitude is continuous. Therefore the movement goes with the magnitude. Because the magnitude is continuous, the movement too must be continuous, and if the movement, then the time, for the time that has passed is always thought to be in proportion to the movement. The distinction of before and after holds primarily, then, in place, and in virtue of relative position. Since then before and after hold in magnitude, they must hold also in movement, these corresponding to those. But also in time the distinction of before and after must hold, for time and movement always correspond with each other. The before and after in motion is identical in substratum with motion, yet differs from it in definition, and is not identical with motion. But we apprehend time only when we have marked motion, marking it by before and after, and it is only when we have perceived before and after in motion that we say that time has elapsed. Now we mark them by judging that A and B are different, and that some third thing is intermediate to them. When we think of the extremes as different from the middle and the mind pronounces that the nows are two, one before and one after, it is then that we say that there is time, and this that we say is time. For what is bounded by the nows thought to be time we may assume this. When, therefore, we perceive the now one, and neither as before and after in emotion nor as an identity but in relation to a before and an after, no time is thought to have elapsed, because there has been no motion either. On the other hand, when we do perceive a before and an after, then we say that there is time. For time is just this number of motion in respect of before and after. Hence time is not movement, but only movement insofar as it admits of enumeration. A proof of this, we discriminate the more or the less by number, but more or less movement by time. Time then is a kind of number. Number, we must note, is used in two senses, both of what is counted or the countable and also of that with which we count. Time obviously is what is counted, not that with which we count. There are different kinds of thing, just as motion is a perpetual succession, so also is time. But every simultaneous time is self-identical, for the now as a subject is an identity, but it accepts different attributes. The now measures time, insofar as time involves the before and after. The now in one sense is the same, in another it is not the same. Insofar as it is in succession, it is different, which is just what its being was supposed to mean, but its substratum is an identity, for motion, as was said, goes with magnitude, and time, as we maintain, with motion. Similarly, then, the corresponds to the point the body which is carried along, and by which we are aware of the motion and of the before and after involved in it. This is an identical substratum, whether a point or a stone or something else of the kind, but it has different attributes, as the sophists assume that Coriscus being in the Lyceum is a different thing from Coriscus being in the marketplace. And the body which is carried along is different, insofar as it is at one time here and at another there. But the now corresponds to the body that is carried along, as time corresponds to the motion. For it is by means of the body that is carried along that we become aware of the before and after the motion, and if we regard these as countable we get the now. Hence in these also the now as substratum remains the same, for it is what is before and after in movement, but what is predicated of it is different, for it is in so far as the before and after is numerable that we get the now. This is what is most knowable, for, similarly, motion is known because of that which is moved, locomotion because of that which is carried. What is carried is a real thing, the movement is not. Thus what is called now in one sense is always the same, in another it is not the same, for this is true also of what is carried. Clearly, too, if there were no time, there would be no now, and vice versa. Just as the moving body and its locomotion involve each other mutually, so too do the number of the moving body and the number of its locomotion. For the number of the locomotion is time, while the now corresponds to the moving body, and is like the unit of number, time, then, also is both made continuous by the now and divided at it. For here too there is a correspondence with the locomotion and the moving body. For the motion or locomotion is made one by the thing which is moved, because it is one, not because it is one in its own nature, for there might be pauses in the movement of such a thing, but because it is one in definition, for this determines the movement as before and after. Here, too, there is a correspondence with the point, for the point also both connects and terminates the length, it is the beginning of one and the end of another. But when you take it in this way, using the one point as two, a pause is necessary, if the same point is to be the beginning and the end. The now on the other hand, since the body carried is moving, is always different. Hence time is not number in the sense in which there is number of the same point because it is beginning and end, but rather as the extremities of a line form a number, and not as the parts of a line do so, both for the reason given, for we can use the middle point as 2, so that on that analogy time might stand still, and further because obviously the now is no part of time nor the section any part of the movement, any more than the points are parts of the line, for it is two lines that are parts of one line. In so far then as the now is a boundary, it is not time, but an attribute of it, in so far as it numbers, it is number, for boundaries belong only to that which they bound, but number, for example 10, is the number of these horses, and belongs also elsewhere. It is clear, then, that time is number of movement in respect of the before and after, and is continuous since it is an attribute of what is continuous. The smallest number, in the strict sense of the word number, is 2. But of number as concrete, sometimes there is a minimum, sometimes not. For example of a line, the smallest in respect of multiplicity is 2, or, if you like, 1, but in respect of size there is no minimum, for every line is divided ad infinitum. Hence it is so with time. In respect of number the minimum is 1, or 2, in point of extent there is no minimum. It is clear, too, that time is not described as fast or slow, but as many or few and as long or short. For as continuous it is long or short, and as a number many or few, but it is not fast or slow any more than any number with which we number is fast or slow. Further, there is the same time everywhere at once, but not the same time before and after, for while the present change is one, the change which has happened and that which will happen are different. Time is not number with which we count, but the number of things which are counted, and this according as it occurs before or after is always different, for the nows are different. and the number of 100 horses and 100 men is the same, but the things numbered are different, the horses from the men. Further, as a movement can be one and the same again and again, so too can time, for example a year or a spring or an autumn. Not only do we measure the movement by the time, but also the time by the movement, because they define each other. The time marks the movement, since it is its number, and the movement the time. We describe the time as much or little, measuring it by the movement, just as we know the number by what is numbered, for example the number of the horses by one horse as the unit. For we know how many horses there are by the use of the number, and again by using the one horse as unit we know the number of the horses itself. So it is with the time and the movement, for we measure the movement by the time and vice versa. It is natural that this should happen, for the movement goes with the distance and the time with the movement, because they are quanta and continuous and divisible. The movement has these attributes because the distance is of this nature, and the time has them because of the movement. And we measure both the distance by the movement and the movement by the distance, for we say that the road is long, if the journey is long, and that this is long, if the road is long the time, too, if the movement, and the movement, if the time. Time is a measure of motion and of being moved, and it measures the motion by determining a motion which will measure exactly the whole motion, as the cubit does the length by determining an amount which will measure out the whole. Further, to be in time means for movement, that both it and its essence are measured by time, for simultaneously it measures both the movement and its essence, and this is what being in time means for it, that its essence should be measured. Clearly then to be in time has the same meaning for other things also, namely, that their being should be measured by time. To be in time is one of two things: 1, to exist when time exists; 2, as we say of some things that they are in number. The latter means either what is a part or mode of number in general, something which belongs to number, or that things have a number. Now, since time is number, the now and the before and the like are in time, just as unit and odd and even are in number, that is in the sense that the one set belongs to number, the other to time. But things are in time as they are in number. If this is so, they are contained by time as things in place are contained by place. Plainly, too, to be in time does not mean to coexist with time, any more than to be in motion or in place means to coexist with motion or place. For if to be in something is to mean this, then all things will be in anything, and the heaven will be in a grain, for when the grain is, then also is the heaven. But this is a merely incidental conjunction, whereas the other is necessarily involved. That which is in time necessarily involves that there is time when it is, and that which is in motion that there is motion when it is. Since what is in time is so in the same sense as what is in number is so, a time greater than everything in time can be found. So it is necessary that all the things in time should be contained by time, just like other things also which are in anything, for example the things in place by place. A thing, then, will be affected by time, just as we are accustomed to say that time wastes things away, and that all things grow old through time, and that there is oblivion owing to the lapse of time. But we do not say the same of getting to know or of becoming young or fair. For time is by its nature the cause rather of decay, since it is the number of change, and change removes what is. Hence, plainly, things which are always are not, as such, in time, for they are not contained time, nor is their being measured by time. A proof of this is that none of them is affected by time, which indicates that they are not in time. Since time is the measure of motion, it will be the measure of rest too indirectly. For all rest is in time. For it does not follow that what is in time is moved, though what is in motion is necessarily moved. For time is not motion, but number of motion, and what is at rest, also, can be in the number of motion. Not everything that is not in motion can be said to be at rest, but only that which can be moved, though it actually is not moved, as was said above. To be in number means that there is a number of the thing, and that its being is measured by the number in which it is. Hence if a thing is in time it will be measured by time. But time will measure what is moved and what is at rest, the one qua moved, the other qua at rest, for it will measure their motion and rest respectively. Hence what is moved will not be measurable by the time simply in so far as it has quantity, but in so far as its motion has quantity. Thus none of the things which are neither moved nor at rest are in time, for to be in time is to be measured by time, while time is the measure of motion and rest. Plainly, then, neither will everything that does not exist be in time, that is those non-existent things that cannot exist, as the diagonal cannot be commensurate with the side. Generally, if time is directly the measure of motion and indirectly of other things, it is clear that a thing whose existence is measured by it will have its existence in rest or motion. Those things therefore which are subject to perishing and becoming generally, those which at one time exist, at another do not are necessarily in time, for there is a greater time which will extend both beyond their existence and beyond the time which measures their existence. Of things which do not exist but are contained by time, some were, for example Homer once was, some will be, for example a future event. This depends on the direction in which time contains them. If on both, they have both modes of existence. As to such things as it does not contain in any way, they neither were nor are nor will be. These are those non-existents whose opposites always are, as the incommensurability of the diagonal always is, and this will not be in time. Nor will the commensurability, therefore, hence this eternally is not, because it is contrary to what eternally is. A thing whose contrary is not eternal can be and not be, and it is of such things that there is coming to be and passing away. The now is the link of time, as has been said, for it connects past and future time, and it is a limit of time, for it is the beginning of the one and the end of the other. But this is not obvious as it is with the point, which is fixed. It divides potentially, and in so far as it is dividing the now is always different, but in so far as it connects it is always the same, as it is with mathematical lines. For the intellect it is not always one and the same point, since it is other and other when one divides the line, but in so far as it is one, it is the same in every respect. So the now also is in one way a potential dividing of time, in another the termination of both parts, and their unity. And the dividing and the uniting are the same thing and in the same reference, but in essence they are not the same. So one kind of now is described in this way, another is when the time is near this kind of now. He will come now because he will come today, he has come now because he came today. But the things in the Iliad have not happened now, nor is the flood now, not that the time from now to them is not continuous, but because they are not near. At some time means a time determined in relation to the first of the two types of now. For example, at some time Troy was taken, and at some time there will be a flood, for it must be determined with reference to the now. There will thus be a determinate time from this now to that, and there was such in reference to the past event. But if there be no time which is not some time, every time will be determined. Will time then fail? Surely not, if motion always exists. Is time then always different, or does the same time recur? Clearly time is, in the same way as motion is. For if one and the same motion sometimes recurs, it will be one and the same time, and if not, not. Since the now is an end and a beginning of time, not at the same time however, but the end of that which is past and the beginning of that which is to come, it follows that, as the circle has its convexity and its concavity, in a sense, in the same thing, so time is always at a beginning and at an end. And for this reason it seems to be always different, for the now is not the beginning and the end of the same thing. If it were, it would be at the same time and in the same respect two opposites. And time will not fail, for it is always at a beginning. Presently or just refers to the part of future time which is near the indivisible present now. When do you walk? Presently, because the time in which he is going to do so is near, and to the part of past time which is not far from the now. When do you walk? I have just been walking. But to say that Troy has just been taken, we do not say that, because it is too far from the now. Lately, too, refers to the part of past time which is near the present now. When did you go? Lately, if the time is near the existing now. Long ago refers to the distant past. Suddenly refers to what has departed from its former condition in a time imperceptible because of its smallness, but it is the nature of all change to alter things from their former condition. In time all things come into being and pass away, for which reason some called it the wisest of all things, but the Pythagorean Pyrrhon called it the most stupid, because in it we also forget, and his was the truer view. It is clear then that it must be in itself, as we said before, the condition of destruction rather than of coming into being, for change, in itself, makes things depart from their former condition, and only incidentally of coming into being, and of being. A sufficient evidence of this is that nothing comes into being without itself moving somehow and acting, but a thing can be destroyed even if it does not move at all. And this is what, as a rule, we chiefly mean by a thing's being destroyed by time. Still, time does not work even this change. Even this sort of change takes place incidentally in time. We have stated, then, that time exists and what it is, and in how many senses we speak of the now, and what at some time, lately, presently or just, long ago, and suddenly mean. These distinctions having been drawn, it is evident that every change and everything that moves is in time, for the distinction of faster and slower exists in reference to all change, since it is found in every instance. In the phrase moving faster I refer to that which changes before another into the condition in question, when it moves over the same interval and with a regular movement. For example, in the case of locomotion, if both things move along the circumference of a circle, or both along a straight line, and similarly in all other cases. But what is before is in time, for we say before and after with reference to the distance from the now, and the now is the boundary of the past and the future, so that since nows are in time, the before and the after will be in time too, for in that in which the now is, the distance from the now will also be. But before is used contrariwise with reference to past into future time, for in the past we call before what is further from the now, and after what is nearer, but in the future we call the nearer before and the farther after. So that since the before is in time, and every movement involves a before, evidently every change and every movement is in time. It is also worth considering how time can be related to the soul, and why time is thought to be in everything, both in earth and in sea and in heaven. Is because it is an attribute, or state, or movement, since it is the number of movement, and all these things are movable, for they are all in place, and time and movement are together, both in respect of potentiality and in respect of actuality. Whether if soul did not exist time would exist or not, is a question that may fairly be asked, for if there cannot be someone to count there cannot be anything that can be counted, so that evidently there cannot be number, for number is either what has been, or what can be, counted. But if nothing but soul, or in soul reason, is qualified to count, there would not be time unless there were soul, but only that of which time is an attribute, that is if movement can exist without soul, and the before and after are attributes of movement, and time is these qua-numerable. One might also raise the question what sort of movement time is the number of. Must we not say of any kind? For things both come into being in time and pass away, and grow, and are altered in time, and are moved locally, thus it is of each movement qua movement that time is the number. And so it is simply the number of continuous movement, not of any particular kind of it. But other things as well may have been moved now, and there would be a number of each of the two movements. Is there another time, then, and will there be two equal times at once? Surely not. For a time that is both equal and simultaneous is one and the same time, and even those that are not simultaneous are one in kind, for if there were dogs, and horses, and 7 of each, it would be the same number. So, two movements that have simultaneous limits have the same time, yet the one may in fact be fast and the other not, and one may be locomotion and the other alteration. Still the time of the two changes is the same if their number also is equal and simultaneous, and for this reason, while the movements are different and separate, the time is everywhere the same, because the number of equal and simultaneous movements is everywhere one and the same. Now there is such a thing as locomotion, and in locomotion there is included circular movement, and everything is measured by some one thing homogeneous with it, units by a unit, horses by a horse, and similarly times by some definite time, and, as we said, time is measured by motion as well as motion by time, this being so because by a motion definite in time the quantity both of the motion and of the time is measured. If, then, what is first is the measure of everything homogeneous with it, regular circular motion is above all else the measure, because the number of this is the best known. Now neither alteration nor increase nor coming into being can be regular, but locomotion can be. This also is why time is thought to be the movement of a sphere, viz. Because the other movements are measured by this, and time by this movement. This also explains the common saying that human affairs form a circle, and that there is a circle in all other things that have a natural movement and coming into being and passing away. This is because all other things are discriminated by time, and end and begin as though conforming to a cycle, for even time itself is thought to be a circle. And this opinion again is held because time is the measure of this kind of locomotion and is itself measured by such. So that to say that the things that come into being form a circle is to say that there is a circle of time, and this is to say that it is measured by the circular movement, for apart from the measure nothing else to be measured is observed. The whole is just a plurality of measures. It is said rightly, too, that the number of the sheep and of the dogs is the same number if the two numbers are equal, but not the same decad or the same 10, just as the equilateral and the scalene are not the same triangle, yet they are the same figure, because they are both triangles. For things are called the same so and so if they do not differ by a differentia of that thing, but not if they do. For example, triangle differs from triangle by a differentia of triangle, therefore they are different triangles, but they do not differ by a differentia of figure, but are in one and the same division of it. For a figure of the one kind is a circle and a figure of another kind of triangle, and a triangle of one kind is equilateral and a triangle of another kind scalene. They are the same figure, then, that triangle, but not the same triangle. Therefore the number of two groups also is the same number, for their number does not differ by a differential of number, but it is not the same decad, for the things of which it is asserted differ, one group are dogs, and the other horses, We have now discussed time, both time itself and the matters appropriate to the consideration of it. Physics, Book V, translated by R.P. Hardy and Dark A.G. Everything which changes does so in one of three senses. It may change, 1. Accidentally, as for instance when we say that something musical walks, that which walks being something in which aptitude for music is an accident. Again, 2. A thing is said without qualification to change because something belonging to it changes, that is in statements which refer to part of the thing in question. Thus the body is restored to health because the eye or the chest, that is to say a part of the whole body, is restored to health. And above all there is, 3. The case of a thing which is in motion neither accidentally nor in respect of something else belonging to it, but in virtue of being itself directly in motion. Here we have a thing which is essentially movable, and that which is so is a different thing according to the particular variety of motion. For instance, it may be a thing capable of alteration, and within the sphere of alteration it is again a different thing according as it is capable of being restored to health or capable of being heated. And there are the same distinctions in the case of the mover. 1. One thing causes motion accidentally. 2. Another partially, because something belonging to it causes motion. 3. Another of itself directly, as, for instance, the physician heals, the hand strikes. We have, then, the following factors: a. On the one hand that which directly causes motion, and, b. On the other hand that which is in motion. Further, we have, c. That in which motion takes place, namely time, and, distinct from these three, d. That from which, and, e. That to which it proceeds, for every motion proceeds from something and to something, that which is directly in motion being distinct from that to which it is in motion and that from which it is in motion. For instance, we may take the three things wood, hot, and cold, of which the first is that which is in motion, the second is that to which the motion proceeds, and the third is that from which it proceeds. This being so, it is clear that the motion is in the wood, not in its form, for the motion is neither caused nor experienced by the form or the place or the quantity. So we are left with a mover, a moved, and a goal of motion. I do not include the starting point of motion, for it is the goal rather than the starting point of motion that gives its name to a particular process of change. Thus perishing is changed to not being, though it is also true that that which perishes changes from being, and becoming is changed to being, though it is also changed from not being. Now a definition of motion has been given above, from which it will be seen that every goal of motion, whether it be a form, an affection, or a place, is immovable, as, for instance, knowledge and heat. Here, however, a difficulty may be raised. Affections, it may be said, are motions, and whiteness is an affection, thus there may be changed to emotion. To this we may reply that it is not whiteness but whitening that is emotion. Here also the same distinctions are to be observed. A goal of motion may be so accidentally, or partially and with reference to something other than itself, or directly and with no reference to anything else. For instance, a thing which is becoming white changes accidentally to an object of thought, the color being only accidentally the object of thought. It changes to color, because white is a part of color, or to Europe, because Athens is a part of Europe, but it changes essentially to white color. It is now clear in what sense a thing is in motion essentially, accidentally, or in respect of something other than itself, and in what sense the phrase itself directly is used in the case both of the mover and of the moved, and it is also clear that the motion is not in the form but in that which is in motion, that is to say the movable in activity. Now accidental change we may leave out of account, for it is to be found in everything, at any time, and in any respect. Change which is not accidental on the other hand is not to be found in everything, but only in contraries, in things intermediate contraries, and in contradictories, as may be proved by induction. An intermediate may be a starting point of change, since for the purposes of the change it serves as contrary to either of two contraries, for the intermediate is in a sense the extremes. Hence we speak of the intermediate as in a sense a contrary relatively to the extremes and of either extreme as a contrary relatively to the intermediate. For instance, the central note is low relatively to the highest and high relatively to the lowest, and gray is light relatively to black and dark relatively to white. And since every change is from something to something as the word itself, metabole, indicates, implying something after, meta, something else, that is to say something earlier and something later, that which changes must change in one of four ways: from subject to subject, from subject to non-subject, from non-subject to subject, or from non-subject to non-subject, whereby subject I mean what is affirmatively expressed. So it follows necessarily from what has been said above that there are only three kinds of change: that from subject to subject, that from subject to non-subject, and that from non-subject to subject. For the fourth conceivable kind, that from non-subject to non-subject, is not change, as in that case there is no opposition, either of contraries or of contradictories. Now change from non-subject to subject, the relation being that of contradiction, is coming to be unqualified coming to be when the change takes place in an unqualified way, particular coming to be when the change is change in a particular character. For instance, a change from not white to white is a coming to be of the particular thing, white, while change from unqualified not being to being is coming to be in an unqualified way, in respect of which we say that a thing comes to be without qualification, not that it comes to be some particular thing. Change from subject to non-subject is perishing unqualified perishing when the change is from being to not being, particular perishing when the change is to the opposite negation. The distinction being the same as that made in the case of coming to be. Now the expression not being is used in several senses, and there can be motion neither of that which is not in respect of the affirmation or negation of a predicate, nor of that which is not in a sense that it only potentially is, that is to say the opposite of that which actually is in an unqualified sense. For although that which is not white or not good may nevertheless be in motion accidentally, for example that which is not white might be a man, yet that which is without qualification not so and so cannot in any sense be in motion, therefore it is impossible for that which is not to be in motion. This being so, it follows that becoming cannot be a motion, for it is that which is not that becomes. For however true it may be that it accidentally becomes, it is nevertheless correct to say that it is that which is not that in an unqualified sense becomes. And similarly it is impossible for that which is not to be at rest. There are these difficulties, then, in the way of the assumption that that which is not can be in motion, and it may be further objected that, whereas everything which is in motion is in space, that which is not in space, for then it would be somewhere. So, too, perishing is not a motion, for a motion has for its contrary either another motion or rest, whereas perishing is the contrary of becoming. Since, then, every motion is a kind of change, and there are only the three kinds of change mentioned above, and since of these three those which take the form of becoming and perishing, that is to say those which imply a relation of contradiction, are not motions, it necessarily follows that only change from subject to subject is motion. And every such subject is either a contrary or an intermediate, for a privation may be allowed to rank as a contrary, and can be affirmatively expressed, as naked, toothless, or black. If, then, the categories are severally distinguished as being quality, place, time, relation, quantity, and activity or passivity, it necessarily follows that there are three kinds of motion: qualitative, quantitative, and local. In respect of substance there is no motion, because substance has no contrary among things that are. Nor is the motion in respect of relation, for it may happen that when one correlative changes, the other, although this does not itself change, is no longer applicable, so that in these cases the motion is accidental. Nor is the motion in respect of agent and patient. In fact there can never be motion of mover and moved, because there cannot be motion of motion or becoming of becoming or in general change of change. For in the first place there are two senses in which motion of motion is conceivable. 1. The motion of which there is motion might be conceived as subject. For example, a man is in motion because he changes from fair to dark. Can it be that in this sense motion grows hot or cold, or changes place, or increases or decreases? Impossible, for change is not a subject. Or, 2. Can there be motion of motion in the sense that some other subject changes from a change to another mode of being, as for example a man changes from falling ill to getting well? Even this is possible only in an accidental sense. For, whatever the subject may be, movement is change from one form to another. And the same holds good of becoming and perishing, except that in these processes we have a change to a particular kind of opposite, while the other, motion, is a change to a different kind. So, if there is to be motion of motion, that which is changing from health to sickness must simultaneously be changing from this very change to another. It is clear, then, that by the time that it has become sick, it must also have changed to whatever may be the other change concerned, for that it should be at rest, though logically possible, is excluded by the theory. Moreover, this other can never be any casual change, but must be a change from something definite to some other definite thing. So in this case it must be the opposite change, viz. Convalescence. It is only accidentally that there can be change of change. For example, there is a change from remembering to forgetting only because the subject of this change changes at one time to knowledge, at another to ignorance. In the second place, if there is to be change of change and becoming of becoming, we shall have an infinite regress. Thus if one of a series of changes is to be a change of change, the preceding change must also be so. For example, if simple becoming was ever in process of becoming, then that which was becoming simple becoming was also in process of becoming, so that we should not yet have arrived at what was in process of simple becoming but only at what was already in process of becoming in process of becoming. And this again was sometime in process of becoming, so that even then we should not have arrived at what was in process of simple becoming. And since in an infinite series there is no first term, here there will be no first stage and therefore no following stage either. On this hypothesis, then, nothing can become or be moved or change. Thirdly, if a thing is capable of any particular motion, it is also capable of the corresponding contrary motion or the corresponding coming to rest, and a thing that is capable of becoming is also capable of perishing. Consequently, if there be becoming of becoming, that which is in process of becoming is in process of perishing at the very moment when it has reached the stage of becoming, since it cannot be in process of perishing when it is just beginning to become or after it has ceased to become, for that which is in process of perishing must be in existence. Fourthly, there must be a substrate underlying all processes of becoming and changing. What can this be in the present case? It is either the body or the soul that undergoes alteration. What is it that correspondingly becomes motion or becoming? And again, what is the goal of their motion? It must be the motion or becoming of something from something to something else. But in what sense can this be so? For the becoming of learning cannot be learning, so neither can the becoming of becoming be becoming, nor can the becoming of any process be that process. Finally, since there are three kinds of motion, the substratum and the goal of motion must be one or other of these. For example, locomotion will have to be altered or to be locally moved. To sum up, then, since everything that is moved in one of three ways, either accidentally, or partially, or essentially, change can change only accidentally, as for example when a man who is being restored to health runs or learns, and accidental change we have long ago decided to leave out of account. Since, then, motion can belong neither to being nor to relation nor to agent and patient, it remains that there can be motion only in respect of quality, quantity, and place, for with each of these we have a pair of contraries. Motion in respect of quality let us call alteration, a general designation that is used to include both contraries, and by quality I do not here mean a property of substance, in that sense that which constitutes a specific distinction is a quality, but a passive quality in virtue of which a thing is said to be acted on or to be incapable of being acted on. Motion in respect of quantity has no name that includes both contraries, but it is called increase or decrease according as one or the other is designated, that is to say motion in the direction of complete magnitude is increase, motion in the contrary direction is decrease. Motion in respect of place has no name either general or particular, but we may designate it by the general name of locomotion, though strictly the term locomotion is applicable to things that change their place only when they have not the power to come to a stand, and to things that do not move themselves locally. Change within the same kind from a lesser to a greater or from a greater to a lesser degree is alteration, for it is motion either from a contrary or to a contrary, whether in an unqualified or in a qualified sense, for change to a lesser degree of a quality will be called change to the contrary of that quality, and change to a greater degree of a quality will be regarded as change from the contrary of that quality to the quality itself. It makes no difference whether the change be qualified or unqualified, except that in the former case the contraries will have to be contrary to one another only in a qualified sense, and a thing's possessing a quality in a greater or in a lesser degree means the presence or absence in it of more or less of the opposite quality. It is now clear, then, that there are only these three kinds of motion. The term immovable we apply in the first place to that which is absolutely incapable of being moved, just as we correspondingly applied the term invisible to sound, in the second place to that which is moved with difficulty after a long time or whose movement is slow at the start, in fact, what we describe as hard to move, and in the third place to that which is naturally designed for incapable of motion, but is not in motion when, where, and as it naturally would be so. This last is the only kind of immovable thing of which I use the term being at rest, for rest is contrary to motion, so that rest will be negation of motion in that which is capable of admitting motion. The foregoing remarks are sufficient to explain the essential nature of motion and rest, the number of kinds of change, and the different varieties of motion. Let us now proceed to define the terms together and apart, in contact, between, in succession, contiguous, and continuous, and to show in what circumstances each of these terms is naturally applicable. Things are said to be together in place when they are in one place, in the strictest sense of the word place, and to be apart when they are in different places. Things are said to be in contact when their extremities are together. That which a changing thing, if it changes continuously in a natural manner, naturally reaches before it reaches that to which it changes last, is between. Thus between implies the presence of at least three things, for in a process of change it is the contrary that is last, and a thing is moved continuously if it leaves no gap or only the smallest possible gap in the material, not in the time, for a gap in the time does not prevent things having a between, while, on the other hand, there is nothing to prevent the highest note sounding immediately after the lowest, but in the material in which the motion takes place. This is manifestly true not only in local changes but in every other kind as well. Now every change implies a pair of opposites, and opposites may be either contraries or contradictories. Since then contradiction admits of no mean term, it is obvious that between must imply a pair of contraries, that is locally contrary which is most distant in a straight line, for the shortest line is definitely limited, and that which is definitely limited constitutes a measure. A thing is in succession when it is after the beginning in position or in form or in some other respect in which it is definitely so regarded, and when further there is nothing of the same kind as itself between it and that to which it is in succession, for example a line or lines if it is a line, a unit or units if it is a unit, a house if it is a house, there is nothing to prevent something of a different kind being between. For that which is in succession to a particular thing, and is something posterior, for one is not in succession to two, nor is the first day of the month to be second, in each case the latter is in succession to the former. A thing that is in succession and touches is contiguous. The continuous is a subdivision of the contiguous. Things are called continuous when the touching limits of each become one and the same and are, as the word implies, contained in each other. Continuity is impossible if these extremities are two. This definition makes it plain that continuity belongs to things that naturally in virtue of their mutual contact form a unity. And in whatever way that which holds them together is one, so too will the whole be one, for example by a rivet or glue or contact or organic union. It is obvious that of these terms in succession is first in order of analysis, for that which touches is necessarily in succession, but not everything that is in succession touches, and so succession is a property of things prior in definition, for example numbers, while contact is not. And if there is continuity there is necessarily contact, but if there is contact, that alone does not imply continuity, for the extremities of things may be together without necessarily being one, but they cannot be one without being necessarily together. So natural junction is last in coming to be, for the extremities must necessarily come into contact if they are to be naturally joined, but things that are in contact are not all naturally joined. While there is no contact clearly there is no natural junction either. Hence, if as some say point and unit have an independent existence of their own, it is impossible for the two to be identical, for points can touch while units can only be in succession. Moreover, there can always be something between points, for all lines are intermediate between points, whereas it is not necessary that there should possibly be anything between units, for there can be nothing between the numbers 1 and 2. We have now defined what is meant by together and apart, contact, between and in succession, contiguous and continuous, and we have shown in what circumstances each of these terms is applicable. There are many senses in which motion is said to be one, for we use the term one in many senses. Motion is one generically according to the different categories to which it may be assigned, thus any locomotion is one generically with any other locomotion, whereas alteration is different generically from locomotion. Motion is one specifically when besides being one generically it also takes place in a species incapable of subdivision, for example color has specific differences, therefore blackening and whitening differ specifically. But at all events every whitening will be specifically the same with every other whitening and every blackening with every other blackening. But white is not further subdivided by specific differences, hence any whitening is specifically one with any other whitening. Where it happens that the genus is at the same time a species, it is clear that the motion will then in a sense be one specifically though not in an unqualified sense. Learning is an example of this, knowledge being on the one hand a species of apprehension and on the other hand a genus including the various knowledges. A difficulty, however, may be raised as to whether a motion is specifically one when the same thing changes from the same to the same, for example when one point changes again and again from a particular place to a particular place. If this motion is specifically one, circular motion will be the same as rectilinear motion, and rolling the same as walking. But is not this difficulty removed by the principle already laid down that if that in which the motion takes place is specifically different, as in the present instance the circular path is specifically different from the straight, the motion itself is also different? We have explained, then, what is meant by saying that motion is one generically or one specifically. Motion is one in an unqualified sense when it is one essentially or numerically, and the following distinctions will make clear what this kind of motion is. There are three classes of things in connection with which we speak of motion, the that which, the that in which, and the that during which. I mean that there must be something that is in motion, for example a man or gold, and it must be in motion in something, for example a place or an affection, and during something, for all motion takes place during a time. Of these three it is the thing in which the motion takes place that makes it one generically or specifically, it is the thing moved that makes the motion one in subject, and it is the time that makes it consecutive, but it is the three together that make it one without qualification. To effect this, that in which the motion takes place, the species, must be one and incapable of subdivision, that during which it takes place, the time, must be one and unintermittent, and that which is in motion must be one not in an accidental sense, that is it must be one as the white that blackens is one or Coriscus who walks is one, not in the accidental sense in which Coriscus and white may be one, nor merely in virtue of community of nature, for there might be a case of two men being restored to health at the same time in the same way, for example from inflammation of the eye, yet this motion is not really one, but only specifically one. Suppose, however, that Socrates undergoes an alteration specifically the same but at one time and again at another. In this case if it is possible for that which ceased to be again to come into being and remain numerically the same, then this motion too will be one, otherwise it will be the same but not one. And akin to this difficulty there is another, viz. Is health one? And generally are the states and affections in bodies severally one in essence, although, as is clear, the things that contain them are obviously in motion and in flux? Thus if a person's health at daybreak and at the present moment is one and the same, why should not this health be numerically one with that which he recovers after an interval? The same argument applies in each case. There is, however, we may answer, this difference, that if the states are two then it follows simply from this fact that the activities must also in point of number be two, for only that which is numerically one can give rise to an activity that is numerically one, but if the state is one, this is not in itself enough to make us regard the activity also as one, for when a man ceases walking, the walking no longer is, but it will again be if he begins to walk again. But, be this as it may, if in the above instance the health is one and the same, then it must be possible for that which is one and the same to come to be and to cease to be many times. However, these difficulties lie outside our present inquiry. Since every motion is continuous, a motion that is one in an unqualified sense must, since every motion is divisible, be continuous, and a continuous motion must be one. There will not be continuity between any motion and any other indiscriminately any more than there is between any two things chosen at random in any other sphere. There can be continuity only when the extremities of the two things are one. Now some things have no extremities at all, and the extremities of others differ specifically although we give them the same name of end. How should for example the end of a line and the end of walking touch or come to be one? Motions that are not the same either specifically or generically may, it is true, be consecutive. For example a man may run and then at once fall ill of a fever, and again, in the torch race we have consecutive but not continuous locomotion, for according to our definition there can be continuity only when the ends of the two things are one. Hence motions may be consecutive or successive in virtue of the time being continuous, but there can be continuity only in virtue of the motions themselves being continuous, that is when the end of each is one with the end of the other. Motion, therefore, that is in an unqualified sense continuous and one must be specifically the same, of one thing, and in one time. Unity is required in respect of time in order that there may be no interval of immobility, for where there is intermission of motion there must be rest, and a motion that includes intervals of rest will be not one but many, so that a motion that is interrupted by stationariness is not one or continuous, and it is so interrupted if there is an interval of time. And though of a motion that is not specifically one, even if the time is unintermittent, the time is one, the motion is specifically different, and so cannot really be one, for motion that is one must be specifically one, though motion that is specifically one is not necessarily one in an unqualified sense. We have now explained what we mean when we call a motion one without qualification. Further, a motion is also said to be one generically, specifically, or essentially when it is complete, just as in other cases completeness and wholeness are characteristics of what is one. And sometimes a motion even if incomplete is said to be one, provided only that it is continuous. And besides the cases already mentioned there is another in which a motion is said to be one, viz. When it is regular, for in a sense a motion that is irregular is not regarded as one, that title belonging rather to that which is regular, as a straight line is regular, the irregular being as such divisible. But the difference would seem to be one of degree. In every kind of motion we may have regularity or irregularity, thus there may be regular alteration and locomotion in a regular path, for example in a circle or on a straight line, and it is the same with regard to increase and decrease. The difference that makes a motion irregular is sometimes to be found in its path, Thus a motion cannot be regular if its path is an irregular magnitude, for example a broken line, a spiral, or any other magnitude that is not such that any part of it taken at random fits onto any other that may be chosen. Sometimes it is found neither in the place nor in the time nor in the goal but in the manner of the motion, for in some cases the motion is differentiated by quickness and slowness, thus if its velocity is uniform a motion is regular, if not it is irregular. So quickness and slowness are not species of motion nor do they constitute specific differences of motion, because this distinction occurs in connection with all the distinct species of motion. The same is true of heaviness and lightness when they refer to the same thing, for example they do not specifically distinguish earth from itself or fire from itself. Irregular motion, therefore, while in virtue of being continuous it is one, is so in a lesser degree, as is the case with locomotion in a broken line, and a lesser degree of something always means an admixture of its contrary. And since every motion that is one can be both regular and irregular, motions that are consecutive but not specifically the same cannot be one and continuous, for how should a motion composed of alteration and locomotion be regular? If a motion is to be regular its parts ought to fit one another. We have further to determine what motions are contrary to each other, and to determine similarly how it is with rest. And we have first to decide whether contrary motions are motions respectively from and to the same thing, for example a motion from health and a motion to health, where the opposition, it would seem, is of the same kind as that between coming to be and ceasing to be, or motions respectively from contraries, for example a motion from health and a motion from disease, or motions respectively to contraries, for example a motion to health and a motion to disease, or motions respectively from a contrary and to the opposite contrary, for example a motion from health and a motion to disease, or motions respectively from a contrary to the opposite contrary and from the latter to the former, for example a motion from health to disease and a motion from disease to health, for motions must be contrary to one another in one or more of these ways, as there is no other way in which they can be opposed. Now motions respectively from a contrary and to the opposite contrary, for example a motion from health and a motion to disease, and not contrary motions, for they are one and the same. Yet their essence is not the same, just as changing from health is different from changing to disease, nor are motion respectively from a contrary and from the opposite contrary motions, for a motion from a contrary is at the same time a motion to a contrary or to an intermediate. Of this, however, we shall speak later. But changing to a contrary rather than changing from a contrary would seem to be the cause of the contrariety of motions, the latter being the loss, the former the gain, of contrariness. Moreover, each several motion takes its name rather from the goal than from the starting point of change, for example motion to health we call convalescence, motion to disease sickening. Thus we are left with motions respectively to contraries, and motions respectively to contraries from the opposite contraries. Now it would seem that motions to contraries are at the same time motions from contraries, though their essence may not be the same. To health is distinct, I mean, from disease, and from health from to disease. Since then change differs from motion, motion being change from a particular subject to a particular subject, it follows that contrary motions are motions respectively from a contrary to the opposite contrary and from the latter to the former, for example a motion from health to disease and a motion from disease to health. Moreover, the consideration of particular examples will also show what kinds of processes are generally recognized as contrary. Thus falling ill is regarded as contrary to recovering one's health, these processes having contrary goals, and being taught as contrary to being led into error by another, it being possible to acquire error, like knowledge, either by one's own agency or by that of another. Similarly we have upward locomotion and downward locomotion, which are contrary lengthwise, locomotion to the right and locomotion to the left, which are contrary breadthwise, and forward locomotion and backward locomotion, which too are contraries. On the other hand, a process simply to a contrary, for example that denoted by the expression becoming white, where no starting point is specified, is a change but not a motion. And in all cases of a thing that has no contrary we have as contraries change from and change to the same thing. Thus coming to be is contrary to ceasing to be, and losing to gaining. But these are changes and not motions. And wherever a pair of contraries admit of an intermediate, motions to that intermediate must be held to be in a sense motions to one or other of the contraries, for the intermediate serves as a contrary for the purposes of the motion, in whichever direction the change may be. For example gray in a motion from gray to white takes the place of black as starting point, in a motion from white to gray it takes the place of black as goal, and in a motion from black to gray it takes the place of white as goal, for the middle is opposed in a sense to either of the extremes, as has been said above. Thus we see that two motions are contrary to each other only when one is a motion from a contrary to the opposite contrary and the other is a motion from the latter to the former. But since a motion appears to have contrary to it not only another motion but also a state of rest, we must determine how this is so. A motion has for its contrary in the strict sense of the term another motion, but it also has for an opposite a state of rest, for rest is the privation of motion and the privation of anything may be called its contrary, and motion of one kind has for its opposite rest of that kind, for example local motion has local rest. This statement, however, needs further qualification. There remains the question, is the opposite of remaining at a particular place motion from or motion to that place? It is surely clear that since there are two subjects between which motion takes place, motion from one of these, A, to its contrary, B, has for its opposite remaining in A while the reverse motion has for its opposite remaining in B. At the same time these two are also contrary to each other, for it would be absurd to suppose that there are contrary motions and not opposite states of rest. States of rest in contraries are opposed. To take an example, a state of rest in health is, 1, contrary to a state of rest in disease, and, 2, the motion to which it is contrary is that from health to disease. 4, 2, it would be absurd that its contrary motion should be that from disease to health, since motion to that in which a thing is at rest is rather a coming to rest, the coming to rest being found to come into being simultaneously with the motion, and one of these two motions it must be. And, 1, rest in whiteness is of course not contrary to rest in health. Of all things that have no contraries there are opposite changes, viz. Change from the thing and change to the thing, for example change from being and change to being, but no motion. So, 2, of such things there is no remaining though there is absence of change. Should there be a particular subject, absence of change in its being will be contrary to absence of change in its not being. And here a difficulty may be raised, if not being is not a particular something, what is it, it may be asked, that is contrary to absence of change in a thing's being? And is this absence of change a state of rest? If it is, then neither it is not true that every state of rest is contrary to emotion or else coming to be and ceasing to be a motion. It is clear then that, since we exclude these from among motions, we must not say that this absence of change is a state of rest, we must say that it is similar to a state of rest and call it absence of change. And it will have for its contrary either nothing or absence of change in the thing's not being, or the ceasing to be of the thing, for such ceasing to be is change from it and the thing's coming to be is change to it. Again, a further difficulty may be raised. How is it, it may be asked, that whereas in local change both remaining and moving may be natural or unnatural, in the other changes this is not so? For example alteration is not now natural and now unnatural, for convalescence is no more natural or unnatural than falling ill, whitening no more natural or unnatural than blackening, so, too, with increase and decrease. These are not contrary to each other in the sense that either of them is natural while the other is unnatural, nor is one increase contrary to another in this sense, and the same account may be given of becoming and perishing. It is not true that becoming is natural and perishing unnatural, for growing old is natural, nor do we observe one becoming to be natural and another unnatural. We answer that if what happens under violence is unnatural, then violent perishing is unnatural and as such contrary to natural perishing. Are there then also some becomings that are violent and not the result of natural necessity, and are therefore contrary to natural becomings, and violent increases and decreases, for example the rapid growth to maturity or profligates and the rapid ripening of seeds even when not packed close in the earth? And how is it with alterations? Surely just the same, we may say that some alterations are violent while others are natural, for example patients alter naturally or unnaturally according as they throw off fevers on the critical days or not. But, it may be objected, then we shall have perishings contrary to one another, not to becoming. Certainly, and why should not this in a sense be so? Thus it is so if one perishing is pleasant and another painful, and so one perishing will be contrary to another not in an unqualified sense, but in so far as one has this quality and the other that. Now motions and states of rest universally exhibit contrariety in the manner described above, for example upward motion and rest above are respectively contrary to downward motion and rest below. These being instances of local contrariety, and upward locomotion belongs naturally to fire and downward to earth, that is the locomotions of the two are contrary to each other. And again, fire moves up naturally and down unnaturally, and its natural motion is certainly contrary to its unnatural motion. Similarly with remaining above is contrary to motion from above downwards, and to earth this remaining comes unnaturally, this motion naturally. so the unnatural remaining of a thing is contrary to its natural motion, just as we find a similar contrariety in the motion of the same thing. One of its motions, the upward or the downward, will be natural, the other unnatural. Here, however, the question arises, has every state of rest that is not permanent a becoming, and is this becoming a coming to a standstill? If so, there must be a becoming of that which is at rest unnaturally, for example of earth at rest above, and therefore this earth during the time that it was being carried violently upward was coming to a standstill. But whereas the velocity of that which comes to a standstill seems always to increase, the velocity of that which is carried violently seems always to decrease, so it will he in a state of rest without having become so. Moreover, coming to a standstill is generally recognized to be identical or at least concomitant with the locomotion of a thing to its proper place. There is also another difficulty involved in the view that remaining in a particular place is contrary to motion from that place. For when a thing is moving from or discarding something, it still appears to have that which is being discarded, so that if a state of rest is itself contrary to the motion from the state of rest to its contrary, the contrary's rest and the motion will be simultaneously predicable of the same thing. May we not say, however, that in so far as the thing is still stationary it is in a state of rest in a qualified sense? For, in fact, whenever a thing is in motion, part of it is at the starting point while part is at the goal to which it is changing, and consequently a motion finds its true contrary rather in another motion than in a state of rest. With regard to motion and rest, then, we have now explained in what sense each of them is one and under what conditions they exhibit contrariety. With regard to coming to a standstill the question may be raised whether there is an opposite state of rest to unnatural as well as to natural motions. It would be absurd if this were not the case, for a thing may remain still merely under violence, thus we shall have a thing being in a non-permanent state of rest without having become so. But it is clear that it must be the case, for just as there is unnatural motion, so, too, a thing may be in an unnatural state of rest. Further, some things have a natural and an unnatural motion. For example, fire has a natural upward motion and an unnatural downward motion. Is it, then, this unnatural downward motion or is it the natural downward motion of earth that is contrary to the natural upward motion? Surely it is clear that both are contrary to it, though not in the same sense. The natural motion of earth is contrary inasmuch as the motion of fire is also natural, whereas the upward motion of fire as being natural is contrary to the downward motion of fire as being unnatural. The same is true of the corresponding cases of remaining. But there would seem to be a sense in which a state of rest and a motion are opposites. Physics, Book V, translated by R.P. Hardy and R.K.G. Now if the terms continuous, in contact, and in succession are understood as defined above, things being continuous if their extremities are one, in contact if their extremities are together, and in succession if there is nothing of their own kind intermediate between them, nothing that is continuous can be composed of indivisibles. For example, a line cannot be composed of points, the line being continuous and the point indivisible. For the extremities of 2 points can neither be one, since of an indivisible there can be no extremity as distinct from some other part, nor together, since that which has no parts can have no extremity. The extremity and the thing of which it is the extremity being distinct. Moreover, if that which is continuous is composed of points, these points must be either continuous or in contact with one another, and the same reasoning applies in the case of all indivisibles. Now for the reason given above they cannot be continuous, and one thing can be in contact with another only if whole is in contact with whole or part with whole. But since indivisibles have no parts, they must be in contact with one another as whole with whole. And if they are in contact with one another as whole with whole, they will not be continuous, for that which is continuous has distinct parts, and these parts into which it is divisible are different in this way, that is spatially separate. Nor, again, can a point be in succession to a point or a moment to a moment in such a way that length can be composed of points or time of moments, for things are in succession if there is nothing of their own kind intermediate between them, whereas that which is intermediate between points is always a line and that which is intermediate between moments is always a period of time. Again, if length and time could thus be composed of indivisibles, they could be divided into indivisibles, since each is divisible into the parts of which it is composed. But, as we saw, no continuous thing is divisible into things without parts. Nor can there be anything of any other kind intermediate between the parts or between the moments, for if there could be any such thing it is clear that it must be either indivisible or divisible, and if it is divisible, it must be divisible either into indivisibles or into divisibles that are infinitely divisible, in which case it is continuous. Moreover, it is plain that everything continuous is divisible into divisibles that are infinitely divisible, for if it were divisible into indivisibles, we should have an indivisible in contact with an indivisible, since the extremities of things that are continuous with one another are one and are in contact. The same reasoning applies equally to magnitude, to time, and to motion. Either all of these are composed of indivisibles and are divisible into indivisibles, or none. This may be made clear as follows. If a magnitude is composed of indivisibles, the motion over that magnitude must be composed of corresponding indivisible motions. For example, if the magnitude ABG is composed of the indivisibles A, B, G, each corresponding part of the motions of O over ABG is indivisible. Therefore, since where there is motion there must be something that is in motion, and where there is something in motion there must be motion, therefore the being moved will also be composed of indivisibles. So O traversed A when its motion was D, B when its motion was E, and G similarly when its motion was Z. Now a thing that is in motion from one place to another cannot at the moment when it was in motion both be in motion and at the same time have completed its motion at the place to which it was in motion. For example, if a man is walking to Thebes, he cannot be walking to Thebes and at the same time have completed his walk to Thebes, and, as we saw, O traverses the partless section A in virtue of the presence of the motion D. Consequently, if O actually passed through A after being in process of passing through, the motion must be divisible, for at the time when O was passing through, it neither was at rest nor had completed its passage but was in an intermediate state, while if it is passing through and has completed its passage at the same moment, then that which is walking will at the moment when it is walking have completed its walk and will be in the place to which it is walking, that is to say, it will have completed its motion at the place to which it is in motion. And if a thing is in motion over the whole KBG and its motion is the 3D, E, and Z, and if it is not in motion at all over the partless section A but has completed its motion over it, then the motion will consist not of motions but of starts, and will take place by a thing's having completed a motion without being in motion, for on this assumption it has completed its passage through A without passing through it. So it will be possible for a thing to have completed a walk without ever walking, for on this assumption it has completed a walk over a particular distance without walking over that distance. Since, then, everything must be either at rest or in motion, and O is therefore at rest in each of the sections A, B, and G, it follows that a thing can be continuously at rest and at the same time in motion, for, as we saw, O is in motion over the whole ABG and at rest in any part, and consequently in the whole of it. Moreover, if the indivisibles composing ts are motions, it would be possible for a thing in spite of the presence in it of motion to be not in motion but at rest, while if they are not motions, it would be possible for motion to be composed of something other than motions. And if length and motion are thus indivisible, it is neither more nor less necessary that time also be similarly indivisible, that is to say be composed of indivisible moments, for if the whole distance is divisible and an equal velocity will cause a thing to pass through less of it in less time, the time must also be divisible, and conversely, if the time in which a thing is carried over the section A is divisible, this section A must also be divisible. And since every magnitude is divisible into magnitudes, for we have shown that it is impossible for anything continuous to be composed of indivisible parts, and every magnitude is continuous, it necessarily follows that the quicker of two things traverses a greater magnitude in an equal time, an equal magnitude in less time, and a greater magnitude in less time, in conformity with the definition sometimes given of the quicker. Suppose that A is quicker than B. Now since of two things that which changes sooner is quicker, in the time ZH, in which A has changed from G to D, B will not yet have arrived at D but will be short of it, so that in an equal time the quicker will pass over a greater magnitude. More than this, it will pass over a greater magnitude in less time, for in the time in which A has arrived at D, B being the slower has arrived, let us say, at E. Then since A has occupied the whole time ZH in arriving at D, will have arrived at O in less time than this, say ZK. Now the magnitude Go that A has passed over is greater than the magnitude Ch, and the time ZK is less than the whole time ZH, so that the quicker will pass over a greater magnitude in less time. And from this it is also clear that the quicker will pass over an equal magnitude in less time than the slower. For since it passes over the greater magnitude in less time than the slower, and, regarded by itself, passes over Lm the greater in more time than Lx the lesser, the time PRH in which it passes over Lm will be more than the time PS, which it passes over Lx, so that, the time PRH being less than the time PCH in which the slower passes over Lx, the time PS will also be less than the time PX, for it is less than the time PRH, and that which is less than something else that is less than a thing is also itself less than that thing. Hence it follows that the quicker will traverse an equal magnitude in less time than the slower. Again, since the motion of anything must always occupy either an equal time or less or more time in comparison with that of another thing, and since, whereas a thing is slower if its motion occupies more time and of equal velocity if its motion occupies an equal time, the quicker is neither of equal velocity nor slower, it follows that the motion of the quicker can occupy neither an equal time nor more time. It can only be, then, that it occupies less time, and thus we get the necessary consequence that the quicker will pass over an equal magnitude, as well as a greater, in less time than the slower. And since every motion is in time and a motion may occupy any time, and the motion of everything that is in motion may be either quicker or slower, both quicker motion and slower motion may occupy any time, and this being so, it necessarily follows that time also is continuous. By continuous I mean that which is divisible into divisibles that are infinitely divisible, and if we take this as the definition of continuous, it follows necessarily that time is continuous. For since it has been shown that the quicker will pass over an equal magnitude in less time than the slower, suppose that A is quicker and B slower, and that the slower has traversed the magnitude GD in the time ZH. Now it is clear that the quicker will traverse the same magnitude in less time than this, let us say in the time ZO. Again, since the quicker has passed over the whole d in the time ZO, the slower will in the same time pass over GK, say, which is less than GD. And since B, the slower, has passed over GK in the time ZO, the quicker will pass over it in less time, so that the time ZO will again be divided. And if this is divided, the magnitude GK will also be divided just as GD was, and again, if the magnitude is divided, the time will also be divided. And we can carry on this process forever, taking the slower after the quicker and the quicker after the slower alternately, and using what has been demonstrated at each stage as a new point of departure, for the quicker will divide the time and the slower will divide the length. If, then, this alternation always holds good, and at every turn involves a division, it is evident that all time must be continuous. And at the same time it is clear that all magnitude is also continuous, for the divisions of which time and magnitude respectively are susceptible are the same and equal. Moreover, the current popular arguments make it plain that, if time is continuous, magnitude is continuous also, inasmuch as a thing passes over half a given magnitude in half the time taken to cover the whole. In fact, without qualification it passes over a less magnitude in less time, for the divisions of time and of magnitude will be the same. And if either is infinite, so is the other, and the one is so in the same way as the other, that is if time is infinite in respect of its extremities, length is also infinite in respect of its extremities. If time is infinite in respect of divisibility, length is also infinite in respect of divisibility, and if time is infinite in both respects, magnitude is also infinite in both respects. Hence Zeno's argument makes a false assumption in asserting that it is impossible for a thing to pass over or severally to come in contact with infinite things in the finite time. For there are two senses in which length and time and generally anything continuous are called infinite. They are called so either in respect of divisibility or in respect of their extremities. So while a thing in a finite time cannot come in contact with things quantitatively infinite, it can come in contact with things infinite in respect of divisibility, for in this sense the time itself is also infinite, and so we find that the time occupied by the passage over the infinite is not a finite but an infinite time, and the contact with the infinites is made by means of moments not finite but infinite in number. The passage over the infinite, then, cannot occupy a finite time, and the passage over the finite cannot occupy an infinite time. If the time is infinite the magnitude must be infinite also, and if the magnitude is infinite, so also is the time. This may be shown as follows. Let AB be a finite magnitude, and let us suppose that it is traversed in infinite time g, and let a finite period gd of the time be taken. Now in this period the thing in motion will pass over a certain segment of the magnitude, let v be the segment that it has thus passed over. This will be either an exact measure of AB or less or greater than an exact measure, it makes no difference which it is. Then, since a magnitude equal to B will always be passed over in an equal time, and B measures the whole magnitude, the whole time occupied in passing over AB will be finite, for it will be divisible into periods equal in number to the segments into which the magnitude is divisible. Moreover, if it is the case that infinite time is not occupied in passing over every magnitude, but it is possible to pass over some magnitude, say B, in a finite time, and if this B measures the whole of which it is a part, and if an equal magnitude is passed over in an equal time, then it follows that the time like the magnitude is finite. That infinite time will not be occupied in passing over B is evident if the time be taken as limited in one direction, for as the part will be passed over in less time than the whole, the time occupied in traversing this part must be finite, the limit in one direction being given. The same reasoning will also show the falsity of the assumption that infinite length can be traversed in a finite time. It is evident, then, from what has been said that neither a line nor a surface nor in fact anything continuous can be indivisible. This conclusion follows not only from the present argument but from the consideration that the opposite assumption implies the divisibility of the indivisible. For since the distinction of quicker and slower may apply to motions occupying any period of time and in an equal time the quicker passes over a greater length, it may happen that it will pass over a length twice, or 1.5 times, as great as that passed over by the slower, for their respective velocities may stand to one another in this proportion. Suppose, then, that the quicker has in the same time been carried over a length 1.5 times as great as that traversed by the slower, and that the respective magnitudes are divided, that of the quicker, the magnitude ABGD, into 3 indivisibles, and that of the slower into the 2 indivisibles as ZH. Then the time may also be divided into 3 indivisibles, for an equal magnitude will be passed over an unequal time. Suppose then that it is thus divided into KL, LM, MN. Again, since in the same time the slower has been carried over as ZH, the time may also be similarly divided into 2. Thus the indivisible will be divisible, and that which has no parts will be passed over not in an indivisible but in a greater time. It is evident, therefore, that nothing continuous is without parts. The present also is necessarily indivisible. The present, that is, not in the sense in which the word is applied to one thing in virtue of another, but in its proper and primary sense, in which sense it is inherent in all time. For the present is something that is an extremity of the past, no part of the future being on this side of it, and also of the future, no part of the past being on the other side of it. It is, as we have said, a limit of both. And if it is once shown that it is essentially of this character and one and the same, it will at once be evident also that it is indivisible. Now the present that is the extremity of both times must be one and the same, for if each extremity were different, the one could not be in succession to the other, because nothing continuous can be composed of things having no parts, and if the one is apart from the other, there will be time intermediate between them, because everything continuous is such that there is something intermediate between its limits and described by the same name as itself. But if the intermediate thing is time, it will be divisible, for all time has been shown to be divisible. Thus on this assumption the present is divisible. But if the present is divisible, there will be part of the past in the future and part of the future in the past, for past time will be marked off from future time at the actual point of division. Also the present will be a present not in the proper sense but in virtue of something else, for the division which yields it will not be a division proper. Furthermore, there will be a part of the present that is past and a part that is future, and it will not always be the same part that is past or future. In fact, one and the same present will not be simultaneous, for the time may be divided at many points. If, therefore, the present cannot possibly have these characteristics, it follows that it must be the same present that belongs to each of the 2 times. But if this is so, it is evident that the present is also indivisible, for if it is divisible it will be involved in the same implications as before. It is clear, then, from what has been said that time contains something indivisible, and this is what we call a present. We will now show that nothing can be in motion in a present. For if this is possible, there can be both quicker and slower motion in the present. Suppose then that in the present and the quicker has traversed the distance ab. That being so, the slower will in the same present traverse a distance less than ab, say ag. But since the slower will have occupied the whole present in traversing ag, the quicker will occupy less than this in traversing it. Thus we shall have a division of the present, whereas we found it to be indivisible. It is impossible, therefore, for anything to be in motion in a present, nor can anything be at rest in a present, for, as we were saying, only can be at rest which is naturally designed to be in motion but is not in motion when, where, or as it would naturally be so, since, therefore, nothing is naturally designed to be in motion in a present, it is clear that nothing can be at rest in a present either. Moreover, inasmuch as it is the same present that belongs to both the times, and it is possible for a thing to be in motion throughout one time and to be at rest throughout the other, and that which is in motion or at rest for the whole of a time will be in motion or at rest as the case may be in any part of it in which it is naturally designed to be in motion or at rest. This being so, the assumption that there can be motion or rest in a present will carry with it the implication that the same thing can at the same time be at rest and in motion, for both the times have the same extremity, viz. the present. Again, when we say that a thing is at rest, we imply that its condition in whole and in part is at the time of speaking uniform with what it was previously, but the present contains no previously, consequently, there can be no rest in it. It follows then that the motion of that which is in motion and the rest of that which is at rest must occupy time. Further, everything that changes must be divisible. For since every change is from something to something, and when a thing is at the goal of its change it is no longer changing, and when both it itself and all its parts are at the starting point of its change it is not changing, for that which is in whole and in part in an unvarying condition is not in a state of change. It follows, therefore, that part of that which is changing must be at the starting point and part at the goal, for as a whole it cannot be in both or in neither. Here by goal of change I mean that which comes first in the process of change. For example, in a process of change from white the goal in question will be gray, not black, for it is not necessary that that which is changing should be at either of the extremes. It is evident, therefore, that everything that changes must be divisible. Now motion is divisible in two senses. In the first place it is divisible in virtue of the time that it occupies. In the second place it is divisible according to the motions of the several parts of that which is in motion. For example, if the whole AG is in motion, there will be a motion of AB and a motion of BG. That being so, let D be the motion of the part AB and S the motion of the part BG. Then the whole DZ must be the motion of AG, for DZ must constitute the motion of AG inasmuch as D and S severally constitute the motions of each of its parts. But the motion of a thing can never be constituted by the motion of something else, consequently the whole motion is the motion of the whole magnitude. Again, since every motion is a motion of something, and the whole motion dz is not the motion of either of the parts, for each of the parts d, as is the motion of one of the parts ab, bg, or of anything else, for, the whole motion being the motion of a whole, the parts of the motion are the motions of the parts of that whole, and the parts of dz are the motions of ab, bg and of nothing else, for, as we saw, a motion that is one cannot be the motion of more things than one. Since this is so, the whole motion will be the motion of the magnitude abg. Again, if there is a motion of the whole other than dz, say that the of each of the arts may be subtracted from it, and these motions will be equal to d, as respectively, for the motion of that which is one must be one. So if the whole motion I may be divided into the motions of the parts, I will be equal to dz. If on the other hand there is any remainder, say k, this will be a motion of nothing, for it can be the motion neither of the whole nor of the parts, as the motion of that which is one must be one, nor of anything else, for a motion that is continuous must be the motion of things that are continuous. And the same result follows if the division of I reveals a surplus on the side of the motions of the parts. Consequently, if this is impossible, the whole motion must be the same as and equal to dz. This then is what is meant by the division of motion according to the motions of the parts, and it must be applicable to everything that is divisible into parts. Motion is also susceptible of another kind of division, that according to time. For since all motion is in time and all time is divisible, and in less time the motion is less, it follows that every motion must be divisible according to time. And since everything that is in motion in a certain sphere and for a certain time and has a motion belonging to it, it follows that the time, the motion, the being in motion, the thing that is in motion, and the sphere of the motion must all be susceptible of the same divisions. Those spheres of motion are not all divisible in a like manner, thus quantity is essentially, quality accidentally divisible. For suppose that A is the time occupied by the motion B. Then if all the time has been occupied by the whole motion, it will take less of the motion to occupy half the time, less again to occupy further subdivision of the time, and so on to infinity. Again, the time will be divisible similarly to the motion, for if the whole motion occupies all the time half the motion will occupy half the time, and less of the motion again will occupy less of the time. In the same way the being in motion will also be divisible. For let G be the whole being in motion. Then the being in motion that corresponds to half the motion will be less than the whole being in motion, that which corresponds to a quarter of the motion will be less again, and so on to infinity. Moreover, by setting out successively the being in motion corresponding to each of the two motions dg, say, and j, we may argue that the whole being in motion will correspond to the whole motion, for if it were some other being in motion that corresponded to the whole motion, there would be more than one being in motion corresponding to the same motion, the argument being the same as that whereby we showed that the motion of a thing is divisible into the motions of the parts of the thing, for if we take separately the being in motion corresponding to each of the two motions, we shall see that the whole being in motion is continuous. The same reasoning will show the divisibility of the length, and in fact of everything that forms a sphere of change, though some of these are only accidentally divisible because that which changes is so, for the division of one term will involve the division of all. So, too, In the matter of their being finite or infinite, they will all alike be either the one or the other. And we now see that in most cases the fact that all the terms are divisible or infinite is a direct consequence of the fact that the thing that changes is divisible or infinite, for the attributes divisible and infinite belong in the first instance to the thing that changes. That divisibility does so we have already shown, that infinity does so will be made clear in what follows. Since everything that changes changes from something to something, that which has changed must at the moment when it has first changed be in that to which it has changed. For that which changes retires from or leaves that from which it changes, and leaving, if not identical with changing, is at any rate a consequence of it. And if leaving is a consequence of changing, having left is a consequence of having changed, for there is a like relation between the two in each case. One kind of change, then, being change in a relation of contradiction, where a thing has changed from not being to being it has left not being. Therefore it will be in being, for everything must either be or not be. It is evident, then, that in contradictory change that which has changed must be in that to which it has changed. And if this is true in this kind of change, it will be true in all other kinds as well, for in this matter what holds good in the case of one will hold good likewise in the case of the rest. Moreover, if we take each kind of change separately, the truth of our conclusion will be equally evident, on the ground that that which has changed must be somewhere or in something. For, since it has left that from which it has changed and must be somewhere, it must be either in that to which it has changed or in something else. If, then, that which has changed to B is in something other than B, say G, it must again be changing from G to B, for it cannot be assumed that there is no interval between G and B, since change is continuous. Thus we have the result that the thing that has changed, at the moment when it has changed, is changing to that to which it has changed, which is impossible. That which has changed, therefore, must be in that to which it has changed. So it is evident likewise that which has come to be, at the moment when it has come to be, will be. And that which has ceased to be will not be, for what we have said applies universally to every kind of change, and its truth is most obvious in the case of contradictory change. It is clear, then, that which has changed, at the moment when it has first changed, is in that to which it has changed. We will now show that the primary when in which that which has changed effected the completion of its change must be indivisible, where by primary I mean possessing the characteristics in question of itself and not in virtue of the possession of them by something else belonging to it. For let AG be divisible, and let it be divided at B. If then the completion of change has been effected in AB or again in BG, AG cannot be the primary thing in which the completion of change has been effected. If, on the other hand, it has been changing in both AB and BG, for it must either have changed or be changing in each of them, it must have been changing in the whole AG, but our assumption was that AG contains only the completion of the change. It is equally impossible to suppose that one part of AG contains the process and the other the completion of the change, for then we shall have something prior to what is primary. So that in which the completion of change has been effected must be indivisible. It is also evident, therefore, that in which that which has ceased to be and that in which that which has come to be are indivisible. But there are two senses of the expression the primary when in which something has changed. On the one hand it may mean the primary when containing the completion of the process of change the moment when it is correct to say it has changed, on the other hand it may mean the primary when containing the beginning of the process of change. Now the primary when that has reference to the end of the change is something really existent, for a change may really be completed, and there is such a thing as an end of change, which we have in fact shown to be indivisible because it is a limit. But that which has reference to the beginning is not existent at all, for there is no such thing as a beginning of a process of change, and the time occupied by the change does not contain any primary when in which the change began. For suppose that AD is such a primary when. Then it cannot be indivisible, for, if it were, the moment immediately preceding the change in the moment in which the change begins would be consecutive, and moments cannot be consecutive. Again, if the changing thing is at rest in the whole preceding time Ga, for we may suppose that it is at rest in A also, so if AD is without parts, it will simultaneously be at rest and have changed, for it is at rest in A and has changed in D. Since then AD is not without parts, it must be divisible, and the changing thing must have changed in every part of it, for if it has changed in neither of the two parts into which AD is divided, it has not changed in the whole either. If, on the other hand, it is in process of change in both parts, it is likewise in process of change in the whole. And if, again, it has changed in one of the two parts, the whole is not the primary when in which it has changed, it must therefore have changed in every part. It is evident, then, that with reference to the beginning of change there is no primary when in which change has been effected, for the divisions are infinite. So, too, of that which has changed there is no primary part that has changed. For suppose that of E the primary part that has changed is as, everything that changes having been shown to be divisible, and let I be the time in which dz has changed. If, then, in the whole time dz has changed, in half the time there will be a part that has changed, less than and therefore prior to dz, and again there will be another part prior to this, and yet another, and so on to infinity. Thus of that which changes there cannot be any primary part that has changed. It is evident, then, from what has been said, that neither of that which changes nor of the time in which it changes is there any primary part. With regard, however, to the actual subject of change, that is to say that in respect of which a thing changes there is a difference to be observed. For in a process of change we may distinguish three terms: that which changes, that in which it changes, and the actual subject of change, for example the man, the time, and the fair complexion. Of these the man and the time are divisible, but with the fair complexion it is otherwise, though they are all divisible accidentally, for that in which the fair complexion or any other quality is an accident is divisible. For of actual subjects of change it will be seen that those which are classed as essentially, not accidentally, divisible have no primary part. Take the case of magnitudes. Let A be a magnitude, and suppose that it has moved from B to a primary where G. Then if BG is taken to be indivisible, two things without parts will have to be contiguous, which is impossible. If on the other hand it is taken to be divisible, there will be something prior to G to which the magnitude has changed, and something else again prior to that, and so on to infinity, because the process of division may be continued without end. Thus there can be no primary where to which a thing has changed. And if we take the case of quantitative change, we shall get a like result, for here too the change is in something continuous. It is evident, then, that only in qualitative motion can there be anything essentially indivisible. Now everything that changes time, and that in two senses, for the time in which a thing is said to change may be the primary time, or on the other hand it may have an extended reference, as for example when we say that a thing changes in a particular year because it changes in a particular day. That being so, that which changes must be changing in any part of the primary time in which it changes. This is clear from our definition of primary, in which the word is said to express just this. It may also, however, be made evident by the following argument. Let CHRH be the primary time in which that which is in motion, and, as all time is divisible, let it be divided at k. Now in the time CHK it either is in motion or is not in motion, and the same is likewise true of the time KRH. Then if it is in motion in neither of the two parts, it will be at rest in the whole, for it is impossible that it should be in motion in a time in no part of which it is in motion. If on the other hand it is in motion in only one of the two parts of the time, CHRH cannot be the primary time in which it is in motion, for its motion will have reference to a time other than CHRH. It must, then, have been in motion in any part of CHRH. And now that this has been proved, it is evident that everything that is in motion must have been in motion before. For if that which is in motion has traversed the distance KL in the primary time CHRH, in half the time a thing that is in motion with equal velocity and began its motion at the same time will have traversed half the distance. But if this second thing whose velocity is equal has traversed a certain distance in a certain time, the original thing that is in motion must have traversed the same distance in the same time. Hence that which is in motion must have been in motion before. Again, if by taking the extreme moment of the time, for it is the moment that defines the time, and time is that which is intermediate between moments, we are enabled to say that motion has taken place in the whole time CHRH, or in fact in any period of it. Motion may likewise be said to have taken place in every other such period. But half the time finds an extreme in the point of division. Therefore motion will have taken place in half the time and in fact in any part of it, for as soon as any division is made there is always a time defined by moments. If, then, all time is divisible, and that which is intermediate between moments is time, everything that is changing must have completed an infinite number of changes. Again, since a thing that changes continuously and has not perished or ceased from its change must either be changing or have changed in any part of the time of its change, and since it cannot be changing in a moment, it follows that it must have changed at every moment in the time. Consequently, since the moments are infinite in number, everything that is changing must have completed an infinite number of changes. And not only must that which is changing have changed, but that which has changed must also previously have been changing, since everything that has changed from something to something has changed in a period of time. For suppose that a thing has changed from A to B in a moment. Now the moment in which it has changed cannot be the same as that in which it is at A, since in that case it would be in A and B at once, for we have shown above that which has changed, when it has changed, is not in that from which it has changed. If, on the other hand, it is a different moment, there will be a period of time intermediate between the two, for, as we saw, moments are not consecutive. Since, then, it has changed in a period of time, and all time is divisible, in half the time it will have completed another change, in a quarter another, and so on to infinity. Consequently, when it has changed, it must have previously been changing. Moreover, the truth of what has been said is more evident in the case of magnitude, because the magnitude over which what is changing changes is continuous. For suppose that a thing has changed from G to D. Then if GD is indivisible, two things without parts will be consecutive. But since this is impossible, that which is intermediate between them must be a magnitude and divisible into an infinite number of segments. Consequently, before the change is completed, the thing changes to those segments. Everything that has changed, therefore, must previously have been changing, for the same proof also holds good of change with respect to what is not continuous, changes, that is to say, between contraries and between contradictories. In such cases we have only to take the time in which a thing has changed and again apply the same reasoning. So that which has changed must have been changing and that which is changing must have changed, and a process of change is preceded by a completion of change and a completion by a process, and we can never take any stage and say that it is absolutely the first. The reason of this is that no two things without parts can be contiguous, and therefore in change the process of division is infinite, just as lines may be infinitely divided so that one part is continually increasing and the other continually decreasing. So it is evident also that which has become must previously have been in process of becoming, and that which is in process of becoming must previously have become. Everything, that is divisible and continuous, though it is not always the actual thing that is in process of becoming of which this is true, sometimes it is something else, that is to say, some part of the thing in question, for example the foundation stone of a house. So, too, in the case of that which is perishing and that which has perished, for that which becomes and that which perishes must contain an element of infiniteness as an immediate consequence of the fact that they are continuous things, and so a thing cannot be in process of becoming without having become or have become without having been in process of becoming. So, too, in the case of perishing and having perished, perishing must be preceded by having perished, and having perished must be preceded by perishing. It is evident, then, that which has become must previously have been in process of becoming, and that which is in process of becoming must previously have become, for all magnitudes and all periods of time are infinitely divisible. Consequently no absolutely first stage of change can be represented by any particular part of space or time which the changing thing may occupy. Now since the motion of everything that is in motion occupies a period of time, and a greater magnitude is traversed in a longer time, it is impossible that a thing should undergo a finite motion in an infinite time, if this is understood to mean not that the same motion or a part of it is continually repeated, but that the whole infinite time is occupied by the whole finite motion. In all cases where a thing is in motion with uniform velocity it is clear that the finite magnitude is traversed in a finite time. For if we take a part of the motion which shall be a measure of the whole motion is completed in as many equal periods of the time as there are parts of the motion. Consequently, since these parts are finite, both in size individually and in number collectively, the whole time must also be finite, for it will be a multiple of the portion, equal to the time occupied in completing the aforesaid part multiplied by the number of the parts. But it makes no difference even if the velocity is not uniform. For let us suppose that the line AB represents a finite stretch over which a thing has been moved in the given time, and let GD be the infinite time. Now if one part of the stretch must have been traversed before another part, this is clear, that in the earlier and in the later part of the time a different part of the stretch has been traversed, for as the time lengthens a different part of the motion will always be completed in it, whether the thing in motion changes with uniform velocity or not, and whether the rate of motion increases or diminishes or remains stationary this is none the less so. Let us then take a part of the whole stretch of motion AB which shall be a measure of AB. Now this part of the motion occupies a certain period of the infinite time, it cannot itself occupy an infinite time, for we are assuming that is occupied by the whole AB. And if again I take another part equal to E, that also must occupy a finite time in consequence of the same assumption. And if I go on taking parts in this way, on the one hand there is no part which will be a measure of the infinite time, for the infinite cannot be composed of finite parts whether equal or unequal, because there must be some unity which will be a measure of things finite in multitude or in magnitude, which, whether they are equal or unequal, are nonetheless limited in magnitude, while on the other hand the finite stretch of motion ab is a certain multiple of e, consequently the motion ab must be accomplished in a finite time. Moreover, it is the same with coming to rest as with motion. And so it is impossible for one and the same thing to be infinitely in process of becoming or of perishing. The reasoning he will prove that in a finite time there cannot be an infinite extent of motion or of coming to rest, whether the motion is regular or irregular. For if we take a part which shall be a measure of the whole time, in this part a certain fraction, not the whole, of the magnitude will be traversed, because we assume that the traversing of the whole occupies all the time. Again, in another equal part of the time another part of the magnitude will be traversed, and similarly in each part of the time that we take, whether equal or unequal to the part originally taken. It makes no difference whether the parts are equal or not, if only each is finite, for it is clear that while the time is exhausted by the subtraction of its parts, the infinite magnitude will not be thus exhausted, since the process of subtraction is finite both in respect of the quantity subtracted and of the number of times a subtraction is made. Consequently the infinite magnitude will not be traversed in finite time, and it makes no difference whether the magnitude is infinite in only one direction or in both, for the same reasoning will hold good. This having been proved, it is evident that neither can a finite magnitude traverse an infinite magnitude in a finite time. The reason being the same as that given above, in part of the time it will traverse a finite magnitude and in each several part likewise, so that in the whole time it will traverse a finite magnitude. And since a finite magnitude will not traverse an infinite in a finite time, it is clear that neither will an infinite traverse a finite in the finite time. For if the infinite could traverse the finite could traverse the infinite, for it makes no difference which of the two is the thing in motion, either case involves the traversing of the infinite by the finite. For when the infinite magnitude A is in motion a part of it, say GD, will occupy the finite and then another, and so on to infinity. Thus the two results will coincide, the infinite will have completed a motion over the finite and the finite will have traversed the infinite, for it would seem to be impossible for the motion of the infinite over the finite to occur in any way other than by the finite traversing the infinite either by locomotion over it or by measuring it. Therefore, since this is impossible, the infinite cannot traverse the finite, nor again will the infinite traverse the infinite in a finite time. Otherwise it would also traverse the finite, for the infinite includes the finite. We can further prove this in the same way by taking the time as our starting point, since, then, it is established that in a finite time neither will the finite traverse the infinite, nor the infinite the finite, nor the infinite. It is evident also that in a finite time there cannot be infinite motion, for what difference does it make whether we take the motion or the magnitude to be infinite? If either of the two is infinite, the other must be so likewise, for all locomotion is in space, since everything to which motion or rest is natural is in motion or at rest in the natural time, place, and manner, that which is coming to a stand, when it is coming to a stand, must be in motion, for if it is not in motion it must be at rest, but that which is at rest cannot be coming to rest. From this it evidently follows that coming to a stand must occupy a period of time, for the motion of that which is in motion occupies a period of time, and that which is coming to a stand has been shown to be in motion, consequently coming to a stand must occupy a period of time. Again, since the terms quicker and slower are used only of that which occupies a period of time, and the process of coming to a stand may be quicker or slower, the same conclusion follows. And that which is coming to a stand must be coming to a stand in any part of the primary time in which it is coming to a stand. For if it is coming to a stand in neither of two parts into which the time may be divided, it cannot be coming to a stand in the whole time, with the result that that which is coming to a stand will not be coming to a stand. If on the other hand it is coming to a stand in only one of the two parts of the time, the whole cannot be the primary time in which it is coming to a stand, for it is coming to a stand in the whole time not primarily but in virtue of something distinct from itself, the argument being the same as that which we used above about things in motion. And just as there is no primary time in which that which is in motion, so too there is no primary time in which that which is coming to a stand is coming to a stand, there being no primary stage either of being in motion or of coming to a stand. For let ab be the primary time in which a thing is coming to a stand. Now ab cannot be without parts, for there cannot be motion in that which is without parts, because the moving thing would necessarily have been already moved for part of the time of its movement, and that which is coming to a stand has been shown to be in motion. But since ab is therefore divisible, The thing is coming to a stand in every one of the parts of AB, for we have shown above that it is coming to a stand in every one of the parts in which it is primarily coming to a stand. Since then, that in which primarily a thing is coming to a stand must be a period of time and not something indivisible, and since all time is infinitely divisible, there cannot be anything in which primarily it is coming to a stand. Nor again can there be a primary time at which the being at rest of that which is at rest occurred, for it cannot have occurred in that which has no parts, because there cannot be motion in that which is indivisible, and that in which rest takes place is the same as that in which motion takes place, for we defined a state of rest to be the state of a thing to which motion is natural but which is not in motion when, that is to say in that in which, motion would be natural to it. Again, our use of the phrase being at rest also implies that the previous state of a thing is still unaltered, not one point only but two at least being thus needed to determine its presence, consequently that in which a thing is at rest cannot be without parts. Since, then it is divisible, it must be a period of time, and the thing must be at rest in every one of its parts, as may be shown by the same method as that used above in similar demonstrations. So there can be no primary part of the time, and the reason is that rest and the motion are always in a period of time, and a period of time has no primary part any more than a magnitude or in fact anything continuous, for everything continuous is divisible into an infinite number of parts. And since everything that is in motion in a period of time and changes from something to something, when its motion is comprised within a particular period of time essentially that is to say when it fills the whole and not merely a part of the time in question, it is impossible that in that time that which is in motion should be over against some particular thing primarily. For if a thing itself and each of its parts occupies the same space for a definite period of time, it is at rest. For it is in just these circumstances that we use the term being at rest when at one moment after another it can be said with truth that a thing, itself and its parts, occupies the same space. So if this is being at rest it is impossible for that which is changing to be as a whole, at the time when it is primarily changing, over against any particular thing, for the whole period of time is divisible, so that in one part of it after another it will be true to say that the thing, itself and its parts, occupies the same space. If this is not so and the aforesaid proposition is true only at a single moment, then the thing will be over against a particular thing not for any period of time but only at a moment that limits the time. It is true that at any moment it is always over against something stationary, but it is not at rest, for at a moment it is not possible for anything to be either in motion or at rest. So while it is true to say that that which is in motion is at a moment not in motion and is opposite some particular thing, it cannot in a period of time be over against that which is at rest, for that would involve the conclusion that that which is in locomotion is at rest. Zeno's reasoning, however, is fallacious, when he says that if everything when it occupies an equal space is at rest, and if that which is in locomotion is always occupying such a space at any moment, the flying arrow is therefore motionless. This is false, for time is not composed of indivisible moments any more than any other magnitude is composed of indivisibles. Zeno's arguments about motion, which cause so much disquietude to those who try to solve the problems that they present, are four in number. The first asserts the non-existence of motion on the ground that that which is in locomotion must arrive at the halfway stage before it arrives at the goal. This we have discussed above. The second is the so-called Achilles, and it amounts to this, that in a race the quickest runner can never overtake the slowest, since the pursuer must first reach the point whence the pursued started, so that the slower must always hold the lead. This argument is the same in principle as that which depends on bisection, though it differs from it in that the spaces with which we successively have to deal are not divided into halves. The result of the argument is that the slower is not overtaken, but it proceeds along the same lines as the bisection argument, for in both the division of the space in a certain way leads to the result that the goal is not reached, though the Achilles goes further in that it affirms that even the quickest runner in legendary tradition must fail in his pursuit of the slowest, so that the solution must be the same. And the axiom that that which holds a lead is never overtaken is false. It is not overtaken, it is true, while it holds a lead, but it is overtaken nevertheless if it is granted that it traverses the finite distance prescribed. These then are two of his arguments. The third is that already given above, to the effect that the flying arrow is at rest, which result follows from the assumption that time is composed of moments. If this assumption is not granted, the conclusion will not follow. The fourth argument is that concerning the two rows of bodies, each row being composed of an equal number of bodies of equal size, passing each other on a racecourse as they proceed with equal velocity in opposite directions, the one row originally occupying the space between the goal and the middle point of the course and the other that between the middle point and the starting post. This, he thinks, involves the conclusion that half a given time is equal to double that time. The fallacy of the reasoning lies in the assumption that a body occupies an equal time in passing with equal velocity a body that is in motion and a body of equal size that is at rest, which is false. For instance, so runs the argument, let A, be the stationary bodies of equal size, B, the bodies, equal in number and in size to A, originally occupying the half of the course from the starting post to the middle of the A's, and G, those originally occupying the other half from the goal to the middle of the A's, equal in number, size, and velocity to B. Then three consequences follow. First, as the B's and the G's pass one another, the first B reaches the last G at the same moment as the first G reaches the last B. Secondly, at this moment the first G has passed all the A's, whereas the first B has passed only half the A's, and has consequently occupied only half the time occupied by the first G, since each of the two occupies an equal time in passing each A. Thirdly, at the same moment all the B's have passed all the G's, for the first G and the first B will simultaneously reach the opposite ends of the course, since, so says Zeno, the time occupied by the first G in passing each of the B's is equal to that occupied by it in passing each of the A's, because an equal time is occupied by both the first B and the first G in passing all the A's. This is the argument, but it presupposed the aforesaid fallacious assumption. Nor in reference to contradictory change shall we find anything unanswerable in the argument that if a thing is changing from not white, say, to white, and is in neither condition, then it will be neither white nor not white. For the fact that it is not wholly in either condition will not preclude us from calling it white or not white. We call a thing white or not white not necessarily because it is be one or the other, but cause most of its parts or the most essential parts of it are so. Not being in a certain condition is different from not being wholly in that condition. So, too, in the case of being and not being and all other conditions which stand in a contradictory relation, while the changing thing must of necessity be in one of the two opposites, it is never wholly in either. Again, in the case of circles and spheres and everything whose motion is confined within the space that it occupies, it is not true to say the motion can be nothing but rest, on the ground that such things in motion, themselves and their parts, will occupy the same position for a period of time, and that therefore they will be at once at rest and in motion. For in the first place the parts do not occupy the same position for any period of time, and in the second place the whole also is always changing to a different position. For if we take the orbit as described from a point A on a circumference, it will not be the same as the orbit as described from B or G or any other point on the same circumference except in an accidental sense, the sense that is to say in which a musical man is the same as a man. Thus one orbit is always changing into another, and the thing will never be at rest. And it is the same with the sphere and everything else whose motion is confined within the space that it occupies. Our next point is that that which is without parts cannot be in motion except accidentally. That is, it can be in motion only in so far as the body or the magnitude is in motion and the partless is in motion by inclusion therein, just as that which is in a boat may be in motion in consequence of the locomotion of the boat, or a part may be in motion in virtue of the motion of the whole. It must be remembered, however, that by that which is without parts I mean that which is quantitatively indivisible, and that the case of the motion of a part is not exactly parallel, for parts have motions belonging essentially and severally to themselves distinct from the motion of the whole. The distinction may be seen most clearly in the case of a revolving sphere, in which the velocities of the parts near the center and of those on the surface are different from one another and from that of the whole. This implies that there is not one motion but many. As we have said, then, that which is without parts can be in motion in the sense in which a man sitting in a boat is in motion when the boat is traveling, but it cannot be in motion of itself. For suppose that it is changing from AB to BG either from one magnitude to another, or from one form to another, or from some state to its contradictory, and let D be the primary time in which it undergoes the change. Then in the time in which it is changing it must be either in AB or in BG or partly in one and partly in the other, for this, as we saw, is true of everything that is changing. Now it cannot be partly in each of the two, for then it would be divisible into parts. Nor again can it be in BG, for then it will have completed the change, whereas the assumption is that the change is in process. It remains, then, that in the time in which it is changing, it is in AB. That being so, it will be at rest, for, as we saw, to be in the same condition for a period of time is to be at rest. So it is not possible for that which has no parts to be in motion or to change in any way, for only one condition could have made it possible for it to have motion, viz. That time should be composed of moments, in which case at any moment it would have completed a motion or a change, so that it would never be in motion, but would always have been in motion. But this we have already shown above to be impossible. Time is not composed of moments, just as a line is not composed of points, and motion is not composed of starts, for this theory simply makes motion consist of indivisibles in exactly the same way as time is made to consist of moments or a length of points. Again, it may be shown in the following way that there can be no motion of a point or of any other indivisible. That which is in motion can never traverse a space greater than itself without first traversing a space equal to or less than itself. That being so, it is evident that the point also must first traverse a space equal to or less than itself. But since it is indivisible, there can be no space less than itself for it to traverse first, so it will have to traverse a distance equal to itself. Thus the line will be composed of points, for the point, as it continually traverses a distance equal to itself, will be a measure of the whole line. But since this is impossible, it is likewise impossible for the indivisible to be in motion. Again, since motion is always in a period of time and never in a moment, and all time is divisible, for everything that is in motion there must be a time less than that in which it traverses a distance as great as itself. For that in which it is in motion will be a time, because all motion is in a period of time, and all time has been shown above to be divisible. Therefore, if a point is in motion, there must be a time less than that in which it has itself traversed any distance. But this is impossible, for in less time it must traverse less distance, and thus the indivisible will be divisible into something less than itself, just as the time is so divisible, the fact being that the only condition under which that which is without parts and indivisible could be in motion would have been the possibility of the infinitely small being in motion in a moment, for in the two questions, that of motion in a moment and that of motion of something indivisible, the same principle is involved. Our next point is that no process of change is infinite, for every change, whether between contradictories or between contraries, is a change from something to something. Thus in contradictory changes the positive or the negative, as the case may be, is the limit. For example, being is the limit of coming to be and not being is the limit of ceasing to be, and in contrary changes the particular contraries are the limits, since these are the extreme points of any such process of change, and consequently of every process of alteration, for alteration is always dependent upon some contraries. Similarly, contraries are the extreme points of processes of increase and decrease. The limit of increase is to be found in the complete magnitude proper to the peculiar nature of the thing that is increasing, while the limit of decrease is the complete loss of such magnitude. Locomotion, it is true, we cannot show to be finite in this way, since it is not always between contraries. But since that which cannot be cut, in the sense that it is inconceivable that it should be cut, the term cannot being used in several senses, since it is inconceivable that that which in this sense cannot be cut should be in process of being cut, and generally that that which cannot come to be should be in process of coming to be, it follows that it is inconceivable that that which cannot complete a change should be in process of changing to that to which it cannot complete a change. If, then, it is to be assumed that that which is in locomotion is in process of changing, it must be capable of completing the change. Consequently its motion is not infinite, and it will not be in locomotion over an infinite distance, for it cannot traverse such a distance. It is evident, then, that a process of change cannot be infinite in the sense that it is not defined by limits. But it remains to be considered whether it is possible in the sense that one and the same process of change may be infinite in respect of the time which it occupies. If it is not one process, it would seem that there is nothing to prevent its being infinite in this sense. For example, if a process of locomotion be succeeded by a process of alteration and that by a process of increase and that again by a process of coming to be, in this way there may be motion forever so far as the time is concerned, but it will not be one motion, because all these motions do not compose one. If it is to be one process, no motion can be infinite in respect of the time that it occupies, with the single exception of rotatory locomotion. Physics, Book 7. Translated by R.P. Hardy and R.K. Everything that is in motion must be moved by something. For if it has not the source of its motion in itself, it is evident that it is moved by something other than itself, for there must be something else that moves it. If on the other hand it has the source of its motion in itself, let AB be taken to represent that which is in motion essentially of itself and not in virtue of the fact that something belonging to it is in motion. Now in the first place to assume that AB, because it is in motion as a whole and is not moved by anything external to itself, is therefore moved by itself. This is just as if, supposing that KL is moving LM and is also itself in motion, we were to deny that KM is moved by anything on the ground that it is not evident which is the part that is moving it and which the part that is moved. In the second place, that which is in motion without being moved by anything does not necessarily cease from its motion because something else is at rest. but a thing must be moved by something if the fact of something else having ceased from its motion causes it to be at rest. Thus, if this is accepted, everything that is in motion must be moved by something. For ab, which has been taken to represent that which is in motion, must be divisible since everything that is in motion is divisible. Let it be divided, then, at G. Now if GB is not in motion, then AB will not be in motion, for if it is clear that AG would be in motion while BG is at rest, and thus AB cannot be in motion essentially and primarily. But X hypothesis AB is in motion essentially and primarily. Therefore if GB is not in motion AB will be at rest. But we have agreed that that which is at rest if something else is not in motion must be moved by something. Consequently, everything that is in motion must be moved by something, for that which is in motion will always be divisible, and if a part of it is not in motion the whole must be at rest. Since everything that is in motion must be moved by something, let us take the case in which a thing is in locomotion and is moved by something that is itself in motion, and that again is moved by something else that is in motion, and that by something else, and so on continually. Then the series cannot go on to infinity, but there must be some first movement. For let us suppose that this is not so and take the series to be infinite. Let then be moved by B, B by G, G by D, and so on, each member of the series being moved by that which comes next to it. Then since X hypothesis the movement while causing motion is also itself in motion, and the motion of the moved and the motion of the movement must proceed simultaneously, for the movement is causing motion and the moved is being moved simultaneously, it is evident that the respective motions of A, B, G, and each of the other moved movements are simultaneous. Let us take the motion of each separately and let E be the motion of A, Z of B, and H and O respectively the motions of G and D, for though they are all moved severally one by another, yet we may still take the motion of each as numerically one, since every motion is from something to something and is not infinite in respect of its extreme points. By a motion that is numerically one I mean a motion that proceeds from something numerically one and the same to something numerically one and the same in a period of time numerically one and the same, for a motion may be the same generically, specifically, or numerically. It is generically the same if it belongs to the same category, for example substance or quality. It is specifically the same if it proceeds from something specifically the same to something specifically the same, for example from white to black or from good to bad, which is not of a kind specifically distinct. It is numerically the same if it proceeds from something numerically one to something numerically one in the same period of time, for example from a particular white to a particular black, or from a particular place to a particular place, in a particular period of time, for if the period of time were not one and the same, the motion would no longer be numerically one though it would still be specifically one. We have dealt with this question above. Now let us further take the time in which A has completed its motion, and let it be represented by K. Then since the motion of A is finite the time will also be finite. But since the movements and the things moved are infinite, the motion as ho, that is the motion that is composed of all the individual motions, must be infinite. For the motions of A, B, and the others may be equal, or the motions of the others may be greater, but assuming what is conceivable, we find that whether they are equal or some are greater, in both cases the whole motion is infinite. And since the motion of A and that of each of the others are simultaneous, the whole motion must occupy the same time as the motion of A, but the time occupied by the motion of A is finite, consequently the motion will be infinite in a finite time, which is impossible. It might be thought that what we set out to prove has thus been shown, but our argument so far does not prove it, because it does not yet prove that anything impossible results from the contrary supposition, for in a finite time there may be an infinite motion, though not of one thing, but of many, and in the case that we are considering this is so, for each thing accomplishes its own motion, and there is no impossibility in many things being in motion simultaneously. But if, as we see to be universally the case, that which primarily is moved locally and corporeally must be either in contact with or continuous with that which moves it, the things moved and the movements must be continuous or in contact with one another, so that together they all form a single unity. Whether this unity is finite or infinite makes no difference to our present argument. For in any case since the things in motion are infinite in number the whole motion will be infinite, if, as is theoretically possible, each motion is either equal to or greater than that which follows it in a series, for we shall take as actual that which is theoretically possible. If, then, A, B, G, D form an infinite magnitude that passes through the motion as ho in the finite time K, this involves the conclusion that an infinite motion is passed through in a finite time. And whether the magnitude in question is finite or infinite this is in either case impossible. Therefore the series must come to an end, and there must be a first movement and a first moved, for the fact that this impossibility results only from the assumption of a particular case is immaterial, since the case assumed is theoretically possible, and the assumption of a theoretically possible case ought not to give rise to any impossible result. That which is the first movement of a thing in the sense that it supplies not that for the sake of which but the source of the motion is always together with that which is moved by it. By together I mean that there is nothing intermediate between them. This is universally true wherever one thing is moved by another. And since there are three kinds of motion, local, qualitative, and quantitative, there must also be three kinds of movement, that which causes locomotion, that which causes alteration, and that which causes increase or decrease. Let us begin with locomotion, for this is the primary motion. Everything that is in locomotion is moved either by itself or by something else. In the case of things that are moved by themselves, it is evident that the moved and the movant are together, for they contain within themselves their first movement, so that there is nothing in between. The motion of things that are moved by something else must proceed in one of four ways, for there are four kinds of locomotion caused by something other than that which is in motion, viz. Pulling, pushing, carrying, and twirling. All forms of locomotion are reducible to these. Thus pushing on is a form of pushing in which that which is causing motion away from itself follows up that which it pushes and continues to push it. Pushing off occurs when the movement does not follow up the thing that it has moved. Throwing when the movement causes a motion away from itself more violent than the natural locomotion of the thing moved, which continues its course so long as it is controlled by the motion imparted to it. Again, pushing apart and pushing together are forms respectively of pushing off and pulling. Pushing apart is pushing off, which may be a motion either away from the pusher or away from something else, while pushing together is pulling, which may be a motion towards something else as well as the puller. We may similarly classify all the varieties of these last two, for example packing and combing. The former is a form of pushing together, the latter a form of pushing apart. The same is true of the other processes of combination and separation. They will all be found to be forms of pushing apart or of pushing together, except such as are involved in the processes of becoming and perishing. At same time it is evident that there is no other kind of motion but combination and separation, for they may all be apportioned to one or other of those already mentioned. Again, inhaling is a form of pulling, exhaling a form of pushing, and the same is true of spitting and of all other motions that proceed through the body, whether secretive or assimilative, the assimilative being forms of pulling, the secretive of pushing off. All other kinds of locomotion must be similarly reduced, for they all fall under one or other of our four heads. And again, of these four, carrying and twirling are to pulling and pushing. For carrying always follows one of the other three methods, for that which is carried is in motion accidentally, because it is in or upon something that is in motion, and that which carries it is in doing so being either pulled or pushed or twirled. Thus carrying belongs to all the other three kinds of motion in common. And twirling is a compound of pulling and pushing. For that which is twirling a thing must be pulling one part of the thing and pushing another part, since it impels one part away from itself and another part towards itself. If, therefore, it can be shown that that which is pushing and that which is pushing and pulling are adjacent respectively to that which is being pushed and that which is being pulled, it will be evident that in all locomotion there is nothing intermediate between moved and movement. But the former fact is clear even from the definitions of pushing and pulling. For pushing is motion to something else from oneself or from something else, and pulling is motion from something else to oneself or to something else, when the motion of that which is pulling is quicker than the motion that would separate from one another the two things that are continuous, for it is this that causes one thing to be pulled on along with the other. It might indeed be thought that there is a form of pulling that arises in another way, that would, for example, pulls fire in a manner different from that described above. But it makes no difference whether that which pulls is in motion or is stationary when it is pulling. In the latter case it pulls to the place where it is, while in the former it pulls to the place where it was. Now it is impossible to move anything either from oneself to something else or something else to oneself without being in contact with it. It is evident, therefore, that in all locomotion there is nothing intermediate between moved and movement. Nor again is there anything intermediate between that which undergoes and that which causes alteration. This can be proved by induction. For in every case we find that the respective extremities of that which causes and that which undergoes alteration are adjacent. For our assumption is that things that are undergoing alteration are altered in virtue of their being affected in respect of their so-called affective qualities, since that which is of a certain quality is altered in so far as it is sensible, and the characteristics in which bodies differ from one another are sensible characteristics. For every body differs from another in possessing a greater or lesser number of sensible characteristics or in possessing the same sensible characteristics in a greater or lesser degree. But the alteration of that which undergoes alteration is also caused by the above-mentioned characteristics, which are affections of some particular underlying quality. Thus we say that a thing is altered by becoming hot or sweet or thick or dry or white, and we make these assertions alike of what is inanimate and of what is animate, and further, where animate things are in question, we make them both of the parts that have no power of sense perception and of the senses themselves. For in a way even the senses undergo alteration, since the active sense is a motion through the body in the course of which the sense is affected in a certain way. We see, then, that the animate is capable of every kind of alteration of which the inanimate is capable, but the inanimate is not capable of every kind of alteration of which the animate is capable, since it is not capable of alteration in respect of the senses. Moreover, the inanimate is unconscious of being affected by alteration, whereas the animate is conscious of it, though there is nothing to prevent the animate also being unconscious of it when the process of the alteration does not concern the senses. Since, then, the alteration of that which undergoes alteration is caused by sensible things, in every case of such alteration it is evident that the respective extremities of that which causes and that which undergoes alteration are adjacent. Thus the air is continuous with that which causes the alteration, and the body that undergoes alteration is continuous with the air. Again, the color is continuous with the light and the light with the sight. And the same is true of hearing and smelling, for the primary movement in respect to the moved is the air. Similarly, in the case of tasting, the flavor is adjacent to the sense of taste. And it is just the same in the case of things that are inanimate and incapable of sense perception. Thus there can be nothing intermediate between that which undergoes and that which causes alteration, nor, again, can there be anything intermediate between that which suffers and that which causes increase, for the part of the latter that starts the increase does so by becoming attached in such a way to the former that the whole becomes one. Again, the decrease of that which suffers decrease is caused by a part of the thing becoming detached. So that which causes increase and that which causes decrease must be continuous with that which suffers increase and that which suffers decrease respectively, and if two things are continuous with one another there can be nothing intermediate between them. It is evident, therefore, that between the extremities of the moved and the movant that are respectively first and last in reference to the moved there is nothing intermediate. Everything, we say, that undergoes alteration is altered by sensible causes, and there is alteration only in things that are said to be essentially affected by sensible things. The truth of this is to be seen from the following considerations. Of all other things it would be most natural to suppose that there is alteration in figures and shapes, and in acquired states and in the processes of acquiring and losing these. But as a matter of fact in neither of these two classes of things is there alteration. In the first place, when a particular formation of a thing is completed, we do not call it by the name of its material. For example, we do not call the statue bronze or the pyramid wax or the bed wood, but we use a derived expression and call them of bronze, waxen, and wooden respectively. But when a thing has been affected and altered in any way we still call it by the original name. Thus we speak of the bronze or the wax being dry or fluid or hard or hot. And not only so, we also speak of the particular fluid or hot substance as being bronze, giving the material the same name as that which we use to describe the affection. Since, therefore, having regard to the figure or shape of a thing we no longer call that which has become of a certain figure by the name of the material that exhibits the figure, whereas having regard to a thing's affections or alterations we still call it by the name of its material, it is evident that becomings of the former kind cannot be alterations. Moreover, it would seem absurd even to speak in this way, to speak, that is to say, of a man or house or anything else that has come into existence as having been altered. Though it may be true that every such becoming is necessarily the result of something's being altered, the result, for example, of the materials being condensed or rarefied or heated or cooled, nevertheless it is not the things that are coming into existence that are altered, and their becoming is not an alteration. Again, acquired states, whether of the body or of the soul, are not alterations. For some are excellences and others are defects, and neither excellence nor defect is an alteration. Excellence is a perfection, for when anything acquires its proper excellence we call it perfect, since it is then if ever that we have a thing in its natural state. For example, we have a perfect circle when we have one as good as possible, while defect is a perishing of or departure from this condition. So as when speaking of a house we do not call its arrival at perfection an alteration, for it would be absurd to suppose that the coping or the tiling is an alteration or that in receiving its coping or its tiling a house is altered and not perfected. The same also holds good in the case of excellences and defects and of the persons or things that possess or acquire them, for excellences are perfections of a thing's nature and defects are departures from it, consequently they are not alterations. Further, we say that all excellences depend upon particular relations. Thus bodily excellences such as health and a good state of body we regard as consisting in a blending of hot and cold elements within the body in due proportion, in relation either to one another or to the surrounding atmosphere, and in like manner we regard beauty, strength, and all the other bodily excellences and defects. Each of them exists in virtue of a particular relation and puts that which possesses it in a good or bad condition with regard to its proper affections, where by proper affections I mean those influences that from the natural constitution of a thing tend to promote or destroy its existence. Since then, relatives are neither themselves alterations nor the subjects of alteration or of becoming or in fact of any change whatever, it is evident that neither states nor the processes of losing and acquiring states are alterations, though it may be true that their becoming or perishing is necessarily, like the becoming or perishing of a specific character or form, the result of the alteration of certain other things, for example hot and cold or dry and wet elements or the elements, whatever they may be, on which the states primarily depend. For each several bodily defect or excellence involves a relation with those things from which the possessor of the defect or excellence is naturally subject to alteration. Thus excellence disposes its possessor to be unaffected by these influences or to be affected by those of them that ought to be admitted, while defect disposes its possessor to be affected by them or to be unaffected by those of them that ought to be admitted. And the case is similar in regard to the states of the soul, all of which, like those of body, exist in virtue of particular relations, the excellences being perfections of nature and the defects departures from it. Moreover, excellence puts its possessor in good condition, while defect puts its possessor in a bad condition, to meet his proper affections. Consequently these cannot any more than the bodily states be alterations, nor can the processes of losing and acquiring them be so, though their becoming is necessarily the result of an alteration of the sensitive part of the soul, and this is altered by sensible objects, for all moral excellence is concerned with bodily pleasures and pains, which again depend either upon acting or upon remembering or upon anticipating. Now those that depend upon action are determined by sense perception, that is they are stimulated by something sensible, and those that depend upon memory or anticipation are likewise to be traced to sense perception, for in these cases pleasure is felt either in remembering what one has experienced or in anticipating what one is going to experience. Thus all pleasure of this kind must be produced by sensible things, and since the presence in any one of moral defect or excellence involves the presence in him of pleasure or pain, with which moral excellence and defect are always concerned, and these pleasures and pains are alterations of the sensitive part, it is evident that the loss and acquisition of these states no less than the loss and acquisition of the states of the body must be the result of the alteration of something else. Consequently, though their becoming is accompanied by an alteration, they are not themselves alterations. Again, the states of the intellectual part of the soul are not alterations, nor is there any becoming of them. In the first place it is much more true of the possession of knowledge that it depends upon a particular relation. And further, it is evident that there is no becoming of these states. For that which is potentially possessed of knowledge becomes actually possessed of it not by being set in motion at all itself but by reason of the presence of something else, that is it is when it meets with the particular object that it knows in a manner the particular through its knowledge of the universal. Again, there is no becoming of the actual use and activity of these states, unless it is thought that there is a becoming of vision and touching and that the activity in question is similar to these, and the original acquisition of knowledge is not a becoming or an alteration, for the terms knowing and understanding imply that the intellect has reached a state of rest and come to a standstill, and there is no becoming that leads to a state of rest, since, as we have said above, change at all can have a becoming. Moreover, just as to say, when anyone has passed from a state of intoxication or sleep or disease to the contrary state, that he has become possessed of knowledge again is incorrect in spite of the fact that he was previously incapable of using his knowledge, so, too, when anyone originally acquires the state, it is incorrect to say that he becomes possessed of knowledge, for the possession of understanding and knowledge is produced by the soul's settling down out of the restlessness natural to it. Hence, too, in learning and in forming judgments on matters relating to their sense perceptions children are inferior to adults owing to the great amount of restlessness and motion in their souls. Nature itself causes the soul to settle down and come to a state of rest for the performance of some of its functions, while for the performance of others other things do so, but in either case the result is brought about through the alteration of something in the body, as we see in the case of the use and activity of the intellect arising from a man's becoming sober or being awakened. It is evident, then, from the preceding argument that alteration and being altered occur in sensible things and in the sensitive part of the soul, and, except accidentally, in nothing else. A difficulty may be raised as to whether every motion is commensurable with every other or not. Now if they are all commensurable and if two things to have the same velocity must accomplish an equal motion in an equal time, then we may have a circumference equal to a straight line, or, of course, the one may be greater or less than the other. Further, if one thing alters and another accomplishes a locomotion in an equal time, we may have an alteration and a locomotion equal to one another, thus an affection will be equal to a length, which is impossible. But is it not only when an equal motion is accomplished by two things in an equal time that the velocities of the two are equal? Now an affection cannot be equal to a length. Therefore there cannot be an alteration equal to or less than a locomotion, and consequently it is not the case that every motion is commensurable with every other. But how will our conclusion work out in the case of the circle and the straight line? It would be absurd to suppose that the motion of one in a circle and of another in a straight line cannot be similar, but that the one must inevitably move more quickly or more slowly than the other, just as if the course of one were downhill and of the other uphill. Moreover, it does not as a matter of fact make any difference to the argument to say that the one motion must inevitably be quicker or slower than the other, for then the circumference can be greater or less than the straight line, and if so it is possible for the two to be equal. For if in the time A the quicker, B, passes over the distance B and the slower, G, passes over the distance G, B will be greater than G, for this is what we took quicker to mean, and so quicker motion also implies that one thing traverses an equal distance in less time than another. Consequently there will be a part of A in which B will pass over a part of the circle equal to G, while G will occupy the whole of A in passing over G. Nonetheless, if the two motions are commensurable, we are confronted with the consequence stated above, viz. that there may be a straight line equal to a circle. But these are not commensurable, and so the corresponding motions are not commensurable either. But may we say that things are always commensurable if the same terms are applied to them without equivocation? For example, a pen, a wine, and the highest note in a scale are not commensurable. We cannot say whether any one of them is sharper than any other, and why is this? They are incommensurable because it is only equivocally that the same term sharp is applied to them, whereas the highest note in a scale is commensurable with the leading note, because the term sharp has the same meaning as applied to both. Can it be, then, that the term quick has not the same meaning as applied to straight motion and to circular motion respectively? If so, far less will it have the same meaning as applied to alteration and to locomotion. Or shall we in the first place deny that things are always commensurable if the same terms are applied to them without equivocation? For the term much has the same meaning whether applied to water or to air, yet water and air are not commensurable in respect of it, or, if this illustration is not considered satisfactory, double at any rate would seem to have the same meaning as applied to each, denoting in each case the proportion of 2 to 1, yet water and air are not commensurable in respect of it. But here again may we not take up the same position and say that the term much is equivocal? In fact there are some terms of which even the definitions are equivocal. For example, if much were defined as so much and more, so much would mean something different in different cases. Equal is similarly equivocal, and one again is perhaps inevitably an equivocal term, and if one is equivocal, so is two. Otherwise why is it that some things are commensurable while others are not, if the nature of the attribute in the two cases is really one and the same? Can it be that the incommensurability of two things in respect of any attribute is due to a difference in that which is primarily capable of carrying the attribute? Thus horse and dog are so commensurable that we may say which is the whiter, since that which primarily contains the whiteness is the same in both, viz. the surface, and similarly they are commensurable in respect of size. But water and speech are not commensurable in respect of clearness, since that which primarily contains the attribute is different in the two cases. It would seem, however, that we must reject this solution, since clearly we could thus make all equivocal attributes univocal and say merely that that contains each of them is different in different cases, thus equality, sweetness, and whiteness will severally always be the same, though that which contains them is different in different cases. Moreover, it is not any casual thing that is capable of carrying any attribute. Each single attribute can be carried primarily only by one single thing. Must we then say that, if two things are to be commensurable in respect of any attribute, not only must the attribute in question be applicable to both without equivocation, but there must also be no specific differences either in the attribute itself or in that which contains the attribute, that these, I mean, must not be divisible in the way in which color is divided into kinds? Thus in this respect one thing will not be commensurable with another, that is, we cannot say that one is more colored than the other where only color in general and not any particular color is meant, but they are commensurable in respect of whiteness. Similarly in the case of motion, two things are of the same velocity if they occupy an equal time in accomplishing a certain equal amount of motion. Suppose, then, that in a certain time an alteration is undergone by one half of a body's length and a locomotion is accomplished the other half. Can we say that in this case the alteration is equal to the locomotion and of the same velocity? That would be absurd, and the reason is that there are different species of motion. And if in consequence of this we must say that two things are of equal velocity if they accomplish locomotion over an equal distance in an equal time, we have to admit the equality of a straight line and a circumference. What, then, is the reason of this? Is it that locomotion is a genus or that line is a genus? We may leave the time out of account, since that is one and the same. If the lines are specifically different, the locomotions also differ specifically from one another, for locomotion is specifically differentiated according to the specific differentiation of that over which it takes place. It is also similarly differentiated, it would seem, accordingly as the instrument of the locomotion is different. Thus if feet are the instrument, it is walking, if wings it is flying. But perhaps we should rather say that this is not so, and that in this case the differences in the locomotion are merely differences of posture in that which is in motion. We may say, therefore, that things are of equal velocity in an equal time they traverse the same magnitude, and when I call it the same I mean that it contains no specific difference and therefore no difference in the motion that takes place over it. So we have now to consider how motion is differentiated. And this discussion serves to show that the genus is not a unity but contains a plurality latent in it and distinct from it, and that in the case of equivocal terms sometimes the different senses in which they are used are far removed from one another, while sometimes there is a certain likeness between them, and sometimes again they are nearly related either generically or analogically, with the result that they seem not to be equivocal though they really are. When, then, is there a difference of species? Is an attribute specifically different if the subject is different while the attribute is the same, or must the attribute itself be different as well? And how are we to define the limits of a species? What will enable us to decide that particular instances of whiteness or sweetness are the same or different? Is it enough that it appears different in one subject from what appears in another? Or must there be no sameness at all? And further, where alteration is in question, how is one alteration to be of equal velocity with another? One person may be cured quickly and another slowly, and cures may also be simultaneous, so that, recovery of health being an alteration, we have here alterations of equal velocity, since each alteration occupies an equal time. But what alteration? We cannot here speak of an equal alteration. What corresponds in the category of quality to a quality in the category of quantity is likeness. However, let us say that there is equal velocity where the same change is accomplished in an equal time. Are we, then, to find the commensurability in the subject of the affection or in the affection itself? In the case that we have just been considering, it is the fact that health is one and the same that enables us to arrive at the conclusion that the one alteration is neither more nor less than the other, but that both are alike. If on the other hand the affection is different in the two cases, for example when the alterations take the form of becoming white and becoming healthy respectively, here there is no sameness or equality or likeness inasmuch as the difference in the affections at once makes the alterations specifically different, and there is no unity of alteration any more than there would be unity of locomotion under like conditions. So we must find out how many species there are of alteration and of locomotion respectively. Now if the things that are in motion, that is to say, the things to which the motions belong essentially and not accidentally, differ specifically, then their respective motions will also differ specifically. If on the other hand they differ generically or numerically, the motions also will differ generically or numerically as the case may be. But there still remains the question whether, supposing that two alterations are of equal velocity, we ought to look for this equality in the sameness, or likeness, of the affections, or in the things altered, to see for example whether a certain quantity of each has become white. Or ought we not rather to look for it in both? That is to say, the alterations are the same or different according as the affections are the same or different, while they are equal or unequal according as the things altered are equal or unequal. And now we must consider the same question in the case of becoming and perishing. How is one becoming of equal velocity with another? They are of equal velocity if in an equal time there are produced two things that are the same and specifically inseparable, for example two men, not merely generically inseparable as for example two animals. Similarly one is quicker than the other if in an equal time the product is different in the two cases. I state it thus because we have no pair of terms that will convey this difference in the way in which unlikeness is conveyed. If we adopt the theory that it is number that constitutes being, we may indeed speak of a greater number and a lesser number within the same species, but there is no common term that will include both relations, nor other terms to express each of them separately in the same way as we indicate a higher degree or preponderance of an affection by more, of a quantity by greater. Now since wherever there is a movement, its motion always acts upon something, is always in something, and always extends to something. By is always in something I mean that it occupies a time, and by extends to something I mean that it involves the traversing of a certain amount of distance, for at any moment when a thing is causing motion, it also has caused motion, so that there must always be a certain amount of distance that has been traversed and a certain amount of time that has been occupied. Then, the movement have moved b a distance g in a time d, then in the same time the same force A will move 1/2b twice the distance g, and in 1/2d it will move 1/2b the whole distance for g, thus the rules of proportion will be observed. Again, if a given force move a given weight a certain distance in a certain time and half the distance in half the time, half the motive power will move half the weight the same distance in the same time. Let E represent half the motive power A and Z half the weight B, then the ratio between the motive power and the weight in the one case is similar and proportionate to the ratio in the other, so that each force will cause the same distance to be traversed in the same time. But if E moves Z a distance g in a time d, it does not necessarily follow that E can move twice Z half the distance g in the same time. If, then, a move be a distance g in a time d, it does not follow that E, being half of A, will in the time d or in any fraction of it cause B to traverse a part of g. The ratio between which and the whole of g is proportionate to that between A and E, whatever fraction of E may be. In fact, it might well be that it will cause no motion at all, for it does not follow that, if a given motive power causes a certain amount of motion, half that power will cause motion either of any particular amount or in any length of time. Otherwise one man might move a ship, since both the motive power of the ship haulers and the distance that they all cause the ship to traverse are divisible into as many parts as there are men. Hence Zeno's reasoning is false when he argues that there is no part of the millet that does not make a sound, for there is no reason why any such part should not in any length of time fail to move the air that the whole bushel moves in falling. In fact, it does not of itself move even such a quantity of the air as it would move if this part were by itself, for no part even exists otherwise than potentially. If on the other hand we have two forces each of which separately moves one of two weights a given distance in a given time, then the forces in combination will move the combined weights an equal distance in an equal time, for in this case the rules of proportion apply. Then does this hold good of alteration and of increase also? Surely it does, for in any given case we have a definite thing that causes increase and a definite thing that suffers increase, and the one causes and the other suffers a certain amount of increase in a certain amount of time. Similarly we have a definite thing that causes alteration and a definite thing that undergoes alteration, and a certain amount, or other degree, of alteration is completed in a certain amount of time. Thus in twice as much time twice as much alteration will be completed, and conversely twice as much alteration will occupy twice as much time, and the alteration of half of its object will occupy half as much time, and in half as much time half of the object will be altered, or again, in the same amount of time it will be altered twice as much. On the other hand, if that which causes alteration or increase causes a certain amount of increase or alteration respectively in a certain amount of time, it does not necessarily follow that half the force will occupy twice the time in altering or increasing the object, or that in twice the time the alteration or increase will be completed by it. It may happen that there will be no alteration or increase at all, the case being the same as with the weight. Physics, Book 8, translated by R.P. Hardy and Darkegay. It remains to consider the following question. Was there ever a becoming of motion before which it had no being, and is it perishing again so as to leave nothing in motion? Or are we to say that it never had any becoming and is not perishing, but always was and always will be? Is it in fact an immortal never-failing property of things that are, a sort of life as it were to all naturally constituted things? Now the existence of motion is asserted by all who have anything to say about nature, because they all concern themselves with the construction of the world and study the question of becoming and perishing, which processes could not come about without the existence of motion. But those who say that there is an infinite number of worlds, some of which are in process of becoming while others are in process of perishing, assert that there is always motion, for these processes of becoming and perishing of the worlds necessarily involve motion, whereas those who hold that there is only one world, whether everlasting or not, make corresponding assumptions in regard to motion. If then it is possible that at any time nothing should be in motion, this must come about in one of two ways, either in the manner described by Anaxagoras, who says that all things were together and at rest for an infinite period of time, and the then mind introduced motion and separated them, or in the manner described by Empedocles, according to whom the universe is alternately in motion and at rest in motion, when love is making the one out of many, or strife is making many out of one, and at rest in the intermediate periods of time, his account being as follows. Since one hath learned to spring from manifold, and one disjoined makes manifold arise, thus they become, nor stable is their life. But since their motion must alternate be, thus have they ever rest upon their round. For we must suppose that he means by this that they alternate from the one motion to the other. We must consider, then, how this matter stands, for the discovery of the truth about it is of importance, not only for the study of nature, but also for the investigation of the first principle. Let us take our start from what we have already laid down in our course on physics. Motion, we say, is the fulfillment of the movable in so far as it is movable. Each kind of motion, therefore, necessarily involves the presence of the things that are capable of that motion. In fact, even apart from the definition of motion, everyone would admit that in each kind of motion it is that which is capable of that motion that is in motion, thus it is that which is capable of alteration that is altered, and that which is capable of local change that is in locomotion, and so there must be something capable of being burned before there can be a process of being burned, and something capable of burning before there can be a process of burning. Moreover, these things also must either have a beginning before which they had no being, or they must be eternal. Now if there was a becoming of every movable thing, it follows that before the motion in question another change or motion must have taken place in which that which was capable of being moved or of causing motion had its becoming. To suppose, on the other hand, that these things were in being throughout all previous time without there being any motion appears unreasonable on a moment's thought, and still more unreasonable, we shall find, on further consideration. For if we are to say that, while there are on the one hand things that are movable, and on the other hand things that are motive, there is a time when there is a first movement and a first moved, and another time when there is no such thing but only something that is at rest, then this thing that is at rest must previously have been in process of change, for there must have been some cause of its rest, rest being the privation of motion. Therefore, before this first change there will be a previous change. For some things cause motion in only one way, while others can produce either of two contrary motions. Thus fire causes heating but not cooling, whereas it would seem that knowledge may be directed to two contrary ends while remaining one and the same. Even in the former class, however, there seems to be something similar, for a cold thing in a sense causes heating by turning away and retiring, just as one possessed of knowledge voluntarily makes an error when he uses his knowledge in the reverse way. But at any rate all things that are capable respectively of affecting and being affected, or of causing motion and being moved, are capable of it not under all conditions, but only when they are in a particular condition and approach one another. So it is on the approach of one thing to another that the one causes motion and the other is moved, and when they are present under such conditions as render the one motive and the other movable. So if the motion was not always in process, it is clear that they must have been in a condition not such as to render them capable respectively of being moved and of causing motion, and one or other of them must have been in process of change, for in what is relative this is a necessary consequence. For example, if one thing is double another when before it was not so, one or other of them, if not both, must have been in process of change. It follows then, that there will be a process of change previous to the first. Further, how can there be any before and after without the existence of time? Or how can there be any time without the existence of motion? If, then, time is the number of motion or itself a kind of motion, it follows that, if there is always time, motion must also be eternal. But so far as time is concerned we see that all with one exception are in agreement in saying that it is uncreated. In fact, it is just this that enables Democritus to show that all things cannot have had a becoming, for time, he says, is uncreated. Plato alone asserts the creation of time, saying that it had a becoming together with the universe according to him having had a becoming. Now since time cannot exist and is unthinkable apart from the moment, and the moment a kind of middle point, uniting as it does in itself both a beginning and an end, a beginning of future time and an end of past time, it follows that there must always be time, for the extremity of the last period of time that we take must be found in some moment, since time contains no point of contact for us except the moment. Therefore, since the moment is both a beginning and an end, there must always be time on both sides of it. But if this is true of time, it is evident that it must also be true of motion, time being a kind of affection of motion. The same reasoning will also serve to show the imperishability of motion, just as a becoming of motion would involve, as we saw, the existence of the process of change previous to the first. In the same way a perishing of motion would involve the existence of a process of change subsequent to the last, for when a thing ceases to be moved, it does not therefore at the same time cease to be movable. For example, the cessation of the process of being burned does not involve the cessation of the capacity of being burned, since a thing may be capable of being burned without being in process of being burned, nor, when a thing ceases to be movant, does it therefore at the same time cease to be motive. Again, the destructive agent will have to be destroyed, after what it destroys has been destroyed, and then that which has the capacity of destroying it will have to be destroyed afterwards, so that there will be a process of change subsequent to the last, for being destroyed also is a kind of change. If, then, view which we are criticizing involves these impossible consequences, it is clear that motion is eternal and cannot have existed at one time and not at another. In fact, such a view can hardly be described as anything else than fantastic. And much the same may be said of the view that such is the ordinance of nature and that this must be regarded as a principle, as would seem to be the view of Empedocles when he says that the constitution of the world is of necessity such that love and strife alternately predominate and cause motion, while in the intermediate period of time there is a state of rest. Probably also those who like Anaxagoras, assert a single principle, of motion, would hold this view. But that which is produced or directed by nature can never be anything disorderly, for nature is everywhere the cause of order. Moreover, there is no ratio in the relation of the infinite to the infinite, whereas order always means ratio. But if we say that there is first a state of rest for an infinite time, and then motion is started at some moment, and that the fact that it is this rather than a previous moment is of no importance, and involves no order, then we can no longer say that it is nature's work, for if anything is of a certain character naturally, it either is so invariably and is not sometimes of this and sometimes of another character. For example, fire, which travels upwards naturally, does not sometimes do so and sometimes not, or there is a ratio in the variation. It would be better, therefore, to say with Empedocles and anyone else who may have maintained such a theory as his that the universe is alternately at rest and in motion, for in a system of this kind we have at once a certain order. But even here the holder of the theory ought not only to assert the fact, he ought to explain the cause of it, that is he should not make any mere assumption or lay down any gratuitous axiom, but should employ either inductive or demonstrative reasoning. The love and strife postulated by Empedocles are not in themselves causes of the fact in question, nor is it of the essence of either that it should be so, the essential function of the former being to unite, of the latter to separate. If he is to go on to explain this alternate predominance, he should adduce cases where such a state of things exists, as he points to the fact that among mankind we have something that unites men, namely love, while on the other hand enemies avoid one another. Thus from the observed fact that this occurs in certain cases comes the assumption that it occurs also in the universe. Then, again, some argument is needed to explain why the predominance of each of the two forces lasts for an equal period of time. But it is a wrong assumption to suppose universally that we have an adequate first principle in virtue of the fact that something always is so or always happens so. Thus Democritus reduces the causes that explain nature to the fact that things happened in the past in the same way as they happen now, but he does not think fit to seek for a first principle to explain this always, so, while his theory is right in so far as it is applied to certain individual cases, he is wrong in making it of universal application. Thus, a triangle always has its angles equal to two right angles, but there is nevertheless an ulterior cause of the eternity of this truth, whereas first principles are eternal and have no ulterior cause. Let this conclude what we have to say in support of our contention that there never was a time when there was not motion, and never will be a time when there will not be motion. The arguments that may be advanced against this position are not difficult to dispose of. The chief considerations that might be thought to indicate that motion may exist though at one time it had not existed at all are the following. First, it may be said that no process of change is eternal, for the nature of all change is such that it proceeds from something to something, so that every process of change must be bounded by the contraries that mark its course, and no motion can go on to infinity. Secondly, we see that a thing that neither is in motion nor contains any motion within itself can be set in motion, for example inanimate things that are, whether the whole or some part is in question, not in motion but at rest, are at some moment set in motion, whereas, if motion cannot have a becoming before which it had no being, these things ought to be either always or never in motion. Thirdly, the fact is evident above all in the case of animate beings, for it sometimes happens that there is no motion in us and we are quite still, and that nevertheless we are then at some moment set in motion. That is to say, it sometimes happens that we produce a beginning of motion in ourselves spontaneously without anything having set us in motion from without. We see nothing like this in the case of inanimate things, which are always set in motion by something else from without. The animal, on the other hand, we say, moves itself. Therefore, if an animal is ever in a state of absolute rest, we have a motionless thing in which motion can be produced from the thing itself, and not from without. Now if this can occur in an animal, why should not the same be true also of the universe as a whole? If it can occur in a small world, it could also occur in a great one, and if it can occur in the world, it could also occur in the infinite, that is, if the infinite could as a whole possibly be in motion or at rest. Of these objections, then, the first mentioned motion to opposites is not always the same and numerically one a correct statement. In fact, this may be said to be a necessary conclusion, provided that it is possible for the motion of that which is one and the same to be not always one and the same. I mean that, for example, we may question whether the note given by a single string is one and the same, or is different each time the string is struck, although the string is in the same condition and is moved in the same way, but still, however this may be, there is nothing to prevent there being a motion that is the same in virtue of being continuous and eternal. We shall have something to say later that will make this point clearer. As regards the second objection, no absurdity is involved in the fact that something not in motion may be set in motion, that which caused the motion from without being at one time present, and at another absent. Nevertheless, how this can be so remains matter for inquiry. How it comes about, I mean, that the same motive force at one time causes a thing to be in motion, and at another does not do so. For the difficulty raised by our objector really amounts to this: why is it that some things are not always at rest, and the rest always in motion? The third objection may be thought to present more difficulty than the others, namely, that which alleges that motion arises in things in which it did not exist before, and adduces in proof the case of animate things. Thus an animal is first at rest and afterwards walks, not having been set in motion apparently by anything from without. This, however, is false. For we observe that there is always some part of the animal's organism in motion, and the cause of the motion of this part is not the animal itself, but, it may be, its environment. Moreover, we say that the animal itself originates not all its motions but its locomotion. So it may well be the case, or rather we may perhaps say that it must necessarily be the case, that many motions are produced in the body by its environment, and some of these set in motion the intellect or the appetite, and this again then sets the whole animal in motion. This is what happens when animals are asleep. Though there is then no perceptive motion in them, there is some motion that causes them to wake up again. But we will leave this point also to be elucidated at a later stage in our discussion. Our inquiry will resolve itself at the outset into a consideration of the above-mentioned problem: what can be the reason why some things in the world at one time are in motion and at another are at rest again? Now one of three things must be true: either all things are always at rest, or all things are always in motion, or some things are in motion and others at rest, and in this last case again neither the things that are in motion are always in motion and the things that are at rest are always at rest, or they are all constituted so as to be capable alike of motion and of rest, or there is yet a third possibility remaining: it may be that some things in the world are always motionless, others always in motion, while others again admit of both conditions. This last is the account of the matter that we must give, for herein lies the solution of all the difficulties raised and the conclusion of the investigation upon which we are engaged. To maintain that all things are at rest, and to disregard sense perception in an attempt to show the theory to be reasonable, would be an instance of intellectual weakness. It would call in question a whole system, not a particular detail. Moreover, it would be an attack not only on the physicist but on almost all sciences and all received opinions, since motion plays a part in all of them. Further, just as in arguments about mathematics objections that involve first principles do not affect the mathematician and the other sciences are in similar case, so, too, objections involving the point that we have just raised do not affect the physicist, for it is a fundamental assumption with him that motion is ultimately referable to nature herself. The assertion that all things are in motion we may fairly regard as equally false, though it is less subversive of physical science. For though in our course on physics it was laid down that rest no less than motion is ultimately referable to nature herself, nevertheless motion is the characteristic fact of nature. Moreover, the view is actually held by some that not merely some things but all things in the world are in motion and always in motion, though we cannot apprehend the fact by sense perception. Although the supporters of this theory do not state clearly what kind of motion they mean, or whether they mean all kinds, it is no hard matter to reply to them. Thus we may point out that there cannot be a continuous process either of increase or of decrease, that which comes between the two has to be included. The theory resembles that about the stone being worn away by the drop of water or split by plants growing out of it. If so much has been extruded or removed by the drop, it does not follow that half the amount has previously been extruded or removed in half the time. The case of the hauled ship is exactly comparable. Here we have so many drops setting so much in motion, but a part of them will not set as much in motion in any period of time. The amount removed is, it is true, divisible into a number of parts, but no one of these was set in motion separately. They were all set in motion together. It is evident, then, that from the fact that the decrease is divisible into an infinite number of parts, it does not follow that some part must always be passing away. It all passes away at a particular moment. Similarly, too, in the case of any alteration whatever, if that which suffers alteration is infinitely divisible, it does not follow from this that the same is true of the alteration itself, which often occurs all at once, as in freezing. Again, when anyone has fallen ill, there must follow a period of time in which his restoration to health is in the future. The process of change cannot take place in an instant, yet the change cannot be a change to anything else but health. The assertion, therefore, that alteration is continuous is an extravagant calling into question of the obvious, for alteration is a change from one contrary to another. Moreover, we notice that a stone becomes neither harder nor softer. Again, in the matter of locomotion, it would be a strange thing if a stone could be falling or resting on the ground without our being able to perceive the fact. Further, it is a law of nature that earth and all other bodies should remain in their proper places and be moved from them only by violence. From the fact then that some of them are in their proper places, it follows that in respect of place also all things cannot be in motion. These and other similar arguments, then, should convince us that it is impossible either that all things are always in motion or that all things are always at rest. Nor again can it be that some things are always at rest, others always in motion, and nothing sometimes at rest and sometimes in motion. This theory must be pronounced impossible on the same grounds as those previously mentioned, viz., that we see the above-mentioned changes occurring in the case of the same things. We may further point out that the defender of this position is fighting against the obvious, for on this theory there can be no such thing as increase, nor can there be any such thing as compulsory motion, if it is impossible that a thing can be at rest before being set in motion unnaturally. This theory, then, does away with becoming and perishing. Moreover, motion, it would seem, is generally thought to be a sort of becoming and perishing, for that to which a thing changes comes to be, or occupancy of it comes to be, and that from which a thing changes ceases to be, or there ceases to be occupancy of it. It is clear, therefore, that there are cases of occasional motion and occasional rest. We have now to take the assertion that all things are sometimes at rest and sometimes in motion and to confront it with the arguments previously advanced. We must take our start as before from the possibilities that we distinguished just above. Either all things are at rest, or all things are in motion, or some things are at rest and others in motion. And if some things are at rest and others in motion, then it must be that either all things are sometimes at rest and sometimes in motion, or some things are always at rest and the remainder always in motion, or some of the things are always at rest and others always in motion while others again are sometimes at rest and sometimes in motion. Now we have said before that it is impossible that all things should be at rest. Nevertheless we may now repeat that assertion. We may point out that, even if it is really the case, as certain persons assert, that the existent is infinite and motionless, it certainly does not appear to be so if we follow sense perception. Many things that exist appear to be in motion. Now if there is such a thing as false opinion or opinion at all, there is also motion, and similarly if there is such a thing as imagination, or if it is the case that anything seems to be different at different times, for imagination and opinion are thought to be motions of a kind. But to investigate this question at all, to seek a reasoned justification of a belief with regard to which we are too well off to require reasoned justification, implies bad judgment of what is better and what is worse, what commends itself to belief and what does not, what is ultimate and what is not. It is likewise impossible that all things should be in motion or that some things should be always in motion and the remainder always at rest. We have sufficient ground for rejecting all these theories in the single fact that we see some things that are sometimes in motion and sometimes at rest. It is evident, therefore, that it is no less impossible that some things should be always in motion and the remainder always at rest than that all things should be at rest or that all things should be in motion continuously. It remains, then, to consider whether all things are so constituted as to be capable both of being in motion and of being at rest, or whether, while some things are so constituted, some are always at rest and some are always in motion, for it is this last view that we have to show to be true. Now of things that cause motion or suffer motion, to some the motion is accidental, to others essential. Thus it is accidental to what merely belongs to or contains as a part a thing that causes motion or suffers motion, essential to a thing that causes motion or suffers motion not merely by belonging to such a thing or containing it as a part of things to which the motion is essential. Some derive their motion from themselves, others from something else, and in some cases their motion is natural, in others violent and unnatural. Thus in things that derive their motion from themselves, for example all animals, the motion is natural, for when an animal is in motion its motion is derived from itself, and whenever the source of the motion of a thing is in the thing itself we say that the motion of that thing is natural. Therefore the animal as a whole moves itself naturally, but the body of the animal may be in motion unnaturally as well as naturally. It depends upon the kind of motion that it may chance to be suffering and the kind of element of which it is composed. And the motion of things that derive their motion from something else is in some cases natural, in other unnatural. For example, upward motion of earthy things and downward motion of fire are unnatural. Moreover, the parts of animals are often in motion in an unnatural way, their positions and the character of the motion being abnormal. The fact that a thing that is in motion derives its motion from something is most evident in things that are in motion unnaturally, because in such cases it is clear that the motion is derived from something other than the thing itself. Next to things that are in motion unnaturally, those whose motion while natural is derived from themselves, for example animals, make this fact clear, for here the uncertainty is not as to whether the motion is derived from something but as to how we ought to distinguish in the thing between the movant and the moved. It would seem that in animals, just as in ships and things not naturally organized, that which causes motion is separate from that which suffers motion, and that it is only in this sense that the animal as a whole causes its own motion. The greatest difficulty, however, is presented by the remaining case of those that we last distinguished. Where things derive their motion from something else, we distinguished the cases in which the motion is unnatural. We are left with those that are to be contrasted with the others by reason of the fact that the motion is natural. It is in these cases that difficulty would be experienced in deciding whence the motion is derived, for example in the case of light and heavy things. When these things are in motion to positions the reverse of those they would properly occupy, their motion is violent. When they are in motion to their proper positions, the light thing up and the heavy thing down, their motion is natural, but in this latter case it is no longer evident, as it is when the motion is unnatural, whence their motion is derived. It is impossible to say that their motion is derived from themselves. This is a characteristic of life and peculiar to living things. Further, if it were, it would have been in their power to stop themselves. I mean that if for example a thing can cause itself to walk, it can also cause itself not to walk, and so, since on this supposition fire itself possesses the power of upward locomotion, it is clear that it should also possess the power of downward locomotion. Moreover, if things move themselves, it would be unreasonable to suppose that in only one kind of motion is their motion derived from themselves. Again, how can anything of continuous and naturally connected substance move itself? In so far as a thing is one and continuous not merely in virtue of contact, it is impassive. It is only in so far as a thing is divided that one part of it is by nature active and another passive. Therefore none of the things that we are now considering move themselves, for they are of naturally connected substance, nor does anything else that is continuous. In each case the movant must be separate from the moved, as we see to be the case with inanimate things when an animate thing moves them. It is the fact that these things also always derive their motion from something. What it is would become evident if we were to distinguish the different kinds of cause. The above-mentioned distinctions can also be made in the case of things that cause motion. Some of them are capable of causing motion unnaturally, for example the lever is not naturally capable of moving the weight, others naturally, for example what is actually hot is naturally capable of moving what is potentially hot, and similarly in the case of all other things of this kind. In the same way, too, what is potentially of a certain quality or of a certain quantity in a certain place is naturally movable when it contains the corresponding principle in itself and not accidentally, for the same thing may be both of a certain quality and of a certain quantity, but the one is an accidental, not an essential property of the other. So when fire or earth is moved by something the motion is violent when it is unnatural, and natural when it brings to actuality the proper activities that they potentially possess. But the fact that the term potentially is used in more than one sense is the reason why it is not evident whence such motions as the upward motion of fire and the downward motion of earth are derived. One who is learning a science potentially knows it in a different sense from one who while already possessing the knowledge is not actually exercising it. Wherever we have something capable of acting and something capable of being correspondingly acted on, in the event of any such pair being in contact, what is potential becomes at times actual. For example, the learner becomes from one potential something another potential something, for one who possesses knowledge of a science but is not actually exercising it knows the science potentially in a sense, though not in the same sense as he knew it potentially before he learnt it. And when he is in this condition, if something does not prevent him, he actively exercises his knowledge, otherwise he would be in the contradictory state of not knowing. In regard to natural bodies also the case is similar. Thus what is cold is potentially hot, then a change takes place and it is fire, and it burns, unless something prevents and hinders it. So, too, with heavy and light, light is generated from heavy, for example air from water, for water is the first thing that is potentially light, and air is actually light, and will at once realize its proper activity as such unless something prevents it. The activity of lightness consists in the light thing being in a certain situation, namely high up. When it is in the contrary situation, it is being prevented from rising. The case is similar also in regard to quantity and quality. But, be it noted, this is the question we are trying to answer: how can we account for the motion of light things and heavy things to their proper situations? The reason for it is that they have a natural tendency respectively towards a certain position, and this constitutes the essence of lightness and heaviness, the former being determined by an upward, the latter by a downward, tendency. As we have said, a thing may be potentially light or heavy in more senses than one. Thus not only when a thing is water is it in a sense potentially light, but when it has become air it may be still potentially light, for it may be that through some hindrance it does not occupy an upper position, whereas, if what hinders it is removed, it realizes its activity and continues to rise higher. The process whereby what is of a certain quality changes to a condition of active existence is similar, thus the exercise of knowledge follows at once upon the possession of it unless something prevents it. So, too, what is of a certain quantity extends itself over a certain space unless something prevents it. The thing in a sense is and in a sense is not moved by one who moves what is obstructing and preventing its motion, for example one who pulls away a pillar from under a roof or one who removes a stone from a wineskin in the water is the accidental cause of motion, and in the same way the real cause of the motion of a ball rebounding from a wall is not the wall but the thrower. So it is clear that in all these cases the thing does not move itself, but it contains within itself the source of motion, not of moving something or of causing motion, but of suffering it. If then the motion of all things that are in motion is either natural or unnatural and violent, and all things whose motion is violent and unnatural are moved by something, and something other than themselves, and again all things whose motion is natural are moved by something, both those that are moved by themselves and those that are not moved by themselves, for example light things and heavy things, which are moved either by that which brought the thing into existence as such and made it light and heavy, or by that which released what was hindering and preventing it, then all things that are in motion must be moved by something. Now this may come about in either of two ways. Either the movement is not itself responsible for the motion, which is to be referred to something else which moves the movement, or the movement is itself responsible for the motion. Further, in the latter case, either the movement immediately precedes the last thing in the series, or there may be one or more intermediate links. For example the stick moves the stone and is moved by the hand, which again is moved by the man. In the man, however, we have reached a movement that is not so in virtue of being moved by something else. Now we say that the thing is moved both by the last and by the first movement in the series, but more strictly by the first, since the first movement moves the last, whereas the last does not move the first, and the first will move the thing without the last, but the last will not move it without the first. For example the stick will not move anything unless it is itself moved by the man. If then everything that is in motion must be moved by something, and the movement must either itself be moved by something else or not, and in the former case there must be some first movement that is not itself moved by anything else, while in the case of the immediate movement being of this kind there is no need of an intermediate movement that is also moved, for it is impossible that there should be an infinite series of movements, each of which is itself moved by something else, since in an infinite series there is no first term. If then everything that is in motion is moved by something, and the first movement is moved but not by anything else, it must be moved by itself. This same argument may also be stated in another way as follows. Every movement moves something and moves it with something, either with itself or with something else. For example a man moves a thing either himself or with a stick, and a thing is knocked down either by the wind itself or by a stone propelled by the wind. But it is impossible for that with which a thing is moved to move it without being moved by that which imparts motion by its own agency. On the other hand, if a thing imparts motion by its own agency, it is not necessary that there should be anything else with which it imparts motion, whereas if there is a different thing with which it imparts motion, there must be something that imparts motion not with something else but with itself, or else there will be an infinite series. If, then, anything is a movement while being itself moved, the series must stop somewhere and not be infinite. Thus, If the stick moves something in virtue of being moved by the hand moves the stick, and if something else moves with the hand also is moved by something different from itself. So when motion by means of an instrument is at each stage caused by something different from the instrument, this must always be preceded by something else which imparts motion with itself. Therefore, if this last movement is in motion and there is nothing else that moves it, it must move itself. So this reasoning also shows that when a thing is moved, if it is not moved immediately by something that moves itself, the series brings us at some time or other to a movement of this kind. And if we consider the matter in yet a third way, we shall get this same result as follows. If everything that is in motion is moved by something that is in motion, either this being in motion is an accidental attribute of the movements in question, so that each of them moves something while being itself in motion, but not always because it is itself in motion, or it is not accidental but an essential attribute. Let us consider the former alternative. If then it is an accidental attribute, it is not necessary that is in motion should be in motion, and if this is so, it is clear that there may be a time when nothing that exists is in motion, since the accidental is not necessary but contingent. Now if we assume the existence of a possibility, any conclusion that we thereby reach will not be an impossibility, though it may be contrary to fact. But the non-existence of motion is an impossibility, for we have shown above that there must always be motion. Moreover, the conclusion to which we have been led is a reasonable one. For there must be three things: the moved, the movant, and the instrument of motion. Now the moved must be in motion, but it need not move anything else. The instrument of motion must both move something else and be itself in motion, for it changes together with the moved, with which it is in contact and continuous, as is clear in the case of things that move other things locally, in which case the two things must up to a certain point be in contact, and the movant, that is to say, that which causes motion in such a manner that it is not merely the instrument of motion, must be unmoved. Now we have visual experience of the last term in this series, namely that which has the capacity of being in motion, but does not contain a motive principle, and also of that which is in motion but is moved by itself and not by anything else. It is reasonable, therefore, not to say necessary, to suppose the existence of the third term also, that which causes motion but is itself unmoved. So, too, Anaxagoras is right when he says that mind is impassive and unmixed, since he makes it the principle of motion, for it could cause motion in this sense only by being itself unmoved, and have supreme control only by being unmixed. We will now take the second alternative. If the movement is not accidentally but necessarily in motion, so that, if it were not in motion, it would not move anything, then the movement, in so far as it is in motion, must be in motion in one of two ways. It is moved either as that is which is moved with the same kind of motion, or with the different kind, either that which is heating, is itself in process of becoming hot, that which is making healthy in process of becoming healthy, and that which is causing locomotion in process of locomotion, or else that which is making healthy is, let us say, in process of locomotion, and that which is causing locomotion in process of, say, increase. But it is evident that this is impossible. For if we adopt the first assumption, we have to make it apply within each of the very lowest species into which motion can be divided. For example, we must say that if someone is teaching some lesson in geometry, he is also in process of being taught that same lesson in geometry, and that if he is throwing, he is in process of being thrown in just the same manner. Or if we reject this assumption, we must say that one kind of motion is derived from another, for example that which is causing locomotion is in process of increase, that which is causing this increase is in process of being altered by something else, and that which is causing this alteration is in process of suffering some different kind of motion. But the series must stop somewhere, since the kinds of motion are limited, and if we say that the process is reversible, and that which is causing alteration is in process of locomotion, we do no more than if we had said at the outset that which is causing locomotion is in process of locomotion, and that one who is teaching is in process of being taught. For it is clear that everything that is moved by the movement that is further back in the series as well as by that which immediately moves it. In fact, the earlier movement is that which more strictly moves it. But this is of course impossible, for it involves the consequence that one who is teaching is in process of learning what he is teaching, whereas teaching necessarily implies possessing knowledge, and learning not possessing it. Still more unreasonable is the consequence involved that, since everything that is moved by something that is itself moved by something else, everything that has a capacity for causing motion has as such a corresponding capacity for being moved, that is, it will have a capacity for being moved in the sense in which one might say that everything that has a capacity for making healthy, and exercises that capacity, has as such a capacity for being made healthy, and that which has a capacity for building has as such a capacity for being built. It will have the capacity for being thus moved either immediately or through one or more links, as it will live, while everything that has a capacity for causing motion has as such a capacity for being moved by something else. The motion that it has the capacity for suffering is not that with which it affects what is next to it, but a motion of a different kind. For example, that which has a capacity for making healthy might as such have a capacity for learn. The series, however, could be traced back, as we said before, until at some time or other we arrived at the same kind of motion. Now the first alternative is impossible, and the second is fantastic. It is absurd that that which has a capacity for causing alteration should as such necessarily have a capacity, let us say, for increase. It is not necessary, therefore, that that which is moved should always be moved by something else that is itself moved by something else, so there will be an end to the series. Consequently the first thing that is in motion will derive its motion either from something that is at rest or from itself. But if there were any need to consider which of the two, that which moves itself or that which is moved by something else, is the cause and principle of motion, everyone would decide the former, for that which is itself independently a cause is always prior as a cause to that which is so only in virtue of being itself dependent upon something else that makes it so. We must therefore make a fresh start and consider the question, if a thing moves itself, in what sense and in what manner does it do so? Now everything that is in motion must be infinitely divisible, for it has been shown already in our general course on physics, that everything that is essentially in motion is continuous. Now it is impossible that that which moves itself should in its entirety move itself, for then, while being specifically one and indivisible, it would as a whole both undergo and cause the same locomotion or alteration. Thus it would at the same time be both teaching and being taught the same thing, or both restoring to and being restored to the same health. Moreover, we have established the fact that it is the movable that is moved, and this is potentially, not actually, in motion, but the potential is in process to actuality, and motion is an incomplete actuality of the movable. The movement on the other hand is already an activity. For example, it is that which is hot that produces heat. In fact, that which produces the form is always something that possesses it. Consequently, if a thing can move itself as a whole, the same thing in respect of the same thing may be at the same time both hot and not hot. So, too, in every other case where the movement must be described by the same name in the same sense as the moved. Therefore when a thing moves itself it is one part of it that is the movement and another part that is moved. But it is not self-moving in the sense that each of the two parts is moved by the other part. The following considerations make this evident. In the first place, if each of the two parts is to move the other, there will be no first movement. If a thing is moved by a series of movements, that which is earlier in the series is more the cause of its being moved than that which comes next, and will be more truly the movement, for we found that there are two kinds of movement, that which is itself moved by something else and that which derives its motion from itself, and that which is further from the thing that is moved is nearer to the principle of motion than that which is intermediate. In the second place, there is no necessity for the movement part to be moved by anything but itself, so it can only be accidentally that the other part moves it in return. I take then the possible case of its not moving it, then there will be a part that is moved and a part that is an unmoved movement. In the third place, there is no necessity for the movement to be moved in return. On the contrary, the necessity that there should always be motion makes it necessary that there should be some movement that is either unmoved or moved by itself. In the fourth place, we should then have a thing undergoing the same motion that it is causing that which is producing heat, therefore, being heated. But as a matter of fact, that which primarily moves itself cannot contain either a single part that moves itself or a number of parts each of which moves itself. For, if the whole is moved by itself, it must be moved either by some part of itself or as a whole by itself as a whole. If, then, it is moved in virtue of some part of it being moved by that part itself, it is this part that will be the primary self-movement, since, if this part is separated from the whole, the part will still move itself, but the whole will do so no longer. If on the other hand the whole is moved by itself as a whole, it must be accidentally that the parts move themselves, and therefore, their self-motion not being necessary, we may take the case of their not being moved by themselves. Therefore in the whole of the thing we may distinguish that which imparts motion without itself being moved and that which is moved, for only in this way is it possible for a thing to be self-moved. Further, if the whole moves itself we may distinguish in it that which imparts the motion and that which is moved, so while we say that AB is moved by itself, we may also say that it is moved by A. And since that which imparts motion may be either a thing that is moved by something else or a thing that is unmoved, and that which is moved may be either a thing that imparts motion to something else or a thing that does not. That which moves itself must be composed of something that is unmoved but imparts motion, and also of something that is moved but does not necessarily impart motion but may or may not do so. Thus let A be something that imparts motion but is unmoved, B something that is moved by A and moves G, G something that is moved by B but moves nothing. Granted that we eventually arrive at G, we may take it that there is only one intermediate term, though there may be more. Then the whole ABG moves itself. But if I take away G, AB will move itself, A imparting motion and B being moved, whereas G will not move itself or in fact be moved at all. Nor again will BG move itself apart from A, for B imparts motion only through being moved by something else, not through being moved by any part of itself. So only AB moves itself. That which moves itself, therefore, must comprise something that imparts motion but is unmoved and something that is moved but does not necessarily move anything else, and each of these two things, or at any rate one of them, must be in contact with the other. If, then, that which imparts motion is a continuous substance, that which is moved must of course be so. It is clear that it is not through some part of the whole being of such a nature as to be capable of moving itself that the whole moves itself. It moves itself as a whole, both being moved and imparting motion through containing a part that imparts motion and a part that is moved. It does not impart motion as a whole, nor is it moved as a whole. It is A alone that imparts motion and B alone that is moved. It is not true, further, that G is moved by A, which is impossible. Here a difficulty arises. If something is taken away from A, supposing that that which imparts motion but is unmoved is a continuous substance, or from B the part that is moved, will the remainder of A continue to impart motion or the remainder of B continue to be moved? If so, it will not be AB primarily that is moved by itself, since, when something is taken away from AB, the remainder of AB will still continue to move itself. Perhaps we may state the case thus: there is nothing to prevent each of the two parts, or at any rate one of them, that which is moved, being divisible though actually undivided, so that if it is divided it will not continue in the possession of the same capacity, and so there is nothing to prevent self-motion residing primarily in things that are potentially divisible. From what has been said, then, it is evident that that which primarily imparts motion is unmoved, for, whether the series is closed at once by that which is in motion but moved by something else deriving its motion directly from the first unmoved, or whether the motion is derived from what is in motion but moves itself and stops its own motion, on both suppositions we have the result that in all cases of things being in motion that which primarily imparts motion is unmoved. Since there must always be motion without intermission, there must necessarily be something, one thing, or it may be a plurality, that first imparts motion, and this first movement must be unmoved. Now the question whether each of the things that are unmoved but impart motion is eternal is irrelevant to our present argument, but the following considerations will make it clear that there must necessarily be some such thing, which, while it has the capacity of moving something else, is itself unmoved and exempt from all change, which can affect it neither in an unqualified nor in an accidental sense. Let us suppose, if anyone likes, that in the case of certain things it is possible for them at different times to be and not to be, without any process of becoming and perishing. In fact, it would seem to be necessary, if a thing that has not parts at one time is and at another time is not, that any such thing should without undergoing any process of change at one time be and at another time not be. And let us further suppose it possible that some principles that are unmoved but capable of imparting motion at one time are and at another time are not. Even so, this cannot be true of all such principles, since there must clearly be something that causes things that move themselves at one time to be and at another not to be. For, since nothing that has not parts can be in motion, that which moves itself must as a whole have magnitude, though nothing that we have said makes this necessarily true of every movement. So the fact that some things become and others perish, and that this is so continuously, cannot be caused by any one of those things that, though they are unmoved, do not always exist, nor again can it be caused by any of those which move certain particular things, while others move other things. The eternity and continuity of the process cannot be caused either by any one of them singly or by the sum of them, because this causal relation must be eternal and necessary, whereas the sum of these movements is infinite and they do not all exist together. It is clear, then, that though there may be countless instances of the perishing of some principles that are unmoved but impart motion, and though many things that move themselves perish and are succeeded by others that come into being, and though one thing that is unmoved moves one thing while another moves another, nevertheless there is something that comprehends them all, and that as something apart from each one of them, And this it is that is the cause of the fact that some things are and others are not, and of the continuous process of change, and this causes the motion of the other movements, while they are the causes of the motion of other things. Motion, then, being eternal, the first movement, if there is but one, will be eternal also. If there are more than one, there will be a plurality of such eternal movements. We ought, however, to suppose that there is one rather than many, and a finite rather than an infinite number. When the consequences of either assumption are the same, we should always assume that things are finite rather than infinite in number, since in things constituted by nature that which is finite and that which is better ought, if possible, to be present rather than the reverse, and here it is sufficient to assume only one movement, the first of unmoved things, which being eternal will be the principle of motion to everything else. The following argument also makes it evident that the first movement must be something that is one and eternal. We have shown that there must always be motion. That being so, motion must also be continuous, because what is always is continuous, whereas what is merely in succession is not continuous. But further, if motion is continuous, it is one, and it is one only if the movement and the moved that constitute it are each of them one, since in the event of the things being moved now by one thing and now by another, the whole motion will not be continuous but successive. Moreover, a conviction that there is a first unmoved something may be reached not only from the foregoing arguments, but also by considering again the principles operative in movements. Now it is evident that among existing things there are some that are sometimes in motion and sometimes at rest. This fact has served above to make it clear that it is not true either that all things are in motion or that all things are at rest, or that some things are always at rest and the remainder always in motion. On this matter proof is supplied by things that fluctuate between the two and have the capacity of being sometimes in motion and sometimes at rest. The existence of things of this kind is clear to all. But we wish to explain also the nature of each of the other two kinds and show that there are some things that are always unmoved and some things that are always in motion. In the course of our argument directed to this end we established the fact that everything that is in motion is moved by something, and that the movement is either unmoved or in motion, and that, if it is in motion, it is moved either by itself or by something else, and so on throughout the series. And so we proceeded to the position that the first principle that directly causes things that are in motion to be moved is that which moves itself, and the first principle of the whole series is the unmoved. Further, it is evident from actual observation that there are things that have the characteristic of moving themselves, for example the animal kingdom and the whole class of living things. This being so, then, the view was suggested that perhaps it may be possible for motion to come to be in a thing without having been in existence at all before, because we see this actually occurring in animals. They are unmoved at one time and then again they are in motion, as it seems. We must grasp the fact, therefore, that animals move themselves only with one kind of motion, and that this is not strictly originated by them. The cause of it is not derived from the animal itself, it is connected with other natural motions in animals, which they do not experience through their own instrumentality, for example increase, decrease, and respiration. These are experienced by every animal while it is at rest and not in motion in respect of the motion set up by its own agency. Here the motion is caused by the atmosphere and by many things that enter into the animal. Thus in some cases the cause is nourishment. When it is being digested animals sleep, and when it is being distributed through the system they awake and move themselves, the first principle of this motion being thus originally derived from outside. Therefore animals are not always in continuous motion by their own agency, it is something else that moves them, itself being in motion and changing as it comes into relation with each several thing that moves itself. Moreover, in all these self-moving things the first movement and cause of their self-motion is itself moved by itself, though in an accidental sense, that is to say, the body changes its place, so that that which is in the body changes its place also and is a self-movement through its exercise of leverage. Hence we may confidently conclude that if a thing belongs to the class of unmoved movements that are also themselves moved accidentally, it is impossible that it should cause continuous motion. So the necessity that there should be motion continuously requires that there should be a first movement that is unmoved even accidentally, if, as we have said, there is to be in the world of things an unceasing and undying motion, and the world is to remain permanently self-contained and within the same limits, for if the first principle is permanent, the universe must also be permanent, since it is continuous with the first principle. We must distinguish, however, between accidental motion of a thing by itself and such motion by something else, the former being confined to perishable things, whereas the latter belongs also to certain first principles of heavenly bodies, of all those, that is to say, that experience more than one locomotion. And further, if there is always something of this nature, a movement that is itself unmoved and eternal, then that which is first moved by it must be eternal. Indeed, this is clear also from the consideration that there would otherwise be no becoming and perishing and no change of any kind in other things, which require something that is in motion to move them, for the motion imparted by the unmoved will always be imparted in the same way and be one and the same, since the unmoved does not itself change in relation to that which is moved by it. But that which is moved by something that, though it is in motion, is moved directly by the unmoved stands in varying relations to the things that it moves, so that the motion that it causes will not be always the same, by reason of the fact that it occupies contrary positions or assumes contrary forms at different times. It will produce contrary motions in each several thing that it moves and will cause it to be at one time at rest and at another time in motion. The foregoing argument, then, has served to clear up the point about which we raised a difficulty at the outset. Why is it that instead of all things being either in motion or at rest, or some things being always in motion and the remainder always at rest, there are things that are sometimes in motion and sometimes not? The cause of this is now plain. It is because, while some things are moved by an eternal unmoved movement and are therefore always in motion, other things are moved by a movement that is in motion and changing, so that they too must change. But the unmoved movement, as has been said, since it remains permanently simple and unvarying and in the same state, will cause motion that is one and simple. This matter will be made clearer, however, if we start afresh from another point. We must consider whether it is or is not possible that there should be a continuous motion, and, if it is possible, which this motion is, and which is the primary motion, for it is plain that if there must always be motion, and a particular motion is primary and continuous, then it is this motion that is imparted by the first movement, and so it is necessarily one and the same and continuous and primary. Now of the three kinds of motion that there are: motion in respect of magnitude, motion in respect of affection, and motion in respect of place, it is this last, which we call locomotion, that must be primary. This may be shown as follows. It is impossible that there should be increase without the previous occurrence of alteration, for that which is increased, although in a sense it is increased by what is like itself, is in a sense increased by what is unlike itself. Thus it is said that contrary is nourishment to contrary, but growth is effected only by things becoming like to like. There must be alteration, then, in that there is this change from contrary to contrary. But the fact that a thing is altered requires that there should be something that alters it, something for example that makes the potentially hot into the actually hot, so it is plain that the movement does not maintain a uniform relation to it but is at one time nearer to and at another farther from that which is altered, and we cannot have this without locomotion. If, therefore, there must always be motion, there must also always be locomotion as the primary motion, and, if there is a primary as distinguished from a secondary form of locomotion, it must be the primary form. Again, all affections have their origin in condensation and rarefaction. Thus heavy and light, soft and hard, hot and cold, are considered to be forms of density and rarity. But condensation and rarefaction are nothing more than combination and separation, processes in accordance with which substances are said to become and perish, and in being combined and separated things must change in respect of place. And further, when a thing is increased or decreased its magnitude changes in respect of place. Again, there is another point of view from which it will be clearly seen that locomotion is primary. As in the case of other things, so too in the case of motion the word primary may be used in several senses. A thing is said to be prior to other things when, if it does not exist, the others will not exist, whereas it can exist without the others, and there is also priority in time and priority in perfection of existence. Let us begin, then, with the first sense. Now there must be motion continuously, and there may be continuously either continuous motion or successive motion. The former, however, in a higher degree than the latter. Moreover, it is better that it should be continuous rather than successive motion, and we always assume the presence in nature of the better, if it be possible, since, then, continuous motion is possible. This will be proved later. For the present let us take it for granted, and no other motion can be continuous except locomotion. Locomotion must be primary. For there is no necessity for the subject of locomotion to be the subject either of increase or of alteration, nor need it become or perish. On the other hand, there cannot be any one of these processes without the existence of the continuous motion imparted by the first movement. Secondly, locomotion must be primary in time, for this is the only motion possible for things. It is true indeed that, in the case of any individual thing that has a becoming, locomotion must be the last of its motions, for after its becoming it first experiences alteration and increase, and locomotion is a motion that belongs to such things only when they are perfected. But there must previously be something else that is in process of locomotion to be the cause even of the becoming of things that become, without itself being in process of becoming. As for example, the begotten is preceded by what begot it, otherwise becoming might be thought to be the primary motion on the ground that the thing must first become. But though this is so in the case of any individual thing that becomes, nevertheless before anything becomes, something else must be in motion, not itself becoming but being, and before this there must again be something else. And since becoming cannot be primary, for, if it were, everything that is in motion would be perishable, it is plain that no one of the motions next in order can be prior to locomotion. By the motions next in order I mean increase and then alteration, decrease, and perishing. All these are posterior to becoming, consequently, if not even becoming is prior to locomotion, then no one of the other processes of change is so either. Thirdly, that which is in process of becoming appears universally as something imperfect and proceeding to a first principle, and so what is posterior in the order of becoming is prior in the order of nature. Now all things that go through the process of becoming acquire locomotion last. It is this that accounts for the fact that some living things, for example plants and many kinds of animals, owing to lack of the requisite organ, are entirely without motion, whereas others acquire it in the course of their being perfected. Therefore, if the degree in which things possess locomotion corresponds to the degree in which they have realized their natural development, then this motion must be prior to all others in respect of perfection of existence, and not only for this reason but also because a thing that is in motion loses its essential character less in the process of locomotion than in any other kind of motion. It is the only motion that does not involve a change of being in the sense in which there is a change in quality when a thing is altered and a change in quantity when a thing is increased or decreased. Above all, it is plain that this motion in respect of place, is what is in the strictest sense produced by that which moves itself, but it is the self-movement that we declare to be the first principle of things that are moved and impart motion and the primary source to which things that are in motion are to be referred. It is clear, then, from the foregoing arguments that locomotion is the primary motion. We have now to show which kind of locomotion is primary. The same process of reasoning will also make clear at the same time the truth of the assumption we have made both now and at a previous stage that it is possible that there should be a motion that is continuous and eternal. Now it is clear from the following considerations that no other than locomotion can be continuous. Every other motion and changes from an opposite to an opposite, thus for the processes of becoming and perishing the limits of the existent and the non-existent, for alteration the various pairs of contrary affections, and for increase and decrease either greatness and smallness or perfection and imperfection of magnitude, and changes to the respective contraries are contrary changes. Now a thing that is undergoing any particular kind of motion, but though previously existent has not always undergone it, must previously have been at rest so far as that motion is concerned. It is clear, then, that for the changing thing the contraries will be states of rest. And we have a similar result in the case of changes that are not motions, for becoming and perishing, whether regarded simply as such without qualification or as affecting something in particular, are opposites. Therefore, provided it is impossible for a thing to undergo opposite changes at the same time, the change will not be continuous, but a period of time will intervene between the opposite processes. The question whether these contradictory changes are contraries or not makes no difference, provided only it is impossible for them both to be present to the same thing at the same time. The point is of no importance to the argument. Nor does it matter if the thing need not rest in the contradictory state, or if there is no state of rest as a contrary to the process of change. It may be true that the non-existent is not at rest, and that perishing is a process to the non-existent. All that matters is the intervention of a time. It is this that prevents the change from being continuous. So, too, in our previous instances the important thing was not the relation of contrariety but the impossibility of the two processes being present to a thing at the same time. And there is no need to be disturbed by the fact that on this showing there may be more than one contrary to the same thing, that a particular motion will be contrary both to rest and to motion in the contrary direction. We have only to grasp the fact that a particular motion is in a sense the opposite both of a state of rest and of the contrary motion, in the same way as that which is of equal or standard measure is the opposite both of that which surpasses it and of that which it surpasses, and that it is impossible for the opposite motions or changes to be present to a thing at the same time. Furthermore, in the case of becoming and perishing it would seem to be an utterly absurd thing if as soon as anything has become it must necessarily perish and cannot continue to exist for any time, and, if this is true of becoming and perishing, we have fair grounds for inferring the same to be true of the other kinds of change, since it would be in the natural order of things that they should be uniform in this respect. Let us now proceed to maintain that it is possible that there should be an infinite motion that is single and continuous, and that this motion is rotatory motion. The motion of everything that is in process of locomotion is either rotatory or rectilinear or a compound of the two. Consequently, if one of the former two is not continuous, that which is composed of them both cannot be continuous either. Now it is plain that if the locomotion of a thing is rectilinear and finite, it is not continuous locomotion, for the thing must turn back, and that which turns back in a straight line undergoes two contrary locomotions, since, so far as motion in respect of place is concerned, upward motion is the contrary of downward motion, forward motion of backward motion, and motion to the left of motion to the right, these being the pairs of contraries in the sphere of place. But we have already defined single and continuous motion to be motion of a single thing in a single period of time and operating within a sphere admitting of no further specific differentiation, for we have three things to consider: first, that which is in motion, for example a man or a god; secondly, the when of the motion, that is to say, the time; and thirdly, the sphere within which it operates, which may be either place or affection or essential form or magnitude, and contraries are specifically not one and the same but distinct, and within the sphere of place we have the above-mentioned distinctions. Moreover, we have an indication that motion from A to B is the contrary of motion from B to A in the fact that, if they occur at the same time, they arrest and stop each other. And the same is true in the case of a circle. The motion from A towards B is the contrary of the motion from A towards G, for even if they are continuous and there is no turning back, they arrest each other, because contraries annihilate or obstruct one another. On the other hand, lateral motion is not the contrary of upward motion. But what shows most clearly that rectilinear motion cannot be continuous is the fact that turning back necessarily implies coming to a stand, not only when it is a straight line that is traversed, but also in the case of locomotion in a circle, which is not the same thing as rotatory locomotion, for, when a thing merely traverses a circle, it may either proceed on its course without a break or turn back again when it has reached the same point from which it started. We may assure ourselves of the necessity of this coming to a stand not only on the strength of observation, but also on theoretical grounds. We may start as follows: we have 3 points, starting point, middle point, and finishing point, of which the middle point in virtue of the relations in which it stands severally to the other two is both a starting point and a finishing point, and though numerically 1 is theoretically 2. We have further the distinction between the potential and the actual. So in the straight line in question, any one of the points lying between the two extremes is potentially a middle point, but it is not actually so unless that which is in motion divides the line by coming to a stand at that point and beginning its motion again. Thus the middle point becomes both a starting point and a goal, the starting point of the latter part and the finishing point of the first part of the motion. This is the case, for example, when A in the course of its locomotion comes to a stand at B and starts again towards G. But when its motion is continuous, A cannot either have come to B or have ceased to be at the point B, it can only have been there at the moment of passing, its passage not being contained within any period of time except the whole of which the particular moment is a dividing point. To maintain that it has come to be and ceased to be there will involve the consequence that A in the course of its locomotion will always be coming to a stand, for it is impossible that A should simultaneously have come to be at B and ceased to be there, so that the two things must have happened at different points of time, and therefore there will be the intervening period of time. Consequently A will be in a state of rest at B, and similarly at all other points, since the same reasoning holds good in every case. When to A, that which is in process of locomotion, B, the middle point, serves both as a finishing point and as a starting point for its motion, A must come to a stand at B, because it makes it 2 just as one might do in thought. However, the point A is the real starting point at which the moving body has ceased to be, and it is at G that it has really come to be when its course is finished and it comes to a stand. So this is how we must meet the difficulty that then arises, which is as follows. Suppose the line E is equal to the line Z, that A proceeds in continuous locomotion from the extreme point of E to G, and that, at the moment when A is at the point B, D is proceeding in uniform locomotion and with the same velocity as A from the extremity of Z to H. Then, says the argument, D will have reached H before A has reached G, for that which makes an earlier start and departure must make an earlier arrival. The reason, then, for the late arrival of A is that it has not simultaneously come to B and ceased to be at B, otherwise it will not arrive later. For this to happen it will be necessary that it should come to a stand there. Therefore we must not hold that there was a moment when A came to be at B and that at the same moment D was in motion from the extremity of Z, for the fact of A's having come to be at B will involve the fact of its also ceasing to be there, and the two events will not be simultaneous, whereas the truth is that A is at B at a sectional point of time and does not occupy time there. In this case, therefore, where the motion of a thing is continuous, it is impossible to use this form of expression. On the other hand, in the case of a thing that turns back in its course, we must do so. For suppose h in the course of its locomotion proceeds to d and then turns back and proceeds downwards again, then the extreme point d has served as finishing point and as starting point for it, one point thus serving as 2, therefore h must have come to a stand there, it cannot have come to be at d and departed from d simultaneously, for in that case it would simultaneously be there and not be there at the same moment. And here we cannot apply the argument used to solve the difficulty stated above. We cannot argue that h is at d at a sectional point of time and has not come to be or ceased to be there. For here the goal that is reached is necessarily one that is actually, not potentially, existent. Now the point in the middle is potential, but this one is actual, and regarded from below it is a finishing point, while regarded from above it is a starting point, so that it stands in these same two respective relations to the two motions. Therefore that which turns back in traversing a rectilinear course must in so doing come to a stand. Consequently there cannot be a continuous rectilinear motion that is eternal. The same method should also be adopted in replying to those who ask, in the terms of Zeno's argument, whether we admit that before any distance can be traversed half the distance must be traversed, that these half distances are infinite in number, and that it is impossible to traverse distances infinite in number, or some on the lines of this same argument put the questions in another form, and would have us grant that in the time during which a motion is in progress it should be possible to reckon a half motion before the whole for every half distance that we get, so that we have the result that when the whole distance is traversed we have reckoned an infinite number, which is admittedly impossible. Now when we first discussed the question of motion we put forward a solution of this difficulty turning on the fact that the period of time occupied in traversing the distance contains within itself an infinite number of units. There is no absurdity, we said, in supposing the traversing of infinite distances in infinite time, and the element of infinity is present in the time no less than in the distance. But, although this solution is adequate as a reply to the questioner, the question asked being whether it is possible in a finite time to traverse or reckon an infinite number of units, nevertheless as an account of the fact and explanation of its true nature it is inadequate. For suppose the distance to be left out of account and the question asked to be no longer whether it's possible in a finite time to traverse an infinite number of distances, and suppose that the inquiry is made to refer to the time taken by itself, for the time contains an infinite number of divisions, then this solution will no longer be adequate, and we must apply the truth that we enunciated in our recent discussion, stating it in the following way. In the act of dividing the continuous distance into two halves one point is treated as 2, since we make it a starting point and a finishing point, and the same result is also produced by the act of reckoning halves as well as by the act of dividing into halves. But if divisions are made in this way, neither the distance nor the motion will be continuous, for motion if it is to be continuous must relate to what is continuous, and though what is continuous contains an infinite number of halves, they are not actual but potential halves. If the halves are made actual, we shall get not a continuous but an intermittent motion. In the case of reckoning the halves, it is clear that this result follows, for then one point must be reckoned as 2, it will be the finishing point of the one half and the starting point of the other, if we reckon not the one continuous whole but the two halves. Therefore to the question whether it is possible to pass through an infinite number of units either of time or of distance we must reply that in a sense it is and in a sense it is not. If the units are actual, it is not possible, if they are potential, it is possible. For in the course of a continuous motion the traveler has traversed an infinite number of units in an accidental sense but not in an unqualified sense, for though it is an accidental characteristic of the distance to be an infinite number of half distances, this is not its real and essential character. It is also plain that unless we hold that the point of time that divides earlier from later always belongs only to the later so far as the thing is concerned, we shall be involved in the consequence that the same thing is at the same moment existent and not existent, and that a thing is not existent at the moment when it has become. It is true that the point is common to both times, the earlier as well as the later, and that, while numerically one and the same, it is theoretically not so, being the finishing point of the one and the starting point of the other, but so far as the thing is concerned it belongs to the later stage of what happens to it. Let us suppose a time A B G and a thing D, D being white in the time A and not white in the time B. Then D is at the moment G white and not white, for if we were right in saying that it is white during the whole time A, it is true to call it white at any moment of A, and not white in B. And G is in both A and B. We must not allow, therefore, that it is white in the whole of A, but must say that it is so in all of it except the last moment G. G belongs already to the later period, and if in the whole of A not white was in process of becoming and white of perishing, at G the process is complete. and so G is the first moment at which it is true to call the thing white or not white respectively. Otherwise a thing may be non-existent at the moment when it has become and existent at the moment when it has perished, or else it must be possible for a thing at the same time to be white and not white and in fact to be existent and non-existent. Further, if anything that exists after having been previously non-existent must become existent and does not exist when it is becoming, time cannot be divisible into time atoms. For suppose that D was becoming white in the time A and that at another time B, a time atom consecutive with the last atom of A, D has already become white and so is white at that moment, then, inasmuch as in the time it was becoming white and so was not white and at the moment B it is white, there must have been a becoming between A and B and therefore also a time in which the becoming took place. On the other hand, those who deny atoms of time, as we do, are not affected by this argument. According to them D has become and so is white at the last point of the actual time in which it was becoming white, and this point has no other point consecutive with or in succession to it, whereas time atoms are conceived as successive. Moreover, it is clear that if D was becoming white in the whole time A, the time occupied by it in having become white in addition to having been in process of becoming white is no more than all that it occupied in the mere process of becoming white. These and such like, then, are the arguments for our conclusion that derive cogency from the fact that they have a special bearing on the point at issue. If we look at the question from the point of view of general theory, the same result would also appear to be indicated by the following arguments. Everything whose motion is continuous must, on arriving at any point in the course of its locomotion, have been previously also in process of locomotion to that point, if it is not forced out of its path by anything. For example, on arriving at B a thing must also have been in process of locomotion to B, and that not merely when it was near to B, but from the moment of its starting on its course, since there can be no reason for its being so at any particular stage rather than at an earlier one. So, too, in the case of the other kinds of motion. Now we are to suppose that a thing proceeds in locomotion from A to G and that at the moment of its arrival at G the continuity of its motion is unbroken and will remain so until it has arrived back at A. Then when it is undergoing locomotion from A to G it is at the same time undergoing also its locomotion to A from G, consequently it is simultaneously undergoing two contrary motions, since the two motions that follow the same straight line are contrary to each other. With this consequence there also follows another. We have a thing that is in process of change from a position in which it has not yet been, so, inasmuch as this is impossible, the thing must come to a stand at G. Therefore the motion is not a single motion, since motion that is interrupted by stationariness is not single. Further, the following argument will serve better to make this point clear universally in respect of every kind of motion. If the motion undergone by that which is in motion is always one of those already enumerated, and the state of rest that it undergoes is one of those that are the opposites of the motions, for we found that there could be no other besides these, and moreover that which is undergoing but does not always undergo a particular motion, by this I mean one of the various specifically distinct motions, not some particular part of the whole motion, must have been previously undergoing the state of rest that is the opposite of the motion, the state of rest being privation of motion. Then, inasmuch as the two motions that follow the same straight line are contrary motions, and it is impossible for a thing to undergo simultaneously two contrary motions, that which is undergoing locomotion from A to G cannot also simultaneously be undergoing locomotion from G to A, and since the latter locomotion is not simultaneous with the former but is still to be undergone, before it is undergone there must occur a state of rest at G, for this, as we found, is the state of rest that is the opposite of the motion from G. The foregoing argument, then, makes it plain that the motion in question is not continuous. Our next argument has a more special bearing than the foregoing on the point at issue. We will suppose that there has occurred in something simultaneously a perishing of not white and a becoming of white. Then if the alteration to white and from white is a continuous process and the white does not remain any time, there must have occurred simultaneously a perishing of not white, a becoming of white, and a becoming of not white, for the time of the three will be the same. Again, from the continuity of the time in which the motion takes place we cannot infer continuity in the motion, but only successiveness. In fact, how could contraries, for example whiteness and blackness, meet in the same extreme point? On the other hand, in motion on a circular line we shall find singleness and continuity, for here we are met by no impossible consequence. That which is in motion from A will in virtue of the same direction of energy be simultaneously in motion to A, since it is in motion to the point at which it will finally arrive, and yet will not be undergoing two contrary or opposite motions, for a motion to a point and a motion from that point are not always contraries or opposites. They are contraries only if they are on the same straight line, for then they are contrary to one another in respect of place, as for example the two motions along the diameter of the circle, since the ends of this are at the greatest possible distance from one another, and they are opposites only if they are along the same line. Therefore in the case we are now considering there is nothing to prevent the motion being continuous and free from all intermission, for rotatory motion is motion of a thing from its place to its place, whereas rectilinear motion is motion from its place to another place. Moreover, the progress of rotatory motion is never localized within certain fixed limits, whereas that of rectilinear motion repeatedly is so. Now a motion that is always shifting its ground from moment to moment can be continuous, but a motion that is repeatedly localized within certain fixed limits cannot be so, since then the same thing would have to undergo simultaneously two opposite motions. So, too, there cannot be continuous motion in a semicircle or in any other arc of a circle, since here also the same ground must be traversed repeatedly and two contrary processes of change must occur. The reason is that in these motions the starting point and the termination do not coincide, whereas in motion over a circle they do coincide, and so this is the only perfect motion. This differentiation also provides another means of showing that the other kinds of motion cannot be continuous either, for in all of them we find that there is the same ground to be traversed repeatedly. Thus in alteration there are the intermediate stages of the process, and in quantitative change there are the intervening degrees of magnitude, and in becoming and perishing the same thing is true. It makes no difference whether we take the intermediate stages of the process to be few or many, or whether we add or subtract one, for in either case we find that there is still the same ground to be traversed repeatedly. Moreover, it is plain from what has been said that those physicists who assert that all sensible things are always in motion are wrong, for their motion must be one or other of the motions just mentioned. In fact, they mostly conceive it as alteration. Things are always in flux and decay, they say, and they go so far as to speak even of becoming and perishing as a process of alteration. On the other hand, our argument has enabled us to assert the fact, applying universally to all motions, that no motion admits of continuity except rotatory motion, consequently neither alteration nor increase admits of continuity. We need now say no more in support of the position that there is no process of change that admits of infinity or continuity except rotatory locomotion. It can now be shown plainly that rotation is the primary locomotion. Every locomotion, as we said before, is either rotatory or rectilinear or a compound of the two, and the two former must be prior to the last, since they are the elements of which the latter consists. Moreover, rotatory locomotion is prior to rectilinear locomotion, because it is more simple and complete, which may be shown as follows. The straight line traversed in rectilinear motion cannot be infinite, for there is no such thing as an infinite straight line, and even if there were, it would not be traversed by anything in motion, for the impossible does not happen and it is impossible to traverse an infinite distance. On the other hand, rectilinear motion on a finite straight line is if it turns back a composite motion, in fact two motions, while if it does not turn back it is incomplete and perishable, and in the order of nature, of definition, and of time alike the complete is prior to the incomplete and the imperishable to the perishable. Again, a motion that admits of being eternal is prior to one that does not. Now rotatory motion can be eternal, but no other motion, whether locomotion or motion of any other kind, can be so, since in all of them rest must occur and with the occurrence of rest the motion has perished. Moreover, the result at which we have arrived, that rotatory motion is single and continuous, and rectilinear motion is not, is a reasonable one. In rectilinear motion we have a definite starting point, finishing point, middle point, which all have their place in it in such a way that there is a point from which that which is in motion can be said to start and a point at which it can be said to finish its course, for when anything is at the limits of its course, whether at the starting point or at the finishing point, it must be in a state of rest. On the other hand, in circular motion there are no such definite points, for why should any one point on the line be a limit rather than any other? Any one point as much as any other is alike starting point, middle point, and finishing point, so that we can say of certain things both that they are always and that they never are at a starting point and at a finishing point, so that a revolving sphere, while it is in motion, is also in a sense at rest, for it continues to occupy the same place. The reason of this is that in this case all these characteristics belong to the center, that is to say, the center is alike starting point, middle point, and finishing point of the space traversed. Consequently, since this point is not a point on the circular line, there is no point at which that which is in process of locomotion can be in a state of rest as having traversed its course, because in its locomotion it is proceeding always about a central point and not to an extreme point, therefore it remains still, and the whole is in a sense always at rest as well as continuously in motion. Our next point gives a convertible result. On the one hand, Because rotation is the measure of motions, it must be the primary motion, for all things are measured by what is primary. On the other hand, because rotation is the primary motion, it is the measure of all other motions. Again, rotatory motion is also the only motion that admits of being regular. In rectilinear locomotion, the motion of things in leaving the starting point is not uniform with their motion in approaching the finishing point, since the velocity of a thing always increases proportionately as it removes itself farther from its position of rest. On the other hand, rotatory motion is the only motion whose course is naturally such that it has no starting point or finishing point in itself but is determined from elsewhere. As to locomotion being the primary motion, this is a truth that is attested by all who have ever made mention of motion in their theories. They all assign their first principles of motion to things that impart motion of this kind. Thus separation and combination are motions in respect of place, and the motion imparted by love and strife takes these forms, the latter separating and the former combining. Anaxagoras, too, says that mind, his first movement, separates. Similarly, those who assert no cause of this kind but say that void accounts for motion, they also hold that the motion of natural substance is motion in respect of place, for their motion that is accounted for by void is locomotion, and its sphere of operation may be said to be place. Moreover, they are of opinion that the primary substances are not subject to any of the other motions, though the things that are compounds of these substances are so subject. The processes of increase and decrease and alteration, they say, are effects of the combination and separation of atoms. It is the same, too, with those who make out that the becoming or perishing of a thing is accounted for by density or rarity, for it is by combination and separation that the place of these things in their systems is determined. Moreover, to these we may add those who make soul the cause of motion, for they say that things that undergo motion have as their first principle that which moves itself, and when animals and all living things move themselves, the motion is motion in respect of place. Finally, it is to be noted that we say that a thing is in motion in the strict sense of the term only when its motion is motion in respect of place. If a thing is in process of increase or decrease or is undergoing some alteration while remaining at rest in the same place, we say that it is in motion in some particular respect. We do not say that it is in motion without qualification. Our present position, then, is this: we have argued that there always was motion and always will be motion throughout all time. And we have explained what is the first principle of this eternal motion. We have explained further which is the primary motion and which is the only motion that can be eternal, and we have pronounced the first movement to be unmoved. We have now to assert that the first movement must be without parts and without magnitude, beginning with the establishment of the premises on which this conclusion depends. One of these premises is that nothing finite can cause motion during an infinite time. We have three things: the movement, the moved, and thirdly that in which the motion takes place, namely the time. And these are either all infinite or all finite, or partly, that is to say two of them or one of them finite and partly infinite. Let A be the movement, B the moved, and G the infinite time. Now let us suppose that D moves E, a part of B. Then the time occupied by this motion cannot be equal to G, for the greater the amount moved, the longer the time occupied. It follows that the time Z is not infinite. Now we see that by continuing to add to D, I shall use up A, and by continuing to add to E, I shall use up B, but I shall not use up the time by continually subtracting a corresponding amount from it, because it is infinite. Consequently, the duration of the part of G which is occupied by all A in moving the whole of B, will be finite. Therefore a finite thing cannot impart to anything an infinite motion. It is clear, then, that it is impossible for the finite to cause motion during an infinite time. It has now to be shown that in no case is it possible for an infinite force to reside in a finite magnitude. This can be shown as follows. We take it for granted that the greater force is always that which in less time than another does an equal amount of work when engaged in any activity in heating, for example, or sweetening or throwing, in fact, in causing any kind of motion. Then that on which the forces act must be affected to some extent by our supposed finite magnitude possessing an infinite force as well as by anything else, in fact to a greater extent than by anything else, since the infinite force is greater than any other. But then there cannot be any time in which its action could take place. Suppose that A is the time occupied by the infinite power in the performance of an act of heating or pushing, and that AB is the time occupied by a finite power in the performance of the same act. Then by adding to the latter another finite power and continually increasing the magnitude of the power so added, I shall at some time or other reach a point at which the finite power has completed the motive act in the time A. For by continual addition to a finite magnitude I must arrive at a magnitude that exceeds any assigned limit, and in the same way by continual subtraction I must arrive at one that falls short of any assigned limit. So we get the result that the finite force will occupy the same amount of time in performing the motive act as the infinite force. But this is impossible. Therefore nothing finite can possess an infinite force. So it is also impossible for a finite force to reside in an infinite magnitude. It is true that a greater force can reside in a lesser magnitude, but the superiority of any such greater force can be still greater if the magnitude in which it resides is greater. Now let AB be an infinite magnitude. Then BG possesses a certain force that occupies a certain time, let us say the time Z in moving D. Now if I take a magnitude twice as great at BG, the time occupied by this magnitude in moving D will be half of is, assuming this to be the proportion, so we may call this time ZH. That being so, by continually taking a greater magnitude in this way I shall never arrive at the full AB, whereas I shall always be getting a lesser fraction of the time given. Therefore the force must be infinite, since it exceeds any finite force. Moreover the time occupied by the action of any finite force must also be finite, for if a given force moves something in a certain time, a greater force will do so in a lesser time, but still a definite time, in inverse proportion. But a force must always be infinite just as a number or a magnitude is if it exceeds all definite limits. This point may also be proved in another way by taking a finite magnitude in which there resides a force the same in kind as that which resides in the infinite magnitude, so that this force will be a measure of the finite force residing in the infinite magnitude. It is plain, then, from the foregoing arguments that it is impossible for an infinite force to reside in a finite magnitude or for a finite force to reside in an infinite magnitude. But before proceeding to our conclusion it will be well to discuss a difficulty that arises in connection with locomotion. If everything that is in motion with the exception of things that move themselves is moved by something else, how is it that some things, for example things thrown, continue to be in motion when their movement is no longer in contact with them? If we say that the movement in such cases moves something else at the same time, that the thrower for example also moves the air, and that this in being moved is also a movement, then it would be no more possible for this second thing than for the original thing to be in motion when the original movement is not in contact with it or moving it. All the things moved would have to be in motion simultaneously and also to have ceased simultaneously to be in motion when the original movement ceases to move them, even if, like the magnet, it makes that which it has moved capable of being a movement. Therefore, while we must accept this explanation to the extent of saying that the original movement gives the power of being a movement either to air or to water or to something else of the kind, naturally adapted for imparting and undergoing motion, we must say further that this thing does not cease simultaneously to impart motion and to undergo motion. It ceases to be in motion at the moment when its movement ceases to move it. But it still remains a movement, and so it causes something else consecutive with it to be in motion, and of this again the same may be said. The motion begins to cease when the motive force produced in one member of the consecutive series is at each stage less than that possessed by the preceding member, and it finally ceases when one member no longer causes the next member to be a movement but only causes it to be in motion. The motion of these last two of the one as movement and of the other as moved must cease simultaneously, and with this the whole motion ceases. Now the things in which this motion is produced are things that admit of being sometimes in motion and sometimes at rest. And the motion is not continuous but only appears so, for it is motion of things that are either successive or in contact, there being not one movement but number of movements consecutive with one another, and so motion of this kind takes place in air and water. Some say that it is mutual replacement, but we must recognize that the difficulty raised cannot be solved otherwise than in the way we have described. So far as they are affected by mutual replacement, all the members of the series are moved and impart motion simultaneously, so that their motions also cease simultaneously, but our present problem concerns the appearance of continuous motion in a single thing, and therefore, since it cannot be moved throughout its motion by the same movement, the question is, what moves it? Resuming our main argument, we proceed from the positions that there must be continuous motion in the world of things, that this is a single motion, that a single motion must be a motion of a magnitude, for that which is without magnitude cannot be in motion, and that the magnitude must be a single magnitude moved by a single movement, for otherwise there will not be continuous motion but a consecutive series of separate motions, and that if the movement is a single thing, it is either itself in motion or itself unmoved. If, then, it is in motion, it will have to be subject to the same conditions as that which it moves, that is to say it will itself be in process of change and in being so will also have to be moved by something, so we have a series that must come to an end, and a point will be reached at which motion is imparted by something that is unmoved. Thus we have a movement that has no need to change along with that which it moves but will be able to cause motion always, for the causing of motion under these conditions involves no effort, and this motion alone is regular, or at least it is so in a higher degree than any other, since the movement is never subject to any change. So, too, in order that the motion may continue to be of the same character, the moved must not be subject to change in respect of its relation to the movement. Moreover, the movement must occupy either the center or the circumference, since these are the first principles from which a sphere is derived. But the things nearest the movement are those whose motion is quickest, and in this case it is the motion of the circumference that is the quickest, therefore the movement occupies the circumference. There is a further difficulty in supposing it to be possible for anything that is in motion to cause motion continuously and not merely in the way in which it is caused by something repeatedly pushing, in which case the continuity amounts to no more than successiveness. Such a movement must either itself continue to push or pull or perform both these actions, or else the action must be taken up by something else and be passed on from one movement to another, the process that we described before as occurring in the case of things thrown, since the air or the water, being divisible, is a movement only in virtue of the fact that different parts of the air are moved one after another, and in either case the motion cannot be a single motion, but only a consecutive series of motions. The only continuous motion, then, is that which is caused by the unmoved movement, and this motion is continuous because the movement remains always invariable, so that its relation to that which it moves remains also invariable and continuous. Now that these points are settled, it is clear that the first unmoved movement cannot have any magnitude. For if it has magnitude, this must be either a finite or an infinite magnitude. Now we have already proved in our course on physics that there cannot be an infinite magnitude, and we have now proved that it is impossible for a finite magnitude to have an infinite force, and also that it is impossible for a thing to be moved by a finite magnitude during an infinite time. But the first movement causes a motion that is eternal and does cause it during an infinite time. It is clear, therefore, that the first movement is indivisible and is without parts and without magnitude. On the Heavens, Book I, translated by J. L. Stokes. The science which has to do with nature clearly concerns itself for the most part with bodies and magnitudes and their properties and movements, but also with the principles of this sort of substance, as many as they may be. For of things constituted by nature some are bodies and magnitudes, some possess body and magnitude, and some are principles of things which possess these. Now a continuum is that which is divisible into parts always capable of subdivision, and a body is that which is every way divisible. A magnitude if divisible one way is a line, if two ways a surface, and if three a body. Beyond these there is no other magnitude, because the three dimensions are all that there are, and that which is divisible in three directions is divisible in all. For, as the Pythagoreans say, the world and all that is in it is determined by the number 3, since beginning and middle and end give the number of an all, and the number they give is the triad. And so, having taken these three from nature as, so to speak, laws of it, we make further use of the number 3 in the worship of the gods. Further, we use the terms in practice in this way. Of two things, or men, we say both, but not all. 3 is the first number to which the term all has been appropriated. And in this, as we have said, we do but follow the lead which nature gives. Therefore, since every and all and complete do not differ from one another in respect of form, but only, if at all, in their matter and in that to which they are applied, body alone among magnitudes can be complete. For it alone is determined by the three dimensions, that is an all. But if it is divisible in three dimensions it is every way divisible, while the other magnitudes are divisible in one dimension or in two alone, for the divisibility and continuity of magnitudes depend upon the number of the dimensions, one sort being continuous in one direction, another in two, another in all. All magnitudes, then, which are divisible are also continuous. Whether we can also say that whatever is continuous is divisible does not yet, on our present grounds, appear. One thing, however, is clear. We cannot pass beyond body to a further kind, as we passed from length to surface, and from surface to body. For if we could, it would cease to be true that body is complete magnitude. We could pass beyond it only in virtue of a defect in it, and that which is complete cannot be defective, since it is being in every respect. Now bodies which are classed as parts of the whole are each complete according to our formula, since each possesses every dimension. But each is determined relatively to that part which is next to it by contact, for which reason each of them is in a sense many bodies. But the whole of which they are parts must necessarily be complete, and thus, in accordance with the meaning of the word, of being, not in some respect only, but in every respect. The question as to the nature of the whole, whether it is infinite in size or limited in its total mass, is a matter for subsequent inquiry. We will now speak of those parts of a whole which are specifically distinct. Let us take this as our starting point. All natural bodies and magnitudes we hold to be, as such, capable of locomotion, for nature, we say, is their principle of movement. But all movement that is in place, all locomotion, as we term it, is either straight or circular or a combination of these two, which are the only simple movements. And the reason of this is that these two, the straight and the circular line, are the only simple magnitudes. Now revolution about the center is circular motion, while the upward and downward movements are in a straight line, upward meaning motion away from the center, and downward motion towards it. All simple motion, then, must be motion either away from or towards or about the center. This seems to be in exact accord with what we said above. As body found its completion in 3 dimensions, so its movement completes itself in 3 forms. Bodies are either simple or compounded of such, and by simple bodies I mean those which possess a principle of movement in their own nature, such as fire and earth with their kinds, and whatever is akin to them. Necessarily, then, movements also will be either simple or in some sort compound. Simple in the case of the simple bodies, compound in that of the composite, and in the latter case the motion will be that of the simple body which prevails in the composition. Supposing, then, that there is such a thing as simple movement, and that circular movement is an instance of it, and that both movement of a simple body is simple and simple movement is of a simple body, for if it is movement of a compound it will be in virtue of a prevailing simple element, then there must necessarily be some simple body which revolves naturally and in virtue of its own nature with a circular movement. By constraint, of course, it may be brought to move with the motion of something else different from itself, but it cannot so move naturally, since there is one sort of movement natural to each of the simple bodies. Again, if the unnatural movement is the contrary of the natural and a thing can have no more than one contrary, it will follow that circular movement, being a simple motion, must be unnatural, if it is not natural, to the body moved. If then, 1, the body, whose movement is circular, is fire or some other element, its natural motion must be the contrary of the circular motion. But a single thing has a single contrary, and upward and downward motion are the contraries of one another. If, on the other hand, 2, the body moving with this circular motion which is unnatural to it is something different from the elements, there will be some other motion which is natural to it. But this cannot be. For if the natural motion is upward, it will be fire or air, and if downward, water or earth. Further, this circular motion is necessarily primary. For the perfect is naturally prior to the imperfect, and the circle is a perfect thing. This cannot be said of any straight line, not of an infinite line, for, if it were perfect, it would have a limit and an end, nor of any finite line, for in every case there is something beyond it, since any finite line can be extended. And so, since the prior movement belongs to the body which naturally prior, and circular movement is prior to straight, and movement in a straight line belongs to simple bodies, fire moving straight upward and earthy bodies straight downward towards the center. Since this is so, it follows that circular movement also must be the movement of some simple body. For the movement of composite bodies is, as we said, determined by that simple body which preponderates in the composition. These premises clearly give the conclusion that there is in nature some bodily substance other than the formations we know, prior to them all and more divine than they. But it may also be proved as follows. We may take it that all movement is either natural or unnatural, and that the movement which is unnatural to one body is natural to another, as, for instance, is the case with the upward and downward movements, which are natural and unnatural to fire and earth respectively. It necessarily follows that circular movement, being unnatural to these bodies, is the natural movement of some other. Further, if, on the one hand, circular movement is natural to something, it must surely be some simple and primary body which is ordained to move with a natural circular motion, as fire is ordained to fly up and earth down. If, on the other hand, the movement of the rotating bodies about the center is unnatural, it would be remarkable and indeed quite inconceivable that this movement alone should be continuous and eternal, being nevertheless contrary to nature. At any rate, the evidence of all other cases goes to show that it is the unnatural which quickest passes away. And so, if, as some say, the body so moved is fire, this movement is just as unnatural to it as downward movement, for anyone can see that fire moves in a straight line away from the center. On all these grounds, therefore, we may infer with confidence that there is something beyond the bodies that are about us on this earth, different and separate from them, and that the superior glory of its nature is proportionate to its distance from this world of ours. In consequence of what has been said, in part by way of assumption and in part by way of proof, it is clear that not every body either possesses lightness or heaviness. As a preliminary, we must explain in what sense we are using the words heavy and light. Sufficiently, at least, for our present purpose. We can examine the terms more closely later, when we come to consider their essential nature. Let us then apply the term heavy to that which naturally moves towards the center, and light to that which moves naturally away from the center. The heaviest thing will be that which sinks to the bottom of all things that move downward, and the lightest that which rises to the surface of everything that moves upward. Now, necessarily, everything which moves either up or down possesses lightness or heaviness or both, but not both relatively to the same thing, for things are heavy and light relatively to one another. Air, for instance, is light relatively to water, and water light relatively to earth. The body, then, which moves in a circle cannot possibly possess either heaviness or lightness. For neither naturally nor unnaturally can it move either towards or away from the center. Movement in a straight line certainly does not belong to it naturally, since one sort of movement is, as we saw, appropriate to each simple body, and so we should be compelled to identify it with one of the bodies which move in this way. Suppose, then, that the movement is unnatural. In that case, if it is the downward movement which is unnatural, the upward movement will be natural, and if it is the upward which is unnatural, the downward will be natural. For we decided that of contrary movements, if the one is unnatural to anything, the other will be natural to it. But since the natural movement of the whole and of its part of earth, for instance, as a whole and of a small clod have one and the same direction, it results, in the first place, that this body can possess no lightness or heaviness at all, for that would mean that it could move by its own nature either from or towards the center, which, as we know, is impossible, and, secondly, that it cannot possibly move in the way of locomotion by being forced violently aside in an upward or downward direction. For neither naturally nor unnaturally can it move with any other motion but its own, either itself or any part of it, since the reasoning which applies to the whole applies also to the part. It is equally reasonable to assume that this body will be ungenerated and indestructible and exempt from increase and alteration, since everything that comes to be comes into being from its contrary and in some substrate, and passes away likewise in a substrate by the action of the contrary into the contrary, as we explained in our opening discussions. Now the motions of contraries are contrary. If then this body can have no contrary, because there can be no contrary motion to the circular, nature seems justly to have exempted from contraries the body which was to be ungenerated and indestructible. For it is in contraries that generation and decay subsist. Again, that which is subject to increase increases upon contact with a kindred body, which is resolved into its matter. But there is nothing out of which this body can have been generated. And if it is exempt from increase and diminution, the same reasoning leads us to suppose that it is also unalterable. For alteration is movement in respect of quality, and qualitative states and dispositions, such as health and disease, do not come into being without changes of properties. But all natural bodies which change their properties we see to be subject without exception to increase and diminution. This is the case, for instance, with the bodies of animals and their parts and with vegetable bodies, and similarly also with those of the elements. And so, if the body which moves with a circular motion cannot admit of increase or diminution, it is reasonable to suppose that it is also unalterable. The reasons why the primary body is eternal and not subject to increase or diminution, but unaging and unalterable and unmodified, will be clear from what has been said to anyone who believes in our assumptions. Our theory seems to confirm experience and to be confirmed by it. For all men have some conception of the nature of the gods, and all who believe in the existence of gods at all, whether barbarian or Greek, agree in allotting the highest place to the deity, surely because they suppose that immortal is linked with immortal and regard any other supposition as inconceivable. If then there is, as there certainly is, anything divine, what we have just said about the primary bodily substance was well said. The mere evidence of the senses is enough to convince us of this, at least with human certainty. For in the whole range of time past, so far as our inherited records reach, no change appears to have taken place either in the whole scheme of the outermost heaven or in any of its proper parts. The common name, too, which has been handed down from our distant ancestors even to our own day, seems to show that they conceived of it in the fashion which we have been expressing. The same ideas, one must believe, recur in men's minds not once or twice but again and again. And so, implying that the primary body is something else beyond earth, fire, air, and water, they gave the highest place a name of its own, there, derived from the fact that it runs always for an eternity of time. Anaxagoras, however, scandalously misuses this name, taking there as equivalent to fire. It is also clear from what has been said why the number of what we call simple bodies cannot be greater than it is. the motion of a simple body must itself be simple, and we assert that there are only these two simple motions, the circular and the straight, the latter being subdivided into motion away from and motion towards the center. That there is no other form of motion opposed as contrary to the circular may be proved in various ways. In the first place, there is an obvious tendency to oppose the straight line to the circular. The concave and convex are not only regarded as opposed to one another, but they are also coupled together and treated as a unity in opposition to the straight. And so, if there is a contrary to circular motion, motion in a straight line must be recognized as having the best claim to that name. But the two forms of rectilinear motion are opposed to one another by reason of their places, for up and down is a difference and a contrary opposition in place. Secondly, it may be thought that the same reasoning which holds good of the rectilinear path applies also the circular, movement from A to B being opposed as contrary to movement from B to A. But what is meant is still rectilinear motion. For that is limited to a single path, while the circular paths which pass through the same 2 points are infinite in number. Even if we are confined to the single semicircle and the opposition is between movement from C to D and from D to C along that semicircle, the case is no better. For the motion is the same as that along the diameter, since we invariably regard the distance between 2 points as the length of the straight line which joins them. It is no more satisfactory to construct a circle and treat motion along one semicircle as contrary to motion along the other. For example, taking a complete circle, motion from E to F on the semicircle G may be opposed to motion from F to E on the semicircle H. But even supposing these are contraries, it in no way follows that the reverse motions on the complete circumference contraries. Nor again can motion along the circle from A to B be regarded as the contrary of motion from A to C, for the motion goes from the same point towards the same point, and contrary motion was distinguished as motion from a contrary to its contrary. And even if the motion round a circle is the contrary of the reverse motion, one of the two would be ineffective, for both move to the same point, because that which moves in a circle, at whatever point it begins, must necessarily pass through all the contrary places alike. By contrarieties of place I mean up and down, back and front, and right and left, and the contrary oppositions of movements are determined by those of places. One of the motions, then, would be ineffective, for if the two motions were of equal strength, there would be no movement either way, and if one of the two were preponderant, the other would be inoperative. So that if both bodies were there, one of them, inasmuch as it would not be moving with its own movement, would be useless, in the sense in which a shoe is useless when it is not worn. But God and nature create nothing that is not its use. This being clear, we must go on to consider the questions which remain. First, is there an infinite body, as the majority of the ancient philosophers thought, or is this an impossibility? The decision of this question, either way, is not unimportant, but rather all-important, to our search for the truth. It is this problem which has practically always been the source of the differences of those who have written about nature as a whole. So it has been and so it must be, since the least initial deviation from the truth is multiplied later 1,000-fold. Admit, for instance, the existence of a minimum magnitude, and you will find that the minimum which you have introduced, small as it is, causes the greatest truths of mathematics to totter. The reason is that a principle is great rather in power than in extent, hence that which was small at the start turns out a giant at the end. Now the conception of the infinite possesses this power of principles, and indeed in the sphere of quantity possesses it in a higher degree than any other conception, so that it is in no way absurd or unreasonable that the assumption that an infinite body exists should be of peculiar moment to our inquiry. The infinite, then, we must now discuss, opening the whole matter from the beginning. Every body is necessarily to be classed either as simple or as composite. The infinite body, therefore, will be either simple or composite. But it is clear, further, that if the simple bodies are finite, the composite must also be finite, since that which is composed of bodies finite both in number and in magnitude is itself finite in respect of number and magnitude. Its quantity is in fact the same as that of the bodies which compose it. What remains for us to consider, then, is whether any of the simple bodies can be infinite in magnitude, or whether this is impossible. Let us try the primary body first, and then go on to consider the others. The body which moves in a circle must necessarily be finite in every respect, for the following reasons. 1. If the body so moving is infinite, the radii drawn from the center will be infinite. But the space between infinite radii is infinite, and by the space between the radii I mean the area outside which no magnitude which is in contact with the two lines can be conceived as falling. This, I say, will be infinite, first, because in the case of finite radii it is always finite, and secondly, because in it one can always go on to a width greater than any given width, Thus the reasoning which forces us to believe an infinite number, because there is no maximum, applies also to the space between the radii. Now the infinite cannot be traversed, and if the body is infinite the interval between the radii is necessarily infinite, circular motion therefore is an impossibility. Yet our eyes tell us that the heavens revolve in a circle, and by argument also we have determined that there is something to which circular movement belongs. 2. Again, if from a finite time be subtracted, what remains must be finite and ever beginning. And if the time of a journey has a beginning, there must be a beginning also of the movement, and consequently also of the distance traversed. This applies universally. Take a line, ACE, infinite in one direction, E, and another line, BB, infinite in both directions. Let ACE describe a circle, revolving upon C as center. In its movement it will cut BB continuously for a certain time. This will be a finite time, since the total time is finite in which the heavens complete their circular orbit, and consequently the time subtracted from it, during which the one line in its motion cuts the other, is also finite. Therefore there will be a point at which ACE began for the first time to cut BB. This, however, is impossible. The infinite, then, cannot revolve in a circle, nor could the world, if it were infinite. 3. That the infinite cannot move may also be shown as follows. Let A be a finite line moving past the finite line, B. Of necessity A will pass clear of B and B of A at the same moment, for each overlaps the other to precisely the same extent. Now if the two were both moving, and moving in contrary directions, they would pass clear of one another more rapidly, if one were still and the other moving past it, less rapidly, provided that the speed of the latter were the same in both cases. This, however, is clear, that it is impossible to traverse an infinite line in a finite time. Infinite time, then, would be required. This we demonstrated above in the discussion of movement, and it makes no difference whether a finite is passing by an infinite or an infinite by a finite. For when A is passing B, then B overlaps A, and it makes no difference whether B is moved or unmoved, except that, if both move, they pass clear of one another more quickly. It is, however, quite possible that a moving line should in certain cases pass one which is stationary quicker than it passes one moving in an opposite direction. One has only to imagine the movement to be slow where both move and much faster where one is stationary. To suppose one line stationary, then, makes no difficulty for our argument, since it is quite possible for A to pass B at a slower rate when both are moving than when only one is. If, therefore, the time which the finite moving line takes to pass the other is infinite, then necessarily the time occupied by the motion of the infinite past the finite is also infinite. For the infinite to move at all is thus absolutely impossible, since the very smallest movement conceivable must take an infinity of time. Moreover the heavens certainly revolve, and they complete their circular orbit in a finite time, so that they pass round the whole extent of any line within that orbit, such as the finite line AB. The revolving body, therefore, cannot be infinite. 4. Again, as a line which has a limit cannot be infinite, or, if it is infinite, is so only in length, so a surface cannot be infinite in that respect in which it has a limit, or, indeed, if it is completely determinate, in any respect whatever. Whether it be a square or a circle or a sphere, it cannot be infinite, any more than a foot rule can. There is then no such thing as an infinite sphere or square or circle, and where there is no circle there can be no circular movement, and similarly where there is no infinite at all there can be no infinite movement, and from this it follows that, an infinite circle being itself an impossibility, there can be no circular motion of an infinite body. 5. Again, take a center C, an infinite line, AB, another infinite line at right angles to it, E, and a moving radius, CD. CD will never cease contact with E, but the position will always be something like CD cutting E at F. The infinite line, therefore, refuses to complete the circle. 6. Again, if the heaven is infinite and moves in a circle, we shall have to admit that in a finite time it has traversed the infinite. For suppose the fixed heaven infinite, and that which moves within it equal to it. It results that when the infinite body has completed its revolution, it has traversed an infinite equal to itself in a finite time. But that we know to be impossible. 7. It can also be shown, conversely, that if the time of revolution is finite, the area traversed must also be finite, but the area traversed was equal to itself, therefore, it is itself finite. We have now shown that the body which moves in a circle is not endless or infinite, but has its limit. Further, neither that which moves towards nor that which moves away from the center can be infinite. For the upward and downward motions are contraries and are therefore motions towards contrary places. But if one of a pair of contraries is determinate, the other must be determinate also. Now the center is determined, for, from whatever point the body which sinks to the bottom starts its downward motion, it cannot go farther than the center. The center, therefore, being determinate, the upper place must also be determinate. But if these two places are determined and finite, the corresponding bodies must also be finite. Further, if up and down are determinate, the intermediate place is also necessarily determinate. For, if it is indeterminate, the movement within it will be infinite, and that we have already shown to be an impossibility. The middle region then is determinate, and consequently any body which either is in it, or might be in it, is determinate. But the bodies which move up and down may be in it, since the one moves naturally away from the center and the other towards it. From this alone it is clear that an infinite body is an impossibility, but there is a further point. If there is no such thing as infinite weight, then it follows that none of these bodies can be infinite. For the supposed infinite body would have to be infinite in weight. The same argument applies to lightness, for as the one supposition involves infinite weight, so the infinity of the body which rises to the surface involves infinite lightness. This is proved as follows. Assume the weight to be finite, and take an infinite body, ab, of the weight c. Subtract from the infinite body a finite mass, bd, the weight of which shall be e. E then is less than c, since it is the weight of a lesser mass. Suppose then that the smaller goes into the greater a certain number of times, and take bf bearing the same proportion to bd which the greater weight bears to the smaller. For you may subtract as much as you please from an infinite. If now the masses are proportionate to the weights, and the lesser weight is that of the lesser mass, the greater must be that of the greater. The weights, therefore, of the finite and of the infinite body are equal. Again, if the weight of a greater body is greater than that of a less, the weight of GB will be greater than that of FB, and thus the weight of the finite body is greater than that of the infinite. And, further, the weight of unequal masses will be the same, since the infinite and the finite cannot be equal. It does not matter whether the weights are commensurable or not. If, a, they are incommensurable, the same reasoning holds. For instance, suppose E multiplied by 3 is rather more than C, the weight of 3 masses of the full size of BD will be greater than C. We thus arrive at the same impossibility as before. Again, b, we may assume weights which are commensurate, for it makes no difference whether we begin with a weight or with a mass. For example, assume the weight T to be commensurate with C, and take from the infinite mass a part BD of weight E. Then let a mass BF be taken having the same proportion to BD which the two weights have to one another. For the mass being infinite you may subtract from it as much as you please. These assumed bodies will be commensurate in mass and in weight alike. Nor again does it make any difference to our demonstration whether the total mass has its weight equally or unequally distributed. For it must always be possible to take from the infinite mass a body of equal weight to BD by diminishing or increasing the size of the section to the necessary extent. From what we have said, then, it is clear that the weight of the infinite body cannot be finite. It must then be infinite. We have therefore only to show this to be impossible in order to prove an infinite body impossible. But the impossibility of infinite weight can be shown in the following way. A given weight moves a given distance in a given time, a weight which is as great and more moves the same distance in a less time, the times being in inverse proportion to the weights. For instance, if one weight is twice another, it will take half as long over a given movement. Further, a finite weight traverses any finite distance in a finite time. It necessarily follows from this that infinite weight, if there is such a thing, being, on the one hand, as great and more than as great as the finite, will move accordingly, but being, on the other hand, compelled to move in a time inversely proportionate to its greatness, cannot move at all. The time should be less in proportion as the weight is greater. But there is no proportion between the infinite and the finite. Proportion can only hold between a less and a greater finite time. And though you may say that the time of the movement can be continually diminished, yet there is no minimum. Nor, if there were, would it help us. For some finite body could have been found greater than the given finite in the same proportion which is supposed to hold between the infinite and the given finite, so that an infinite and a finite weight must have traversed an equal distance in equal time. But that is impossible. Again, whatever the time, so long as it is finite, in which the infinite performs the motion, a finite weight must necessarily move a certain finite distance in that same time. Infinite weight is therefore impossible, and the same reasoning applies also to infinite lightness. Bodies then of infinite weight and of infinite lightness are equally impossible. That there is no infinite body may be shown, as we have shown it, by a detailed consideration of the various cases. But it may also be shown universally, not only by such reasoning as we advanced in our discussion of principles, though in that passage we have already determined universally the sense in which the existence of an infinite is to be asserted or denied, but also suitably to our present purpose in the following way. That will lead us to a further question. Even if the total mass is not infinite, it may yet be great enough to admit a plurality of universes. The question might possibly be raised whether there is any obstacle to our believing that there are other universes composed on the pattern of our own, more than one, though stopping short of infinity. First, however, let us treat of the infinite universally. Every body must necessarily be either finite or infinite, and if infinite, either of similar or of dissimilar parts. If its parts are dissimilar, they must represent either a finite or an infinite number of kinds. That the kinds cannot be infinite is evident, if our original presuppositions remain unchallenged. For the primary movements being finite in number, the kinds of simple body are necessarily also finite, since the movement of a simple body is simple, and the simple movements are finite, and every natural body must always have its proper motion. Now if the infinite body is to be composed of a finite number of kinds, then each of its parts must necessarily be infinite in quantity, that is to say, the water, fire, and sea, which compose it. But this is impossible, because, as we have already shown, infinite weight and lightness do not exist. Moreover, it would be necessary also that their places should be infinite in extent, so that the movements too of all these bodies would be infinite. But this is not possible, if we are to hold to the truth of our original presuppositions and to the view that neither that which moves downward, nor, by the same reasoning, that which moves upward, can prolong its movement to infinity. For it is true in regard to quality, quantity, and place alike that any process of change is impossible which can have no end. I mean that if it is impossible for a thing to have come to be white, or a cubit long, or in Egypt, it is also impossible for it to be in process of coming to be any of these. It is thus impossible for a thing to be moving to a place at which in its motion it can never by any possibility arrive. Again, suppose the body to exist in dispersion, it may be maintained none the less that the total of all these scattered particles, say, of fire, is infinite. But body we saw to be that which has extension every way. How can there be several dissimilar elements, each infinite? Each would have to be infinitely extended every way. It is no more conceivable, again, that the infinite should exist as a whole of similar parts. For, in the first place, there is no other, straight, movement beyond those mentioned, we must therefore give it one of them. And if so, we shall have to admit either infinite weight or infinite lightness. Nor, secondly, could the body whose movement is circular be infinite, since it is impossible for the infinite to move in a circle. This, indeed, would be as good as saying that the heavens are infinite, which we have shown to be impossible. Moreover, in general, it is impossible that the infinite should move at all. If it did, it would move either naturally or by constraint, and if by constraint, it possesses also a natural motion, that is to say, there is another place, infinite like itself, to which it will move. But that is impossible. That in general it is impossible for the infinite to be acted upon by the finite or to act upon it may be shown as follows. 1. The infinite cannot be acted upon by the finite, let A be an infinite, B a finite, see the time of a given movement produced by one in the other. Suppose, then, that A was heated, or impelled, or modified in any way, or caused to undergo any sort of movement whatever, by in the time C. Let D be less than B, and, assuming that a lesser agent moves a lesser patient in an equal time, call the quantity thus modified by D, E. Then, as D is to B, so is E to some finite quantum. We assume that the alteration of equal by equal takes equal time, and the alteration of less by less or of greater by greater takes the same time, if the quantity of the patient is such as to keep the proportion which obtains between the agents, greater and less. If so, no movement can be caused in the infinite by any finite agent in any time whatever. For a less agent will produce that movement in a less patient in an equal time, and the proportionate equivalent of that patient will be a finite quantity, since no proportion holds between finite and infinite. 2. The infinite cannot act upon the finite, nor, again, can the infinite produce a movement in the finite in any time whatever. Let A be an infinite, B a finite, C the time of action. In the time C, D will produce that motion in a patient less than B, say F. Then take E, bearing the same proportion to D as the whole BF bears to F. E will produce the motion in BF in the time C. Thus the finite and infinite effect the same alteration in equal times. But this is impossible, for the assumption is that the greater effects it in a shorter time. It will be the same with any time that can be taken, so that there will no time in which the infinite can affect this movement. And, as to infinite time, in that nothing can move another or be moved by it. For such time has no limit, while the action and reaction have. 3. There is no interaction between infinites, nor can infinite be acted upon in any way by infinite. Let 2 and b be infinites, CD being the time of the action A of upon B. Now the whole B was modified in a certain time, and the part of this infinite, E, cannot be so modified in the same time, since we assume that a less quantity makes the movement in a less time. Let E then, when acted upon by A, complete the movement in the time D. Then, as D is to CD, so is E to some finite part of B. This part will necessarily be moved by A in the time CD. For we suppose that the same agent produces a given effect on a greater and a smaller mass in longer and shorter times, the times and masses varying proportionately. There is thus no finite time in which infinites can move one another. Is there time then infinite? No, for infinite time has no end, but the movement communicated has. If therefore every perceptible body possesses the power of acting or of being acted upon, or both of these, it is impossible that an infinite body should be perceptible. All bodies, however, that occupy place are perceptible. There is therefore no infinite body beyond the heaven. Nor again is there anything of limited extent beyond it. And so beyond the heaven there is no body at all. For if you suppose it an object of intelligence, it will be in a place, since place is what within and beyond denote, and therefore an object of perception. But nothing that is not in a place is perceptible. The question may also be examined in the light of more general considerations as follows. The infinite, considered as a whole of similar parts, cannot, on the one hand, move in a circle. For there is no center of the infinite, and that which moves in a circle moves about the center. Nor again can the infinite move in a straight line. For there would have to be another place infinite like itself to be the goal of its natural movement, and another, equally great, for the goal of its unnatural movement. Moreover, whether its rectilinear movement is natural or constrained, in either case the force which causes its motion will have to be infinite. For infinite force is force of an infinite body, and of an infinite body the force is infinite. So the motive body also will be infinite. The proof of this is given in our discussion of movement, where it is shown that no finite thing possesses infinite power, and no infinite thing finite power. If then that which moves naturally can also move unnaturally, there will be two infinites, one which causes, and another which exhibits the latter motion. Again, what is it that moves the infinite? If it moves itself, it must be animate. But how can it possibly be conceived as an infinite animal? And if there is something else that moves it, there will be two infinites, that which moves and that which is moved, differing in their form and power. If the whole is not continuous, but exists, as Democritus and Leucippus think, in the form of parts separated by void, there must necessarily be one movement of all the multitude. They are distinguished, we are told, from one another by their figures, but their nature is one, like many pieces of gold separated from one another. But each piece must, as we assert, have the same motion. For a single clod moves to the same place as the whole mass of earth, and a spark to the same place as the whole mass of fire. So that if it be weight that all possess, no body is, strictly speaking, light, and if lightness be universal, none is heavy. Moreover, whatever possesses weight or lightness will have its place either at one of the extremes or in the middle region. But this is impossible while the world is conceived as infinite. And, generally, that which has no center or extreme limit, no up or down, gives the bodies no place for their motion, and without that movement is impossible. A thing must move either naturally or unnaturally, and the two movements are determined by the proper and alien places. Again, a place in which a thing rests or to which it moves unnaturally, must be the natural place for some other body, as experience shows. Necessarily, therefore, not everything possesses weight or lightness, but some things do and some do not. From these arguments then it is clear that the body of the universe is not infinite. We must now proceed to explain why there cannot be more than one heaven, the further question mentioned above. For it may be thought that we have not proved universal of bodies that none whatever can exist outside our universe, and that our argument applied only to those of indeterminate extent. Now all things rest and move naturally and by constraint. A thing moves naturally to a place in which it rests without constraint, and rests naturally in a place to which it moves without constraint. On the other hand, a thing moves by constraint to a place in which it rests by constraint, and rests by constraint in a place to which it moves by constraint. Further, if a given movement is due to constraint, its contrary is natural. If, then, it is by constraint that earth moves from a certain place to the center here, its movement from here to there will be natural, and if earth from the rests here without constraint, its movement here there will be natural. And the natural movement in each case is one. Further, these worlds, being similar in nature to ours, must all be composed of the same bodies as it. Moreover, each of the bodies, fire, and earth and their intermediates, must have the same power as in our world. For if these names are used equivocally, if the identity of name does not rest upon an identity of form in these elements and ours, then the whole to which they belong can only be called a world by equivocation. Clearly, then, one of the bodies will move naturally away from the center and another towards the center, since fire must be identical with fire, earth with earth, and so on, as the fragments of each are identical in this world. That this must be the case is evident from the principles laid down in our discussion of the movements, for these are limited in number, and the distinction of the elements depends upon the distinction of the movements. Therefore, since the movements are the same, the elements must also be the same everywhere. The particles of earth, then, in another world move naturally also to our center and its fire to our circumference. This, however, is impossible, since, if it were true, earth must, in its own world, move upwards, and fire to the center, in the same way the earth of our world must move naturally away from the center when it moves towards the center of another universe. This follows from the supposed juxtaposition of the worlds. For either we must refuse to admit the identical nature of the simple bodies in the various universes, or, admitting this, we must make the center and the extremity one as suggested. This being so, it follows that there cannot be more worlds than one. To postulate a difference of nature in the simple bodies according as they are more or less distant from their proper places is unreasonable. For what difference can it make whether we say that a thing is this distance away or that? One would have to suppose a difference proportionate to the distance and increasing with it. But the form is in fact the same. Moreover, the bodies must have some movement, since the fact that they move is quite evident. Are we to say then that all their movements, even those which are mutually contrary, are due to constraint? No, for a body which has no natural movement at all cannot be moved by constraint. If then the bodies have a natural movement, the movement of the particular instances of each form must necessarily have for goal a place numerically one, that is a particular center or a particular extremity. If it be suggested that the goal in each case is one in form but numerically more than one, on the analogy of particulars which are many though each undifferentiated in form, we reply that the variety of goal cannot be limited to this portion or that but must extend to all alike. For all are equally undifferentiated in form, but any one is different numerically from any other. What I mean is this: if the portions in this world behave similarly both to one another and to those in another world, then the portion which is taken hence will not behave differently either from the portions in another world or from those in the same world, but similarly to them, since in form no portion differs from another. The result is that we must either abandon our present assumption or assert that the center and the extremity are each numerically one. But this being so, the heaven, by the same evidence and the same necessary inferences, must be one only and no more. A consideration of the other kinds of movement also makes it plain that there is some point to which earth and fire move naturally. For in general that which is moved changes from something into something, the starting point and the goal being different in form, and always it is a finite change. For instance, to recover health is to change from disease to health, to increase is to change from smallness to greatness. Locomotion must be similar, for it also has its goal and starting point, and therefore the starting point and the goal of the natural movement must differ in form, just as the movement of coming to health does not take any direction which chance or the wishes of the mover may select. Thus, too, fire and earth move not to infinity but to opposite points, and since the opposition in place is between above and below, these will be the limits of their movement. Even in circular movement there is a sort of opposition between the ends of the diameter, though the movement as a whole has no contrary, so that here too the movement has in a sense an opposed and finite goal. There must therefore be some end to locomotion. It cannot continue to infinity. This conclusion that local movement is not continued to infinity is corroborated by the fact that earth moves more quickly the nearer it is to the center, and fire the nearer it is to the upper place. But if movement were infinite, speed would be infinite also, and if speed, then weight and lightness. For as superior speed in downward movement implies superior weight, so infinite increase of weight necessitates infinite increase of speed. Further, it is not the action of another body that makes one of these bodies move up and the other down, nor is it constraint, like the extrusion of some writers. For in that case the larger the mass of fire or earth the slower would be the upward or downward movement, but the fact is the reverse: the greater the mass of fire or earth the quicker always is its movement towards its own place. Again, The speed of the movement would not increase towards the end if it were due to constraint or extrusion, for a constrained movement always diminishes in speed as the source of constraint becomes more distant, and a body moves without constraint to the place whence it was moved by constraint. A consideration of these points, then, gives adequate assurance of the truth of our contentions. The same could also be shown with the aid of the discussions which fall under first philosophy, as well as from the nature of the circular movement, which must be eternal both here and in the other worlds. It is plain, too, from the following considerations that the universe must be one. The bodily elements are three, and therefore the places of the elements will be three also, the place, first, of the body which sinks to the bottom, namely the region about the center, the place, secondly, of the revolving body, namely the outermost place, and thirdly, the intermediate place, belonging to the intermediate body. Here in this third place will be the body which rises to the surface, since, if not here, it will be elsewhere, and it cannot be elsewhere, for we have two bodies, one weightless, one endowed with weight, and below is place of the body endowed with weight, since the region about the center has been given to the heavy body. And its position cannot be unnatural to it, for it would have to be natural to something else, and there is nothing else. It must then occupy the intermediate place. What distinctions there are within the intermediate itself we will explain later on. We have now said enough to make plain the character and number of the bodily elements, the place of each, and further, in general, how many in number the various places are. We must show not only that the heaven is one, but also that more than one heaven is, and, further, that, as exempt from decay and generation, the heaven is eternal. We may begin by raising a difficulty. From one point of view it might seem impossible that the heaven should be one and unique, since in all formations and products whether of nature or of art we can distinguish the shape in itself and the shape in combination with matter. For instance, the form of the sphere is one thing and the gold or bronze sphere another, the shape of the circle again is one thing, the bronze or wooden circle another. For when we state the essential nature of a sphere or circle we do not include in the formula gold or bronze, because they do not belong to the essence, but if we are speaking of the copper or gold sphere we do include them. We still make the distinction even if we cannot conceive or apprehend any other example beside the particular thing. This may, of course, sometimes be the case. It might be, for instance, that only one circle could be found, yet nonetheless the difference will remain between the being a circle and of this particular circle, the one being form, the other form in matter, that is a particular thing. Now since the universe is perceptible it must be regarded as a particular, for everything that is perceptible subsists, as we know, in matter. But if it is a particular, there will be a distinction between the being of this universe and of universe unqualified. There is a difference, then, between this universe and simple universe. The second is form and shape, the first form in combination with matter, and any shape or form has, or may have, more than one particular instance. On the supposition of forms such as some assert, this must be the case, and equally on the view that no such entity has a separate existence. For in every case in which the essence is in matter it is a fact of observation that the particulars of like form are several or infinite in number. Hence there either are, or may be, more heavens than one. On these grounds, then, it might be inferred either that there are or that there might be several heavens. We must, however, return and ask how much of this argument is correct and how much not. Now it is quite right to say that the formula of the shape apart from the matter must be different from that of the shape in the matter, and we may allow this to be true. We are not, however, therefore compelled to assert a plurality of worlds. Such a plurality is in fact impossible if this world contains the entirety of matter, as in fact it does. But perhaps our contention can be made clearer in this way. Suppose aquilinity to be curvature in the nose or flesh, and flesh to be the matter of aquilinity. Suppose further, that all flesh came together into a single whole of flesh endowed with this aquiline quality. Then neither would there be, nor could there arise, any other thing that was aquiline. Similarly, suppose flesh and bones to be the matter of man, and suppose a man to be created of all flesh and all bones in indissoluble union. The possibility of another man would be removed. Whatever case you took it would be the same. The general rule is this: a thing whose essence resides in a substratum of matter can never come into being in the absence of all matter. Now the universe is certainly a particular and a material thing. If however, it is composed not of a part but of the whole of matter, then though the being of universe and of this universe are still distinct, yet there is no other universe, and no possibility of others being made, because all the matter is already included in this. It remains, then, only to prove that it is composed of all natural perceptible body. First, however, We must explain what we mean by heaven and in how many senses we use the word, in order to make clear the object of our inquiry. In one sense, then, we call heaven the substance of the extreme circumference of the whole, or that natural body whose place is at the extreme circumference. We recognize habitually a special right to the name heaven in the extremity or upper region, which we take to be the seat of all that is divine. In another sense, we use this name for the body continuous with the extreme circumference which contains the moon, the sun, and some of the stars. These we say are in the heaven. In yet another sense we give the name to all body included within extreme circumference, since we habitually call the whole or totality the heaven. The word, then, is used in three senses. Now the whole included within the extreme circumference must be composed of all physical and sensible body, because there neither is, nor can come into being, any body outside the heaven. For if there is a natural body outside the extreme circumference, it must be either a simple or a composite body, and its position must be either natural or unnatural. But it cannot be any of the simple bodies. For, first, it has been shown that that which moves in a circle cannot change its place. And, secondly, it cannot be that which moves from the center or that which lies lowest. Naturally they could not be since their proper places are elsewhere, and if these are there unnaturally, the exterior place will be natural to some other body, since a place which is unnatural to one body must be natural to another. But we saw that there is no other body besides these. Then it is not possible that any simple body should be outside the heaven. But, if no simple body, neither can any mixed body be for the presence of the simple body is involved in the presence of the mixture. Further, neither can any body come into that place, for it will do so either naturally or unnaturally, and will be either simple or composite, so that the same argument will apply, since it makes no difference whether the question is does exist, or could come to exist. From our arguments then it is evident not only that there is not, but also that there could never come to be, any bodily mass whatever outside the circumference. The world as a whole, therefore, includes all its appropriate matter, which is, as we saw, natural perceptible body. So that neither are there now, nor have there ever been, nor can there ever be formed more heavens than one, but this heaven of ours is one and unique and complete. It is therefore evident that there is also no place or void or time outside the heaven. For in every place body can be present, and void is said to be that in which the presence of body, though not actual, is possible, and time is the number of movement. But in the absence of natural body there is no movement, and outside the heaven, as we have shown, body neither exists nor can come to exist. It is clear then that there is neither place, nor void, nor time, outside the heaven. Hence whatever is there, is of such a nature as not to occupy any place, nor does time age it, nor is there any change in any of the things which lie beyond the outermost motion. They continue through their entire duration unalterable and unmodified, living the best and the most self-sufficient of lives. As a matter of fact, this word duration possessed a divine significance for the ancients, for the fulfillment which includes the period of life of any creature, outside of which no natural development can fall, has been called its duration. On the same principle the fulfillment of the whole heaven, the fulfillment which includes all time and infinity, is duration, a name based upon the fact that it is always duration immortal and divine. From it derive the being and life which other things, some more or less articulately but others feebly, enjoy. So, too, in its discussions concerning the divine, popular philosophy often propounds the view that whatever is divine, whatever is primary and supreme, is necessarily unchangeable. This fact confirms what we have said. For there is nothing else stronger than it to move it, since that would mean more divine, and it has no defect and lacks none of its proper excellences. Its unceasing movement, then, is also reasonable, since everything ceases to move when it comes to its proper place, but the body whose path is the circle has one and the same place for starting point and goal. Having established these distinctions, we may now proceed to the question whether the heaven is ungenerated or generated, indestructible or destructible. Let us start with a review of the theories of other thinkers, for the proofs of a theory are difficulties for the contrary theory. Besides, those who have first heard the pleas of our adversaries will be more likely to credit the assertions which we are going to make. We shall be less open to the charge of procuring judgment by default. To give a satisfactory decision as to the truth, it is necessary to be rather an arbitrator than a party to the dispute. That the world was generated all are agreed, but, generation over, some say that it is eternal. Others say that it is destructible like any other natural formation. Others again, with Empedocles of Acragas and Heraclitus of Ephesus, believe that there is alternation in the destructive process, which takes now this direction, now that, and continues without end. Now to assert that it was generated and yet is eternal is to assert the impossible, for we cannot reasonably attribute to anything any characteristics but those which observation detects in many or all instances. But in this case the facts point the other way. Generated things are seen always to be destroyed. Further, a thing whose present state had no beginning and which could not have been other than it was at any previous moment throughout its entire duration, cannot possibly be changed. For there will have to be some cause of change, and if this had been present earlier it would have made possible another condition of that to which any other condition was impossible. Suppose that the world was formed out of elements which were formerly otherwise conditioned than as they are now. Then, 1. If their condition was always so and could not have been otherwise, the world could never have come into being. And, 2. If the world did come into being, then, clearly, their condition must have been capable of change and not eternal. After combination therefore they will be dispersed, just as in the past after dispersion they came into combination, and this process either has been, or could have been, indefinitely repeated. But if this is so, the world cannot be indestructible, and it does not matter whether the change of condition has actually occurred or remains a possibility. Some of those who hold that the world, though indestructible, was yet generated, try to support their case by a parallel which is illusory. They say that in their statements about its generation they are doing what geometricians do when they construct their figures, not implying that the universe really had a beginning, but for didactic reasons facilitating understanding by exhibiting the object, like the figure, as in course of formation. The two cases, as we said, are not parallel, for, in the construction of the figure, when the various steps are completed the required figure forthwith results, but in these other demonstrations what results is not that which was required. Indeed it cannot be so, for antecedent and consequent, as assumed, are in contradiction. The ordered, it is said, arose out of the unordered, and the same thing cannot be at the same time both ordered and unordered. There must be a process and a lapse of time separating the two states. In the figure, on the other hand, there is no temporal separation. It is clear then that the universe cannot be at once eternal and generated. To say that the universe alternately combines and dissolves is no more paradoxical than to make it eternal but varying in shape. It is as if one were to think that there was now destruction and now existence when from a child a man is generated, and from a man a child. For it is clear that when the elements come together the result is not a chance system and combination, but the very same as before, especially on the view of those who hold this theory, since they say that the contrary is the cause of each state. So that if the totality of body, which is a continuum, is now in this order or disposition and now in that, and if the combination of the whole is a world or heaven, then it will not be the world that comes into being and is destroyed, but only its dispositions. If the world is believed to be one, it is impossible to suppose that it should be, as a whole, first generated and then destroyed, never to reappear, since before it came into being there was always present the combination prior to it, and that, we hold, could never change if it was never generated. If, on the other hand, the worlds are infinite in number the view is more plausible. But whether this is, or is not, impossible will be clear from what follows. For there are some who think it possible both for the ungenerated to be destroyed and for the generated to persist undestroyed. This is held in the Timaeus, where Plato says that the heaven, though it was generated, will nonetheless exist to eternity. So far as the heaven is concerned we have answered this view with arguments appropriate to the nature of the heaven. On the general question we shall attain clearness when we examine the matter universally. We must first distinguish the senses in which we use the words ungenerated and generated, destructible and indestructible. These have many meanings, and though it may make no difference to the argument, yet some confusion of mind must result from treating as uniform in its use a word which has several distinct applications. The character which is the ground of the predication will always remain obscure. The word ungenerated then is used, in one sense whenever something now is which formerly was not, no process of becoming or change being involved. Such is the case, according to some, with contact and motion, since there is no process of coming to be in contact or in motion. It is used in another sense, when something which is capable of coming to be, with or without process, does not exist. Such a thing is ungenerated in the sense that its generation is not a fact but a possibility. It is also applied where there is general impossibility of any generation such that the thing now is which then was not. And impossibility has two uses: first, where it is untrue to say that the thing can ever come into being, and secondly, where it cannot do so easily, quickly, or well. In the same way the word generated is used, first, where what formerly was not afterwards is, whether a process of becoming was or was not involved, so long as that which then was not, now, be. Secondly, of anything capable of existing, capable being defined with reference either to truth or to facility. C. Thirdly, of anything to which the passage from not being to being belongs, whether already actual, if its existence is due to a past process of becoming, or not yet actual but only possible. The uses of the words destructible and indestructible are similar. Destructible is applied, a. to that which formerly was and afterwards either is not or might not be, whether a period of being destroyed and changed intervenes or not, and, b. sometimes we apply the word to that which a process of destruction may cause not to be, and also, c. in a third sense, to that which is easily destructible, to the easily destroyed, so to speak. Of the indestructible the same account holds good. It is either, a. that which now is and now is not, without any process of destruction, like contact, which without being destroyed afterwards is not, though formerly it was, or, b. that which is but might not be, or which will at some time not be, though it now. For you exist now and so does the contact, yet both are destructible, because a time will come when it will not be true of you that you exist, nor of these things that they are in contact. Thirdly, c. in its most proper use, it is that which is, but is incapable of any destruction such that the thing which now is later ceases to be or might cease to be, or again, that which has not yet been destroyed, but in the future may cease to be. For indestructible is also used of that which is destroyed with difficulty. This being so, we must ask what we mean by possible and impossible. For in its most proper use the predicate indestructible is given because it is impossible that the thing should be destroyed, that is exist at one time and not at another. And ungenerated also involves impossibility when used for that which cannot be generated, in such fashion that, while formerly it was not, later it is. An instance is a commensurable diagonal. Now when we speak of a power to move or to lift weights, we refer always to the maximum. We speak, for instance, of a power to lift 100 talents or walk 100 stades, though a power to effect the maximum is also a power to effect any part of the maximum, since we feel obliged in defining the power to give the limit or maximum. A thing, then, which is within it. If, for example, a man can lift 100 talents, he can also lift 2, and if he can walk 100 stades, he can also walk 2. But the power is of the maximum, and a thing said, with reference to its maximum, to be incapable of so much is also incapable of any greater amount. It is, for instance, clear that a person who cannot walk 1,000 stades will also be unable to walk 1,001. This point need not trouble us, for we may take it as settled that what is, in the strict sense, possible is determined by a limiting maximum. Now perhaps the objection might be raised that there is no necessity in this, since he who sees a stade need not see the smaller measures contained in it, while, on the contrary, he who can see a dot or hear a small sound will perceive what is greater. This, however, does not touch our argument. The maximum may be determined either in the power or in its object. The application of this is plain. Superior sight is sight of the smaller body, but superior speed is that of the greater body. Having established these distinctions, we can now proceed to the sequel. If there are things capable both of being and of not being, there must be some definite maximum time of their being and not being, a time, I mean, during which continued existence is possible to them and a time during which continued non-existence is possible. And this is true in every category, whether the thing is, for example, man, or white, or 3 cubits long, or whatever it may be. For if the time is not definite in quantity, but longer than any that can be suggested and shorter than none, then it will be possible for one and the same thing to exist for infinite time and not to exist for another infinity. This, however, is impossible. Let us take our start from this point. The impossible and the false have not the same significance. One use of impossible and possible, and false and true, is hypothetical. It is impossible, for instance, on a certain hypothesis that the triangle should have its angles equal to 2 right angles, and on another the diagonal is commensurable. But there are also things possible and impossible, false and true, absolutely. Now it is one thing to be absolutely false, and another thing to be absolutely impossible. To say that you are standing when you are not standing is to assert a falsehood, but not an impossibility. Similarly, to say that a man who is playing the harp, but not singing, is to say what is false but not impossible. To say, however, that you are at once standing and sitting, or that the diagonal is commensurable, is to say what is not only false but also impossible. Thus it is not the same thing to make a false and to make an impossible hypothesis, and from the impossible hypothesis impossible results follow. A man has, it is true, the capacity at once of sitting and of standing, because when he possesses the one he also possesses the other. But it does not follow that he can at once sit and stand, only that at another time he can do the other also. But if a thing has for infinite time more than one capacity, another time is impossible and the times must coincide. Thus if a thing which exists for infinite time is destructible, it will have the capacity of not being. Now if it exists for infinite time, let this capacity be actualized, and it will be in actuality at once existent and non-existent. Thus a false conclusion would follow because a false assumption was made, but if what was assumed had not been impossible, its consequence would not have been impossible. Anything then which always exists is absolutely imperishable. It is also ungenerated, since if it was generated it will have the power for some time of not being. For as that which formerly was, but now is not, or is capable at some future time of not being, is destructible, so that which is capable of formerly not having been is generated. But in the case of that which always is, there is no time for such a capacity of not being, whether the supposed time is finite or infinite, for its capacity of being must include the finite time since it covers infinite time. It is therefore impossible that one and the same thing should be capable of always existing and of always not existing. And not always existing, the contradictory, is also excluded. Thus it is impossible for a thing always to exist and yet to be destructible. Nor, similarly, can it be generated. For of two attributes if B cannot be present without A, the impossibility A proves the impossibility of B. What always is, then, since it is incapable of ever not being, cannot possibly be generated. But since the contradictory of that which is always capable of being that which is not always capable of being, while that which is always capable of not being is the contrary, whose contradictory in turn is that which is not always capable of not being, it is necessary that the contradictories of both terms should be predicable of one and the same thing, and thus that, intermediate between what always is and what always is not, there should be that to which being and not being are both possible, for the contradictory of each will at times be true of it unless it always exists. Hence that which not always is not will sometimes be and sometimes not be, and it is clear that this is true also of that which cannot always be but sometimes is and therefore sometimes is not. One thing, then, will have the power of being, and will thus be intermediate between the other two. Expressed universally our argument is as follows. Let there be two attributes, A and B, not capable of being present in any one thing together, while either A or C and either B or D are capable of being present in everything. Then C and D must be predicated of everything of which neither A nor B is predicated. Let E lie between A and B, for that which is neither of two contraries is a mean between them. In E both C and D must be present, for either A or C is present everywhere and therefore in E. Since then A is impossible, C must be present, and the same argument holds of D. Neither that which always is, therefore, nor that which always is not is either generated or destructible. And clearly whatever is generated or destructible is not eternal. If it were, it would be at once capable of always being and capable of not always being, but it has already been shown that this is impossible. Surely then whatever is ungenerated and in being must be eternal, and whatever is indestructible and in being must equally be so. I use the words ungenerated and indestructible in their proper sense, ungenerated for that which now is and could not at any previous time have been truly said not to be, indestructible for that which now is and cannot at any future time be truly said not to be. If, again, the two terms are coincident, if the ungenerated is indestructible, and the indestructible ungenerated, then each of them is coincident with eternal. Anything ungenerated is eternal and anything indestructible is eternal. This is clear too from the definition of the terms. Whatever is destructible must be generated, for it is either ungenerated, or generated, but, if ungenerated, it is by hypothesis indestructible. Whatever, further, is generated must be destructible. For it is either destructible or indestructible, but, if indestructible, it is by hypothesis ungenerated. If, however, indestructible and ungenerated are not coincident, there is no necessity that either the ungenerated or the indestructible should be eternal. But they must be coincident, for the following reasons. The terms generated and destructible are coincident. This is obvious from our former remarks, since between what always is and what always is not there is an intermediate which is neither, and that intermediate is the generated and destructible. For whatever is either of these is capable both of being and of not being for a definite time. In either case, I mean, there is a certain period of time during which the thing is and another during which it is not. Anything therefore which is generated or destructible must be intermediate. Now let A be that which always is and B that which always is not, C the generated, and D the destructible. Then C must be intermediate between A and B. for in their case there is no time in the direction of either limit, in which either A is not or B is. But for the generated there must be such a time either actually or potentially, though not for A and B in either way. C then will be, and also not be, for a limited length of time, and this is true also of D, the destructible. Therefore each is both generated and destructible. Therefore generated and destructible are coincident. Now let E stand for the ungenerated, F for the generated, G for the indestructible, and H for the destructible. As for F and H, it has been shown that they are coincident. But when terms stand to one another as these do, F and H coincident, E and F never predicated of the same thing but one nor other of everything, and G and H likewise, then E and G must needs be coincident. For suppose that E is not coincident with G, then F will be, since either E or F is predictable of everything. But of that of which F is predicated H will be predicable also. H will then be coincident with G, but this we saw to be impossible. And the same argument shows that G is coincident with E. Now the relation of the ungenerated, E, to the generated, F, is the same as that of the indestructible, G, to the destructible, H. To say then that there is no reason why anything should not be generated and yet indestructible or ungenerated and yet destroyed, to imagine that in the one case generation and in the other case destruction occurs once for all, is to destroy part of the data. For, 1, everything is capable of acting or being acted upon, of being or not being, either for an infinite, or for a definitely limited space of time, and the infinite time is only a possible alternative because it is after a fashion defined, as a length of time which cannot be exceeded. But infinity in one direction is neither infinite or finite. 2. Further, why, after always existing, was the thing destroyed? Why, after an infinity of not being, was it generated, at one moment rather than another? If every moment is alike and the moments are infinite in number, it is clear that a generated or destructible thing existed for an infinite time. It has therefore for an infinite time the capacity of not being, since the capacity of being and the capacity of not being will be present together, if destructible, in the time before destruction, if generated, in the time after generation. If then we assume the two capacities to be actualized, opposites will be present together. 3. Further, this second capacity will be present like the first at every moment, so that the thing will have for an infinite time the capacity both of being and of not being, but this has been shown to be impossible. 4. Again, if the capacity is present prior to the activity, it will be present for all time, even while the thing was as yet ungenerated and non-existent, throughout the infinite time in which it was capable of being generated. At that time, then, when it was not, at that same time it had the capacity of being, both of being then and of being thereafter, and therefore for an infinity of time. It is clear also on other grounds that it is impossible that the destructible should not at some time be destroyed. For otherwise it will always be at once destructible and in actuality indestructible, so that it will be at the same time capable of always existing and of not always existing. Thus the destructible is at some time actually destroyed. The generable, similarly, has been generated, for it is capable of having been generated and thus also of not always existing. We may also see in the following way how impossible it is either for a thing which is generated to be thenceforward indestructible, or for a thing which is ungenerated and has always hitherto existed to be destroyed. Nothing that is by chance can be indestructible or ungenerated, since the products of chance and fortune are opposed to what is, or comes to be, always or usually, while anything which exists for a time infinite either absolutely or in one direction, is in existence either always or usually. That which is by chance, then, is by nature such as to exist at one time and not at another. But in things of that character the contradictory states proceed from one and the same capacity, the matter of the thing being the cause equally of its existence and of its non-existence. Hence contradictories would be present together in actuality. Further, it cannot truly be said of a thing now that it exists last year, nor could it be said last year that it exists now. It is therefore impossible for what once did not exist later to be eternal. For in its later state it will possess the capacity of not existing, only not of not existing at a time when it exists, since then it exists in actuality, but of not existing last year or in the past. Now suppose it to be in actuality what it is capable of being. It will then be true to say now that it does not exist last year. But this is impossible. No capacity relates to being in the past, but always to being in the present or future. It is the same with the notion of an eternity of existence followed later by non-existence. In the later state the capacity will be present for that which is not there in actuality. Actualize, then, the capacity. It will be true to say now that this exists last year or in the past generally. Considerations also not general like these but proper to the subject show it to be impossible that what was formerly eternal should later be destroyed, or that what formerly was not should later be eternal. Whatever is destructible or generated is always alterable. Now alteration is due to contraries, and the things which compose the natural body are the very same that destroy it. On the Heavens, Book 2, translated by J. L. Stocks. That the heaven as a whole neither came into being nor admits of destruction, as some assert, but is one and eternal, with no end or beginning of its total duration, containing and embracing in itself the infinity of time. We may convince ourselves not only by the arguments already set forth but also by a consideration of the views of those who differ from us in providing for its generation. If our view is a possible one, and the manner of generation which they assert is impossible, this fact will have great weight in convincing us of the immortality and eternity of the world. Hence it is well to persuade oneself of the truth of the ancient and truly traditional theories, that there is some immortal and divine thing which possesses movement, but movement such as has no limit and is rather itself the limit of all other movement. A limit is a thing which contains, and this motion, being perfect, contains those imperfect motions which have a limit and a goal, having itself no beginning or end, but unceasing through the infinity of time, and of other movements, to some the cause of their beginning, to others offering the goal. The ancients gave to the gods the heaven or upper place, as being alone immortal, and our present argument testifies that it is indestructible and ungenerated. Further, it is unaffected by any mortal discomfort, and, in addition, effortless, for it needs no constraining necessity to keep it to its path, and prevent it from moving with some other movement more natural to itself. Such a constrained movement would necessarily involve effort, the more so, the more eternal it were, and would be inconsistent with perfection. Hence we must not believe the old tale which says that the world needs some Atlas to keep its safe tale composed. It would seem, by men who, like later thinkers, conceived of all the upper bodies as earthy and endowed with weight, and therefore supported it in their fabulous way upon animate necessity. We must no more believe that than follow Empedocles when he says that the world, by being whirled round, received a movement quick enough to overpower its own downward tendency, and thus has been kept from destruction all this time. Nor, again, is it conceivable that it should persist eternally by the necessitation of a soul. For a soul could not live in such conditions painlessly or happily, since the movement involves constraint, being imposed on the first body, whose natural motion is different, and imposed continuously. It must therefore be uneasy and devoid of all rational satisfaction, for it could not even, like the soul of mortal animals, take recreation in the bodily relaxation of sleep. A Nixon's lot must needs possess it, without end or respite. If then, as we said, the view already stated of the first motion is a possible one, it is not only more appropriate so to conceive of its eternity, but also on this hypothesis alone are we able to advance a theory consistent with popular divinations of the divine nature. But of this enough for the present. Since there are some who say that there is right and a left in the heaven, with those who are known as Pythagoreans, to whom indeed the view really belongs, we must consider whether, if we are to apply these principles to the body of the universe, we should follow their statement of the matter or find a better way. At the start we may say that, if right and left are applicable, there are prior principles which must first be applied. These principles have been analyzed in the discussion of the movements of animals, for the reason that they are proper to animal nature. For in some animals we find all such distinctions of parts as this of right and left clearly present, and in others some, but in plants we find only above and below. Now if we are to apply to the heaven such a distinction of parts, we must exact, as we have said, to find in it also the distinction which in animals is found first of them all. The distinctions are three, namely, above and below, front and its opposite, right and left. All these three oppositions we expect to find in the perfect body, and each may be called a principle. Above is the principle of length, right of breadth, front of depth. Or again we may connect them with the various movements, taking principle to mean that part, in a thing capable of movement, from which movement first begins. Growth starts from above, locomotion from the right, sense and movement from in front, for front is simply the part to which the senses are directed. Hence we must not look for above and below, right and left, front and back, in every kind of body, but only in those which, being animate, have a principle of movement within themselves. For in no inanimate thing do we observe a part from which movement originates. Some do not move at all, some move, but not indifferently in any direction, fire, for example, only upward, and earth only to the center. It is true that we speak of above and below, right and left, in these bodies relatively to ourselves. The reference may be to our own right hands, as with the diviner, or to some similarity to our own members, such as the parts of a statue possess, or we may take the contrary spatial order, calling right that which is to our left, and left that which is to our right. We observe, however, in the things themselves none of these distinctions. Indeed, if they are turned round, we proceed to speak of the opposite parts as right and left, above and below, front and back. Hence it is remarkable that the Pythagoreans should have spoken of these two principles, right and left, only, to the exclusion of the other four, which have as good a title as they. There is no less difference between above and below or front and back in animals generally than between right and left. The difference is sometimes only one of function, sometimes also one of shape, and while the distinction of above and below is characteristic of all animate things, whether plants or animals, that of right and left is not found in plants. Further, inasmuch as length is prior to breadth, if above is the principle of length, right of breadth, and if the principle of that which is prior is itself prior, then above will be prior to right, or let us say, since prior is ambiguous, prior in order of generation. If, in addition, above is the region from which movement originates, right the region in which it starts, front the region to which it is directed, then on this ground too above has a certain original character as compared with the other forms of position. On these two grounds, then, they may fairly be criticized, first, for omitting the more fundamental principles, and secondly, for thinking that the two they mentioned were attributable equally to everything. Since we have already determined that functions of this kind belong to things which possess a principle of movement, and that the heaven is animate and possesses a principle of movement, clearly the heaven must also exhibit above and below, right and left. We need not be troubled by the question, arising from the spherical shape of the world, how there can be a distinction of right and left within it, all parts being alike and all forever in motion. We must think of the world as of something in which right differs from left in shape as well as in other respects, which subsequently is included in a sphere. The difference of function will persist, but will appear not by reason of the regularity of shape. In the same fashion must we conceive of the beginning of its movement. For even if it never began to move, yet it must possess a principle from which it would have begun to move if it had begun, and from which it would begin again if it came to a stand. Now by its length I mean the interval between its poles, one pole being above and the other below, for two hemispheres especially distinguished from all others by the immobility of the poles. Further, by transverse in the universe we commonly mean, not above and below, but a direction crossing the line of the poles, which, by implication, is length, for transverse motion is motion crossing motion up and down. Of the poles, that which we see above us is the lower region, and that which we do not see is the upper. For right in anything is, as we say, the region in which locomotion originates, and the rotation of the heaven originates in the region from which the stars rise. So this will be the right, and the region where they set the left. If then they begin from the right and move round to the right, the upper must be the unseen pole. For if it is the pole we see, the movement will be leftward, which we deny to be the fact. Clearly then the invisible pole is above. And those who live in the other hemisphere are above and to the right, while we are below and to the left. This is just the opposite of the view of the Pythagoreans, who make us above and on the right side and those in the other hemisphere below and on the left side, the fact being the exact opposite. Relatively, however, to the secondary revolution, I mean that of the planets, we are above and on the right and they are below and on the left. For the principle of their movement has the reverse position, since the movement itself is the contrary of the other, hence it follows that we are at its beginning and they at its end. Here we may end our discussion of the distinctions of parts created by the three dimensions and of the consequent differences of position. Since circular motion is not the contrary of the reverse circular motion, we must consider why there is more than one motion, though we have to pursue our inquiries at a distance created not so much by our spatial position as by the fact that our senses enable us to perceive very few of the attributes of the heavenly bodies. But let not that deter us. The reason must be sought in the following facts. Everything which has a function exists for its function. The activity of God is immortality, that is eternal life. Therefore the movement of that which is divine must be eternal. But such is the heaven, viz. A divine body, and for that reason to it is given the circular body whose nature it is to move always in a circle. Why, then, is not the whole body of the heaven of the same character as that part? Because there must be something at rest at the center of the revolving body, and of that body no part can be at rest, either elsewhere or at the center. It could do so only if the body's natural movement were towards the center. But the circular movement is natural, since otherwise it could not be eternal, for nothing unnatural is eternal. The unnatural is subsequent to the natural, being a derangement of the natural which occurs in the course of its generation. Earth then has to exist, for it is earth which is at rest at the center. At present we may take this for granted. It shall be explained later, but if earth must exist, so must fire. For, if one of a pair of contraries naturally exists, the other, if it is really contrary, exists also naturally. In some form it must be present, since the matter of contraries is the same. Also, the positive is prior to its privation. Warm, for instance, to cold, and rest and heaviness stand for the privation of lightness and movement. But further, if fire and earth exist, the intermediate bodies must exist also. Each element stands in a contrary relation to every other. This, again, we will here take for granted and try later to explain. These four elements' generation clearly is involved, since none of them can be eternal, for contraries interact with one another and destroy one another. Further, it is inconceivable that a movable body should be eternal, if its movement cannot be regarded as naturally eternal, and these bodies we know to possess movement. Thus we see that generation is necessarily involved. But if so, there must be at least one other circular motion, for a single movement of the whole heaven would necessitate an identical relation of the elements of bodies to one another. This matter also shall be cleared up in what follows, but for the present so much is clear, that the reason why there is more than one circular body is a necessity of generation, which follows on the presence of fire, which, with that of the other bodies, follows on that of earth, and earth is required because eternal movement in one body necessitates eternal rest in another. The shape of the heaven is of necessity spherical, for that is the shape most appropriate to its substance and also by nature primary. First, let us consider generally which shape is primary among planes and solids alike. Every plane figure must be either rectilinear or curvilinear. Now the rectilinear is bounded by more than one line, the curvilinear by one only. But since in any kind the one is naturally prior to the many and the simple to the complex, the circle will be the first of plane figures. Again, if by complete, as previously defined, we mean a thing outside which no part of itself can be found, and if addition is always possible to the straight line but never to the circular, clearly the line which embraces the circle is complete. If then the complete is prior to the incomplete, it follows on this ground also that the circle is primary among figures. And the sphere holds the same position among solids. For it alone is embraced by a single surface, while rectilinear solids have several. The sphere is among solids what the circle is among plane figures. Further, those who divide bodies into planes and generate them out of planes seem to bear witness to the truth of this. Alone among solids they leave the sphere undivided, as not possessing more than one surface, for the division into surfaces is not just dividing a whole by cutting it into its parts, but division of another fashion into parts different in form. It is clear, then, that the sphere is first of solid figures. If, again, one orders figures according to their numbers, it is most natural to arrange them in this way. The circle corresponds to the number 1, the triangle, being the sum of two right angles, to the number 2. But if 1 is assigned to the triangle, the circle will not be a figure at all. Now the first figure belongs to the first body, and the first body is that at the farthest circumference. It follows that the body which revolves with a circular movement must be spherical. The same then will be true of the body continuous with it, for that which is continuous with the spherical is spherical. The same again holds of the bodies between these and the center. Bodies which are bounded by the spherical and in contact with it must be, as wholes, spherical, and the bodies below the sphere of the planets are contiguous with the sphere above them. The sphere then will be spherical throughout, for every body within it is contiguous and continuous with spheres. Again, since the whole revolves, palpably and by assumption, in a circle, and since it has been shown that outside the farthest circumference there is neither void nor place, from these grounds also it will follow necessarily that the heaven is spherical. For if it is to be rectilinear in shape, it will follow that there is place and body and void without it. For a rectilinear figure as it revolves never continues in the same room, but where formerly was body, is now none, and where now is none, body will be in a moment because of the projection at the corners. Similarly, if the world had some other figure with unequal radii, if, for instance, it were lentiform, or oviform, in every case we should have to admit space and void outside the moving body, because the whole body would not always occupy the same room. Again, if the motion of the heaven is the measure of all movements whatever in virtue of being alone continuous and regular and eternal, and if, in each kind, the measure is the minimum, and the minimum movement is the swiftest, then, clearly, the movement of the heaven must be the swiftest of all movements. Now of lines which return upon themselves the line which bounds the circle is the shortest, and that movement is the swiftest which follows the shortest line. Therefore, if the heaven moves in a circle and moves more swiftly than anything else, it must necessarily be spherical. Corroborative evidence may be drawn from the bodies whose position is about the center. If earth is enclosed by water, water by air, air by fire, and these similarly by the upper bodies which while not continuous are yet contiguous with them, and if the surface of water is spherical, and that which is continuous with or embraces the spherical must itself be spherical, then on these grounds also it is clear that the heavens are spherical. But the surface of water is seen to be spherical if we take as our starting point the fact that water naturally tends to collect in a hollow place, hollow meaning nearer the center. Draw from the center the lines AB, AC, and let their extremities be joined by the straight line BC. The line AD, drawn to the base of the triangle, will be shorter than either of the radii. Therefore the place in which it terminates will be a hollow place. The water then will collect there until equality is established, that is until the line E is equal to the two radii. Thus water forces its way to the ends of the radii, and there only will it rest, but the line which connects the extremities of the radii is circular, therefore the surface of the water beck is spherical. It is plain from the foregoing that the universe is spherical. It is plain, further, that it is turned, so to speak, with a finish which no manufactured thing nor anything else within the range of our observation can even approach. For the matter of which these are composed does not admit of anything like the same regularity and finish as the substance of the enveloping body, since with each step away from earth the matter manifestly becomes finer in the same proportion as water is finer than earth. Now there are two ways of moving along a circle, from A to B or from A to C, and we have already explained that these movements are not contrary to one another. But nothing which concerns the eternal can be a matter of chance or spontaneity, and the heaven and its circular motion are eternal. We must therefore ask why this motion takes one direction and not the other. Either this is itself an ultimate fact or there is an ultimate fact behind it. It may seem evidence of excessive folly or excessive zeal to try to provide an explanation of some things, or of everything, admitting no exception. The criticism, however, is not always just. One should first consider what reason there is for speaking, and also what kind of certainty is looked for, whether human merely or of a more cogent kind. When anyone shall succeed in finding proofs of greater precision, gratitude will be due to him for the discovery, but at present we must be content with a probable solution. If nature always follows the best course possible, and, just as upward movement is the superior form of rectilinear movement, since the upper region is more divine than the lower, so forward movement is superior to backward, then front and back exhibits, like right and left, as we said before and as the difficulty just stated itself suggests, the distinction of prior and posterior, which provides a reason and so solves our difficulty. Supposing that nature is ordered in the best way possible, this may stand as the reason of the fact mentioned. For it is best to move with a movement simple and unceasing, and, further, in the superior of two possible directions. We have next to show that the movement of the heaven is regular and not irregular. This applies only to the first heaven and the first movement, for the lower spheres exhibit a composition of several movements into one. If the movement is uneven, clearly there will be acceleration, maximum speed, and retardation, since these appear in all irregular motions. The maximum may occur either at the starting point or at the goal or between the two, and we expect natural motion to reach its maximum at the goal, unnatural motion at the starting point, and missiles midway between the two. But circular movement, having no beginning or limit or middle in the direct sense of the words, has neither whence nor whither nor middle, for in time it is eternal, and in length it returns upon itself without a break. If then its movement has no maximum, it can have no irregularity, since irregularity is produced by retardation and acceleration. Further, since everything that is moved by something, the cause of the irregularity of movement must lie either in the mover or in the moved or both. For if the mover moved not always with the same force, or if the moved were altered and did not remain the same, or if both were to change, the result might well be an irregular movement in the moved. But none of these possibilities can be conceived as actual in the case of the heavens. As to that which is moved, we have shown that it is primary and simple and ungenerated and indestructible and generally unchanging, and the mover has an even better right to these attributes. It is the primary that moves the primary, the simple, the indestructible and ungenerated that which is indestructible and ungenerated. Since then that which is moved, being a body, is nevertheless unchanging, how should the mover, which is incorporeal, be changed? It follows then, further, that the motion cannot be irregular. For if irregularity occurs, there must be change either in the movement as a whole, from fast to slow and slow to fast, or in its parts. That there is no irregularity in the parts is obvious, since, if there were, some divergence of the stars would have taken place before now in the infinity of time, as one moved slower and another faster, but no alteration of their intervals is ever observed. Nor again is a change in the movement as a whole admissible. Retardation is always due to incapacity, and incapacity is unnatural. The incapacities of animals, age, decay, and the like, are all unnatural, due, it seems, to the fact that the whole animal complex is made up of materials which differ in respect of their proper places, and no single part occupies its own place. If therefore that which is primary contains nothing unnatural, being simple and unmixed and in its proper place and having no contrary, then it has no place for incapacity, nor, consequently, for retardation or, since acceleration involves retardation, for acceleration. Again, it is inconceivable that the mover should first show incapacity for an infinite time, and capacity afterwards for another infinity. For clearly nothing which, like incapacity, unnatural ever continues for an infinity of time, nor does the unnatural endure as long as the natural, or any form of incapacity as long as the capacity. But if the movement is retarded, it must necessarily be retarded for an infinite time. Equally impossible is perpetual acceleration or perpetual retardation. For such movement would be infinite and indefinite, but every movement, in our view, proceeds from one point to another and is definite in character. Again, suppose one assumes a minimum time in less than which the heaven could not complete its movement. For, as a given walk or a given exercise on the harp cannot take any and every time, but every performance has its definite minimum time which is unsurpassable, so, one might suppose, the movement of the heaven could not be completed in any and every time. But in that case perpetual acceleration is impossible, and, equally, perpetual retardation, for the argument holds of both and each, if we may take acceleration to proceed by identical or increasing additions of speed and for an infinite time. The remaining alternative is to say that the movement exhibits an alternation of slower and faster, but this is a mere fiction and quite inconceivable. Further, irregularity of this kind would be particularly unlikely to pass unobserved, since contrast makes observation easy. That there is one heaven, then, only, and that it is ungenerated and eternal, and further that its movement is regular, has now been sufficiently explained. We have next to speak of the stars, as they are called, of their composition, shape, and movements. It would be most natural and consequent upon what has been said that each of the stars should be composed of that substance in which their path lies, since, as we said, there is an element whose natural movement is circular. In so saying we are only following the same line of thought as those who say that the stars are fiery because they believe the upper body to be fire, the presumption being that a thing is composed of the same stuff as that in which it is situated. The warmth and light which proceed from them are caused by the friction set up in the air by their motion. Movement tends to create fire in wood, stone, and iron, and with even more reason should it have that effect on air, a substance which is closer to fire than these. An example is that of missiles, which as they move are themselves fired so strongly that leaden balls are melted, and if they are fired the surrounding air must be similarly affected. Now while the missiles are heated by reason of their motion in air, which is turned into fire by the agitation produced by their movement, the upper bodies are carried on a moving sphere, so that, though they are not themselves fired, yet the air underneath the sphere of the revolving body is necessarily heated by its motion, and particularly in that part where the sun is attached to it. Hence warmth increases as the sun gets nearer or higher or overhead. Of the fact, then, that the stars are neither fiery nor move in fire, enough has been said, since changes evidently occur not only in the position of the stars but also in that of the whole heaven. There are three possibilities. Either, 1, both are at rest, or, 2, both are in motion, or, 3, the one is at rest and the other in motion. 1, that both should be at rest is impossible, for, if the earth is at rest, the hypothesis does not account for the observations, and we take it as granted that the earth is at rest. It remains either that both are moved, or that the one is moved and the other at rest. 2, on the view, first, that both are in motion, we have the absurdity that the stars and the circles move with the same speed, that is that the arc of every star is that of the circle in it moves. For star and circle are seen to come back to the same place at the same moment, from which it follows that the star has traversed the circle and the circle has completed its own movement, that is traversed its own circumference, at one and the same moment. But it is difficult to conceive that the pace of each star should be exactly proportioned to the size of its circle. That the pace of each circle should be proportionate to its size is not absurd but inevitable, but that the same should be true of the movement of the stars contained in the circles is quite incredible. For if, on the one hand, we suppose that the star which moves on the greater circle is necessarily swifter, Clearly we also admit that if stars shifted their position so as to exchange circles, the slower would become swifter and the swifter slower. But this would show that their movement was not their own, but due to the circles. If, on the other hand, the arrangement was a chance combination, the coincidence in every case of a greater circle with a swifter movement of the star contained in it is too much to believe. In one or two cases it might not inconceivably fall out so, but to imagine it in every case alike is a mere fiction. Besides, chance has no place in that which is natural, and what happens everywhere and in every case is no matter of chance. 3. The same absurdity is equally plain if it is supposed that the circles stand still and that it is the stars themselves which move. For it will follow that the outer stars are the swifter, and that the pace of the stars corresponds to the size of their circles, since, then, we cannot reasonably suppose either that both are in motion or that the star alone moves. The remaining alternative is that the circles should move, while the stars are at rest and move with the circles to which they are attached. Only on this supposition are we involved in no absurd consequence. 4. In the first place, the quicker movement of the larger circle is natural when all the circles are attached to the same center. Whenever bodies are moving with their proper motion, the larger moves quicker. It is the same here with the revolving bodies, for those that are intercepted by two radii will be larger in the larger circle, and hence it is not surprising that the revolution of the larger circle should take the same time as that of the smaller. And secondly, the fact that the heavens do not break in pieces follows not only from this but also from the proof already given of the continuity of the whole. Again, since the stars are spherical, as our opponents assert and we may consistently admit, inasmuch as we construct them out of the spherical body, and since the spherical body has two movements proper to itself, namely rolling and spinning, it follows that if the stars have a movement of their own, it will be one of these. But neither is observed. 1. Suppose them to spin. They would then stay where they were, and not change their place, as, by observation and general consent, they do. Further, one would expect them all to exhibit the same movement, but the only star which appears to possess this movement is the sun, at sunrise or sunset, and this appearance is due not to the sun itself but to the distance from which we observe it. The visual ray being excessively prolonged becomes weak and wavering. The same reason probably accounts for the apparent twinkling of the fixed stars and the absence of twinkling in the planets. The planets are near, so that the visual ray reaches them in its full vigor. But when it comes to the fixed stars it is quivering because of the distance and its excessive extension, and its tremor produces an appearance of movement in the star, for it makes no difference whether movement is set up in the ray or in the object of vision. 2. On the other hand, it is also clear that the stars do not roll. For rolling involves rotation, but the face, as it is called, of the moon is always seen. Therefore, since any movement of their own which the stars possessed would presumably be one proper to themselves, and no such movement is observed in them, clearly they have no movement of their own. There is, further, the absurdity that nature has bestowed upon them no organ appropriate to such movement. For nature leaves nothing to chance, and would not, while caring for animals, overlook things so precious. Indeed, nature seems deliberately to have stripped them of everything which makes self-originated progression possible, and to have removed them as far as possible from things which have organs of movement. This is just why it seems proper that the whole heaven and every star should be spherical. For while of all shapes the sphere is the most convenient for movement in one place, making possible, as it does, the swiftest and the most self-contained motion, for forward movement it is the most unsuitable, least of all resembling shapes which are self-moved, in that it has no dependent or projecting part, as a rectilinear figure has, and is in fact as far as possible removed in shape from ambulatory bodies. Since, therefore, the heavens have to move in one place, and the stars are not required to move themselves forward, it is natural that both should be spherical, a shape which best suits the movement of the one and the immobility of the other. From all this it is clear that the theory that the movement of the stars produces a harmony, that is that the sounds they make are concordant, in spite of the grace and originality with which it has been stated, is nevertheless untrue. Some thinkers suppose that the motion of bodies of that size must produce a noise, since on our earth the motion of bodies far inferior in size and in speed of movement has that effect. Also, when the sun and the moon, they say, and all the stars, so great in number and in size, are moving with so rapid a motion, how should they not produce a sound immensely great? Starting from this argument and from the observation that their speeds, as measured by their distances, are in the same ratios as musical concordances, they assert that the sound given forth by the circular movement of the stars is a harmony. Since, however, it appears unaccountable that we should not hear this music, They explain this by saying that the sound is in our ears from the very moment of birth and is thus indistinguishable from its contrary silence, since sound and silence are discriminated by mutual contrast. What happens to men, then, is just what happens to coppersmiths, who are so accustomed to the noise of the smithy that it makes no difference to them. But, as we said before, melodious and poetical as the theory is, it cannot be a true account of the facts. There is not only the absurdity of our hearing nothing, the ground of which they try to remove, but also the fact that no effect other than sensitive is produced upon us. Excessive noises, we know, shatter the solid bodies even of inanimate things. The noise of thunder, for instance, splits rocks and the strongest of bodies. But if the moving bodies are so great, and the sound which penetrates to us is proportionate to their size, that sound must needs reach us in an intensity many times that of thunder, and the force of its action must be immense. Indeed, the reason why we do not hear, and show in our bodies none of the effects of violent force, is easily given. It is that there is no noise. But not only is the explanation evident, it is also a corroboration of the truth of the views we have advanced. For the very difficulty which made the Pythagoreans say that the motion of the stars produces a concord corroborates our view. Bodies which are themselves in motion, produce noise and friction, but those which are attached or fixed to a moving body, as the parts to a ship, can no more create noise, than a ship on a river moving with a stream. Yet by the same argument one might say it was absurd that on a large vessel the motion of mast and poop should not make a great noise, and the like might be said of the movement of the vessel itself. But sound is caused when a moving body is enclosed in an unmoved body, and cannot be caused by one enclosed in, and continuous with, a moving body which creates no friction. We may say, then, in this matter that if the heavenly bodies moved in a generally diffused mass of air or fire, as everyone supposes, their motion would necessarily cause a noise of tremendous strength, and such a noise would necessarily reach and shatter us. Since, therefore, this effect is evidently not produced, it follows that none of them can move with a motion either of animate nature or of constraint. It is as though nature had foreseen the result, that if their movement were other than it is, nothing on this earth could maintain its character. That the stars are spherical and are not self-moved, has now been explained. With their order I mean the position of each, as involving the priority of some and the posteriority of others, and their respective distances from the extremity. With this astronomy may be left to deal, since the astronomical discussion is adequate. This discussion shows that the movements of the several stars depend, as regards the varieties of speed which they exhibit, on the distance of each from the extremity. It is established that the outermost revolution of the heavens is a simple movement and the swiftest of all, and that the movement of all other bodies is composite and relatively slow, for the reason that each is moving on its own circle with a reverse motion to that of the heavens. This at once leads us to expect that the body which is nearest to that first simple revolution should take the longest time to complete its circle, and that which is farthest from it the shortest, the others taking a longer time the nearer they are and a shorter time the farther away they are. For it is the nearest body which is most strongly influenced, and the most remote, by reason of its distance, which is least affected, the influence on the intermediate bodies varying, as the mathematicians show, with their distance. With regard to the shape of each star, the most reasonable view is that they are spherical. It has been shown that it is not in their nature to move themselves, and, since nature is no wanton or random creator, clearly she will have given things which possess no movement a shape particularly unadapted to movement. Such a shape is the sphere, since it possesses no instrument of movement. Clearly then their mass will have the form of a sphere. Again, what holds of one holds of all, and the evidence of our eyes shows us that the moon is spherical. For how else should the moon as it waxes and wanes show for the most part a crescent-shaped or gibbous figure, and only at one moment a half-moon? And astronomical arguments give further confirmation, for no other hypothesis accounts for the crescent shape of the sun's eclipses. 1. Then, of the heavenly bodies being spherical, clearly the rest will be spherical also. There are two difficulties, which may very reasonably here be raised, of which we must now attempt to state the probable solution. For we regard the zeal of one whose thirst after philosophy leads him to accept even slight indications where it is very difficult to see one's way, as a proof rather of modesty than of overconfidence. Of many such problems one of the strangest is the problem why we find the greatest number of movements in the intermediate bodies, and not, rather, in each successive body a variety of movement proportionate to its distance from the primary motion. For we should expect, since the primary body shows one motion only, that the body which is nearest to it should move with the fewest movements, say 2, and the one next after that with 3, or some similar arrangement. But the opposite is the case. The movements of the sun and moon are fewer than those of some of the planets. Yet these planets are farther from the center and thus nearer to the primary body than they, as observation has itself revealed. For we have seen the moon, half full, pass beneath the planet Mars, which vanished on its shadow side and came forth by the bright and shining part. Similar accounts of other stars are given by the Egyptians and Babylonians, whose observations have been kept for very many years past, and from whom much of our evidence about particular stars is derived. A second difficulty which may with equal justice be raised is this. Why is it that the primary motion includes such a multitude of stars that their whole array seems to defy counting, while of the other stars each one is separated off, and in no case do we find two or more attached to the same motion? On these questions, I say, it is well that we should seek to increase our understanding, though we have but little to go upon, and are placed at so great a distance from the facts in question. Nevertheless, there are certain principles on which if we base our consideration we shall not find this difficulty by any means insoluble. We may object that we have been thinking of the stars as mere bodies, and as units with a serial order indeed but entirely inanimate, but should rather conceive them as enjoying life and action. On this view the facts cease to appear surprising. For it is natural that the best conditioned of all things should have its good without action, that which is nearest to it should achieve it by little and simple action, and that which is further removed by a complexity of actions, just as with men's bodies one is in good condition without exercise at all, another after a short walk, while another requires running and wrestling and hard training, and there are yet others who however hard they work themselves could never secure this good, but only some substitute for it. To succeed often or in many things is difficult. For instance, to throw 10,000 cone throws with the dice would be impossible, but to throw one or two is comparatively easy. In action, again, when A has to be done to get B, B to get C, and C to get D, one step or two present little difficulty, but as the series extends the difficulty grows. We must, then, think of the action of the lower stars as similar to that of animals and plants. For on our earth it is man that has the greatest variety of actions, for there are many goods that man can secure, hence his actions are various and directed to ends beyond them, while the perfectly conditioned has no need of action, since it is itself the end, and action always requires two terms, end and means. The lower animals have less variety of action than man, and plants perhaps have little action and of one kind only. For either they have but one attainable good, as indeed man has, or, if several, each contributes directly to their ultimate good. One thing then has and enjoys the ultimate good, other things attain to it, one immediately by few steps, another by many, while yet another does not even attempt to secure it but is satisfied to reach a point not far removed from that consummation. Thus, taking health as the end, there will be one thing that always possesses health, others that attain it, one by reducing flesh, another by running and thus reducing flesh, another by taking steps to enable himself to run, thus further increasing the number of movements, while another cannot attain health itself, but only running or reduction of flesh, so that one or other of these is for such a being the end. For while it is clearly best for any being to attain the real end, yet, if that cannot be, the nearer it is to the best the better will be its state. It is for this reason that the earth moves not at all and the bodies near to it with few movements. For they do not attain the final end, but only come as near to it as their share in the divine principle permits. But the first heaven finds it immediately with a single movement, and the bodies intermediate between the first and last heavens attain it indeed, but at the cost of a multiplicity of movement. As to the difficulty that into the one primary motion is crowded a vast multitude of stars, while of the other stars each has been separately given special movements of its own, there is in the first place this reason for regarding the arrangement as a natural one. In thinking of the life and moving principle of the several heavens one must regard the first as far superior to the others. Such a superiority would be reasonable. For this single first motion has to move many of the divine bodies, while the numerous other motions move only one each, since each single planet moves with a variety of motions. Thus, then, nature makes matters equal and establishes a certain order, giving to the single motion many bodies and to the single body many motions. And there is a second reason why the other motions have each only one body, in that each of them except the last, that is that which contains the one star, is really moving many bodies. For this last sphere moves with many others, to which it is fixed, each sphere being actually a body, so that its movement will be a joint product. Each sphere, in fact, has its particular natural motion, to which the general movement is, as it were, added. But the force of any limited body is only adequate to moving a limited body. The characteristics of the stars which move with a circular motion, in respect of substance and shape, movement and order, have now been sufficiently explained. It remains to speak of the earth, of its position, of the question whether it is at rest or in motion, and of its shape. As to its position there is some difference of opinion. Most people, all, in fact, who regard the whole heaven as finite, say it lies at the center. But the Italian philosophers known as Pythagoreans take the contrary view. At the center, they say, is fire, and the earth is one of the stars, creating night and day by its circular motion about the center. They further construct another earth in opposition to ours, to which they give the name counter-earth. In all this they are not seeking for theories and causes to account for observed facts, but rather forcing their observations and trying to accommodate them to certain theories and opinions of their own. But there are many others who would agree that it is wrong to give the earth the central position, looking for confirmation rather to theory than to the facts of observation. Their view is that the most precious place befits the most precious thing, but fire, they say, is more precious than earth, and the limit than the intermediate, and the circumference and the center are limits. Reasoning on this basis they take the view that it is not earth that lies at the center of the sphere, but rather fire. The Pythagoreans have a further reason. They hold that the most important part of the world, which is the center, should be most strictly guarded, and name it, or rather the fire which occupies that place, the guardhouse of Zeus, as if the word center were quite unequivocal, and the center of the mathematical figure were always the same with that of the thing or the natural center. But it is better to conceive of the case of the whole heaven as analogous to that of animals, in which the center of the animal and that of the body are different. For this reason they have no need to be so disturbed about the world, or to call in a guard for its center. Rather let them look for the center in the other sense and tell us what it is like and where nature has set it. That center will be something primary and precious, but to the mere position we should give the last place rather than the first. For the middle is what is defined, and what defines it is the limit. And that which contains or limits is more precious than that which is limited, seeing that the latter is the matter and the former the essence of the system. 2. As to the position of the earth, then, this is the view which some advance, and the views advanced concerning its rest or motion are similar. For here too there is no general agreement. All who deny that the earth lies at the center think that it revolves about the center, and not the earth only but, as we said before, the counter-earth as well. Some of them even consider it possible that there are several bodies so moving, which are invisible to us owing to the interposition of the earth. This, they say, accounts for the fact that eclipses of the moon are more frequent than eclipses of the sun, for in addition to the earth each of these moving bodies can obstruct it. Indeed, as in any case the surface of the earth is not actually a center but distant from it a full hemisphere, there is no more difficulty, they think, in accounting for the observed facts on their view that we do not dwell at the center, than on the common view that the earth is in the middle. Even as it is, there is nothing in the observations to suggest that we are removed from the center by half the diameter of the earth. Others, again, say that the earth, which lies at the center, is rolled, and thus in motion, about the axis of the whole heaven, so it stands written in the Timaeus. 3. There are similar disputes about the shape of the earth. Some think it is spherical, others that it is flat and drum-shaped. For evidence they bring the fact that, as the sun rises and sets, the part concealed by the earth shows a straight and not a curved edge, whereas if the earth were spherical the line of section would have to be circular. In this they leave out of account the great distance of the sun from the earth and the great size of the circumference, which, seen from a distance on these apparently small circles appears straight. Such an appearance ought not to make them doubt the circular shape of the earth. But they have another argument. They say that because it is at rest, the earth must necessarily have this shape. For there are many different ways in which the movement or rest of the earth has been conceived. The difficulty must have occurred to everyone. It would indeed be a complacent mind that felt no surprise that, while a little bit of earth, let loose in midair moves and will not stay still, and more there is of it the faster it moves, the whole earth, free in midair, should show no movement at all. Yet here is this great weight of earth, and it is at rest. And again, from beneath one of these moving fragments of earth, before it falls, take away the earth, and it will continue its downward movement with nothing to stop it. The difficulty then, has naturally passed into a commonplace of philosophy, and one may well wonder that the solutions offered are not seen to involve greater absurdities than the problem itself. By these considerations some have been led to assert that the earth below us is infinite, saying, with Xenophanes of Colophon, that it has pushed its roots to infinity, in order to save the trouble of seeking for the cause. Hence the sharp rebuke of Empedocles, in the words, if the deeps of the earth are endless and endless the ample ether, such is the vain tale told by many a tongue, poured from the mouths of those who have seen but little of the whole. Others say the earth rests upon water. This, indeed, is the oldest theory that has been preserved, and is attributed to Thales of Meltis. It was supposed to stay still because it floated like wood and other similar substances, which are so constituted as to rest upon but not upon air. As if the same account had not to be given of the water which carries the earth as of the earth itself. It is not the nature of water, any more than of earth, to stay in mid-air. It must have something to rest upon. Again, as air is lighter than water, so is water than earth. How then can they think that the naturally lighter substance lies below the heavier? Again, if the earth as a whole is capable of floating upon water, that must obviously be the case with any part of it. But observation shows that this is not the case. Any piece of earth goes to the bottom, the quicker the larger it is. These thinkers seem to push their inquiries some way into the problem, but not so far as they might. It is what we are all inclined to do, to direct our inquiry not by the matter itself, but by the views of our opponents, and even when interrogating oneself one pushes the inquiry only to the point at which one can no longer offer any opposition. Hence a good inquirer will be one who is ready in bringing forward the objections proper to the genus, and that he will be when he has gained an understanding of all the differences. Anaximenes and Anaxagoras and Democritus give the flatness of the earth as the cause of its staying still. Thus, they say, it does not cut, but covers like a lid, the air beneath it. This seems to be the way of flat-shaped bodies, for even the wind can scarcely move them because of their power of resistance. The same immobility, they say, is produced by the flatness of the surface which the earth presents to the air which underlies it, while the air, not having room enough to change its place because it is underneath the earth, stays there in a mass, like the water in the case of the water clock. And they adduce an amount of evidence to prove that air, when cut off and at rest, can bear a considerable weight. Now, first, if the shape of the earth is not flat, its flatness cannot be the cause of its immobility. But in their own account it is rather the size of the earth than its flatness that causes it to remain at rest. For the reason why the air is so closely confined that it cannot find a passage, and therefore stays where it is its great amount, and this amount great because the body which isolates it, the earth, is very large. This result, then, will follow, even if the earth is spherical, so long as it retains its size. So far as their arguments go, the earth will still be at rest. In general, our quarrel with those who speak of movement in this way cannot be confined to the parts, it concerns the whole universe. One must decide at the outset whether bodies have a natural movement or not, whether there is no natural but only constrained movement. Seeing, however, that we have already decided this matter to the best of our ability, we are entitled to treat our results as representing fact. Bodies, we say, which have no natural movement, have no constrained movement, and where there is no natural and no constrained movement there will be no movement at all. This is a conclusion, the necessity of which we have already decided, and we have seen further that rest also will be inconceivable, since rest, like movement, is either natural or constrained. But if there is any natural movement, constraint will not be the sole principle of motion or of rest. If, then, it is by constraint that the earth now keeps its place, the so-called whirling movement by which its parts came together at the center was also constrained. The form of causation supposed they all borrow from observations of liquids and of air, in which the larger and heavier bodies always move to the center of the whirl. This is thought by all those who try to generate the heavens to explain why the earth came together at the center. They then seek a reason for its staying there, and some say, in the manner explained, that the reason is its size and flatness, others, with empedocles, that the motion of the heavens, moving about it at a higher speed, prevents movement of the earth, as the water in a cup, when the cup is given a circular motion, though it is often underneath the bronze, is for this same reason prevented from moving with the downward movement which is natural to it. But suppose both the whirl and its flatness, the air beneath being withdrawn, cease to prevent the earth's motion, where will the earth move to then? Its movement to the center was constrained, and its rest at the center is due to constraint, but there must be some motion which is natural to it. Will this be upward motion or downward or what? It must have some motion, and if upward and downward motion are alike to it, and the air above the earth does not prevent upward movement, then no more could air below it prevent downward movement. For the same cause must necessarily have the same effect on the same thing. Further, against empedocles there is another point which might be made. When the elements were separated off by hate, what caused the earth to keep its place? Surely the world cannot have been then also the cause. It is absurd too not to perceive that, while the whirling movement may have been responsible for the original coming together of the art of earth at the center, the question remains, why now do all heavy bodies move to the earth? For the whirl surely does not come near us. Why, again, does fire move upward? Not, Surely, because of the whirl. But if fire is naturally such as to move in a certain direction, clearly the same may be supposed to hold of earth. Again, it cannot be the whirl which determines the heavy and the light. Rather that movement caused the pre-existent heavy and light things to go to the middle and stay on the surface respectively. Thus, before ever the whirl began, heavy and light existed, and what can have been the ground of their distinction, or the manner and direction of their natural movements? In the infinite chaos there can have been neither above nor below, and it is by these that heavy and light are determined. It is to these causes that most writers pay attention, but there are some, Anaximander, for instance, among the ancients, who say that the earth keeps its place because of its indifference. Motion upward and downward and sideways were all, they thought, equally inappropriate to that which is set at the center and indifferently related to every extreme point, and to move in contrary directions at the same time was impossible, so it must needs remain still. This view is ingenious but not true. The argument would prove that everything, whatever it be, which is put at the center, must stay there. Fire, then, will rest at the center, for the proof turns on no peculiar property of earth. But this does not follow. The observed facts about earth are not only that it remains at the center, but also that it moves to the center. The place to which any fragment of earth moves must necessarily be the place to which the whole moves, and in the place to which a thing naturally moves, it will naturally rest. The reason then is not in the fact that the earth is indifferently related to every extreme point, for this would apply to any body, whereas movement to the center is peculiar to earth. Again, it is absurd to look for a reason why the earth remains at the center and not for a reason why fire remains at the extremity. If the extremity is the natural place of fire, clearly earth must also have a natural place. But suppose that the center is not its place, and that the reason of its remaining there is this necessity of indifference on the analogy of the hair which, it is said, however great the tension, will not break under it, if it be evenly distributed, or of the men who, though exceedingly hungry and thirsty, and both equally, yet being equidistant from food and drink, is therefore bound to stay where he is. Even so, it still remains to explain why fire stays at the extremities. It is strange, too, to ask about things staying still but not about their motion. Why, I mean, one thing, if nothing stops it, moves up, and another thing to the center. Again, their statements are not true. It happens, indeed, to be the case that a thing to which movement this way and that is equally inappropriate is obliged to remain at the center. But so far as their argument goes, instead of remaining there, it will move, only not as a mass but in fragments. For the argument applies equally to fire. Fire, if set at the center, should stay there, like earth, since it will be indifferently related to every point on the extremity. Nevertheless it will move, as in fact it always does move when nothing stops it, away from the center to the extremity. It will not, however, move en masse to a single point on the circumference, the only possible result on the lines of the indifference theory, but rather each corresponding portion of fire to the corresponding part of the extremity, each fourth part, for instance, to a fourth part of the circumference. For since no body is a point, it will have parts. The expansion, when the body increased the place occupied, would be on the same principle as the contraction, in which the place was diminished. Thus, for all the indifference theory shows to the contrary, earth also would have moved in this manner away from the center, unless the center had been its natural place. We have now outlined the views held as to the shape, position, and rest or movement of the earth. Let us first decide the question whether the earth moves or is at rest. For, as we said, there are some who make it one of the stars, and others who, setting it at the center, suppose it to be rolled and in motion about the polar axis. That both views are untenable will be clear if we take as our starting point the fact that the earth's motion, whether the earth be at the center or away from it, must needs be a constrained motion. It cannot be the movement of the earth itself. If it were, any portion of it would have this movement, but in fact every part moves in a straight line to the center. Being, then, constrained and unnatural, the movement could not be eternal. But the order of the universe is eternal. Again, everything that moves with the circular movement, except the first sphere, is observed to be past, and to move with more than one motion. The earth, then, also, whether it move about the center or as stationary at it, must necessarily move with two motions. But if this were so, there would have to be passings and turnings of the fixed stars. Yet no such thing is observed. The same stars always rise and set in the same parts of the earth. Further, the natural movement of the earth, part and whole alike, is the center of the whole, whence the fact that it is now actually situated at the center. But it might be questioned, since both centers are the same, which center it is that portions of earth and other heavy things move to. Is this their goal because it is the center of the earth or because it is the center of the whole? The goal, surely, must be the center of the whole. For fire and other light things move to the extremity of the area which contains the center. It happens, however, that the center of the earth and of the whole is the same. Thus they do move to the center of the earth, but accidentally, in virtue of the fact that the earth's center lies at the center of the whole. That the center of the earth is the goal of their movement is indicated by the fact that heavy bodies moving towards the earth do not parallel but so as to make equal angles, and thus to a single center, that of the earth. It is clear, then, that the earth must be at the center and immovable, not only for the reasons already given, but also because heavy bodies forcibly thrown quite straight upward return to the point from which they started, even if they are thrown to an infinite distance. From these considerations then it is clear that the earth does not move and does not lie elsewhere than at the center. From what we have said the explanation of the earth's immobility is also apparent. If it is the nature of earth, as observation shows, to move from any point to the center, as a fire contrariwise to move from the center to the extremity, it is impossible that any portion of earth should move away from the center except by constraint. For a single thing has a single movement, and a simple thing is simple. Contrary movements cannot belong to the same thing, and movement away from the center is the contrary of movement to it. If then no portion of earth can move away from the center, obviously still less can the earth as a whole so move. For it is the nature of the whole to move to the point to which the part naturally moves. Since, then, it would require a force greater than itself to move it, it must needs stay at the center. This view is further supported by the contributions of mathematicians to astronomy, since the observations made as the shapes change by which the order of the stars is determined, are fully accounted for on the hypothesis that the earth lies at the center. Of the position of the earth and of the manner of its rest or movement, our discussion may here end. Its shape must necessarily be spherical. For every portion of earth has weight until it reaches the center, and the jostling of parts greater and smaller would bring about not a waved surface, but rather compression and convergence of part and part until the center is reached. The process should be conceived by supposing the earth to come into being in the way that some of the natural philosophers describe. Only they attribute the downward movement to constraint, and it is better to keep to the truth and say that the reason of this motion is that a thing which possesses weight is naturally endowed with a centripetal movement. When the mixture, then, was merely potential, the things that were separated off moved similarly from every side towards the center. Whether the parts which came together at the center were distributed at the extremities evenly, or in some other way, makes no difference. If, on the one hand, there were a similar movement from each quarter of the extremity to the single center, it is obvious that the resulting mass would be similar on every side. For if an equal amount is added on every side, the extremity of the mass will be everywhere equidistant from its center, that is, the figure will be spherical. But neither will it in any way affect the argument if there is not a similar accession of concurrent fragments from every side. For the greater quantity, finding a lesser in front of it, must necessarily drive it on, both having an impulse whose goal is the center, and the greater weight driving the lesser forward till this goal is reached. In this we have also the solution of a possible difficulty. The earth, it might be argued, is at the center and spherical in shape. If, then, a weight many times that of the earth were added to one hemisphere, the center of the earth and of the whole will no longer be coincident. So that either the earth will not stay still at the center, or if it does, it will be at rest without having its center at the place to which it is still its nature to move. Such is the difficulty. A short consideration will give us an easy answer, if we first give precision to our postulate that any body endowed with weight, of whatever size, moves towards the center. Clearly it will not stop when its edge touches the center. The greater quantity must prevail until the body's center occupies the center. For that is the goal of its impulse. Now it makes no difference whether we apply this to a clod or common fragment of earth or to the earth as a whole. The fact indicated does not depend upon degrees of size but applies universally to everything that has the centripetal impulse. Therefore earth in motion, whether in a mass or in fragments, necessarily continues to move until it occupies the center equally every way, the less being forced to equalize itself by the greater owing to the forward drive of the impulse. If the earth was generated, then, it must have been formed in this way, and so clearly its generation was spherical, and if it is ungenerated and has remained so always, its character must be that which the initial generation, if it had occurred, would have given it. But the spherical shape, necessitated by this argument, follows also from the fact that the motions of heavy bodies always make equal angles, and are not parallel. This would be the natural form of movement towards what is naturally spherical. Either then the earth is spherical or it is at least naturally spherical. and it is right to call anything that which nature intends it to be, and which belongs to it, rather than that which it is by constraint and contrary to nature. The evidence of the senses further corroborates this. How else would eclipses of the moon show segments shaped as we see them? As it is, the shapes which the moon itself each month shows are of every kind, straight, gibbous, and concave, but in eclipses the outline is always curved, and, since it is the interposition of the earth that makes the eclipse, the form of this line will be caused by the form of the earth's surface, which is therefore spherical. Again, our observations of the stars make it evident, not only that the earth is circular, but also that it is a circle of no great size. For quite a small change of position to south or north causes a manifest alteration of the horizon. There is much change, I mean, in the stars which are overhead, and the stars seen are different, as one moves northward or southward. Indeed, there are some stars seen in Egypt and in the neighborhood of Cyprus which are not seen in the northerly regions, and stars, which in the north are never beyond the range of observation, in those regions rise and set. All of which goes to show not only that the earth is circular in shape, but also that it is a sphere of no great size, for otherwise the effect of so slight a change of place would not be quickly apparent. Hence one should not be too sure of the incredibility of the view of those who conceive that there is continuity between the parts about the Pillars of Hercules and the parts about India, and that in this way the ocean is one. As further evidence in favor of this they quote the case of elephants, a species occurring in each of these extreme regions, suggesting that the common characteristic of these extremes is explained by their continuity. Also, those mathematicians who try to calculate the size of the Earth's circumference arrive at the figure 400,000 stades. This indicates not only that the Earth's mass is spherical in shape, but also that as compared with the stars it is not of great size. On the Heavens, Book 3, translated by J. L. Stocks, we have already discussed the first heaven and its parts, the moving stars within it, the matter of which these are composed and their bodily constitution, and we have also shown that they are ungenerated and indestructible. Now things that we call that natural are either substances or functions and attributes of substances. As substances I class the simple bodies fire, earth, and the other terms of the series and all things composed of them, for example, the heaven as a whole and its parts, animals, again, and plants and their parts. By attributes and functions I mean the movements of these and of all other things in which they have power in themselves to cause movement, and also their alterations and reciprocal transformations. It is obvious, then, that the greater part of the inquiry into nature concerns bodies, for a natural substance is either a body or a thing which cannot come into existence without body and magnitude. This appears plainly from an analysis of the character of natural things, and equally from an inspection of the instances of inquiry into nature. Since, then, we have spoken of the primary element, of its bodily constitution, and of its freedom from destruction and generation, it remains to speak of the other two. In speaking of them we shall be obliged also to inquire into generation and destruction. For if there is generation anywhere, it must be in these elements and things composed of them. This is indeed the first question we have to ask: is generation a fact or not? Earlier speculation was at variance both with itself and with the views here put forward as to the true answer to this question. Some removed generation and destruction from the world altogether. Nothing that is, they said, is generated or destroyed, and our conviction to the contrary is an illusion. So maintain the school of Melissus and Parmenides. But however excellent their theories may otherwise be, anyhow they cannot be held to speak as students of nature. There may be things not subject to generation or any kind of movement, but if so they belong to another and a higher inquiry than the study of nature. They, however, had no idea of any form of being other than the substance of things perceived, and when they saw, what no one previously had seen, that there could be no knowledge or wisdom without some such unchanging entities, they naturally transferred what was true of them to things perceived. Others, perhaps intentionally, maintain precisely the contrary opinion to this. It has been asserted that everything in the world was subject to generation and nothing was ungenerated, but that after being generated some things remained indestructible while the rest were again destroyed. This had been asserted in the first instance by Hesiod and his followers, but afterwards outside his circle by the earliest natural philosophers. But what these thinkers maintained was that all else has been generated and, as they said, is flowing away, nothing having any solidity, except one single thing which persists as the basis of all these transformations. So we may interpret the statements of Heraclitus of Ephesus and many others. And some subject all bodies whatever to generation, by means of the composition and separation of planes. Discussion of the other views may be postponed. But this last theory which composes every body of planes is, as the most superficial observation shows, in many respects in plain contradiction with mathematics. It is, however, wrong to remove the foundations of a science unless you can replace them with others more convincing. And, secondly, the same theory which composes solids of planes clearly composes planes of lines and lines of points, so that a part of a line need not be a line. This matter has been already considered in our discussion of movement, where we have shown that an indivisible length is impossible. But with respect to natural bodies there are impossibilities involved in the view which asserts indivisible lines, which we may briefly consider at this point. For the impossible consequences which result from this view in the mathematical sphere will reproduce themselves when it is applied to physical bodies. But there will be difficulties in physics which are not present in mathematics, for mathematics deals with an abstract and physics with a more concrete object. There are many attributes necessarily present in physical bodies which are necessarily excluded by indivisibility, all attributes, in fact, which are divisible. There can be nothing divisible in an indivisible thing, but the attributes of bodies are all divisible in one of two ways. They are divisible into kinds, as color is divided into white and black, and they are divisible per accidens when that which has them is divisible. In this latter sense attributes which are simple are nevertheless divisible. Attributes of this kind will serve, therefore, to illustrate the impossibility of the view. It is impossible, if two parts of a thing have no weight, that the two together should have weight. But either all perceptible bodies or some, such as earth and water, have weight, as these thinkers would themselves admit. Now if the point has no weight, clearly the lines have not either, and, if they have not, neither have the planes. Therefore no body has weight. It is, further, manifest that their point cannot have weight. For while a heavy thing may always be heavier than something and a light thing lighter than something, a thing which is heavier or lighter than something need not be itself heavy or light, just as a large thing is larger than others, but what is larger is not always large. A thing which, judged absolutely, is small may nonetheless be larger than other things. Whatever, then, is heavy and also heavier than something else, must exceed this by something which is heavy. A heavy thing therefore is always divisible. But it is common ground that a point is indivisible. Again, suppose that what is heavy or weight is a dense body, and what is light rare. Dense differs from rare in containing more matter in the same cubic area. A point, then, if it may be heavy or light, may be dense or rare. But the dense is divisible while a point is indivisible. And if what is heavy must be either hard or soft, an impossible consequence is easy to draw. For a thing is soft if its surface can be pressed in, hard if it cannot, and if it can be pressed in it is divisible. Moreover, no weight can consist of parts not possessing weight. For how, except by the merest fiction, can they specify the number and character of the parts which will produce weight? And, further, when one weight is greater than another, the difference is a third weight, from which it will follow that every indivisible part possesses weight. For suppose that a body of 4 points possesses weight. A body composed of more than 4 points will superior in weight to it, a thing which has weight. But the difference between weight and weight must be a weight, as the difference between white and whiter is white. Here the difference which makes the superior weight heavier is the single point which remains when the common number, 4, is subtracted. A single point, therefore, has weight. Further, to assume, on the one hand, that the planes can only be put in linear contact would be ridiculous. For just as there are two ways of putting lines together, namely, and to and side by side, so there must be two ways of putting planes together. Lines can be put together so that contact is linear by laying one along the other, though not by putting them end to end. But if, similarly, in putting the lanes together, superficial contact is allowed as an alternative to linear, that method will give them bodies which are not any element nor composed of elements. Again, if it is the number of planes in a body that makes one heavier than another, as the Timaeus explains, clearly the line and the point will have weight. For the three cases are, as we said before, analogous. But if the reason of differences of weight is not this, but rather the heaviness of earth and the lightness of fire, then some of the planes will be light and others heavy, which involves a similar distinction in the lines and the points. The earth plane, I mean, will be heavier than the fire plane. In general, the result is either that there is no magnitude at all, or that all magnitude could be done away with. For a point is to a line as a line is to a plane and as a plane is to a body. Now the various forms in passing into one another will each be resolved into its ultimate constituents. It might happen therefore that nothing existed except points, and that there was no body at all. A further consideration is that if time is similarly constituted, there would be, or might be, a time at which it was done away with. For the indivisible now is like a point in a line. The same consequences follow from composing the heaven of numbers, as some of the Pythagoreans do who make all nature out of numbers. For natural bodies are manifestly endowed with weight and lightness, but an assemblage of units can neither be composed to form a body nor possess weight. The necessity that each of the simple bodies should have a natural movement may be shown as follows. They manifestly move, and if they have no proper movement they must move by constraint, and the constrained is the same as the unnatural. Now an unnatural movement presupposes a natural movement which it contravenes, and which, however many the unnatural movements, is always one. For naturally a thing moves in one way, while its unnatural movements are manifold. The same may be shown, from the fact of rest. Rest, also, must either be constrained or natural, constrained in a place to which movement was constrained, natural in a place movement to which was natural. Now manifestly there is a body which is at rest at the center. If then this rest is natural to it, clearly motion to this place is natural to it. If, on the other hand, its rest is constrained, what is hindering its motion? Something, which is at rest, but if so, we shall simply repeat the same argument, and either we shall come to an ultimate something to which rest where it is, or we shall have an infinite process, which is impossible. The hindrance to its movement, then, we will suppose, is a moving thing, as Empedocles says that it is the vortex which keeps the earth still, but in that case we ask, where would it have moved to but for the vortex? It could not move infinitely, for to traverse an infinite is impossible, and impossibilities do not happen. So the moving thing must stop somewhere, and the rest not by constraint but naturally. But a natural rest proves a natural movement to the place of rest. Hence Leucippus and Democritus, who say that the primary bodies are in perpetual movement in the void or infinite, may be asked to explain the manner of their motion and the kind of movement which is natural to them. For if the various elements are constrained by one another to move as they do, each must still have a natural movement which the constraint contravenes, and the prime mover must cause motion not by constraint but naturally. If there is no ultimate natural cause of movement and each preceding term in the series is always moved by constraint, we shall have an infinite process. The same difficulty is involved even if it is supposed, as we read in the Timaeus, that before the ordered world was made the elements moved without order. Their movement must have been due either to constraint or to their nature. And if their movement was natural, a moment's consideration shows that there was already an ordered world. For the prime mover must cause motion in virtue of its own natural movement, and the other bodies, moving without constraint, as they came to rest in their proper places, would fall into the order in which they now stand, the heavy bodies moving towards the center and the light bodies away from it. But that is the order of their distribution in our world. There is a further question, too, which might be asked. Is it possible or impossible that bodies in unordered movement should combine in some cases into combinations like those of which bodies of nature's composing are composed, such, I mean, as bones and flesh? Yet this is what Empedocles asserts to have occurred under love. Many a head, says he, came to birth without a neck. The answer to the view that there are infinite bodies moving in an infinite is that, if the cause of movement is single, they must move with a single motion, and therefore not without order, and if, on the other hand, the causes are of infinite variety, their motions too must be infinitely varied. For a finite number of causes would produce a kind of order, since absence of order is not proved by diversity of direction in motions. Indeed, in the world we know, not all bodies, but only bodies of the same kind, have a common goal of movement. Again, disorderly movement means in reality unnatural movement, since the order proper to perceptible things is their nature. And there is also absurdity and impossibility in the notion that the disorderly movement is infinitely continued. For the nature of things is the nature which most of them possess for most of the time. Thus their view brings them into the contrary position that disorder is natural, and order or system unnatural. But no natural fact can originate in chance. This is a point which Anaxagoras seems to have thoroughly grasped, for he starts his cosmogony from unmoved things. The others, it is true, make things collect together somehow before they try to produce motion and separation. But there is no sense in starting generation from an original state in which bodies are separated and in movement. Hence Empedocles begins after the process ruled by love, for he could not have constructed the heaven by building it up out of bodies in separation, making them to combine by the power of love, since our world has its constituent elements in separation, and therefore presupposes a previous state of unity and combination. These arguments make it plain that every body has its natural movement, which is not constrained or contrary to its nature. We go on to show that there are certain bodies whose necessary impetus is that of weight and lightness. Of necessity, we assert, they must move, and a moved thing which has no natural impetus cannot move either towards or away from the center. Suppose a body A without weight, and a body B endowed with weight. Suppose the weightless body to move the distance CD, while B in the same time moves the distance s, which will be greater since the heavy thing must move further. Let the heavy body then be divided in the proportions CD, for there is no reason why a part of B should not stand in this relation to the whole. Now if the whole moves the whole distance s, the part must in the same time move the distance CD. A weightless body, therefore, and one which has weight will move the same distance, which is impossible. And the same argument would fit the case of lightness. Again, a body which is in motion but has neither weight nor lightness, must be moved by constraint, and must continue its constrained movement infinitely. For there will be a force which moves it, and the smaller and lighter a body is the further will a given force move it. Now let A, the weightless body, be moved the distance s, and B, which has weight, be moved in the same time the distance CD. Dividing the heavy body in the proportions CD, we subtract from the heavy body a part which will in the same time move the distance s, since the whole moved CD, for the relative speeds of the two bodies will be in inverse ratio to their respective sizes. Thus the weightless body will move the same distance as the heavy in the same time. But this is impossible. Hence, since the motion of the weightless body will cover a greater distance than any that is suggested, it will continue infinitely. It is therefore obvious that every body must have a definite weight or lightness. But since nature means a source of movement within the thing itself, while a force is a source of movement in something other than it or in itself qua other, and since movement is always due either to nature or to constraint, movement which is natural, as downward movement is to a stone, will be merely accelerated by an external force, while an unnatural movement will be due to the force alone. In either case the air is as it were instrumental to the force. For air is both light and heavy, and thus qua light produces upward motion, being propelled and set in motion by the force, and qua heavy produces a downward motion. In either case the force transmits the movement to the body by first, as it were, impregnating the air. That is why a body moved by constraint continues to move when that which gave the impulse ceases to accompany it. Otherwise, that is if the air were not endowed with this function, constrained movement would be impossible. And the natural movement of a body may be helped on in the same way. This discussion suffices to show, 1. That all bodies are either light or heavy, and, 2. How unnatural movement takes place. From what has been said earlier it is plain that there cannot be generation either of everything or in an absolute sense of anything. It is impossible that everything should be generated, unless an extracorporeal void is possible. 4. Assuming generation, the place which is to be occupied by that which is coming to be, must have been previously occupied by void in which no body was. Now it is quite possible for one body to be generated out of another, air for instance out of fire, but in the absence of any pre-existing mass generation is impossible. That which is potentially a certain kind of body may, it is true, become such in actuality, but if the potential body was not already in actuality some other kind of body, the existence of an extracorporeal void must be admitted. It remains to say what bodies are subject to generation, and why. Since in every case knowledge depends on what is primary, and the elements are the primary constituents of bodies, we must ask which of such bodies are elements, and why, and after that what is their number and character. The answer will be plain if we first explain what kind of substance an element is. An element, we take it, is a body into which other bodies may be analyzed, present in them potentially or in actuality, which of these, is still disputable, and not itself divisible into bodies different in form. That, or something like it, is what all men in every case mean by element. Now if what we have described is an element, clearly there must be such bodies. For flesh and wood and all other similar bodies contain potentially fire and earth, since one sees these elements exuded from them, and, on the other hand, neither in potentiality nor in actuality does fire contain flesh or wood, or it would exude them. Similarly, even if there were only one elementary body, it would not contain them. For though it will be either flesh or bone or something else, that does not at once show that it contained these in potentiality. The further question remains, in what manner it becomes them. Now Anaxagoras opposes Empedocles' view of the elements. Empedocles says that fire and earth and the related bodies are elementary bodies of which all things are composed, but this Anaxagoras denies. His elements are the homoemerous things, viz. Flesh, bone, and the like. Earth and fire are mixtures, composed of them and all the other seeds, each consisting of a collection of all the homoemerous bodies, separately invisible, and that explains why from these two bodies all others are generated. To him fire and air are the same thing, but since every natural body has its proper movement, and movements are either simple or mixed in mixed bodies and simple in simple, there must obviously be simple bodies, for there are simple movements. It is plain, then, that there are elements, and why. The next question to consider is whether the elements are finite or infinite in number, and, if finite, what their number is. Let us first show reason or denying that their number is infinite, as some suppose. We begin with the view of Anaxagoras that all the homoemerous bodies are elements. Anyone who adopts this view misapprehends the meaning of element. Observation shows that even mixed bodies are often divisible into homoemerous parts. Examples are flesh, bone, wood, and stone. Since then the composite cannot be an element, not every homoemerous body can be an element, only, as we said before, that which is not divisible into bodies different in form. But even taking element as they do, they need not assert an infinity of elements, since the hypothesis of a finite number will give identical results. Indeed, even 2 or 3 such bodies serve the purpose as well, as Empedocles' attempt shows. Again, even on their view it turns out that all things are not composed of homoemerous bodies. They do not pretend that a face is composed of faces, or that any other natural conformation is composed of parts like itself. Obviously then it would be better to assume a finite number of principles. They should, in fact, be as few as possible, consistently with proving what has to be proved. This is the common demand of mathematicians, who always assume as principles things finite either in kind or in number. Again, if body is distinguished from body by the appropriate qualitative difference, and there is a limit to the number of differences, for the difference lies in qualities apprehended by sense, which are in fact finite in number, though this requires proof, then manifestly there is necessarily a limit to the number of elements. There is, further, another view, that of Leucippus and Democritus of Abdera, the implications of which are also unacceptable. The primary masses, according to them, are infinite in number and indivisible in mass. One cannot turn into many nor many into one, and all things are generated by their combination and involution. Now this view in a sense makes things out to be numbers or composed of numbers. The exposition is not clear, but this is its real meaning. And further, they say that since the atomic bodies differ in shape, and there is an infinity of shapes, there is an infinity of simple bodies. But they have never explained in detail the shapes of the various elements, except so far to allot the sphere to fire, air, water, and the rest they distinguished by the relative size of the atom, assuming that the atomic substance was a sort of master seed for each and every element. Now, in the first place, they make the mistake already noticed. The principles which they assume are not limited in number, though such limitation would necessitate no other alteration in their theory. Further, if the differences of bodies are not infinite, plainly the elements will not be an infinity. Besides, a view which asserts atomic bodies must needs come into conflict with the mathematical sciences, in addition to invalidating many common opinions and apparent data of sense perception. But of these things we have already spoken in our discussion of time and movement. They are also bound to contradict themselves. For if the elements are atomic, air, earth, and water cannot be differentiated by the relative sizes of their atoms, since then they could not be generated out of one another. The extrusion of the largest atoms is a process that will in time exhaust the supply, and it is by such a process that they account for the generation of water, air, and earth from one another. Again, even on their own presuppositions it does not seem as if the elements would be infinite in number. The atoms differ in figure, and all figures are composed of pyramids, rectilinear the case of rectilinear figures, while the sphere has 8 pyramidal parts. The figures must have their principles, and, whether these are 1 or 2 or more, the simple bodies must be the same in number as they. Again, if every element has its proper movement, and a simple body has a simple movement, and the number of simple movements is not infinite, because the simple motions are only 2 and the number of places is not infinite, on these grounds also we should have to deny that the number of elements is infinite. Since the number of the elements must be limited, it remains to inquire whether there is more than one element. Some assume one only, which is according to some water, to others air, to others fire, to others again something finer than water and denser than air, an infinite body, so they say, bracing all the heavens. Now those who decide for a single element, which is either water or air or a body finer than water and denser than air, and proceed to generate other things out of it by use of the attributes density and rarity, all alike fail to observe the fact that they are depriving the element of its priority. Generation out of the elements is, as they say, synthesis, and generation into the elements is analysis, so that the body with the finer parts must have priority in the order of nature. But they say that fire is of all bodies the finest. Hence fire will be first in the natural order. And whether the finest body is fire or not makes no difference, anyhow it must be one of the other bodies that is primary and not that which is intermediate. Again, density and rarity, as instruments of generation, are equivalent to fineness and coarseness, since the fine is rare, and coarse in their use means dense. But fineness and coarseness, again, are equivalent to greatness and smallness, since a thing with small parts is fine and a thing with large parts coarse. For that which spreads itself out widely is fine, and a thing composed of small parts is so spread out. In the end, then, they distinguish the various other substances from the element by the greatness and smallness of their parts. This method of distinction makes all judgment relative. There will be no absolute distinction between fire, water, and air, but one and the same body will be relatively to this fire, relatively to something else air. The same difficulty is involved equally in the view elements and distinguishes them by their greatness and smallness. The principle of distinction between bodies being quantity, the various sizes will be in a definite ratio, and whatever bodies are in this ratio to one another must be air, fire, earth, and water respectively. For the ratios of smaller bodies may be repeated among greater bodies. Those who start from fire as the single element, while avoiding this difficulty, involve themselves in many others. Some of them give fire a particular shape, like those who make it a pyramid, and this on one of two grounds. The reason given may be more crudely that the pyramid is the most piercing of figures as fire is of bodies, or more ingeniously the position may be supported by the following argument. As all bodies are composed of that which has the finest parts, so all solid figures are composed of pyramids. But the finest body is fire, while among figures the pyramid is primary and has the smallest parts, and the primary body must have the primary figure, therefore fire will be a pyramid. Others, again, express no opinion on the subject of its figure, but simply regard it as the of the finest parts, which in combination will form other bodies, as the fusing of gold dust produces solid gold. Both of these views involve the same difficulties. For, 1, if, on the one hand, they make the primary body an atom, the view will be open to the objections already advanced against the atomic theory. And further the theory is inconsistent with a regard for the facts of nature. For if all bodies are quantitatively commensurable, and the relative size of the various homogeneous masses and of their several elements are in the same ratio, so that the total mass of water, for instance, is related to the total mass of air as the elements of each are to one another, and so on, and if there is more air than water and, generally, more of the finer body than of the coarser, obviously the element of water will be smaller than that of air. But the lesser quantity is contained in the greater. Therefore the air element is divisible. And the same could be shown of fire and of all bodies whose parts are relatively fine. 2. If, on the other hand, the primary body is divisible, then, a. those who give fire a special shape will have to say that a part of fire is not fire, because a pyramid is not composed of pyramids, and also that not every body is either an element or composed of elements, since a part of fire will be neither fire nor any other element. And, b. those whose ground of distinction is size will have to recognize an element prior to the element, a regress which continues infinitely, since every body is divisible and that which has the smallest parts is the element. Further, they too will have to say that the same body is relatively to this fire and relatively to that air, to others again water and earth. The common error of all views which assume a single element is that they allow only one natural movement, which is the same for every body. For it is a matter of observation that a natural body possesses a principle of movement. If then all bodies are one, all will have one movement. With this motion the greater their quantity the more they will move, just as fire, in proportion as its quantity is greater, moves faster with the upward motion which belongs to it. But the fact is that increase of quantity makes many things move the faster downward. For these reasons, then, as well as from the distinction already established of a plurality of natural movements, it is impossible that there should be only one element. But if the elements are not an infinity and not reducible to one, they must be several and finite in number. First we must inquire whether the elements are eternal or subject to generation and destruction, for when this question has been answered their number and character will be manifest. In the first place, they cannot be eternal. It is a matter of observation that fire, water, and every simple body undergo a process of analysis, which must either continue infinitely or stop somewhere. 1. Suppose it infinite. Then the time occupied by the process will be infinite, and also that occupied by the reverse process of synthesis. For the processes of analysis and synthesis succeed one another in the various parts. It will follow that there are two infinite times which are mutually exclusive, the time occupied by the synthesis, which is infinite, being preceded by the period of analysis. There are thus two mutually exclusive infinites, which is impossible. 2. Suppose, on the other hand, that the analysis stops somewhere. Then the body at which it stops will be either atomic or, as Empedocles seems to have intended, a divisible body which will yet never be divided. The foregoing arguments show that it cannot be an atom, but neither can it be a divisible body which analysis will never reach. For a smaller body is more easily destroyed than a larger, and a destructive process which succeeds in destroying, that is, in resolving into smaller bodies, a body of some size, cannot reasonably be expected to fail with the smaller body. Now in fire we observe a destruction of two kinds. It is destroyed by its contrary when it is quenched, and by itself when it dies out. But the effect is produced by a greater quantity upon a lesser, and the more quickly the smaller it is. The elements of bodies must therefore be subject to destruction and generation. Since they are generated, they must be generated either from something incorporeal or from a body, and if from a body, either from one another or from something else. The theory which generates them from something incorporeal requires an extracorporeal void. For everything that comes to be in something, and that in which the generation takes place must either be incorporeal or possess body, and if it has body, there will be two bodies in the same place at the same time, viz. that which is coming to be and that which was previously there, while if it is incorporeal, there must be an extracorporeal void. But we have already shown that this is impossible. But, on the other hand, it is equally impossible that the elements should be generated from some kind of body. That would involve a body distinct from the elements and prior to them. But if this body possesses weight or lightness, it will be one of the elements, and if it has no tendency to movement, it will be an immovable or mathematical entity, and therefore not in a place at all. A place in which a thing is at rest is a place in which it might move, either by constraint, that is unnaturally, or in the absence of constraint, that is naturally. If, then, it is in a place and somewhere, it will be one of the elements, and if it is not in a place, nothing can come from it, since that which comes into being and that out of which it comes must needs be together. The elements therefore cannot be generated from something incorporeal nor from a body which is not an element, and the only remaining alternative is that they are generated from one another. We must, therefore, turn to the question, what is the manner of their generation from one another? Is it as Empedocles and Democritus say, or as those who resolve bodies into planes say, or is there yet another possibility? 1. What the followers of Empedocles do, though without observing it themselves, is to reduce the generation of elements out of one another to an illusion. They make it a process of excretion from a body of what was in it all the time, as though generation required a vessel rather than a material, so that it involves no change of anything. And even if this were accepted, there are other implications equally unsatisfactory. We do not expect a mass of matter to be made heavier by compression. But they will be bound to maintain this, if they say that water is a body present in air and excreted from air, since air becomes heavier when it turns into water. Again, when the mixed body is divided, they can show no reason why one of the constituents must by itself take up more room than the body did, but when water turns into air, the room occupied is increased. The fact is that the finer body takes up more room, as is obvious in any case of transformation. As the liquid is converted into vapor or air, the vessel which contains it is often burst because it does not contain room enough. Now, if there is no void at all, and if, as those who take this view say, there is no expansion of bodies, the impossibility of this is manifest, and if there is void and expansion, there is no accounting for the fact that the body which results from division occupies of necessity a greater space. It is inevitable, too, that generation of one out of another should come to a stop, since a finite quantum cannot contain an infinity of finite quanta. When earth produces water, something is taken away from the earth, for the process is one of excretion. The same thing happens again when the residue produces water. But this can only go on forever, if the finite body contains an infinity, which is impossible. Therefore the generation of elements out of one another will not always continue. 2. We have now explained that the mutual transformations of the elements cannot take place by means of excretion. The remaining alternative is that they should be generated by changing into one another. And this in one of two ways, either by change of shape, as the same wax takes the shape both of a sphere and of a cube, or, as some assert, by resolution into planes. A generation by change of shape would necessarily involve the assertion of atomic bodies. For if the particles were divisible, there would be a part of fire which was not fire and a part of earth which was not earth, for the reason that not every part of a pyramid is a pyramid nor of a cube a cube. But if, B, The process is resolution into planes. The first difficulty is that the elements cannot all be generated out of one another. This they are obliged to assert, and do assert. It is absurd, because it is unreasonable that one element alone should have no part in the transformations, and also contrary to the observed data of sense, according to which all alike change into one another. In fact, their explanation of the observations is not consistent with the observations. And the reason is that their ultimate principles are wrongly assumed. They had certain predetermined views, and were resolved to bring everything into line with them. It seems that perceptible things require perceptible principles, eternal things eternal principles, corruptible things corruptible principles, and, in general, every subject matter principles homogeneous with itself. But they, owing to their love for their principles, fall into the attitude of men who undertake the defense of a position in argument. In the confidence that the principles are true, they are ready to accept any consequence of their application. As though some principles did not require to be judged from their results, and particularly from their final issue. And that issue, which in the case of productive knowledge is the product, in the knowledge of nature is the unimpeachable evidence of the senses as to each fact. The result of their view is that earth has the best right to the name element, and is alone indestructible, for that which is indissoluble is indestructible and elementary, and earth alone cannot be dissolved into any body but itself. Again, in the case of those elements which do suffer dissolution, the suspension of the triangles is unsatisfactory. But this takes place whenever one is dissolved into another, because of the numerical inequality of the triangles which compose them. Further, those who hold these views must needs suppose that generation does not start from a body. For what is generated out of planes cannot be said to have been generated from a body. And they must also assert that not all bodies are divisible, coming thus into conflict with our most accurate sciences, namely the mathematical, which assume that even the intelligible is divisible, while they, in their anxiety to save their hypothesis, cannot even admit this of every perceptible thing. For anyone who gives each element a shape of its own, and makes this the ground of distinction between the substances, has to attribute to them indivisibility, since division of a pyramid or a sphere must leave somewhere at least a residue which is not sphere or a pyramid. Either, then, a part of fire is not fire, so that there is a body prior to the element, for every body is either an element or composed of elements, or not every body is divisible. In general, the attempt to give a shape to each of the simple bodies is unsound, for the reason, first, that they will not succeed in filling the whole. It is agreed that there are only three plane figures which can fill a space: the triangle, the square, and the hexagon, and only two solids, the pyramid and the cube. But the theory needs more than these, because the elements which it recognizes are more in number. Secondly, it is manifest that the simple bodies are often given a shape by the place in which they are included, particularly water and air. In such a case the shape of the element cannot persist, for, if it did, the contained mass would not be in continuous contact with the containing body, while, if its shape is changed, it will cease to be water, since the distinctive quality is shape. Clearly, then, their shapes are not fixed. Indeed, nature itself seems to offer corroboration of this theoretical conclusion. Just as in other cases the substratum must be formless and unshapen, for thus the all-receptive, as we read in the Timaeus, will be best for modeling, so the elements should be conceived as a material for composite things, and that is why they can put off their qualitative distinctions and pass into one another. Further, how can they account for the generation of flesh and bone or any other continuous body? The elements alone cannot produce them, because their collocation cannot produce a continuum. Nor can the composition of planes, for this produces the elements themselves, not bodies made up of them. Anyone then who insists upon an exact statement of this kind of theory, instead of assenting after a passing glance at it, will see that it removes generation from the world. Further, the very properties, powers, and motions, to which they paid particular attention in allotting shapes, show the shapes not to be in accord with the bodies. Because fire is mobile and productive of heat and combustion, some made it a sphere, others a pyramid. These shapes, they thought, were the most mobile because they offer the fewest points of contact and are the least stable of any. They were also the most apparent to produce warmth and combustion, because the one is angular throughout while the other has the most acute angles, and the angles, they say, produce warmth and combustion. Now, in the first place, with regard to movement, both are in error. These may be the figures best adapted to movement, they are not, however, well adapted to the movement of fire, which is an upward and rectilinear movement, but rather to that form of circular movement which we call rolling. Earth, again, they call a cube because it is stable and at rest. But it rests only in its own place, not anywhere. From any other it moves if nothing hinders, and fire and the other bodies do the same. The obvious inference, therefore, is that fire and each several element is in a foreign place a sphere or a pyramid, but in its own a cube. Again, if the possession of angles makes a body produce heat and combustion, every element produces heat, though one may do so more than another. For they all possess angles, the octahedron and dodecahedron as well as the pyramid, and Democritus makes even the sphere a kind of angle, which cuts things because of its mobility. The difference, then, will be one of degree, and this is plainly false. They must also accept the inference that the mathematical produce heat and combustion, since they too possess angles and contain atomic spheres and pyramids, especially if there are, as they allege, atomic figures. Anyhow, if these functions belong to some of these things and not to others, they should explain the difference, instead of speaking in quite general terms as they do. Again, combustion of a body produces fire, and fire is a sphere or a pyramid. The body, then, is turned into spheres or pyramids. Let us grant that these figures may reasonably be supposed to cut and break up bodies as fire does, still it remains quite inexplicable that a pyramid must needs produce pyramids or a sphere spheres. One might as well postulate that a knife or a saw divides things into knives or saws. It is also ridiculous to think only of division when allotting fire its shape. Fire is generally thought of as combining and connecting rather than as separating. For though it separates bodies different in kind, it combines those which are the same, and the combining is essential to it, the functions of connecting and uniting being a mark of fire, while the separating is incidental. For the expulsion of the foreign body is an incident in the compacting of the homogeneous. In choosing the shape, then, they should have thought either of both functions or preferably of the combining function. In addition, since hot and cold are contrary powers, it is impossible to allot any shape to the cold. For the shape given must be the contrary of that given to the hot, but there is no contrariety between figures. That is why they have all left the cold out, though properly either all or none should have their distinguishing figures. Some of them, however, do attempt to explain this power, and they contradict themselves. A body of large particles, they say, is cold because instead of penetrating through the passages it crushes. Clearly, then, that which is hot is that which penetrates these passages, or in other words that which has fine particles. It results that hot and cold are distinguished not by the figure but by the size of the particles. Again, if the pyramids are unequal in size, the large ones will not be fire, and that figure will produce not combustion but its contrary. From what has been said it is clear that the difference of the elements does not depend upon their shape. Now the most important differences are those of property, function, and power, for every natural body has, we maintain, its own functions, properties, and powers. Our first business, then, will be to speak of these, and that inquiry will enable us to explain the differences of each from each. On the Heavens, Book 4, translated by J. L. Stocks, we have now to consider the terms heavy and light. We must ask what the bodies so called are, how they are constituted, and what is the reason of their possessing these powers. The consideration of these questions is a proper part of the theory of movement, since we call things heavy and light because they have the power of being moved naturally in a certain way. The activities corresponding to these powers have not been given any name, unless it is thought that impetus is such a name. But because the inquiry into nature is concerned with movement, and these things have in themselves some spark, as it were, of movement, all inquirers avail themselves of these powers, though in all but a few cases without exact discrimination. We must then first look at whatever others have said, and formulate the questions which require settlement in the interests of this inquiry, before we go on to state our own view of the matter. Language recognizes, a, an absolute, b, a relative heavy and light. Of two heavy things, such as wood and bronze, we say that the one is relatively light, the other relatively heavy. Our predecessors have not dealt at all with the absolute use of the terms, but only with the relative. I mean, they do not explain what the heavy is or what the light is, but only the relative heaviness and lightness of things possessing weight. This can be made clearer as follows. There are things whose constant nature it is to move away from the center, while others move constantly towards the center, and of these movements that which is away from the center I call upward movement and that which is towards it I call downward movement. The view, urged by some, that there is no up and no down in the heaven, is absurd. There can be, they say, no up and no down, since the universe is similar every way, and from any point on the earth's surface a man by advancing far enough will come to stand foot to foot with himself. But the extremity of the whole, which we call above, is in position above and in nature primary. And since the universe has an extremity and a center, it must clearly have an up and down. Common usage is thus correct, though inadequate. And the reason of its inadequacy is that men think that the universe is not similar every way. They recognize only the hemisphere which is over us. But if they went on to think of the world as formed on this pattern all round, with a center identically related to each point on the extremity, they would have to admit that the extremity was above and the center below. By absolutely light, then, we mean that which moves upward or to the extremity, and by absolutely heavy that which moves downward or to the center. By lighter or relatively light we mean that one, of two bodies endowed with weight and equal in bulk, which is exceeded by the other in the speed of its natural downward movement. Those of our predecessors who have entered upon this inquiry have for the most part spoken of light and heavy things only in the sense in which one of two things both endowed with weight is said to be the lighter. And this treatment they consider a sufficient analysis also of the notions of absolute heaviness, to which their account does not apply. This, however, will become clearer as we advance. One use of the terms lighter and heavier is that which is set forth in writing in the Timaeus, that the body which is composed of the greater number of identical parts is relatively heavy, while that which is composed of a smaller number is relatively light. As a larger quantity of lead or of bronze is heavier than a smaller, and this holds good of all homogeneous masses, the superior weight always depending upon a numerical superiority of equal parts in precisely the same way, they assert, lead is heavier than wood. For all bodies, in spite of the general opinion to the contrary, are composed of identical parts and of a single material. But this analysis says nothing of the absolutely heavy and light. The facts are that fire is always light and moves upward, while earth and all earthy things move downwards or towards the center. It cannot then be the fewness of the triangles, of which, in their view, all these bodies are composed, which disposes fire to move upward. If it were, the greater the quantity of fire the slower it would move, owing to the increase of weight due to the increased number of triangles. But the palpable fact, on the contrary, is that the greater the quantity, the lighter the mass is and the quicker its upward movement, and, similarly, in the reverse movement from above downward, the small mass will move quicker and the large slower. Further, since to be lighter is to have fewer of these homogeneous parts and to be heavier is to have more, and air, water, and fire are composed of the same triangles, the only difference being in the number of such parts, which must therefore explain any distinction of relatively light and heavy between these bodies, it follows that there must be a certain quantum of air which is heavier than water. But the facts are directly opposed to this. The larger the quantity of air the more readily it moves upward, and any portion of air without exception will rise up out of the water. So much for one view of the distinction between light and heavy. To others the analysis seems insufficient, and their views on the subject, though they belong to an older generation than ours, have an air of novelty. It is apparent that there are bodies which, when smaller in bulk than others, yet exceed them in weight. It is therefore obviously insufficient to say that bodies of equal weight are composed of an equal number of primary parts, for that would give equality of bulk. Those who maintain that the primary or atomic parts, of which bodies endowed with weight are composed, are planes, cannot so speak without absurdity, but those who regard them as solids are in a better position to assert that of such bodies the larger is the heavier. But since in composite bodies the weight obviously does not correspond in this way to the bulk, the lesser bulk being often superior in weight, as, for instance, if one be wool and the other bronze, there are some who think and say that the cause is to be found elsewhere. The void, they say, which is imprisoned in bodies, lightens them and sometimes makes the larger body the lighter. The reason is that there is more void. And this would also account for the fact that a body composed of a number of solid parts equal to, or even smaller than, that of another is sometimes larger in bulk than it. In short, generally and in every case a body is relatively light when it contains a relatively large amount of void. This is the way they put it themselves, but their account requires an addition. Relative lightness must depend not only on an excess of void, but also in a defect of solid, for if the ratio of solid to void exceeds a certain proportion, the relative lightness will disappear. Thus fire, they say, is the lightest of things just for this reason that it has the most void. But it would follow that a large mass of gold, as containing more void than a small mass of fire, is lighter than it, unless it also contains many times as much solid. The addition is therefore necessary. Of those who deny the existence of a void some, like Anaxagoras and Empedocles, have not tried to analyze the notions of light and heavy at all, and those who, while still denying the existence of a void, have attempted this, have failed to explain why there are bodies which are absolutely heavy and light, or in other words why some move upward and others downward. The fact, again, that the body of greater bulk is sometimes lighter than smaller bodies is one which they have passed over in silence, and what they have said gives no obvious suggestion for reconciling their views with the observed facts. But those who attribute the lightness of fire to its containing so much void are necessarily involved in practically the same difficulties. For though fire be supposed to contain less solid than any other body, as well as more void, yet there will be a certain quantum of fire in which the amount of solid or plenum is in excess of the solids contained in some small quantity of earth. They may reply that there is an excess of void also. But the question is, how will they discriminate the absolutely heavy? Presumably, either by its excess of solid or by its defect of void. On the former view there could be an amount of earth so small as to contain less solid than a large mass of fire. And similarly, if the distinction rests on the amount of void, there will be a body, lighter than the absolutely light, which nevertheless moves downward as constantly as the other moves upward. But that cannot be so, since the absolutely light is always lighter than bodies which have weight and move downward, while, on the other hand, that which is lighter need not be light, because in common speech we distinguish a lighter and a heavier, viz. Water and earth, among bodies endowed with weight. Again, the suggestion of a certain ratio between the void and the solid in a body is no more equal to solving the problem before us. The manner of speaking will issue in a similar impossibility. For any two portions of fire, small or great, will exhibit the same ratio of solid to void, but the upward movement of the greater is quicker than that of the less, just as the downward movement of a mass of gold or lead, or of any other body endowed with weight, is quicker in proportion to its size. This, however, should not be the case if the ratio is the ground of distinction between heavy things and light. There is also an absurdity in attributing the upward movement of bodies to a void which does not itself move. If, however, it is the nature of a void to move upward and of a plenum to move downward, and therefore each causes a like movement in other things, there was no need to raise the question why composite bodies are some light and some heavy. They had only to explain why these two things are themselves light and heavy respectively, and to give, further, the reason why the plenum and the void are not eternally separated. It is also unreasonable to imagine a place for the void, as if the void were not itself a kind of place. But if the void is to move, it must have a place out of which and into which the change carries it. Also, what is the cause of its movement? Not, surely, its voidness, for it is not the void only which is moved, but also the solid. Similar difficulties are involved in all other methods of distinction, whether they account for the relative lightness and heaviness of bodies by distinctions of size, or proceed on any other principle, so long as they attribute to each the same matter, or even if they recognize more than one matter, so long as that means only a pair of contraries. If there is a single matter, as with those who compose things of triangles, nothing can be absolutely heavy or light, and if there is one matter and its contrary the void, for instance, and the plenum, no reason can be given for the relative lightness and heaviness of the bodies intermediate between the absolutely light and heavy when compared either with one another or with these themselves. The view which bases the distinction upon differences of size is more like a mere fiction than those previously mentioned, but, in that it is able to make distinctions between the four elements, it is in a stronger position for meeting the foregoing difficulties. Since, however, it imagines that these bodies which differ in size are all made of one substance, it implies, equally with the view that there is but one matter, that there is nothing absolutely light and nothing which moves upward, except as being passed by other things or forced up by them, and since a multitude of small atoms are heavier than a few large ones, it will follow that much air or fire is heavier than a little water or earth, which is impossible. These, then, are the views which have been advanced by others and the terms in which they state them. We may begin our own statement by settling a question which to some has been the main difficulty, the question why some bodies move always and naturally upward and others downward, while others again move both upward and downward. After that we will inquire into light and heavy and of the various phenomena connected with them. The local movement of each body into its own place must be regarded as similar to what happens in connection with other forms of generation and change. There are, in fact, three kinds of movement, affecting respectively the size, the form, and the place of a thing, and in each it is observable that change proceeds from a contrary to a contrary or to something intermediate. It is never the change of any chance subject in any chance direction, nor, similarly, is the relation of the mover to its object fortuitous. The thing altered is different from the thing increased, and precisely the same difference holds between that which produces alteration and that which produces increase. In the same manner it must be thought that produces local motion and that which is so moved are not fortuitously related. Now, that which produces upward and downward movement is that which produces weight and lightness, and that which is moved is that which is potentially heavy or light, and the movement of each body to its own place is motion towards its own form. It is best to interpret in this sense the common statement of the older writers that like moves to like. For the words are not in every sense true to fact. If one were to remove the earth to where the moon now is, the various fragments of earth would each move not towards it but to the place in which is now. In general, when a number of similar and undifferentiated bodies are moved with the same motion, this result is necessarily produced, viz. that the place which is the natural goal of the movement of each single part is also that of the whole. But since the place of a thing is the boundary of that which contains it, and the continent of all things that move upward or downward is the extremity and the center, and this boundary comes to be, in a sense, the form of that which is contained, it is to its like that body moves when it moves to its own place. For the successive members of the scries are like one another, water, I mean, is like air and air like fire, and between intermediates the relation may be converted, though not between them and the extremes. Thus air is like water, but water is like earth, for the relation of each outer body to that which is next within it is that of form to matter. Thus to ask why fire moves upward and earth downward is the same as to ask why the healable, when moved and changed qua healable, attains health and not whiteness, and similar questions might be asked concerning any other subject of evolution. Of course the subject of increase, when changed qua increasable, attains not health but a superior size. The same applies in the other cases. One thing changes in quality, another in quantity, and so in place. A light thing goes upward, a heavy thing downward. The only difference is that in the last case, viz. that of the heavy and the light, the bodies are thought to have a spring of change within themselves, while the subjects of healing and increase are thought to be moved purely from without. Sometimes, however, even they change of themselves, in response to a slight external movement reach health or increase, as the case may be. And since the same thing which is healable is also receptive of disease, it depends on whether it is moved qua healable or qua liable to disease, whether the motion is towards health or towards disease. But the reason why the heavy and the light appear more than these things to contain within themselves the source of their movements is that their matter is nearest to being. This is indicated by the fact that locomotion belongs to bodies only when isolated from other bodies, and is generated last of the several kinds of movement. In order of being then it will be first. Now whenever air comes into being out of water, light out of heavy, it goes to the upper place. It is forthwith light, becoming is at an end, and in that place it has being. Obviously, then, it is a potentiality, which, in its passage to actuality, comes into the place and quantity and quality which belong to its actuality. And the same fact explains why what is already actually fire or earth moves, when nothing obstructs it, towards its own place. For motion is equally immediate in the case of nutriment, when nothing hinders, and in the case of the thing healed, when nothing stays the healing. But the movement is also due to the original creative force and to that which removes the hindrance or off which the moving thing rebounded, as was explained in our opening discussions, where we tried to show how none of these things moves itself. The reason of the various motions of the various bodies, and the meaning of the motion of a body to its own place, have now been explained. We have now to speak of the distinctive properties of these bodies and of the various phenomena connected with them. In accordance with general conviction we may distinguish the absolutely heavy, as that which sinks to the bottom of all things, from the absolutely light, which is that which rises to the surface of all things. I use the term absolutely, in view of the generic character of light and heavy, in order to confine the application to bodies which do not combine lightness and heaviness. It is apparent, I mean, that fire, in whatever quantity, so long as there is no external obstacle, moves upward, and earth downward, and, if the quantity is increased, the movement is the same, though swifter. But the heaviness and lightness of bodies which combine these qualities is different from this, since while they rise to the surface of some bodies they sink to the bottom of others. Such are air and water. Neither of them is absolutely either light or heavy. Both are lighter than earth, for any portion of either rises to the surface of it, but heavier than fire, since a portion of either, whatever its quantity, sinks to the bottom of fire. Compared together, however, the one has absolute weight, the other absolute lightness, since air in any quantity rises to the surface of water, while water in any quantity sinks to the bottom of air. Now other bodies are severally light and heavy, and evidently in them the attributes are due to the difference of their uncompounded parts, that is to say, according as the one or the other happens to preponderate, the bodies will be heavy and light respectively. Therefore we need only speak of these parts, since they are primary and all else consequential, and in so doing we shall be following the advice which we gave to those who attribute heaviness to the presence of plenum and lightness to that of void. It is due to the properties of the elementary bodies that a body which is regarded as light in one place is regarded as heavy in another, and vice versa. In air, for instance, a talent's weight of wood is heavier than a mina of lead, but in water the wood is the lighter. The reason is that all the elements except fire have weight and all but earth lightness. Earth, then, and bodies in which earth preponderates, must needs have weight everywhere, while water is heavy anywhere but in earth, and air is heavy when not in water or earth. In its own place each of these bodies has weight except fire, even air. Of this we have evidence in the fact that a bladder when inflated weighs more than when empty. A body, then, in which air preponderates over earth and water, may well be lighter than something in water and yet heavier than it in air, since such a body does not rise in air but rises to the surface in water. The following account will make it plain that there is an absolutely light and an absolutely heavy body. And by absolutely light I mean one which of its own nature always moves upward, by absolutely heavy one which of its own nature always moves downward, if no obstacle is in the way. There are, I say, these two kinds of body, and it is not the case, as some maintain, that all bodies have weight. Different views are in fact agreed that there is a heavy body, which moves uniformly towards the center, but is also similarly a light body. For we see with our eyes, as we said before, that earthy things sink to the bottom of all things and move towards the center. But the center is a fixed point. If therefore there is some body which rises to the surface of all things and we observe fire to move upward even in air itself, while the air remains at rest, clearly this body is moving towards the extremity. It cannot then have any weight. If it had, there would be another body in which it sank, and if that had weight, there would be yet another which moved to the extremity and thus rose to the surface of all moving things. In fact, however, we have no evidence of such a body. Fire, then, has no weight. Neither has earth any lightness, since it sinks to the bottom of all things, and that which sinks moves to the center. That there is a center towards which the motion of heavy things, and away from which that of light things is directed, is manifest in many ways. First, because no movement can continue to infinity. For what cannot be can no more come to be than be, and movement is a coming to be in one place from another. Secondly, like the upward movement of fire, the downward movement of earth and all heavy things makes equal angles on every side with the earth's surface, it must therefore be directed towards the center. Whether it is really the center of the earth and not rather that of the whole to which it moves, may be left to another inquiry, since these are coincident. But since that which sinks to the bottom of all things moves to the center, necessarily that which rises to the surface moves to the extremity of the region in which the movement of these bodies takes place. For the center is opposed as contrary to the extremity, as that which sinks is opposed to that which rises to the surface. This also gives a reasonable ground for the duality of heavy and light in the spatial duality center and extremity. Now there is also the intermediate region to which each name is given in opposition to the other extreme. For that which is intermediate between the two is in a sense both extremity and center. For this reason there is another heavy and light, namely, water and air. But in our view the continent pertains to form and the contained to matter, and this distinction is present in every genus. Alike in the sphere of quality and in that of quantity there is that which corresponds rather to form and that which corresponds to matter. In the same way, among spatial distinctions, the above belongs to the determinate, the below to matter. The same holds, consequently, also of the matter itself of that which is heavy and light, as potentially possessing the one character, it is matter for the heavy, and as potentially possessing the other, for the light. It is the same matter, but its being is different, as that which is receptive of disease is the same as that which is receptive of health, though in being different from it, and therefore diseasedness is different from healthiness. A thing then which is the one kind of matter is light and always moves upward, while a thing which has the opposite matter is heavy and always moves downward. Bodies composed of kinds of matter different from these but having relatively to each other the character which these have absolutely, possess both the upward and the downward motion. Hence air and water each have both lightness and weight, and water sinks to the bottom of all things except earth, while air rises to the surface of all things except fire. But since there is one body only which rises to the surface of all things and one only which sinks to the bottom of all things, there must needs be two other bodies which sink in some bodies and rise to the surface of others. The kinds of matter, then, must be as numerous as these bodies, that is four, but though they are four there must be a common matter of all, particularly if they pass into one another which in each is in being different. There is no reason why there should not be one nor more intermediates between the contraries, as in the case of color, for intermediate and mean are capable of more than one application. Now in its own place every body endowed with both weight and lightness has weight, whereas earth has weight everywhere, but they only have lightness among bodies to whose surface they rise. Hence when a support is withdrawn, such a body moves downward until it reaches the body next below it, air to the place of water and water to that of earth. But if the fire above air is removed, it will not move upward to the place of fire, except by constraint, and in that way water also may be drawn up, when the upward movement of air which has had a common surface with it is swift enough to overpower the downward impulse of the water. Nor does water move upward to the place of air, except in the manner just described. Earth is not so affected at all, because a common surface is not possible to it. Hence water is drawn up into the vessel to which fire is applied, but not earth. As earth fails to move upward, so fire fails to move downward when air is withdrawn from beneath it, for fire has no weight even in its own place, as earth has no lightness. The other two move downward when the body beneath is withdrawn, because, while the absolutely heavy is that which sinks to the bottom of all things, the relatively heavy sinks to its own place or to the surface of the body in which it rises, since it is similar in matter to it. It is plain that one must suppose as many distinct species of matter as there are bodies. For if, first, there is a single matter of all things, as, for instance, the void or the plenum or extension or the triangles, either all things will move upward or all things will move downward, and the second motion will be abolished. And so, either there will be no absolutely light body, if superiority of weight is due to superior size or number of the constituent bodies or to the fullness of the body, but the contrary is a matter of observation, and it has been shown that the downward and upward movements are equally constant and universal, or, if the matter in question is the void or something similar, which moves uniformly upward, there will be nothing to move uniformly downward. Further, it will follow that the intermediate bodies move downward in some cases quicker than earth, for air in sufficiently large quantity will contain a larger number of triangles or solids or particles. It is, however, manifest that no portion of air whatever moves downward. And the same reasoning applies to lightness, if that is supposed to depend on superiority of quantity of matter. But if, secondly, the kinds of matter are two, it will be difficult to make the intermediate bodies behave as air and water behave. Suppose, for example, that the two asserted are void and plenum. Fire, then, as moving upward, will be void, earth, as moving downward, plenum, and in air, it will be said, fire preponderates, in water, earth. There will then be a quantity of water containing more fire than a little air, and a large amount of air will contain more earth than a little water. Consequently we shall have to say that air in a certain quantity moves downward more quickly than a little water. But such a thing has never been observed anywhere. Necessarily, then, as fire goes up because it is something, for example void, which other things do not have, and earth goes downward because it has plenum, so air goes to its own place above water because it has something else, and water goes downward because of some special kind of body. But if the two bodies are one matter, or two matters both present in each, there will be a certain quantity of each at which water will excel a little air in the upward movement and air excel water in the downward movement, as we have already often said. The shape of bodies will not account for their moving upward or downward in general, though it will account for their moving faster or slower. The reasons for this are not difficult to see. For the problem thus raised is why a flat piece of iron or lead floats upon water, while smaller and less heavy things, so long as they are round or long a needle, for instance sink down. And sometimes a thing floats because it is small, as with gold dust and the various earthy and dusty materials which throng the air. With regard to these questions, it is wrong to accept the explanation offered by Democritus. He says that the warm bodies moving up out of the water hold up heavy bodies which are broad, while the narrow ones fall through, because the bodies which offer this resistance are not numerous. But this would be even more likely to happen in air, an objection which he himself raises. His reply to the objection is feeble. In the air, he says, the drive, meaning by drive the movement of the upward moving bodies, is not uniform in direction. But since some continue are easily divided and others less easily, and things which produce division differ similarly in the case with which they produce it, the explanation must be found in this fact. It is the easily bounded, in proportion as it is easily bounded, which is easily divided, and air is more so than water, water than earth. Further, the smaller the quantity in each kind, the more easily it is divided and disrupted. Thus the reason white broad things keep their place is because they cover so wide a surface and the greater quantity is less easily disrupted. Bodies of the opposite shape sink down because they occupy so little of the surface, which is therefore easily parted. And these considerations apply with far greater force to air, since it is so much more easily divided than water. But since there are two factors, the force responsible for the downward motion of the heavy body and the disruption-resisting force of the continuous surface, there must be some ratio between the two. For in proportion as the force applied by the heavy thing towards disruption and division exceeds that which resides in the continuum, the quicker will it force its way down. Only if the force of the heavy thing is the weaker, will it ride upon the surface. We have now finished our examination of the heavy and the light and of the phenomena connected with them. On Generation and Corruption, Book I, translated by H. Joachim. Our next task is to study coming to be and passing away. We are to distinguish the causes, and to state the definitions, of these processes considered in general as changes predicable uniformly of all the things that come to be and pass away by nature. Further, we are to study growth and alteration. We must inquire what each of them is, and whether alteration is to be identified with coming to be, or whether to these different names there correspond two separate processes with distinct natures. On this question, indeed, the early philosophers are divided. Some of them assert that the so-called unqualified coming to be is alteration, while others maintain that alteration and coming to be are distinct. For those who say that the universe is one something, that is those who generate all things out of one thing, are bound to assert that coming to be is alteration, and that whatever comes to be in the proper sense of the term is being altered. But those who make the matter of things more than one must distinguish coming to be from alteration. To this latter class belong Empedocles, Anaxagoras, and Leucippus. And yet Anaxagoras himself failed to understand his own utterance. He says, at all events, that coming to be and passing away are the same as being altered, yet, in common with other thinkers, he affirms that the elements are many. Thus Empedocles holds that the corporeal elements are four, while all the elements including those which initiate movement are six in number, whereas Anaxagoras agrees with Leucippus and Democritus that the elements are infinite. Anaxagoras posits as elements the homeomeres, viz. Bone, flesh, marrow, and everything else which is such that part and whole are the same in name and nature, while Democritus and Leucippus say that there are indivisible bodies, infinite both in number and in the varieties of their shapes, of which everything else is composed, the compounds differing one from another according to the shapes, positions, and groupings of their constituents. For the views of the school of Anaxagoras seem diametrically opposed to those of the followers of Empedocles. Empedocles says that fire, water, air, and earth are four elements, and are thus simple rather than flesh, bone, and bodies which, like these, are homeomeres. But the followers of Anaxagoras regard the homeomeres as simple and elements, whilst they affirm that earth, fire, water, and air are composite, for each of these is, according to them, a common seminary of all the homeomeres. Those, then, who construct all things out of a single element, must maintain that coming to be and passing away are alteration. For they must affirm that the underlying something always remains identical and one, and change of such a substratum is what we call altering. Those, on the other hand, who make the ultimate kinds of things more than one, must maintain that alteration is distinct from coming to be, for coming to be and passing away result from the consilience and the dissolution of the many kinds. That is why Empedocles too uses languages to this effect, when he says there is no coming to be of anything, but only a mingling and a divorce of what has been mingled. Thus it is clear, that to describe coming to be and passing away in these terms is in accordance with their fundamental assumption, and, 2, that they do in fact so describe them. Nevertheless, they too must recognize alteration as a fact distinct from coming to be, though it is impossible for them to do so consistently with what they say. That we are right in this criticism is easy to perceive. For alteration is a fact of observation. While the substance of the thing remains unchanged, we see it altering just as we see in it the changes of magnitude called growth and diminution. Nevertheless, the statements of those who posit more original reas than one make alteration impossible. For alteration, as we assert, takes place in respect to certain qualities, and these qualities, I mean, for example hot-cold, white-black, dry-moist, soft-hard, and so forth, are, all of them, differences characterizing the elements. The actual words of Empedocles may be quoted in illustration. The sun everywhere bright to see, and hot. The rain everywhere dark and cold. And he distinctively characterizes his remaining elements in a similar manner. Since, therefore, it is not possible for fire to become water, or water to become earth, neither will it be possible for anything white to become black, or anything soft to become hard, and the same argument applies to all the other qualities. Yet this is what alteration essentially is. It follows, as an obvious corollary, that a single matter must always be assumed as underlying the contrary poles of any change, whether change of place, or growth and diminution, or alteration. Further, that the being of this matter and the being of alteration stand and fall together. For if the change is alteration, then the substratum is a single element, that is all things which admit of change into one another have a single matter. And, conversely, if the substratum of the changing things is one, there is alteration. Empedocles, indeed, seems to contradict his own statements as well as the observed facts. For he denies that any one of his elements comes to be out of any other, insisting on the contrary that they are the things out of which everything else comes to be, and yet, having brought the entirety of existing things, except strife, together into one, he maintains, simultaneously with this denial, that each thing once more comes to be out of the one. Hence it was clearly out of the one that this came to be water, and that fire, various portions of it being separated off by certain characteristic differences or qualities, as indeed he calls the sun white and hot, and the earth heavy and hard. If, therefore, these characteristic differences be taken away, for they can be taken away, since they came to be, it will clearly be inevitable for earth to come to be out of water and water out of earth, and for each of the other elements to undergo a similar transformation not only then, but also now if, and because, they change their qualities. And, to judge by what he says, the qualities are such that they can be attached to things and can again be separated from them, especially since strife and love are still fighting with one another for the mastery. It was owing to this same conflict that the elements were generated from the one at the former period. I say generated, for presumably fire, earth, and water had no distinctive existence at all while merged in one. There is another obscurity in the theory Empedocles. Are we to regard the one as his original real? Or is it the many that is fire and earth, and the bodies coordinate with these? For the one is an element in so far as it underlies the process as matter as that out of which earth and fire come to be through a change of qualities due to the motion. On the other hand, in so far as the one results from composition, by a consilience of the many, whereas they result from disintegration, the many are more elementary than the one, and prior to it in their nature. We have therefore to discuss the whole subject of unqualified coming to be and passing away. We have to inquire whether these changes do or do not occur, and, if they occur, to explain the precise conditions of their occurrence. We must also discuss the remaining forms of change, viz. Growth and alteration. For though, no doubt, Plato investigated the conditions under which things come to be and pass away, he confined his inquiry to these changes, and he discussed not all coming to be, but only that of the elements. He asked no questions as to how flesh or bones, or any of the other similar compound things, come to be, nor again did he examine the conditions under which alteration or growth are attributable to things. A similar criticism applies to all our predecessors with the single exception of Democritus. Not one of them penetrated below the surface or made a thorough examination of a single one of the problems. Democritus, however, does seem not only to have thought carefully about all the problems, but also to be distinguished from the outset by his method. For, as we are saying, none of the other philosophers made any definite statement about growth, except such as any amateur might have made. They said that things grow by the accession of like to like, but they did not proceed to explain the manner of this accession. Nor did they give any account of combination, and they neglected almost every single one of the remaining problems, offering no explanation, for example of action or passion, how in physical actions one thing acts and the other undergoes action. Democritus and Leucippus, however, postulate the figures, and make alteration and coming to be result from them. They explain coming to be and passing away by their dissociation and association, but alteration by their grouping and position. And since they thought that the truth lay in the appearance, and the appearances are conflicting and infinitely many, they made the figures infinite in number. Hence, owing to the changes of the compound, the same thing seems different and conflicting to different people. It is transposed by a small additional ingredient, and appears utterly other by the transposition of a single constituent. For tragedy and comedy are both composed of the same letters. Since almost all our predecessors think, I, that coming to be is distinct from alteration, and, 2, that, whereas things alter by change of their qualities, it is by association and dissociation that they come to be and pass away, we must concentrate our attention on these theses. For they lead to many perplexing and well-grounded dilemmas. If, on the one hand, coming to be is association, many impossible consequences result, and yet there are other arguments, not easy to unravel, which force the conclusion upon us that coming to be cannot possibly be anything else. If, on the other hand, coming to be is not association, either there is no such thing as coming to be at all, or it is alteration, or else we must endeavor to unravel this dilemma too, and a stubborn one we shall find it. The fundamental question, in dealing with all these difficulties, is this: do things come to be and alter and grow, and undergo the contrary changes, because the primary rays are indivisible magnitudes? Or is no magnitude indivisible? For the answer we give to this question makes the greatest difference. And again, if the primary rays are indivisible magnitudes, are these bodies, as Democritus and Leucippus maintain? Or are they planes, as is asserted in the Timaeus? To resolve bodies into planes and no further, this, as we have also remarked elsewhere, in itself a paradox. Hence there is more to be said for the view that there are indivisible bodies. Yet even these involve much of paradox. Still, as we have said, it is possible to construct alteration and coming to be with them, if one transposes the same by turning and into contact, and by the varieties of the figures, as Democritus does. His denial of the reality of color is a corollary from this position, for, according to him, things get colored by turning of the figures, but the possibility of such a construction no longer exists for those who divide bodies into planes. For nothing except solids results from putting planes together, they do not even attempt to generate any quality from them. Lack of experience diminishes our power of taking a comprehensive view of the admitted facts. Hence those who dwell in intimate association with nature and its phenomena grow more and more able to formulate, as the foundations of their theories, principles such as to admit of a wide and coherent development, while those whom devotion to abstract discussions has rendered unobservant of the facts are too ready to dogmatize on the basis of a few observations. The rival treatments of the subject now before us will serve to illustrate how great is the difference between a scientific and a dialectical method of inquiry. For, whereas the Platonists argue that there must be atomic magnitudes because otherwise the triangle will be more than one, Democritus would appear to have been convinced by arguments appropriate to the subject, that is drawn from the science of nature. Our meaning will become clear as we proceed. For to suppose that a body, that is a magnitude, is divisible through and through, and that this division is possible, involves a difficulty. What will there be in the body which escapes the division? If it is divisible through and through, and if this division is possible, then it might be, at one and the same moment, divided through and through, even though the dividings had not been effected simultaneously, and the actual occurrence of this result would involve no impossibility. Hence the same principle will apply whenever a body is by nature divisible through and through, whether by bisection, or generally by any method whatever. Nothing impossible will have resulted if it has actually been divided, not even if it has been divided into innumerable parts, themselves divided innumerable times. Nothing impossible will have resulted, though perhaps nobody in fact could so divide it. Since, therefore, the body is divisible through and through, let it have been divided. What, then, will remain? A magnitude? Number that is impossible, since then there will be something not divided, whereas ex hypothesis the body was divisible through and through. But if it be admitted that neither a body nor a magnitude will remain, and yet division is to take place, the constituents of the body will either be points, that is without magnitude, or absolutely nothing. If its constituents are nothings, then it might both come to be out of nothings and exist as a composite of nothings, and thus presumably the whole body will be nothing but an appearance. But if it consists of points, a similar absurdity will result, it will not possess any magnitude. For when the points were in contact and coincided to form a single magnitude, they did not make the whole any bigger, since, when the body was divided into two or more parts, the whole was not a bit smaller or bigger than it was before the division. Hence, even if all the points be put together, they will not make any magnitude. But suppose that, as the body is being divided, a minute section a piece of sawdust, as it were, is extracted, and that in this sense a body comes away from the magnitude, evading the division. Even then the same argument applies. For in what sense is that section divisible? But if what came away was not a body but a separable form or quality, and if the magnitude is points or contacts thus qualified, it is paradoxical that a magnitude should consist of elements, which are not magnitudes. Moreover, where will the points be? And are they motionless or moving? And every contact is always a contact of two somethings, that is, there is always something besides the contact or the division or the point. These, then, are the difficulties resulting from the supposition that any and every body, whatever its size, is divisible through and through. There is, besides, this further consideration. If, having divided a piece of wood or anything else, I put it together, it is again equal to what it was, and is one. Clearly this is so, whatever the point at which I cut the wood. The wood, therefore, has been divided potentially through and through. What, then, is there in the wood besides the division? For even if we suppose there is some quality, yet how is the wood dissolved into such constituents, and how does it come to be out of them? Or how are such constituents separated so as to exist apart from one another? Since, therefore, It is impossible for magnitudes to consist of contacts or points. There must be indivisible bodies and magnitudes. Yet, if we do postulate the latter, we are confronted with equally impossible consequences, which we have examined in other works. But we must try to disentangle these perplexities, and must therefore formulate the whole problem over again. On the one hand, then, it is in no way paradoxical that every perceptible body should be indivisible as well as divisible at any and every point. For the second predicate will tack to it potentially, but the first actually. On the other hand, it would seem to be impossible for a body to be, even potentially, divisible at all points simultaneously. For if it were possible, then it might actually occur, with the result, not that the body would simultaneously be actually both, indivisible and divided, but that it would be simultaneously divided at any and every point. Consequently, nothing will remain and the body will have passed away into what is incorporeal, and so it might come to be again either out of points or absolutely out of nothing. And how is that possible? But now it is obvious that a body is in fact divided into separable magnitudes which are smaller at each division into magnitudes which fall apart from one another and are actually separated. Hence, it is urged, the process of dividing a body part by part is not a breaking up which could continue ad infinitum, nor can a body be simultaneously divided at every point, for that is not possible, but there is a limit, beyond which the breaking up cannot proceed. The necessary consequence, especially if coming to be and passing away are to take place by association and dissociation respectively, is that a body must contain atomic magnitudes which are invisible. Such is the argument which is believed to establish the necessity of atomic magnitudes. We must now show that it conceals a faulty inference, and exactly where it conceals it. For, since point is not immediately next to point, magnitudes are divisible through and through in one sense, and yet not in another. When, however, it is admitted that a magnitude is divisible through and through, it is thought there is a point not only anywhere, but also everywhere, in it. Hence it is supposed to follow, from the admission, that the magnitude must be divided away into nothing. For it is supposed there is a point everywhere within it, so that it consists either of contacts or of points. But it is only in one sense that the magnitude is divisible through and through, viz. insofar as there is one point anywhere within it and all its points are everywhere within it if you take them singly one by one. But there are not more points than one anywhere within it, for the points are not consecutive, hence it is not simultaneously divisible through and through. For if it were, then, if it be divisible at its center, it will be divisible also at a point immediately next to its center. But it is not so divisible, for position is not immediately next to position, nor point to point. In other words, division is not immediately next to division, nor composition to composition. Hence there are both association and dissociation, though neither, a, into, and out of, atomic magnitudes, for that involves many impossibilities, nor, b, so that division takes place through and through, for this would have resulted only if point had been immediately next to point, but dissociation takes place into small, that is relatively small, parts, and association takes place out of relatively small parts. It is wrong, however, to suppose, as some assert, that coming to be and passing away in the unqualified and complete sense are distinctively defined by association and dissociation, while the change that takes place in what is continuous is alteration. On the contrary, this is where the whole error lies. For unqualified coming to be and passing away are not affected by association and dissociation. They take place when a thing changes, from this to that, as a whole. But the philosophers we are criticizing suppose that all such change is alteration, whereas in fact there is a difference. For in that which underlies the change there is a factor corresponding to the definition and there is a material factor. When, then, the change is in these constitutive factors, there will be coming to be or passing away, but when it is in the thing's qualities, that is a change of the thing per accidents, there will be alteration. Dissociation and association affect the thing's susceptibility to passing away. For if water has first been dissociated into smallish drops, air comes to be out of it more quickly, while, if drops of water have first been associated, air comes to be more slowly. Our doctrine will become clearer in the sequel. Meantime, so much may be taken as established, viz. that coming to be cannot be association, at least not the kind of association some philosophers assert it to be. Now that we have established the preceding distinctions, we must first consider whether there is anything which comes to be and passes away in the unqualified sense, or whether nothing comes to be in this strict sense, but everything always comes to be something and out of something. I mean, for example, comes to be healthy out of being ill and ill out of being healthy, comes to be small out of being big and big out of being small, and so on in every other instance. For if there is to be coming to be without qualification, something must without qualification come to be out of not being, so that it would be true to say that not being is an attribute of some things. The qualified coming to be is a process out of qualified not being, for example out of not white or not beautiful, but unqualified coming to be is a process out of unqualified not being. Now unqualified means either, I, the primary predication within each category, or, 2, the universal, that is the all-comprehensive, predication. Hence, if unqualified not being means the negation of being in the sense of the primary term of the category in question, we shall have, in unqualified coming to be, a coming to be of a substance out of not substance. But that which is not a substance or a this clearly cannot possess predicates drawn from any of the other categories either. For example, we cannot attribute to it any quality, quantity, or position. Otherwise, properties would admit of existence in separation from substances. If, on the other hand, unqualified not being means what is not in any sense at all, it will be a universal negation of all forms of being, so that what comes to be will have to come to be out of nothing. Although we have dealt with these problems at greater length in another work, where we have set forth the difficulties and established the distinguishing definitions, the following concise restatement of our results must here be offered. In one sense things come to be out of that which has no being without qualification, yet in another sense they come to be always out of what is. The coming to be necessarily implies the pre-existence of something which potentially is, but actually is not, and this something is spoken of both as being and as not being. These distinctions may be taken as established, but even then it is extraordinarily difficult to see how there can be unqualified coming to be, whether we suppose it to occur out of what potentially is, or in some other way, and we must recall this problem for further examination. For the question might be raised whether substance, that is the this, comes to be at all. Is it not rather the such, the so great, or the somewhere, which comes to be? And the same question might be raised about passing away also. For if a substantial thing comes to be, it is clear that there will be, not actually, but potentially, a substance, out of which its coming to be will proceed and into which the thing that is passing away will necessarily change. Then will any predicate belonging to the remaining categories attach actually to this presupposed substance? In other words, will that which is only potentially a this, which only potentially is, while without the qualification potentially it is not a this, that is not, possess, for example any determinate size or quality or position? For, if it possesses none of these determinations actually, but all of them only potentially, the result is first that a being, which is not a determinate being, is capable of separate existence, and in addition that coming to be proceeds out of nothing pre-existing, a thesis which, more than any other, preoccupied and alarmed the earliest philosophers. On the other hand, 2, if, although it is not to this somewhat or a substance, it is to possess some of the remaining determinations quoted above, then, as we said, properties will be separable from substances. We must therefore concentrate all our powers on the discussion of these difficulties and on the solution of a further question, viz. What is the cause of the perpetuity of coming to be? Why is there always unqualified, as well as partial, coming to be? Cause in this connection has two senses. It means, the source from which, as we say, the process originates, and, 2, the matter. It is the material cause that we have here to state. For, as to the other cause, we have already explained, in our treatise on motion, that it involves, a, something immovable through all time, and, b, something always being moved. And the accurate treatment of the first of these, of the immovable originative source, belongs to the province of the other, or prior, philosophy, while as regards that which sets everything else in motion by being itself continuously moved, we shall have to explain later which amongst the so-called specific causes exhibits this character. But at present we are to state the material cause, the cause classed under the head of matter, to which it is due that passing away and coming to be never fail to occur in nature. For perhaps, if we succeed in clearing up this question, it will simultaneously become clear what account we ought to give of that which perplexed us just now, that is of unqualified passing away and coming to be. Our new question 2, viz. What is the cause of the unbroken continuity of coming to be? Is sufficiently perplexing, if in fact what passes away vanishes into what is not, and what is not is nothing, since what is not is neither a thing, nor possessed of a quality or quantity, nor in any place. If, then, some one of the things which are constantly disappearing, why has not the whole of what has been used up long ago and vanished away, assuming of course that the material of all the several comings to be was finite? For, presumably, the unfailing continuity of coming to be cannot be attributed to the infinity of the material. That is impossible, for nothing is actually infinite. A thing is infinite only potentially, that is, the dividing of it can continue indefinitely, so that we should have to suppose there is only one kind of coming to be in the world, viz. one which never fails, because it is such that what comes to be is on each successive occasion smaller than before. But in fact this is not what we see occurring. Why, then, is this form of change necessarily ceaseless? Is it because the passing away of this is a coming to be of something else, and the coming to be of this a passing away of something else? The cause implied in this solution must no doubt be considered adequate to account for coming to be and passing away in their general character as they occur in all existing things alike. Yet, if the same process is a coming to be of this but a passing away of that, and a passing away of this but a coming to be of that, why are some things said to come to be and pass away without qualification, but others only with a qualification? The distinction must be investigated once more, for it demands some explanation. It is applied in a twofold manner, for, we say it is now passing away without qualification, and not merely this is passing away, and we call this change coming to be, and that passing away, without qualification. And, 2, so and so comes to be something, but does not come to be without qualification, for we say that the student comes to be learned, not comes to be without qualification. Now we often divide terms into those which signify this somewhat and those which do not. And, the first form of the distinction, which we are investigating, results from a similar division of terms, for it makes a difference into what the changing thing changes. Perhaps, for example, the passage into fire is coming to be unqualified, but passing away of something, for example earth, whilst the coming to be of earth is qualified, not unqualified, coming to be, though unqualified passing away, for example of fire. This would be the case on the theory set forth in Parmenides, for he says that the things into which change takes place are two, and he asserts that these two, viz. what is and what is not, are fire and earth. Whether we postulate these, or other things of a similar kind, makes no difference. For we are trying to discover not what undergoes these changes, but what is their characteristic manner. The passage, then, into what is not except with a qualification is unqualified passing away, while the passage into what is without qualification is unqualified coming to be. Hence whatever the contrasted poles of the changes may be, whether fire and earth, or some other couple, the one of them will be a being and the other a not being. We have thus stated one characteristic manner in which unqualified will be distinguished from qualified coming to be and passing away, but they are also distinguished according to the special nature of the material of the changing thing. For a material, whose constitutive differences signify more of this somewhat, is itself more substantial or real, while a material, whose constitutive differences signify privation, is not real. Suppose, for example, that the hot is a positive predication, that is a form, whereas cold is a privation, and that earth and fire differ from one another by these constitutive differences. The opinion, however, which most people are inclined to prefer, is that the distinction depends upon the difference between the perceptible and the imperceptible. Thus, when there is a change into perceptible material, people say there is coming to be, but when there is a change into invisible material, they call it passing away. For they distinguish what is and what is not by their perceiving and not perceiving, just as what is knowable is and what is unknowable is not perception on their view having the force of knowledge. Hence, just as they deem themselves to live and to be in virtue of their perceiving or their capacity to perceive, so too they deem the things to be qua perceived or perceptible, and in this they are in a sense on the track of the truth, though what they actually say is not true. Thus unqualified coming to be and passing away turn out to be different according to common opinion from what they are in truth. For wind and air are in truth more real, more of this somewhat or a form than earth. But they are less real to perception, which explains why things are commonly said to pass away without qualification when they change into wind and air, and to come to be when they change into what is tangible, that is into earth. We have now explained why there is unqualified coming to be, though it is a passing away of something, and unqualified passing away, though it is a coming to be of something. For this distinction of appellation depends upon a difference in the material out of which, and into which, the changes are effected. It depends either upon whether the material is or is not substantial, or upon whether it is more or less substantial, or upon whether it is more or less perceptible. 2. But why are some things said to come to be without qualification, and others only to come to be so and so, in cases different from the one we have been considering, where two things come to be reciprocally out of one another? For at present we have explained no more than this: why, when two things change reciprocally into one another, we do not attribute coming to be and passing away uniformly to them both, although every coming to be is a passing away of something else and every passing away some other thing's coming to be. But the question subsequently formulated involves a different problem, viz. Why, Although the learning thing is said to come to be learned but not to come to be without qualification, yet the growing thing is said to come to be. The distinction here turns upon the difference of the categories. For some things signify this somewhat, others as such, and others as so much. Those things, then, which do not signify substance, are not said to come to be without qualification, but only to come to be so and so. Nevertheless, in all changing things alike, we speak of coming to be when the thing comes to be something in one of the two columns, for example in substance, if it comes to be fire but not if it comes to be earth, and in quality, if it comes to be learned but not when it comes to be ignorant. We have explained why some things come to be without qualification, but not others, both in general, and also when the changing things are substances and nothing else, and we have stated that the substratum is the material cause of the continuous occurrence of coming to be, because it is such as to change from contrary to contrary, and because, in substances, the coming to be of one thing is always a passing away of another, and the passing away of one thing is always another's coming to be. But there is no need even to discuss the other question we raised, viz. Why coming to be continues though things are constantly being destroyed. For just as people speak of a passing away without qualification when a thing has passed into what is imperceptible and what in that sense is not, so also they speak of a coming to be out of a not being when a thing emerges from an imperceptible. Whether, therefore, the substratum is or is not something, what comes to be emerges out of a not being, so that a thing comes to be out of a not being just as much as it passes away into what is not. Hence it is reasonable enough that coming to be should never fail. For coming to be is a passing away of what is not, and passing away is a coming to be of what is not. But what about that which is not except with a qualification? Is it one of the two contrary poles of the Chang, for example earth, that is the heavy, a not being, but fire, that is the light, a being? Or, on the contrary, does what is include earth as well as fire, whereas what is not is matter, the matter of earth and fire alike? And again, is the matter of each different? Or is it the same, since otherwise they would not come to be reciprocally out of one another, that is contraries out of contraries? For these things fire, earth, water, air are characterized by the contraries. Perhaps the solution is that their matter is in one sense the same, but in another sense different. For that which underlies them, whatever its nature may be qua underlying them, is the same, but its actual being is not the same. So much, then, on these topics. Next we must state what the difference is between coming to be and alteration, for we maintain that these changes are distinct from one another. Since, then, we must distinguish, a, the substratum, and, b, the property whose nature it is to be predicated of the substratum, and since change of each of these occurs, there is alteration when the substratum is perceptible and persists, but changes in its own properties, the properties in question being opposed to one another either as contraries or as intermediates. The body, for example, although persisting as the same body, is now healthy and now ill, and the bronze is now spherical and at another time angular, and yet remains the same bronze. But when nothing perceptible persists in its identity as a substratum, and the thing changes as a whole, when for example the seed as a whole is converted into blood, or water into air, or air as a whole into water, such an occurrence is no longer alteration. It is a coming to be of one substance and a passing away of the other, especially if the change proceeds from an imperceptible something to something perceptible, either to touch or to all the senses, as when water comes to be out of, or passes away into, air, for air is pretty well imperceptible. If, however, in such cases, any property, being one of a pair of contraries, persists, in the thing that has come to be, the same as it was in the thing which has passed away, if, for example when water comes to be out of air, both are transparent or cold, the second thing, into which the first changes, must not be a property of this persistent identical something. Otherwise the change will be alteration. Suppose, for example, that the musical man passed away and an unmusical man came to be, and that the man persists as something identical. Now, if musicalness and unmusicalness had not been a property essentially inhering in man, these changes would have been a coming to be of unmusicalness and a passing away of musicalness. But in fact musicalness and unmusicalness are a property of the persistent identity, viz. man. Hence, as regards man, these changes are modifications, though, as regards musical man and unmusical man, they are a passing away and a coming to be, consequently such changes are alteration. When the change from contrary to contrary is in quantity, it is growth and diminution; when it is in place, it is motion; when it is in property, that is in quality, it is alteration. But, when nothing persists, of which the resultant is a property, or an accident in any sense of the term, it is coming to be, and the converse change is passing away. Matter, in the most proper sense of the term, is to be identified with the substratum which is receptive of coming to be and passing away, but the substratum of the remaining kinds of change is also, in a certain sense, matter, because all these substrata are receptive of contrarieties of some kind. So much, then, as an answer to the questions, whether coming to be is or is not, that is what are the precise conditions of its occurrence, and, 2, what alteration is. But we have still to treat of growth. We must explain, wherein growth differs from coming to be and from alteration, and 2, what is the process of growing and this process of diminishing in each and all the things that grow and diminish. Hence our first question is this: do these changes differ from one another solely because of a difference in their respective spheres? In other words, do they differ because, while a change from this to that, viz. from potential to actual substance, is coming to be, a change in the sphere of magnitude is growth and one in the sphere of quality is alteration, both growth and alteration being changes from what is potentially to what is actually magnitude and quality respectively? Or is there also a difference in the manner of the change, since it is evident that, whereas neither what is altering nor what is coming to be necessarily changes its place, what is growing or diminishing changes its spatial position of necessity, though in a different manner from that in which the moving thing does so. For that which is being moved changes its place as a whole, but the growing thing changes its place like a metal that is being beaten, retaining its position as a whole while its parts change their places. They change their places, but not in the same way as the parts of a revolving globe. For the parts of the globe change their places while the whole continues to occupy an equal place, but the parts of the growing thing expand over an ever-increasing place and the parts of the diminishing thing contract within an ever-diminishing area. It is clear, then, that these changes, the changes of that which is coming to be, of that which is altering, and of that which is growing, differ in manner as well as in sphere. But how are we to conceive the sphere of the change which is growth and diminution? The sphere of growing and diminishing is believed to be magnitude. Are we to suppose that body and magnitude come to be out of something which, though potentially magnitude and body, is actually incorporeal and devoid of magnitude? And since this description may be understood in two different ways, in which of these two ways are we to apply it to the process of growth? Is the matter, out of which growth takes place, separate and existing alone by itself, or, 2, separate but contained in another body? Perhaps it is impossible for growth to take place in either of these ways. For since the matter is separate, either, A, it will occupy no place, as if it were a point, or, B, it will be a void, that is a non-perceptible body. But the first of these alternatives is impossible. For since what comes to be out of this incorporeal and sizeless something will always be somewhere, it too must be somewhere either intrinsically or indirectly. And the second alternative necessarily implies that the matter is contained in some other body. But if it is to be in another body and yet remain separate in such a way that it is in no sense a part of that body, neither a part of its substantial being nor an accident of it, many impossibilities will result. It is as if we were to suppose that when, for example, air comes to be out of water, the process were due not to a change of the but to the matter of the air being contained in the water as in a vessel. This is impossible. For, there is nothing to prevent an indeterminate number of matters being thus contained in the water, so that they might come to be actually an indeterminate quantity of air, and, 2, we do not in fact see air coming to be out of water in this fashion, viz. withdrawing out of it and leaving it unchanged. It is therefore better to suppose that in all instances of coming to be the matter is inseparable, being numerically identical and one with the containing body, though isolable from it by definition. But the same reasons also forbid us to regard the matter, out of which the body comes to be, as points or lines. The matter is that of which points and lines are limits, and it is something that can never exist without quality and without form. Now it is no doubt true, as we have also established elsewhere, that one thing comes to be, in the unqualified sense, out of another thing, and further it is true that the efficient cause of its coming to be is either, an actual thing, which is the same as the effect either generically, or the efficient cause of the coming to be of a hard thing is not a hard thing or specifically, as for example fire is the efficient cause of the coming to be of fire, or one man of the birth of another, or, 2, an actuality. Nevertheless, since there is also a matter out of which corporeal substance itself comes to be, corporeal substance, however, already characterized as such and such a determinate body, for there is no such thing as body in general, this same matter is also the matter of magnitude and quality, being separable from these matters by definition, but not separable in place unless qualities are, in their turn, separable. It is evident, from the preceding development and discussion of difficulties, that growth is not a change out of something which, though potentially a magnitude, actually possesses no magnitude. For, if it were, the void would exist in separation, but we have explained in the former work that this is impossible. Moreover, a change of that kind is not peculiarly distinctive of growth, but characterizes coming to be as such or in general. For growth is an increase, and diminution is a lessening, of the magnitude which is there already. That, indeed, is why the growing thing must possess some magnitude. Hence growth must not be regarded as a process from a matter without magnitude to an actuality of magnitude, for this would be a body's coming to be rather than its growth. We must therefore come to closer quarters with the subject of our inquiry. We must grapple with it, as it were, from its beginning, and determine the precise character of the growing and diminishing whose causes we are investigating. It is evident, that any and every part of the growing thing has increased, and that similarly in diminution every part has become smaller. Also, too, that a thing grows by the accession, and diminishes by the departure, of something. Hence it must grow by the accession either, a, of something incorporeal or, b, of a body. Now, if, a, it grows by the accession of something incorporeal, there will exist separate a void, but, as we have stated before, is impossible for a matter of magnitude to exist separate. If, on the other hand, b, it grows by the accession of a body, there will be two bodies, that which grows and that which increases it in the same place, and this too is impossible. But neither is it open to us to say that growth or diminution occurs in the way in which, for example, air is generated from water. For, although the volume has then become greater, the change will not be growth, but a coming to be of the one, viz. Of that into which the change is taking place and a passing away of the contrasted body. It is not a growth of either. Nothing grows in the process, unless indeed there be something common to both things, to that which is coming to be and to that which passed away, for example body, and this grows. The water has not grown, nor has the air, but the former has passed away and the latter has come to be, and if anything has grown there has been a growth of body. Yet this too is impossible. For our account of growth must preserve the characteristics of that which is growing and diminishing. And these characteristics are three, any and every part of the growing magnitude is made bigger. For example, if flesh grows, every particle of the flesh gets bigger, 2, by the accession of something, and 3, in such a way that the growing thing is preserved and persists. For whereas a thing does not persist in the processes of unqualified coming to be or passing away, that which grows or alters persists in its identity through the altering and through the growing or diminishing, though the quality, in alteration, and the size, in growth, do not remain the same. Now if the generation of air from water is to be regarded as growth, a thing might grow without the accession, and without the persistence, of anything, and diminish without the departure of anything, and that which grows need not persist. But this characteristic must be preserved, for the growth we are discussing has been assumed to be thus characterized. One might raise a further difficulty. What is that which grows? Is it that to which something is added? If, for example, a man grows in his shin, is it the shin which is greater but not that whereby he grows, viz. not the food? Then why have not both grown? For when A is added to B, both A and B are greater, as when you mix wine with water, for each ingredient is alike increased in volume. Perhaps the explanation is that the substance of the one remains unchanged, but the substance of the other, viz. of the food, does not. For indeed, even in the mixture of wine and water, it is the prevailing ingredient which is said to have increased in volume. We say, for example, that the wine has increased, because the whole mixture acts as wine but not as water. A similar principle applies also to alteration. Flesh is said to have been altered if, while its character and substance remain, some one of its essential properties, which was not there before, now qualifies it. On the other hand, that whereby it has been altered may have undergone no change, though sometimes it too has been affected. The altering agent, however, and the originative source of the process are in the growing thing and in that which is being altered, for the efficient cause is in these. No doubt the food, which has come in, may sometimes expand as well as the body that has consumed it. That is so, for example, if, after having come in, a food is converted into wind, but when it has undergone this change it has passed away, and the efficient cause is not in the food. We have now developed the difficulties sufficiently and must therefore try to find a solution of the problem. Our solution must preserve intact the three characteristics of growth: that the growing thing persists, that it grows by the accession, and diminishes by the departure, of something, and further that every perceptible particle of it has become either larger or smaller. We must recognize also, a, that the growing body is not void and that yet there are not two magnitudes in the same place, and b. that it does not grow by the accession of something incorporeal. Two preliminary distinctions will prepare us to grasp the cause of growth. We must note, I, that the organic parts grow by the growth of the tissues, for every organ is composed of these as its constituents, and 2, that flesh, bone, and every such part like every other thing which has its form immersed in matter has a twofold nature, for the form as well as the matter is called flesh or bone. Now, that any and every part of the tissue qua form should grow and grow by the accession of something is possible, but not that any and every part of the tissue qua matter should do so. For we must think of the tissue after the image of flowing water that is measured by one and the same measure, particle after particle comes to be, and each successive particle is different. And it is in this sense that the matter of the flesh grows, some flowing out and some flowing in fresh, not in the sense that fresh matter accedes to every particle of it. There is, however, an accession to every part of its figure or form. That growth has taken place proportionally, is more manifest in the organic parts, for example in the hand. For the fact that the matter is distinct from the form is more manifest than in flesh, that is than in the tissues. That is why there is a greater tendency to suppose that a corpse still possesses flesh and bone than that it still has a hand or an arm. Hence in one sense it is true that any and every part of the flesh has grown, but in another sense it is false. For there has been an accession to every part of the flesh in respect to its form, but not in respect to its matter. The whole, however, has become larger. And this increase is due, a. on the one hand to the accession of something, which is called food and is said to be contrary to flesh, but, b. on the other hand to the transformation of this food into the same form as that of flesh, as if, for example, moist were to accede to dry and, having acceded, were to be transformed and to become dry. For in one sense like grows by like, but in another sense unlike grows by unlike. One might discuss what must be the character of that whereby a thing grows. Clearly it must be potentially that which is growing, potentially flesh, for example if it is flesh that is growing. Actually, therefore, it must be other than the growing thing. This actual other, then, has passed away and come to be flesh. But it has not been transformed into flesh alone by itself, for that would have been a coming to be, not a growth. On the contrary, it is the growing thing which has come to be flesh, and grown, by the food. In what way, then, has the food been modified by the growing thing? Perhaps we should say that it has been mixed with it, as if one were to pour water into wine and the wine were able to convert the new ingredient into wine. And as fire lays hold of the inflammable, so the active principle of growth, dwelling in the growing thing, that which is actually flesh, lays hold of an exceeding food which is potentially flesh and converts it into actual flesh. The exceeding food, therefore, must be together with the growing thing, for if it were apart from it, the change would be a coming to be. For it is possible to produce fire by piling logs onto the already burning fire. That is growth. But when the logs themselves are set on fire, that is coming to be. Quantum in general does not come to be any more than animal, which is neither man nor any other of the specific forms of animal. What animal in general is in coming to be, that quantum in general is in growth. But what does come to be in growth is flesh or bone or a hand or a arm, that is the tissues of these organic parts. Such things come to be, then, by the accession not of quantified flesh but of a quantified something. In so far as this exceeding food is potentially the double result, for example is potentially so much flesh, it produces growth, for it is bound to become actually both so much and flesh. But in so far as it is potentially flesh only, it nourishes, for it is thus that nutrition and growth differ by their definition. That is why a body's nutrition continues so long as it is kept alive, even when it is diminishing, though not its growth, and why nutrition, though the same as growth, is yet different from it in its actual being. For in so far as that which exceeds is potentially so much flesh, it tends to increase flesh, whereas, in so far as it is potentially flesh only, it is nourishment. The form of which we have spoken is a kind of power immersed in matter, a duct, as it were. If, then, a matter exceeds a matter, which is potentially a duct and also potentially possesses determinate quantity, the ducts to which it exceeds will become bigger. But if it is no longer able to act, if it has been weakened by the continued influx of matter, just as water, continually mixed in greater and greater quantity with wine, in the end makes the wine watery and converts it into water, then it will cause a diminution of the quantum, though still the form persists. In discussing the causes of coming to be, we must first investigate the matter, that is the so-called elements. We must ask whether they really are clements or not, that is whether each of them is eternal or whether there is a sense in which they come to be. And, if they do come to be, whether all of them come to be in the same manner reciprocally out of one another, or whether one amongst them is something primary. Hence we must begin by explaining certain preliminary matters, about which the statements now current are vague. For all the pluralist philosophers, those who generate the elements as well as those who generate the bodies that are compounded of the elements, make use of dissociation and association, and of action and passion. Now association is combination, but the precise meaning of the process we call combining has not been explained. Again, all the monists make use of alteration, but without an agent and a patient there cannot be altering any more than there can be dissociating and associating. For not only those who postulate a plurality of elements employ their reciprocal action and passion to generate the compounds, those who derive things from a single element are equally compelled to introduce acting. And in this respect Diogenes is right when he argues that unless all things were derived from one, reciprocal action and passion could not have occurred. The hot thing, for example, would not be cooled and the cold thing in turn be warmed, for heat and cold do not change reciprocally into one another. But what changes, it is clear, is the substratum. Hence, whenever there is action and passion between two things, that which underlies them must be a single something. No doubt, it is not true to say that all things are of this character, but it is true of all things between which there is reciprocal action and passion. But if we must investigate action, passion and combination, we must also investigate contact. For action and passion, in the proper sense of the terms, can only occur between things which are such as to touch one another, nor can things enter into combination at all unless they have come into a certain kind of contact. Hence we must give a definite account of these three things of contact, combination, and acting. Let us start as follows. All things which admit of combination must be capable of reciprocal contact, and the same is true of any two things, of which one acts and the other suffers action in the proper sense of the terms. For this reason we must treat of contact first. Every term which possesses a variety of meaning includes those various meanings either owing to a mere coincidence of language, or owing to a real order of derivation in the different things to which it is applied. But, though this may be taken to hold of contact as of all such terms, it is nevertheless true that contact in the proper sense applies only to things which have position. And position belongs only to those things which also have a place, for in so far as we attribute contact to the mathematical things, we must also attribute place to them, whether they exist in separation or in some other fashion. Assuming, therefore, that to touch is as we have defined it in a previous work to have the extremes together, only those things will touch one another which, being separate magnitudes and possessing position, have their extremes together. And since position belongs only to those things which also have a place, while the primary differentiation of place is the above and the below, and the similar pairs of opposites, all things which touch one another will have weight or lightness, either both these qualities or one or the other of them. But bodies which are heavy or light are such as to act and suffer action. Hence it is clear that those things are by nature such as to touch one another, which, being separate magnitudes, have their extremes together and are able to move, and be moved by, one another. The manner in which the move moves the moved not always the same, on the contrary. Whereas one kind of mover can only impart motion by being itself moved, another kind can do so though remaining itself unmoved. Clearly therefore we must recognize a corresponding variety in speaking of the acting thing too, for the mover is said to act, in a sense, and the acting thing to impart motion. Nevertheless there is a difference and we must draw a distinction. For not every mover can act, if, a, the term agent is to be used in contrast to patient and, b, patient is to be applied only to those things whose motion is a qualitative affection, that is a quality, like white or hot, in respect to which they are moved only in the sense that they are altered. On the contrary, to impart motion is a wider term than to act. Still, so much, at any rate, is clear, the things which are such as to impart motion, if that description be interpreted in one sense, will touch the things which are such as to be moved by them, while they will not touch them, if the description be interpreted in a different sense. But the disjunctive definition of touching must include and distinguish, a, contact in general as the relation between two things which, having position, are such that one is able to impart motion and the other to be moved, and, b, reciprocal contact as the relation between two things, one able to impart motion and the other able to be moved in such a way that action and passion are predicable of them. As a rule, no doubt, if A touches B, B touches A. For indeed practically all the movers within our ordinary experience impart motion by being moved. In their case, what touches inevitably must, and also evidently does, touch something which reciprocally touches it. Yet, if A moves B, it is possible as we sometimes express it for A merely to touch B, and that which touches need not touch a something which touches it. Nevertheless, it is commonly supposed that touching must be reciprocal. The reason of this belief is that movers which belong to the same kind as the moved impart motion by being moved. Hence, if anything imparts motion without itself being moved, it may touch the moved and yet itself be touched by nothing. For we say sometimes that the man who grieves us touches us, but not that we touch him. The account just given may serve to distinguish and define the contact which occurs in the things of nature. Next in order we must discuss action and passion. The traditional theories on the subject are conflicting. Most thinkers are unanimous in maintaining, a, that like is always unaffected by like, because, as they argue, neither of two likes is more apparent than the other either to act or to suffer action, since all the properties which belong to the one belong identically and in the same degree to the other, and, b, that unlikes, that is difference, are by nature such as to act and suffer action reciprocally. For even when the smaller fire is destroyed by the greater, it suffers this effect, they say, owing to its contrariety, since the great is contrary to the small. But, 2. Democritus dissented from all the other thinkers and maintained a theory peculiar to himself. He asserts that agent and patient are identical, that is like. It is not possible, he says, that others, that is difference, should suffer action from one another. On the contrary, even if two things, being others, do act in some way on one another, this happens to them not qua others but qua possessing an identical property. Such, then, are the traditional theories, and it looks as if the statements of their advocates were in manifest conflict. But the reason of this conflict is that each group is in fact stating a part, whereas they ought to have taken a comprehensive view of the subject as a whole. If A and B are like absolutely and in all respects without difference from one another, it is reasonable to infer that neither is in any way affected by the other. Why, indeed, should either of them tend to act any more than the other? Moreover, if like can be affected by like, a thing can also be affected by itself, and yet if that were so, if like tended in fact to act qua like, there would be nothing indestructible or removable, for everything would move itself. And, 2, the same consequence follows if A and B are absolutely other, that is in no respect identical. Whiteness could not be affected in any way by line nor line by wiseness except perhaps coincidentally, viz. If the line happened to be white or black, for unless two things either are, or are composed of, contraries, neither drives the other out of its natural condition. But, 3, since only those things which either involve a contrariety or are contraries and not anything selected at random are such as to suffer action and to act, agent and patient must be like, that is identical, in kind and yet unlike, that is contrary, in species. For it is a law of nature that body is affected by body, flavor by flavor, color by color, and so in general what belongs to any kind by a member of the same kind, the reason being that contraries are in every case within a single identical kind, and it is contraries which reciprocally act and suffer action, hence agent and patient must be in one sense identical, but in another sense other than, that is unlike, one another. And since, A, patient and agent are generically identical, that is like, but specifically unlike, while, B, it is contraries that exhibit this character, it is clear that contraries and their intermediates are such as to suffer action and to act reciprocally, for indeed it is these that constitute the entire sphere of passing away and coming to be. We can now understand why fire heats and the cold thing cools, and in general why the active thing assimilates to itself the patient. For agent and patient are contrary to one another, and coming to be is a process into the contrary, hence the patient must change into the agent, since it is only thus that coming to be will be a process into the contrary. And, again, it is intelligible that the advocates of both views, although their theories are not the same, are yet in contact with the nature of the facts. For sometimes we speak of the substratum as suffering action, for example of the man as being healed, being warmed and chilled, and similarly in all the other cases, but at other times we say what is cold is being warmed, what is sick is being healed, and in both these ways of speaking we express the truth, since in one sense it is the matter, while in another sense it is the contrary, which suffers action. We make the same distinction in speaking of the agent, for sometimes we say that the man, but at other times that what is hot, produces heat. Now the one group of thinkers supposed that agent and patient must possess something identical, because they fastened their attention on the substratum, while the other group maintained the opposite because their attention was concentrated on the contraries. We must conceive the same account to hold of action and passion as that which is true of being moved and imparting motion. For the mover, like the agent, has two meanings. Both, A, that which contains the originative source of the motion is thought to impart motion, for the originative source is first amongst the causes, and also, b, that which is last, that is immediately next to the moved thing and to the coming to be. A similar distinction holds also of the agent, for we speak not only, a, of the doctor, but also, b, of the wine, as healing. Now, in motion, there is nothing to prevent the first mover being unmoved. Indeed, as regards some first movers this is actually necessary, although the last mover always imparts motion by being itself moved, and, in action, there is nothing to prevent the first agent being unaffected, while the last agent only acts by suffering action itself. For agent and patient have not the same matter. Agent acts without being affected, thus the art of healing produces health without itself being acted upon in any way by that which is being healed. But, b, the food, in acting, is itself in some way acted upon, for, in acting, it is simultaneously heated or cooled or otherwise affected. Now the art of healing corresponds to an originative source, while the food corresponds to the last, that is continuous, mover. Those active powers, then, whose forms are not embodied in matter, are unaffected, but those whose forms are in matter are such as to be affected in acting. For we maintain that one and the same matter is equally, so to say, the basis of either of the two opposed things being as it were a kind, and that which can heat hot must be made hot, provided the heating agent is there, that is comes near. Hence, as we have said, some of the active powers are unaffected while others are such as to be affected, and what holds of motion is true also of the active powers. For as in motion the first mover is unmoved, so among the active powers the first agent is unaffected. The active power is a cause in the sense of that from which the process originates, but the end, for the sake of which it takes place, is not active. That is why health is not active, except metaphorically, for when the agent is there, the patient he becomes something, but when states are there, the patient no longer becomes but already isn't. Forms, that is lens, are a kind of state. As to the matter, it, qua matter, is passive. Now fire contains the hot embodied in matter, but a hot separate from matter, if such a thing existed, could not suffer any action. Perhaps, indeed, it is impossible that the hot should exist in separation from matter, but if there are any entities thus separable, what we are saying would be true of them. We have thus explained what action and passion are, what things exhibit them, why they do so, and in what manner. We must go on to discuss how it is possible for action and passion to take place. Some philosophers think that the last agent, though agent in the strictest sense, enters in through certain pores, and so the patient suffers action. It is in this way, they assert, that we see and hear and exercise all our other senses. Moreover, according to them, things are seen through air and water and other transparent bodies, because such bodies possess pores, invisible indeed owing to their minuteness, but close set and arranged in rows, and the more transparent the body, the more frequent and serial they suppose its pores to be. Such was the theory which some philosophers, including Empedocles, advanced in regard to the structure of certain bodies. They do not restrict it to the bodies which act and suffer action, but combination too, they say, takes place only between bodies whose pores are in reciprocal symmetry. The most systematic and consistent theory, however, and one that applied to all bodies, was advanced by Leucippus and Democritus, and, in maintaining it, they took as their starting point what naturally comes first. For some of the older philosophers thought that what is must of necessity be one and immovable. The void, they argue, is not, but unless there is a void with a separate being of its own, what is cannot be moved nor again can it be many, since there is nothing to keep things apart. And in this respect, they insist, the view that the universe is not continuous but discrete sin contact is no better than the view that there are many, and not one, and a void. For, suppose that the universe is discrete sin contact. Then, if it is divisible through and through, there is no one, and therefore no may either, but the whole is void, while to maintain that it is divisible at some points, but not at others, looks like an arbitrary fiction. For up to what limit is it divisible? And for what reason is part of the whole indivisible, that is a plenum, and part divided? Further, they maintain, it is equally necessary to deny the existence of motion. Reasoning in this way, therefore, they were led to transcend sense perception, and to disregard it on the ground that one ought to follow the argument, and so they assert that the universe is one and immovable. Some of them add that it is infinite, since the limit, if it had one, would be a limit against the void. There were, then, certain thinkers who, for the reasons we have stated, enunciated views of this kind as their theory of the truth. Moreover, although these opinions appear to follow logically in a dialectical discussion, yet to believe them seems next door to madness when one considers the facts. for indeed no lunatic seems to be so far out of his senses as to suppose that fire and ice are one. It is only between what is right and what seems right from habit, that some people are mad enough to see no difference. Leucippus, however, thought he had a theory which harmonized with sense perception and would not abolish either coming to be and passing away or motion and the multiplicity of things. He made these concessions to the facts of perception. On the other hand, he conceded to the monists that there could be no motion without a void. The result is a theory which he states as follows: the void is a not being, and no part of what is a not being, for what is in the strict sense of the term is an absolute plenum. This plenum, however, is not one, on the contrary, it is a many infinite in number and invisible owing to the minuteness of their bulk. The many move in the void, for there is a void, and by coming together they produce coming to be, while by separating they produce passing away. Moreover, they act and suffer action wherever they chance to be in contact, for they are not one, and they generate by being put together and becoming intertwined. From the genuinely one, on the other hand, there never could have come to be a multiplicity, nor from the genuinely many a one, that is impossible. But, just as Empedocles and some of the other philosophers say that things suffer action through their pause, so, all alteration and all passion take place in the way that has been explained. Breaking up, that is passing away, is effected by means of the void, and so too is growth solids creeping in to fill the void places. Empedocles too is practically bound to adopt the same theory as Leucippus. For he must say that there are certain solids which, however, are indivisible unless there are continuous pores all through the body. But this last alternative is impossible, for then there will be nothing solid in the body, nothing beside the pores, but all of it will be void. It is necessary, therefore, for his contiguous discretes to be indivisible, while the intervals between them which he calls pores must be void. But this is precisely Leucippus' theory of action and passion. Such, approximately, are the current explanations of the manner in which some things act while others suffer action. And as regards the atomists, it is not only clear what their explanation is, it is also obvious that it follows with tolerable consistency from the assumptions they employ. But there is less obvious consistency in the explanation offered by the other thinkers. It is not clear, for instance, how, on the theory of Empedocles, there is to be passing away as well as alteration. For the primary bodies of the atomists, the primary constituents of which bodies are composed, and the ultimate elements into which they are dissolved are indivisible, differing from one another only in figure. In the philosophy of Empedocles, on the other hand, it is evident that all the other bodies down to the elements have their coming to be and their passing away, but it is not clear how the elements themselves, severally in their aggregated masses, come to be and pass away. Nor is it possible for Empedocles to explain how they do so, since he does not assert that fire too, and similarly every one of his other elements, possesses elementary constituents of itself. Such an assertion would commit him to doctrines like those which Plato has set forth in the Timaeus. For although both Plato and Leucippus postulate elementary constituents that are indivisible and distinctively characterized by figures, there is this great difference between the two theories. The indivisibles of Leucippus, I, are solids, while those of Plato are planes, and, 2, are characterized by an infinite variety of figures, while the characterizing figures employed by Plato are limited in number. Thus the comings to be and the dissociations result from the indivisibles, A, according to Leucippus through the void and through contact, for it is at the point of contact that each of the composite bodies is divisible, but, B, according to Plato in virtue of contact alone, since he denies there is a void. Now we have discussed indivisible planes in the preceding treatise. But with regard to the assumption of indivisible solids, although we must not now enter upon a detailed study of its consequences, the following criticisms fall within the compass of a short digression. I. The atomists are committed to the view that every indivisible is incapable alike of receiving a sensible property, for nothing can suffer action except through the void, and of producing one no indivisible can be, for example either hard or cold. Yet it is surely a paradox that an exception is made of the hot being assigned as peculiar to the spherical figure, for, that being so, its contrary also, the cold, is bound to belong to another of the figures. If, however, these properties, heat and cold, do belong to the indivisibles, it is a further paradox that they should not possess heaviness and lightness, and hardness and softness. And yet Democritus says the more any indivisible exceeds, the heavier it is, to which we must clearly add and the hotter it is. But if that is their character, it is impossible they should not be affected by one another. The slightly hot indivisible, for example, will inevitably suffer action from one which far exceeds it in heat. Again, if any indivisible is hard, there must also be one which is soft, but the soft derives its very name from the fact that it suffers a certain action, for soft it is that which yields to pressure. 2. But further, not only is it paradoxical, that no property except figure should belong to the indivisibles, it is also paradoxical, too, that, if other properties do belong to them, one only of these additional properties should attach to each, for example that this indivisible should be cold and that indivisible hot. 4. On that supposition, their substance would not even be uniform. And it is equally impossible, 3, that more than one of these additional properties should belong to the single indivisible. 4. Being indivisible, it will possess these properties in the same point, so that, if it suffers action by being chilled, it will also, chilled, act or suffer action in some other way. And the same line of argument applies to all the other properties too, for the difficulty we have just raised confronts, as a necessary consequence, all who advocate indivisibles, whether solids or planes, since their indivisibles cannot become either rarer or denser inasmuch as there is no void in them. 3. It is a further paradox that there should be small indivisibles, but not large ones. For it is natural enough, from the ordinary point of view, that the larger bodies should be more liable to fracture than the small ones, since they, viz. the large bodies, are easily broken up because they collide with many other bodies. But why should indivisibility as such be the property of small, rather than of large, bodies? 4. Again, is the substance of all those solids uniform, or do they fall into sets which differ from one another, as if, for example, some of them, in their aggregated bulk, were fiery, others earthy? 4. If all of them are uniform in substance, what is it that separated one from another? Or why, when they come into contact, do they not coalesce into one, as drops of water run together when drop touches drop, for the two cases are precisely parallel? On the other hand, 2, if they fall into differing sets, how are these characterized? It is clear, too, that these, rather than the figures, ought to be postulated as original reals, that is, causes from which the phenomena result. Moreover, if they differed in substance, they would both act and suffer action on coming into reciprocal contact. Again, what is it which sets them moving? For if their mover is other than themselves, they are such as to suffer action. If, on the other hand, each of them sets itself in motion, either, A, it will be divisible, imparting motion qua this, being moved qua that, or, B, contrary properties will attach to it in the same respect, that is, matter will be identical in potentiality as well as numerically identical. As to the thinkers who explain modification of property through the movement facilitated by the pores, if this is supposed to occur notwithstanding the fact that the pores are filled, their postulate of pores is superfluous. For if the whole body suffers action under these conditions, it would suffer action in the same way even if it had no pores but were just its own continuous self. Moreover, how can their account of vision through a medium be correct? It is impossible for the visual ray to penetrate the transparent bodies at their contacts, and impossible for it to pass through their pores if every pore be full. For how will it differ from having no pores at all? The body will be uniformly full throughout. But, further, even if these passages, though they must contain bodies, are void, the same consequence will follow once more. And if they are too minute to admit any body, it is absurd to suppose there is a minute void and yet to deny the existence of a big one, no matter how small the big may be, or to imagine the void means anything else than a body's place, whence it clearly follows that to every body there will correspond a void of equal cubic capacity. As a general criticism we must urge that to postulate pores is superfluous. For if the agent produces no effect by touching the patient, neither will it produce any by passing through its pores. On the other hand, if it acts by contact, then even without pores some things will suffer action and others will act, provided they are by nature adapted for reciprocal action and passion. Our arguments have shown that it is either false or futile to advocate pores in the sense in which some thinkers conceive them. But since bodies are divisible through and through, the postulate of pores is ridiculous. 4. Qua divisible, a body can fall into separate parts. Let explain the way in which things in fact possess the power of generating, and of acting and suffering action, and let us start from the principle we have often enunciated. 4. Assuming the distinction between, A, that which is potentially and, B, that which is actually such and such, it is the nature of the first, precisely in so far as it is what it is, to suffer action through and through, not merely to be susceptible in some parts while insusceptible in others. But its susceptibility varies in degree, according as it is more or less, such and such, and one would be more justified in speaking of pores in this connection. For instance, in the metals there are veins of the susceptible stretching continuously through the substance. So long, indeed, as any body is naturally coherent and one, it is insusceptible. So, too, bodies are insusceptible so long as they are not in contact either with one another or with other bodies which are by nature such as to act and suffer action. To illustrate my meaning, fire heats not only when in contact, but also from a distance. For the fire heats the air, and the air being by nature such as both to act and suffer action heats the body, but the supposition that a body is susceptible in some parts, but insusceptible in others, is only possible for those who hold an erroneous view concerning the divisibility of magnitudes. For us, the following account results from the distinctions we established at the beginning. 4. If magnitudes are not divisible through and through, if, on the contrary, there are indivisible solids or planes, then indeed no body would be susceptible through and through, but neither would any be continuous. Since, however, 2, this is false, that is, since every body is divisible, there is no difference between having been divided into parts which remain in contact and being divisible. For if a body can be separated at the contacts, as some thinkers express it, then, even though it has not yet been divided, it will be in a state of dividedness, since, as it can be divided, nothing inconceivable results. And, 3, the supposition is open to this general objection: it is a paradox that passion should occur in this manner only, viz. by the bodies being split. For this theory abolishes alteration. But we see the same body liquid at one time and solid at another, without losing its continuity. It has suffered this change not by division and composition, nor yet by turning and intercontact as Democritus asserts, for it has passed from the liquid to the solid state without any change of grouping or position in the constituents of its substance. Nor are there contained within it those hard, that is congealed, particles indivisible in their bulk. On the contrary, it is liquid and again, solid and congealed uniformly all through. This theory, it must be added, makes growth and diminution impossible also. For if there is to be opposition, instead of the growing thing having changed as a whole, either by the admixture of something or by its own transformation, increase of size will not have resulted in any and every part. So much, then, to establish that things generate and are generated, act and suffer action, reciprocally, and to distinguish the way in which these processes can occur from their impossible way in which some thinkers say they occur. But we have still to explain combination, for that was the third of the subjects we originally proposed to discuss. Our explanation will proceed on the same method as before. We must inquire, what is combination, and what is that which can combine? Of what things, and under what conditions, is combination a property? And, further, does combination exist in fact, or is it false to assert its existence? For, according to some thinkers, it is impossible for one thing to be combined with another. They argue that, if both the combined constituents persist unaltered, they are no more combined now than they were before, but are in the same condition, while, 2, if one has been destroyed, the constituents have not been combined. On the contrary, one constituent is and the other is not, whereas combination demands uniformity of condition in them both. And on the same principle, 3, even if both the combining constituents have been destroyed as the result of their coalescence, they cannot have been combined since they have no being at all. What we have in this argument is, it would seem, a demand for the precise distinction of combination from coming to be and passing away, for it is obvious that combination, if it exists, must differ from these processes, and for the precise distinction of the combinable from that which is such as to come to be and pass away. As soon, therefore, as these distinctions are clear, the difficulties raised by the argument would be solved. Now, we do not speak of the wood as combined with the fire, nor of its burning as a combining either of its particles with one another or of itself with the fire. What we say is that the fire is coming to be, but the wood is passing away. Similarly, we speak neither, 2, of the food as combining with the body, nor, 3, of the shape as combining with the wax and thus fashioning the lump. Nor can body combine with white, nor, to generalize, properties and states with things, for we see them persisting unaltered. But again, 4, white and knowledge cannot be combined either, nor any other of the adjectivals. Indeed, this is a blemish in the theory of those who assert that once upon a time all things were together and combined. For not everything can combine with everything. On the contrary, both of the constituents that are combined in the compound must originally have existed in separation, but no property can have separate existence. Since, however, some things are potentially while others are actually, the constituents combined in a compound can be in a sense and yet not be. The compound may be actually other than the constituents from which it has resulted, nevertheless each of them may still be potentially what it was before they were combined, and both of them may survive undestroyed. For this was the difficulty that emerged in the previous argument, and it is evident that the combining constituents not only coalesce, having formerly existed in separation, but also can again be separated out from the compound. The constituents, therefore, neither a. persist actually, as body and white persist, nor b. are they destroyed, either one of them or both, for their power of action is preserved. Hence these difficulties may be dismissed, but the problem immediately connected with them where the combination is something relative to perception must be set out and discussed. When the combining constituents have been divided into parts so small, and have been juxtaposed in such a manner, that perception fails to discriminate them one from another, have they then been combined, or ought we to say no, not until any and every part of one constituent is juxtaposed to a part of the other? The term, no doubt, is applied in the former sense. We speak, for example, of wheat having been combined with barley when each grain of the one is juxtaposed to a grain of the other. But every body is divisible, and therefore, since body combined with body is uniform in texture throughout, any and every part of each constituent ought to be juxtaposed to a part of the other. No body, however, can be divided into its least parts, and composition is not identical with combination, but other than it. From these premises it clearly follows, that so long as the constituents are preserved in small particles, we must not speak of them as combined. For this will be a composition instead of a blending or combination, nor will every portion of the resultant exhibit the same ratio between its constituents as the whole. But we maintain that, if combination has taken place, the compound must be uniform in texture throughout, any part of such a compound being the same as the whole, just as any part of water is water, whereas, if combination is composition of the small particles, nothing of the kind will happen. On the contrary, the constituents will only be combined relatively to perception, and the same thing will be combined to one percipient, if his sight is not sharp, but not to another, while to the eye of linguists nothing will be combined. It clearly follows, too, that we must not speak of the constituents as combined in virtue of a division such that any and every part of each is juxtaposed to a part of the other, for it is impossible for them to be thus divided. Either, then, there is no combination, or we have still to explain the manner in which it can take place. Now, as we maintain, some things are such as to act and others such as to suffer action from them. Moreover, some things, viz. those which have the same matter reciprocate, that is, are such as to act upon one another and to suffer action from one another, while other things, viz. agents which have not the same matter as their patients, act without themselves suffering action. Such agents cannot combine. That is why neither the art of healing nor health produces health by combining with the bodies of the patients. Amongst those things, however, which are reciprocally active and passive, some are easily divisible. Now, if a great quantity, or a large bulk, of one of these easily divisible reciprocating materials be brought together with a little, or with a small piece, of another, the effect produced is not combination, but increase of the dominant, for the other material is transformed into the dominant. That is why a drop of wine does not combine with 10,000 gallons of water, for its form is dissolved, and it is changed so as to merge in the total volume of water. On the other hand, too, when there is a certain equilibrium between their powers of action, then each of them changes out of its own nature towards the dominant, yet neither becomes the other, but both become an intermediate with properties common to both. Thus it is clear that only those agents are combinable which involve a contrariety, for these are such as to suffer action reciprocally. And, further, they combine more freely if small pieces of each of them are juxtaposed. For in that condition they change one another more easily and more quickly, whereas this effect takes a long time when agent and patient are present in bulk. Hence, amongst the divisible susceptible materials, those whose shape is readily adaptable have a tendency to combine, for they are easily divided into small particles, since that is precisely what being readily adaptable in shape implies. For instance, liquids are the most combinable of all bodies because, of all divisible materials, the liquid is most readily adaptable in shape, unless it be viscous. Viscous liquids, it is true, produce no effect except to increase the volume and bulk. But when one of the constituents is alone susceptible or superlatively susceptible, the other being susceptible in a very slight degree, the compound resulting from their combination is either no greater in volume or only a little greater. This is what happens when tin is combined with bronze. For some things display a hesitating and ambiguous attitude towards one another, showing a slight tendency to combine and also an inclination to behave as receptive matter and form respectively. The behavior of these metals is a case in point. For the tin almost vanishes, behaving as if it were an immaterial property of the bronze. Having been combined, it disappears, leaving no trace except the color it has imparted to the bronze. The same phenomenon occurs in other instances too. It is clear, then, from the foregoing account, that combination occurs, what it is, to what it is due, and what kind of thing is combinable. The phenomenon depends upon the fact that some things are such as to be, a, reciprocally susceptible and, b, readily adaptable in shape, that is easily divisible. For such things can be combined without its being necessary either that they should have been destroyed or that they should survive absolutely unaltered, and their combination need not be a composition, nor merely relative to perception. On the contrary, anything is combinable which, being readily adaptable in shape, is such as to suffer action and to act, and it is combinable with another thing similarly characterized, for the combinable is relative to the combinable, and combination is unification of the combinables, resulting from their alteration. On Generation and Corruption, Book 2, translated by H. Joachim, we have explained under what conditions combination, contact, and action-passion are attributable to the things which undergo natural change. Further, we have discussed unqualified coming to be and passing away, and explained under what conditions they are predicable, of what subject, and owing to what cause. Similarly, we have also discussed alteration, and explained what altering is and how it differs from coming to be and passing away. But we have still to investigate the so-called elements of bodies, for the complex substances whose formation and the maintenance are due to natural processes all presuppose the perceptible bodies as the condition of their coming to be and passing away, but philosophers disagree in regard to the matter which underlies these perceptible bodies. Some maintain it is single, supposing it to be, for example, air or fire, or an intermediate between these two, but still a body with a separate existence. Others, on the contrary, postulate two or more materials ascribing to their association and dissociation, or to their alteration, the coming to be and passing away of things. Some, for instance, postulate fire and earth, some add air, making three, and some, like Empedocles, reckon water as well, thus postulating four. Now we may agree that the primary materials, whose change, whether it be association and dissociation or a process of another kind, results in coming to be and passing away, are rightly described as originative sources, that is elements. But, those thinkers are in error who postulate, beside the bodies we have mentioned, a single matter and that corporeal and separable matter. For this body of theirs cannot possibly exist without a perceptible contrariety, this boundless, which some thinkers identify with the original real, must be either light or heavy, either cold or hot. And, 2, what Plato has written in the Timaeus is not based on any precisely articulated conception. For he has not stated clearly whether his omni-recipient exists in separation from the elements, nor does he make any use of it. He says, indeed, that it is a substratum prior to the so-called elements underlying them, as gold underlies the things that are fashioned of gold. And yet this comparison, if thus expressed, is itself open to criticism. Things which come to be and pass away cannot be called by the name of the material out of which they have come to be. It is only the results of alteration which retain the name of the substratum whose alterations they are. However, he actually says that the truest account is to affirm that each of them is gold apostrophe. Nevertheless, he carries his analysis of the elements solids through they are back to planes, and it is impossible for the nurse, that is the primary matter, to be identical with the planes. Our own doctrine is that although there is a matter of the perceptible bodies, a matter out of which the so-called clements come to be, it has no separate existence, but is always bound up with a contrariety. A more precise account of these presuppositions has been given in another work. We must, however, give a detailed explanation of the primary bodies as well, since they too are similarly derived from the matter. We must reckon as an originative source and as primary the matter which underlies, though it is inseparable from, the contrary qualities, for the hot is not matter for the cold nor the cold for the hot, but the substratum is matter for them both. We therefore have to recognize three originative sources, firstly that which potentially perceptible body, secondly the contrarieties, for example heat and cold, and thirdly fire, water, and the like. Only thirdly, however, for these bodies change into one another, they are not immutable as Empedocles and other thinkers assert, since alteration would then have been impossible, whereas the contrarieties do not change. Nevertheless, even so the question remains, what sorts of contrarieties, and how many of them, are to be accounted originative sources of body? For all the other thinkers assume and use them without explaining why they are these or why they are just so many. Since, then, we are looking for originative sources of perceptible body, and since perceptible is equivalent to tangible, and tangible is that of which the perception is touch, it is clear that not all the contrarieties constitute forms and originative sources of body, but only those which correspond to touch. for it is in accordance with a contrariety, moreover, of tangible qualities that the primary bodies are differentiated. That is why neither whiteness, and blackness, nor sweetness, and bitterness, nor, similarly, any quality belonging to the other perceptible contrarieties either, constitutes an element. And yet vision is prior to touch, so that its object also is prior to the object of touch. The object of vision, however, is a quality of tangible body not qua tangible, but qua something else, qua something which may well be naturally prior to the object of touch. Accordingly, we must segregate the tangible differences and contrarieties, and distinguish which amongst them are primary. Contrarieties correlative to touch are the following: hot cold, dry moist, heavy light, hard soft, viscous brittle, rough smooth, coarse fine. Of these, heavy and light are neither active nor susceptible. Things are not called heavy and light because they act upon, or suffer action from, other things. But the elements must be reciprocally active and susceptible, since they combine and are transformed into one another. On the other hand, hot and cold, and dry and moist, are terms, of which the first pair implies power to act and the second pair susceptibility. Hot is that which associates things of the same kind, for dissociating, which people attribute to fire as its function, is associating things of the same class, since its effect is to eliminate what is foreign, while cold is that which brings together, that is associates, homogeneous and heterogeneous things alike. And moist is that which, being readily adaptable in shape, is not determinable by any limit of its own, while dry is that which is readily determinable by its own limit, but not readily adaptable in shape. From moist and dry are derived, the fine and coarse, viscous and brittle, hard and soft, and the remaining tangible differences. 4a. Since the moist has no determinate shape, but is readily adaptable and follows the outline of that which is in contact with it, it is characteristic of it to be such as to fill up. Now the fine is such as to fill up. For the fine consists of subtle particles, but that which consists of small particles is such as to fill up, inasmuch as it is in contact whole with whole, and the fine exhibits this character in a superlative degree. Hence it is evident that the fine derives from the moist, while the coarse derives from the dry. Again, b. The viscous derives from the moist, for the viscous, for example oil, is a moist modified in a certain way. The brittle, on the other hand, derives from the dry, for brittle is that which is completely dry, so completely, that its solidification has actually been due to failure of moisture. Further, c. The soft derives from the moist. For soft is that which yields to pressure by retiring into itself, though it does not yield by total displacement as the moist does, which explains why the moist is not soft, although the soft derives from the moist. The hard, on the other hand, derives from the dry, for hard is that which is solidified, and the solidified is dry. The terms dry and moist have more senses than one. For the damp, as well as the moist, is opposed to the dry, and again the solidified, as well as the dry, is opposed to the moist. But all these qualities derive from the dry and moist we mentioned first. 4i. The dry is opposed to the damp, that is, damp is that which has foreign moisture on its surface, sodden being that which is penetrated to its core, while dry is that which has lost foreign moisture. Hence it is evident that the damp will derive from the moist, and the dry which is opposed to it will derive from the primary dry. Again, the moist and the solidified derive in the same way from the primary pair. For moist is that which contains moisture of its own deep within it, sodden being that which is deeply penetrated by foreign moisture, whereas solidified is that which has lost this inner moisture. Hence these two derive from the primary pair, the solidified from the dry and the solidified from the dry, the liquefiable from the moist. It is clear, then, that all the other differences reduce to the first four, but that these admit of no further reduction. For the hot is not essentially moist or dry, nor the moist essentially hot or cold, nor are the cold and the dry derivative forms, either of one another or of the hot and the moist. Hence these must be four. The elementary qualities are four, and any four terms can be combined in 6 couples. Contraries, however, refuse to be coupled, for it is impossible for the same thing to be hot and cold, or moist and dry. Hence it is evident that the couplings of the elementary qualities will be 4, hot with dry and moist with hot, and again cold with dry and cold with moist. And these 4 couples have attached themselves to the apparently simple bodies, fire, air, water, and earth, in a manner consonant with theory. For fire is hot and dry, whereas air is hot and moist, air being a sort of aqueous vapor, and water is cold and moist, while earth is cold and dry. Thus the differences are reasonably distributed among the primary bodies, and the number of the latter is consonant with theory. for all who make the simple body's elements postulate either 1, or 2, or 3, or 4. Now, those who assert there is one only, and then generate everything else by condensation and rarefaction, are in effect making their originative sources 2, viz. the rare and the dense, or rather the hot and the cold, for it is these which are the moulding forces, while the one underlies them as a matter. But, 2, those who postulate 2 from the start as Parmenides postulated fire and earth make the intermediates, for example air and water, blends of these. The same course is followed, 3, by those who advocate 3. We may compare what Plato does in Me divisions, for he makes them a blend. Indeed, there is practically no difference between those who postulate 2 and those who postulate 3, except that the former split the middle element into 2, while the latter treat it as only 1. But, 4, some advocate 4 from the start, for example Empedocles, yet he too draws them together so as to reduce them to the 2, for he opposes all the others to fire. In fact, however, fire and air, and each of the bodies we have mentioned, are not simple, but blended. The simple bodies are indeed similar in nature to them, but not identical with them. Thus the simple body corresponding to fire is such as fire, not fire, that which corresponds to air is such as air, and so on with the rest of them. But fire is an excess of heat, just as ice is an excess of cold. For freezing and boiling are excesses of heat and cold respectively. Assuming, therefore, that ice is a freezing of moist and cold, fire analogously will be a boiling of dry and hot, a fact, by the way, which explains why nothing comes to be either out of ice or out of fire. The simple bodies, since they are 4, fall into 2 pairs which belong to the 2 regions, each to each, for fire and air are forms of the body moving towards the limit, while earth and water are forms of the body which moves towards the center. Fire and earth, moreover, are extremes and purest, water and air, on the contrary are intermediates and more like blends. And, further, the members of either pair are contrary to those of the other, water being contrary to fire and earth to air, for the qualities constituting water and earth are contrary to those that constitute fire and air. Nevertheless, since they are 4, each of them is characterized par excellence a single quality, earth by dry rather than by cold, water by cold rather than by moist, air by moist rather than by hot, and fire by hot rather than by dry. It has been established before that the coming to be of the simple bodies is reciprocal. At the same time, it is manifest, even on the evidence of perception, that they do come to be, for otherwise there would not have been alteration, since alteration is change in respect to the qualities of the objects of touch. Consequently, we must explain, what is the manner of their reciprocal transformation, and, 2, whether every one of them can come to be out of every one or whether some can do so, but not others. Now it is evident that all of them are by nature such as to change into one another, for coming to be is a change into contraries and out of contraries, and the elements all involve a contrariety in their mutual relations because their distinctive qualities are contrary. For in some of them both qualities are contrary, for example in fire and water, the first of these being dry and hot, and the second moist and cold, while in others one of the qualities, though only one, is contrary, for example in air and water, the first being moist and hot, and the second moist and cold. It is evident, therefore, if we consider them in general, that every one is by nature such as to come to be out of every one, and when he come to consider them severally, it is not difficult to see the manner in which their transformation is effected. For, though all will result from all, both the speed and the facility of their conversion will differ in degree. Thus, the process of conversion will be quick between those which have interchangeable complementary factors, but slow between those which have none. The reason is that it is easier for a single thing to change than for many. Air, for example, will result from fire if a single quality changes, for fire, as we saw, is hot and dry while air is hot and moist, so that there will be air if the dry be overcome by the moist. Again, water will result from air if the hot be overcome by the cold, for air, as we saw, is hot and moist while water is cold and moist, so that, if the hot changes, there will be water. So too, in the same manner, earth will result from water and fire from earth, since the two elements in both these couples have interchangeable complementary factors. For water is moist and cold while earth is cold and dry, so that, if the moist be overcome, there will be earth, and again, since fire is dry and hot while earth is cold and dry, fire will result from earth if the cold pass away. It is evident, therefore, that the coming to be of the simple bodies will be cyclical, and that this cyclical method of transformation is the easiest, because the consecutive clements contain interchangeable complementary factors. On the other hand, too, the transformation of fire into water and of air into earth, and again of water and earth into fire and air respectively, though possible, is more difficult because it involves the change of more qualities. For if fire is to result from water, both the cold and the moist must pass away, and again, both the cold and the dry must pass away if air is to result from earth. So too, if water and earth are to result from fire and air respectively, both qualities must change. This second method of coming to be, then, takes a longer time. But, 3. If one quality in each of two elements pass away, the transformation, though easier, is not reciprocal. Still, from fire plus water there will result earth and air, and from air plus earth fire and water. For there will be air, when the cold of the water and the dry of the fire have passed away, since the hot of the latter and the moist of the former are left, whereas, when the hot of the fire and the moist of the water have passed away, there will be earth, owing to the survival of the dry of the fire and the cold of the water. So, too, in the same way, fire and water will result from air plus earth. For there will be water, when the hot of the air and the dry of the earth have passed away, since the moist of the former and the cold of the latter are left, whereas, when the moist of the air and the cold of the earth have passed away, there will be fire, owing to the survival of the hot of the air and the dry of the earth, qualities essentially constitutive of fire. Moreover, this mode of fire's coming to be is confirmed by perception. For flame is par excellence fire, but flame is burning smoke, and smoke consists of air and earth. No transformation, however, into any of the simple bodies can result from the passing away of one elementary quality in each of two elements when they are taken in their consecutive order, because either identical or contrary qualities are left in the pair, but no simple body can be formed either out of identical, or out of contrary, qualities. Thus no simple body would result, if the dry of fire and the moist of air were to pass away, for the hot is left in both. On the other hand, if the hot pass away out both, the contraries dry and moist are left. A similar result will occur in all the others too, for all the consecutive elements contain one identical, and one contrary, quality. Hence, too, it clearly follows that, when one of the consecutive elements is transformed into one, the coming to be is effected by the passing away of a single quality, whereas, when two of them are transformed into a third, more than one quality must have passed away. We have stated that all the elements come to be out of any one of them, and we have explained the manner in which their mutual conversion takes place. Let us nevertheless supplement our theory by the following speculations concerning them. If water, air, and the like are a matter of which the natural bodies consist, as some thinkers in fact believe, these clements must be either one, or two, or more. Now they cannot all of them be one, they cannot, for example, all be air or water or fire or earth, because changes into contraries. For if they all were air, then, assuming air to persist, there will be alteration instead of coming to be. Besides, nobody supposes a single element to persist, as the basis of all, in such a way that it is water as well as air, or any other element, at the same time. So there will be a certain contrariety, that is a differentiating quality, and the other member of this contrariety, for example heat, will belong to some other element, for example to fire. But fire will certainly not be hot air. For a change of that kind, A, is alteration, and B, is not what is observed. Moreover, C, if air is again to result out of the fire, it will do so by the conversion of the hot into its contrary. This contrary, therefore, will belong to air, and air will be a cold something. Hence it is impossible for fire to be hot air, since in that case the same thing will be simultaneously hot and cold. Both fire and air, therefore, will be something else which is the same, that is, there will be some matter, other than either, common to both. The same argument applies to all the elements, proving that there is no single one of them out of which they all originate. But neither is there, beside these four, some other body from which they originate, a something intermediate, for example between air and water, coarser than air, but finer than water, or between air and fire, coarser than fire, but finer than air. For the supposed intermediate will be air and fire when a pair of contrasted qualities is added to it, but, since one of every two contrary qualities is a privation, the intermediate never can exist, as some thinkers assert the boundless or the environing exists in isolation. It is, therefore, equally and indifferently any one of the elements, or else it is nothing. Since, then, there is nothing, at least, nothing perceptible prior to these, they must be all. That being so, either they must always persist and not be transformable into one another, or they must undergo transformation, either all of them, or some only, as Plato wrote in the Timachus. Now it has been proved before that they must undergo reciprocal transformation. It has also been proved that the speed with which they come to be, one out of another, is not uniform, since the process of reciprocal transformation is relatively quick between the elements with a complementary factor, but relatively slow between those which possess no such factor. Assuming, then, that the contrariety, in respect to which they are transformed, is 1, the elements will inevitably be 2, for it is matter that is the mean between the two contraries, and matter is imperceptible and inseparable from them. Since, however, the elements are seen to be more than 2, the contrarieties must at the least be 2. But the contrarieties being 2, the elements must be 4, as they evidently are, and cannot be 3, for the couplings are 4, since, though 6 are possible, the 2 in which the qualities are contrary to one another cannot occur. These subjects have been discussed before, but the following arguments will make it clear that, since the elements are transformed into one another, it is impossible for any one of them, whether it be at the end or in the middle, to be an originative source of the rest. There can be no such originative element at the ends, for all of them would then be fire or earth, and this theory amounts to the assertion that all things are made of fire or earth. Nor can a middle element be such an originative source, as some thinkers suppose that air is transformed both into fire and into water, and water both into air and into earth, while the end elements are not further transformed into one another. For the process must come to a stop, and cannot continue ad infinitum in a straight line in either direction, since otherwise an infinite number of contrarieties would attach to the single element. Let E stand for earth, W for water, A for air, and F for fire. Then, I, since A is transformed into F and W, there will be a contrariety belonging to F. Let these contraries be whiteness and blackness. Again, 2, since A is transformed into W, there will be another contrariety, for W is not the same as F. Let this second contrariety be dryness and moistness, D being dryness and M moistness. Now if, when A is transformed into W, the white persists, water will be moist and white, but if it does not persist, water will be black, since changes into contraries. Water, therefore, must be either white or black. Let it then be the first. On similar grounds, therefore, D, dryness, will also belong to F. Consequently F, fire, as well as air, will be able to be transformed into water, for it has qualities contrary to those of water, since fire was first taken to be black and then to be dry, while water was moist and then showed itself white. Thus it is evident that all elements will be able to be transformed out of one another, and that, in the instances we have taken, E, earth, also will contain the remaining 2 complementary factors, viz. the black and the moist, for these have not yet been coupled. We have dealt with this last topic before the thesis we set out to prove. That thesis, viz. that the process cannot continue ad infinitum, will be clear from the following considerations. If fire, which is represented by F, is not to revert, but is to be transformed in turn into some other element, for example into Q, a new contrariety, other than those mentioned, will belong to fire and Q, for it has been assumed that Q is not the same as any of the 4, E, W and F. Let K, then, belong to F and white to Q. Then K will belong to all 4, E, W and F, for they are transformed into one another. This last point, however, we may admit, has not yet been proved, but at any rate it is clear that if Q is to be transformed in turn into yet another element, yet another contrariety will belong not only to Q but also to F, fire. And, similarly, every addition of a new element will carry with it the attachment of a new contrariety to the preceding elements. Consequently, if the elements are infinitely many, there will also belong to the single element an infinite number of contrarieties. But if that be so, it will be impossible to define any element, impossible also for any to come to be. For if one is to result from another, it will have to pass through such a vast number of contrarieties, and indeed even more than any determinate number. Consequently, into some elements transformation will never be effected, viz. if the intermediates are infinite in number, as they must be if the elements are infinitely many. Further, 2, there will not even be a transformation of air into fire, if the contrarieties are infinitely many. Moreover, 3, all the elements become one. For all the contrarieties of the elements above F must belong to those below F, and vice versa, hence they will all be one. As for those who agree with Empedocles that the elements of body are more than one, so that they are not transformed into one another, one may well wonder in what sense it is open to them to maintain that the elements are comparable. Yet Empedocles says, for these are all not only equal. If it is meant that they are comparable in their amount, all the comparables must possess an identical something whereby they are measured. If, for example, 1 pint of water yields 10 of air, both are measured by the same unit, and therefore both were from the first an identical something. On the other hand, suppose, 2, They are not comparable in their amount in the sense that so much of the one yields so much of the other, but comparable in power of action. A pint of water, for example, having a power of cooling equal to that of 10 pints of air. Even so, they are comparable in their amount, though not qua amount but qua so much power. There is also, 3, a third possibility. Instead of comparing their powers by the measure of their amount, they might be compared as terms in a correspondence, for example as X is hot, so correspondingly Y is white. But correspondence, though it means equality in the quantum, means similarity in a quale. Thus it is manifestly absurd that the simple bodies, though they are not transformable, are comparable not merely as corresponding, but by a measure of their powers, that is that so much fire is comparable with many times that amount of air, as being equally or similarly hot. For the same thing, if it be greater in amount, will, since it belongs to the same kind, have its ratio correspondingly increased. A further objection to the theory of empedocles is that it makes even growth impossible, unless it be increased by addition. For his fire increases by fire, and earth increases its own frame and ether increases ether. These, however, are cases of addition, but it is not by addition that growing things are believed to increase. And it is far more difficult for him to account for the coming to be which occurs in nature. For the things which come to be by natural process all exhibit, in their coming to be, a uniformity either absolute or highly regular, while any exceptions, any results which are in accordance neither with the invariable nor with the general rule, are products of chance and luck. Then what is the cause determining that man comes to be from man, that wheat, instead of an olive, comes to be from wheat, either invariably or generally? Are we to say bone comes to be if the elements be put together in such and such a manner? For, according to his own statements, nothing comes to be from their fortuitous consilience, but only from their consilience in a certain proportion. What, then, is the cause of this proportional consilience? Presumably not fire or earth. But neither is it love and strife, for the former is a cause of association only, and the latter only of dissociation. The cause in question is the essential nature of each thing, not merely to quote his words, a mingling and a divorce of what has been mingled. And chance, not proportion, is the name given to these occurrences, for things can be mingled fortuitously. The cause, therefore, of the coming to be of the things which owe their existence to nature is that they are in such and such a determinate condition, and it is this which constitutes the nature of each thing, a nature about which he says nothing. What he says, therefore, is no explanation of nature. Moreover, it is this which is both the excellence of each thing and its good, whereas he assigns the whole credit to the mingling. And yet the elements at all events are dissociated not by strife, but by love, since the elements are by nature prior to the deity, and they too are deities. Again, his account of motion is vague. For it is not an adequate explanation to say that love and strife set things moving, unless the very nature of love is a movement of this kind and the very nature of strife a movement of that kind. He ought, then, either to have defined or to have postulated these characteristic movements, or to have demonstrated them whether strictly or laxly or in some other fashion. Moreover, since, a. the simple bodies appear to move naturally as well as by compulsion, that is in a manner contrary to nature, fire, for example, appears to move upwards without compulsion, though it appears to move by compulsion downwards, and since, b. what is natural is contrary to that which is due to compulsion, and movement by compulsion actually occurs, it follows that natural movement can also occur in fact. Is this, then, the movement that love sets going? 4. On the contrary, the natural movement moves earth downwards and resembles dissociation, and strife rather than love is its cause, so that in general, 2, love rather than strife would seem to be contrary to nature. And unless love or strife is actually setting them in motion, the simple bodies themselves have absolutely no movement or rest. But this is paradoxical, and what is more, they do in fact obviously move. For though strife dissociated, it was not by strife that the ether was borne upwards. On the contrary, sometimes he attributes its movement to something like chance, for thus, as it ran, it happened to meet them then, though often otherwise, while at other times he says it is the nature of fire to be borne upwards, but the ether, to quote his words, sank down upon the earth with long roots. With such statements, too, he combines the assertion that the order of the world is the same now, in the reign of strife, as it was formerly in the reign of love. What, then, is the first mover of the elements? What causes their motion? Presumably not love and strife, on the contrary, these are causes of a particular motion, if at least we assume that first mover to be an originative source. An additional paradox is that the soul should consist of the elements, or that it should be one of them. How are the soul's alterations to take place? How, For example, is the change from being musical to being unmusical, or how is memory or forgetting to occur? For clearly, if the soul be fire, only such modifications will happen to it as characterize fire qua fire, while if it be compounded out of the elements, only the corporeal modifications will occur in it. But the changes we have mentioned are none of them corporeal. The discussion of these difficulties, however, is a task appropriate to a different investigation. Let us return to the elements of which bodies are composed. The theories that there is something common to all the elements and that they are reciprocally transformed, are so related that those who accept either are bound to accept the other as well. Those, on the other hand, who do not make their coming to be reciprocal, who refuse to suppose that any one of the elements comes to be out of any other taken singly, except in the sense in which bricks come to be out of a wall, are faced with a paradox. How, on their theory, are flesh and bones or any of the other compounds to result from the elements taken together? Indeed, the point we have raised constitutes a problem even for those who generate the elements out of one another. In what manner does anything other than, and beside, the elements come to be out of them? Let me illustrate my meaning. Water can come to be out of fire and fire out of water, for their substratum is something common to them both. But flesh too, presumably, and marrow come to be out of them. How, then, do such things come to be? For, a. How is the manner of their coming to be conceived by those who maintain a theory like that of Empedocles? They must conceive it as composition, just as a wall comes to be out of bricks and stones, and the mixture, of which they speak, will be composed of the elements, these being preserved in it unaltered but with their small particles juxtaposed each to each. That will be the manner, presumably, in which flesh and every other compound results from the elements. Consequently, it follows that fire and water do not come to be out of any and every part of flesh. For instance, although a sphere might come to be out of this part of a lump of wax and a pyramid out of some other part, it was nevertheless possible for either figure to have come to be out of either part indifferently. That is the manner of coming to be when both fire and water come to be out of any and every part of flesh. Those, however, who maintain the theory in question, are not at liberty to conceive that both come to be out of flesh in that manner, but only as a stone and a brick both come to be out of a wall, viz. each out of a different place or part. Similarly, b. Even for those who postulate a single matter of their elements, there is a certain difficulty in explaining how anything is to result from two of them taken together, for example from cold and hot, or from fire and earth. For if flesh consists of both and is neither of them, nor again is a composition of them in which they are preserved unaltered, what alternative is left except to identify the resultant of the two elements with their matter? For the passing away of either element produces either the other or the matter. Perhaps we may suggest the following solution. There are differences of degree in hot and cold. Although, therefore, when neither is fully real without qualification, the other will exist potentially, yet, when neither exists in the full completeness of its being, but both by combining destroy one another's excesses, so that there exist instead a hot which, for a hot, is cold, and a cold which, for a cold, is hot, then what results from these two contraries will be neither their matter, nor either of them existing in its full reality without qualification. There will result instead an intermediate, and this intermediate, according as it is potentially more hot than cold or vice versa, will possess a power of heating that is double or triple its power of cooling, or otherwise related thereto in some similar ratio. Thus all the other bodies will result from the contraries, or rather from the elements, insofar as these have been combined, while the elements will result from the contraries, insofar as these exist potentially in a special sense, not as matter exists potentially, but in the sense explained above. And when a thing comes to be in this manner, the process is combination, whereas what comes to be in the other manner is matter. Moreover, two contraries also suffer action, in accordance with the disjunctively articulated definition established in the early part of this work. For the actually hot is potentially cold and the actually cold potentially hot, so that hot and cold, unless they are equally balanced, are transformed into one another, and all the other contraries behave in a similar way. It is thus, then, that in the first place the elements are transformed, and that, in the second place, out of the elements there come to be flesh and bones and the like, the hot becoming cold and the cold becoming hot when they have been brought to the mean. For at the mean is neither hot nor cold. The mean, however, is of considerable extent and not indivisible. Similarly, it is quite reduced to a mean condition that the dry and the moist, as well as the contraries we have used as examples, produce flesh and bone and the remaining compounds. All the compound bodies, all of which exist in the region belonging to the central body, are composed of all the simple bodies. For they all contain earth, because every simple body is to be found specially and most abundantly in its own place. and they all contain water because, a. the compound must possess a definite outline, and water, alone of the simple bodies, is readily adaptable in shape. Moreover, b. earth has no power of cohesion without the moist. On the contrary, the moist is what holds it together, for it would fall to pieces if the moist were eliminated from it completely. They contain earth and water, then, for the reasons we have given, and they contain air and fire, because these are contrary to earth and water, earth being contrary to air and water to fire, in so far as one substance can be contrary to another. Now all compounds presuppose in their coming to be constituents which are contrary to one another, and in all compounds there is contained one set of the contrasted extremes. Hence the other set must be contained in them also, so that every compound will include all the simple bodies. Additional evidence seems to be furnished by the food each compound takes. For all of them are fed by substances which are the same as their constituents, and all of them are fed by more substances than one. Indeed, even the plants, though it might be thought they are fed by one substance only, viz. by water, are fed by more than one, for earth has been mixed with the water. That is why farmers too endeavor to mix before watering. Although food is akin to the matter, that which is fed is the figure, that is the form taken along with the matter. This fact enables us to understand why, whereas all the simple bodies come to be out of one another, fire is the only one of them which, as our predecessors also assert, is fed. For fire alone or more than all the rest is akin to the form because it tends by nature to be borne towards the limit. Now each of them naturally tends to be borne towards its own place, but the figure that is the form of them all is at the limits. Thus we have explained that all the compound bodies are composed of all the simple bodies, since some things are such as to come to be and pass away, and since coming to be in fact occurs in the region about the center, we must explain the number and the nature of the originative sources of all coming to be alike, for a grasp of the true theory of any universal facilitates the understanding of its specific forms. The originative sources, then, of the things which come to be are equal in number to, and identical in kind with, those in the sphere of the eternal and primary things. For there is one in the sense of matter, and a second in the sense of form, and, in addition, the third originative source must be present as well. For the two first are not sufficient to bring things into being, any more than they are adequate to account for the primary things. Now cause, in the sense of material origin, for the things which are such as to come to be is that which can be and not be, and this is identical with that which can come to be and pass away, since the latter, while it is at one time, at another time is not. For whereas some things are of necessity, viz. the eternal things, others of necessity are not. And of these two sets of things, since they cannot diverge from the necessity of their nature, it is impossible for the first not to he and impossible for the second to he. Other things, however, can both be and not he, hence coming to be and passing away must occur within the field of that which can be and not be. This, therefore, is cause in the sense of material origin for the things which are such as to come to be, while cause, in the sense of their end, is their figure or form, and that is the formula expressing the essential nature of each of them. But the third originative source must be present as well, the cause vaguely dreamed of by all our predecessors, definitely stated by none of them. On the contrary, some amongst them thought the nature of the forms was adequate to account for coming to be. Thus Socrates in the Phaedo first blames everybody else for having given no explanation, and then lays it down, that some things are forms, others participants in the forms, and that while a thing is said to be in virtue of the form, it is said to come to be qua sharing in, to pass away qua losing, the form. Hence he thinks that assuming the truth of these theses, the forms must be causes both of coming to be and of passing away. On the other hand, there were others who thought the matter was adequate by itself to account for coming to be, since the movement originates from the matter. Neither of these theories, however, is sound. For, if the forms are causes, why is their generating activity intermittent instead of perpetual and continuous, since there always are participants as well as forms? Besides, in some instances we see that the cause is other than the form. For it is the doctor who implants health and the man of science who implants science, although health itself and science itself are as well as the participants, and the same principle applies to everything else that is produced in accordance with an art. On the other hand, to say that matter generates owing to its movement would be, no doubt, more scientific than to make such statements as are made by the thinkers we have been criticizing. For what alters and transfigures plays a greater part in bringing things into being, and we are everywhere accustomed, in the products of nature and of art alike, to look upon that which can initiate movement as the producing cause. Nevertheless, this second theory is not right either. For, to begin with, it is characteristic of matter to suffer action, that is to be moved, But to move, that is to act, belongs to a different power. This is obvious both in the things that come to be by art and in those that come to be by nature. Water does not of itself produce out of itself an animal, and it is the art, not the wood, that makes a bed. Nor is this their only error. They make a second mistake in omitting the more controlling cause, for they eliminate the essential nature, that is the form. And what is more, since they remove the formal cause, they invest the forces they assign to the simple bodies, the forces which enable these bodies to bring things into being with too instrumental a character. For since, as they say, it is the nature of the hot to dissociate, of the cold to bring together, and of each remaining contrary either to act or to suffer action, it is out of such materials and by their agency, so they maintain, that everything else comes to be and passes away. Yet, A, it is evident that even fire is itself moved, that is suffers action. Moreover, B, their procedure is virtually the same as if one were to treat the saw, and the various instruments of carpentry, as the cause of the things that come to be, for the wood must be divided if a man saws, must become smooth if he planes, and so on with the remaining tools. Hence, however true it may be that fire is active, that it sets things moving, there is a further point they fail to observe, viz. that fire is inferior to the tools or instruments in the manner in which it sets things moving. As to our own theory, we have given a general account of the causes in an earlier work. We have now explained and distinguished the matter and the form. Further, since the change which is motion has been proved to be eternal, the continuity of the occurrence of coming to be follows necessarily from what we have established, for the eternal motion, by causing the generator to approach and retire, will produce coming to be uninterruptedly. At the same time, it is clear that we were right when, in an earlier work, we called motion, not coming to be, the primary form of change. For it is far more reasonable that what is should cause the coming to be of what is not, than that what is not should cause the being of what is. Now that which is being moved is, but that which is coming to be is not. Hence, also, motion is prior to coming to be. We have assumed, and have proved, that coming to be and passing away happen to things continuously, and we assert that motion causes coming to be. That being so, it is evident that, if the motion be single, both processes cannot occur since they are contrary to one another, for it is a law of nature that the same cause, provided it remain in the same condition, always produces the same effect, so that, from a single motion, either coming to be or passing away will always result. The movements must, on the contrary, be more than one, and they must be contrasted with one another either by the sense of their motion or by its irregularity, for contrary effects demand contraries as their causes. This explains why it is not the primary motion that causes coming to be and passing away, but the motion along the inclined circle, for this motion not only possesses the necessary continuity, but includes a duality of movements as well. For if coming to be and passing away are always to be continuous, there must be some body always being moved, in order that these changes may not fail, and moved with a duality of movements, in order that both changes, not one only, may result. Now the continuity of this movement is caused by the motion of the whole, but the approaching and retreating of the moving body are caused by the inclination. For the consequence of the inclination is that the body becomes alternately remote and near, and since its distance is thus unequal, its movement will be irregular. Therefore, if it generates by approaching and by its proximity, it this very same body destroys by retreating and becoming remote, and if it generates by many successive approaches, it also destroys by many successive retirements. The contrary effects demand contraries as their causes, and the natural processes of passing away and coming to be occupy equal periods of time. Hence, too, the times that is the lives of the several kinds of living things have a number by which they are distinguished, for there is an order controlling all things, and every time, that is every life, is measured by a period. Not all of them, however, are measured by the same period, but some by a smaller and others by a greater one, for to some of them the period, which is their measure, is a year, while to some it is longer and to others shorter. And there are facts of observation in manifest agreement with our theories. Thus we see that coming to be occurs as the sun approaches and decay as it retreats, and we see that the two processes occupy equal times. For the durations of the natural processes of passing away and coming to be are equal. Nevertheless, it often happens that things pass away in too short a time. This is due to the intermingling by which the things that come to be and pass away are implicated with one another. For their matter is irregular, that is not everywhere the same, hence the processes by which they come to be must be irregular too, that is some too quick and others too slow. Consequently the phenomenon in question occurs, because the irregular coming to be of these things is the passing away of other things. Coming to be and passing away will, as we have said, always be continuous, and will never fail owing to the cause we stated. And this continuity has a sufficient reason on our theory. For in all things, as we affirm, nature always strives after the better. Now being, we have explained elsewhere the exact variety of meanings we recognize in this term, is better than not being, but not all things can possess being, since they are too far removed from the originative source. God therefore adopted the remaining alternative, and fulfilled the perfection of the universe by making coming to be uninterrupted, for the greatest possible coherence would thus be secured to existence, because that coming to be should itself come to be perpetually is the closest approximation to eternal being. The cause of this perpetuity of coming to be, as we have often said, is circular motion, for that is the only motion which is continuous. That, too, is why all the other things, the things, I mean, which are reciprocally transformed in virtue of their passions and their powers of action, for example the simple bodies imitate circular motion. For when water is transformed into air, air into fire, and the fire back into water, we say the coming to be has completed the circle, because it reverts again to the beginning. Hence it is by imitating circular motion that rectilinear motion too is continuous. These considerations serve at the same time to explain what is to some people a baffling problem, viz. Why the simple bodies, since each them is traveling towards its own place, have not become dissevered from one another in the infinite lapse of time. The reason is their reciprocal transformation. For, had each of them persisted in its own place instead of being transformed by its neighbor, they would have got dissevered long ago. They are transformed, however, owing to the motion with its dual character, and because they are transformed, none of them is able to persist in any place allotted to it by the order. It is clear from what has been said, I, that coming to be and passing away actually occur, 2, what causes them, and 3, what subject undergoes them. But, a, if there is to be movement, as we have explained elsewhere, in an earlier work, there must be something which initiates it. If there is to be movement always, there must always be something which initiates it. If the movement is to be continuous, what initiates it must be single, unmoved, ungenerated, and incapable of alteration. And if the circular movements are more than one, their initiating causes must all of them, in spite of their plurality, be in some way subordinated to a single originative source. Further, b, since time is continuous, movement must be continuous, inasmuch as there can be no time without movement. Time, therefore, is a number of some continuous movement, a number, therefore, of the circular movement, as was established in the discussions at the beginning. But, c, is movement continuous because of the continuity of that which is moved, or because that in which the movement occurs, I mean, for example the place or the quality, is continuous? The answer must clearly be because that which is moved is continuous. For how can the quality be continuous except in virtue of the continuity of the thing to which it belongs? But if the continuity of that in which contributes to make the movement continuous, this is true only of the place in which, for that has magnitude in a sense, but, d, amongst continuous bodies which are moved, only that which is moved in a circle is continuous in such a way that it preserves its continuity with itself throughout the movement. The conclusion therefore is that this is what produces continuous movement, viz. the body which is being moved in a circle, and its movement makes time continuous. Wherever there is continuity in any process, coming to be or alteration or any kind of change whatever, we observe consecutiveness, that is this coming to be after that without any interval. Hence we must investigate whether, amongst the consecutive members, there is any whose future being is necessary, or whether, on the contrary, every one of them may fail to come to be. For that some of them may fail to occur, is clear. A. We need only appeal to the distinction between the statements X will be and X is about to, which depends upon this fact. For if it be true to say of X that it will be, it must at some time be true to say of it that it is, whereas, though it be true to say of X now that it is about to occur, it is quite possible for it not to come to be. Thus a man might not walk, though he is now about to walk. And, b, since, to appeal to a general principle, amongst the things which are some are capable also of not being, it is clear that the same ambiguous character will attach to them no less when they are coming to be, in other words, their coming to be will not be necessary. Then are all the things that come to be of this contingent character? Or, on the contrary, is it absolutely necessary for some of them to come to be? Is there, in fact, a distinction in the field of coming to be corresponding to the distinction, within the field of being, between things that cannot possibly not be and things that cannot be? For instance, is it necessary that solstices shall come to be, that is impossible that they should fail to be able to occur? Assuming that the antecedent must have come to be if the consequent is to be, for example that foundations must have come to be if there is to be a house, clay, if there are to be foundations, is the converse also true? If foundations have come to be, must a house come to be? The answer seems to be that the necessary nexus no longer holds, unless it is necessary for the consequent, as well as for the antecedent, to come to be necessary absolutely. If that be the case, however, a house must come to be if foundations have come to be, as well as vice versa. For the antecedent was assumed to be so related to the consequent that, if the latter is to be, the antecedent must have come to be before it. If, therefore, it is necessary that the consequent should come to be, the antecedent also must have come to be, and if the antecedent has come to be, then the consequent also must come to be, not, however, because of the antecedent, but because the future being of the consequent was assumed as necessary. Hence, in any sequence, when the being of the consequent is necessary, the nexus is reciprocal. In other words, when the antecedent has come to be, the consequent must always come to be too. Now, if the sequence of occurrences is to proceed ad infinitum downwards, the coming to be of any determinate this amongst the later members of the sequence will not be absolutely, but only conditionally, necessary. For it will always be necessary that some other member shall have come to be before this as the presupposed condition of the necessity that this should come to be. Consequently, since what is infinite has no originative source, neither will there be in the infinite sequence any primary member which will make it necessary for the remaining members to come to be. Nor again, too, will it be possible to say with truth, even in regard to the members of a limited sequence, that it is absolutely necessary for any one of them to come to be. We cannot truly say, for example, that it is absolutely necessary for a house to come to be when foundations have been laid, for, unless it is always necessary for a house to be coming to be, we should be faced with the consequence that, when foundations have been laid, a thing, which need not always be, must always be. Number if its coming to be is to be necessary, it must be always in its coming to be. For what is of necessity coincides with what is always, since that which must be cannot possibly not be. Hence a thing is eternal if its being is necessary, and if it is eternal, its being is necessary. And if, therefore, the coming to be of a thing is necessary, its coming to be is eternal, and if eternal, necessary, it follows that the coming to be of anything, if it is absolutely necessary, must be cyclical, that is must return upon itself. For coming to be must either be limited or not limited, and if not limited, it must be either rectilinear or cyclical. But the first of these last two alternatives is impossible if coming to be is to be eternal, because there could not be any originative source whatever in an infinite rectilinear sequence, whether its members be taken downwards, as future events, or upwards, as past events. Yet coming to be must have an originative source, if it is to be necessary and therefore eternal, nor can it be eternal if it is limited. Consequently it must be cyclical. Hence the nexus must be reciprocal. By this I mean that the necessary occurrence of this involves the necessary occurrence of its antecedent, and conversely that, given the antecedent, it is also necessary for the consequent to come to be. And this reciprocal nexus will hold continuously throughout the sequence, for it makes no difference whether the reciprocal nexus, of which we are speaking, is mediated by two, or by many, members. It is in circular movement, therefore, and in cyclical coming to be that the absolutely necessary is to be found. In other words, if the coming to be of any things is cyclical, it is necessary that each of them is coming to be and has come to be, and if the coming to be of any things is necessary, their coming to be is cyclical. The result we have reached is logically concordant with the eternity of circular motion, that is the eternity of the revolution of the heavens, a fact which approved itself on other and independent evidence, since precisely those movements which belong to, and depend upon, this eternal revolution come to be of necessity, and of necessity will be. For since the revolving body is always setting something else in motion, the movement of the things it moves must also be circular. Thus, from the being of the upper revolution it follows that the sun revolves in this determinate manner, and since the sun revolves thus, the seasons in consequence come to be in a cycle, that is return upon themselves, and since they come to be cyclically, so in their turn do the things whose coming to be the seasons initiate. Then why do some things manifestly come to be in this cyclical fashion, as, for example, showers and air, so that it must rain if there is to be a cloud and, conversely, there must be a cloud if it is to rain, while men and animals do not return upon themselves so that the same individual comes to be a second time, for though your coming to be presupposes your father's, his coming to be does not presuppose yours? Why, on the contrary, does this coming to be seem to constitute a rectilinear sequence? In discussing this new problem, we must begin by inquiring whether all things return upon themselves in a uniform manner, or whether, on the contrary, though in some sequences what recurs is numerically the same, in other sequences it is the same only in species. In consequence of this distinction, it is evident that those things, whose substance that which is undergoing the process is imperishable, will be numerically, as well as specifically, the same in their recurrence, for the character of the process is determined by the character of that which undergoes it. Those things, on the other hand, whose substance is perishable, not imperishable, must return upon themselves in the sense that what recurs, though specifically the same, is not the same numerically. That's why, when water comes to be from air and air from water, the air is the same specifically, not numerically, and if these two recur numerically the same, at any rate this does not happen with things whose substance comes to be whose substance is such that it is essentially capable of not being. Meteorology, Book I. Translated by E. W. Webster. We have already discussed the first causes of nature, and all natural motion, also the stars ordered in the motion of the heavens, and the physical element enumerating and specifying them and showing how they change into one another and becoming and perishing in general. There remains for consideration a part of this inquiry which all our predecessors called meteorology. It is concerned with events that are natural, though their order is less perfect than that of the first of the elements of bodies. They take place in the region nearest to the motion of the stars. Such are the Milky Way, and comets, and the movements of meteors. It studies also all the affections we may call common to air and water, and the kinds and parts of the earth and the affections of its parts. These throw light on the causes of winds and earthquakes and all the consequences the motions of these kinds and parts involve. Of these things some puzzle us, while others admit of explanation in some degree. Further, the inquiry is concerned with the falling of thunderbolts and with whirlwinds and fire winds, and further, the recurrent affections produced in these same bodies by concretion. When the inquiry into these matters is concluded, let us consider what account we can give, in accordance with the method we have followed, of animals and plants, both generally and in detail. When that has been done, we may say that the whole of our original undertaking will have been carried out. After this introduction, let us begin by discussing our immediate subject. We have already laid down that there is one physical element which makes up the system of the bodies that move in a circle, and besides this 4 bodies owing their existence to the 4 principles, the motion of these latter bodies being of 2 kinds, either from the center or to the center. These 4 bodies are fire, air, water, earth. Fire occupies the highest place among them all, earth the lowest, and 2 elements correspond to these in their relation to one another, air being nearest to fire, water to earth. The whole world surrounding the earth, then, the affections of which are our subject, is made up of these bodies. This world necessarily has a certain continuity with the upper motions, consequently all its power and order is derived from them. For the originating principle of all motion is the first cause. Besides, that clement is eternal and its motion has no limit in space, but is always complete, whereas all these other bodies have separate regions which limit one another, so we must treat fire and earth and the elements like them as the material causes of the events in this world, meaning by material what is subject and is affected, but must assign causality in the sense of the originating principle of motion to the influence of the eternally moving bodies. Let us first recall our original principles and the distinctions already drawn, and then explain the Milky Way and comets and the other phenomena akin to these. Fire, air, water, earth, we assert, originate from one another, and each of them exists potentially in each, as all things do that can be resolved into a common and ultimate substrate. The first difficulty is raised by what is called the air. What are we to take its nature to be in the world surrounding the earth? And what is its position relatively to the other physical elements? For there is no question as to the relation of the bulk of the earth to the size of the bodies which exist around it, since astronomical demonstrations have by this time proved to us that it is actually far smaller than some individual stars. As for the water, it is not observed to exist collectively and separately, nor can it do so apart from that volume of it which has its seat about the earth, the sea, that is, and rivers, which we can see, and any subterranean water that may be hidden from our observation. The question is really about that which lies between the earth and the nearest stars. Are we to consider it to be one kind of body or more than one? And if more than one, how many other and what are the bounds of their regions? We have already described and characterized the first element, and explained that the whole world of the upper motions is full of that body. This is an opinion we are not alone in holding. It appears to be an old assumption and one which men have held in the past, for the word ether has long been used to denote that element. Anaxagoras, it is true, seems to me to think that the word means the same as fire. For he thought that the upper regions were full of fire, and that men referred to those regions when they spoke of ether. In the latter point he was right, for men seem to have assumed that a body that was eternally in motion was also divine in nature, and, as such a body was different from any of the terrestrial elements, they determined to call it ether. For the opinions appear in cycles among men not once nor twice, but infinitely often. Now there are some who maintain that not only the bodies in motion but that which contains them is pure fire, and the interval between the earth and the stars air. But if they had considered what is now satisfactorily established by mathematics, they might have given up this puerile opinion. For it is altogether childish to suppose that the moving bodies are all of them of a small size, because they so to us, looking at them from the earth. This a matter which we have already discussed in our treatment of the upper region. But we may return to the point now. If the intervals were full of fire and the bodies consisted of fire, every one of the other elements would long ago have vanished. However, they cannot simply be said to be full of air either, for even if there were two elements to fill the space between the earth and the heavens, the air would far exceed the quantity required to maintain its proper proportion to the other elements. For the bulk of the earth, which includes the whole volume of water, is infinitesimal in comparison with the whole world that surrounds it. Now we find that the excess in volume is not proportionately great where water dissolves into air or air into fire. Whereas the proportion between any given small quantity of water and the air that is generated from it ought to hold good between the total amount of air and the total amount of water. Nor does it make any difference if anyone denies that the elements originate from one another, but asserts that they are equal in power. For on this view it is certain amounts of each that are equal in power, just as would be the case if they actually originated from one another. So it is clear that neither air nor fire alone fills the intermediate space. It remains to explain, after a preliminary discussion of difficulties, the relation of the two elements air and fire to the position of the first element, and the reason why the stars in the upper region impart heat to the earth and its neighborhood. Let us first treat of the air, as we proposed, and then go on to these questions. Since water is generated from air, and air from water, why are clouds not formed in the upper air? They ought to form the more, the further from the earth and the colder that region is. For it is neither appreciably near to the heat of the stars, nor to the rays reflected from the earth. It is these that dissolve any formation by their heat and so prevent clouds from forming near the earth. For clouds gather at the point where their reflected rays disperse in the infinity of space and are lost. To explain this we must suppose either that it is not all air which water is generated, or, if it is produced from all are alike, that what immediately surrounds the earth is not mere air, but a sort of vapor, and that its vaporous nature is the reason why it condenses back to water again. But if the whole of that vast region is vapor, the amount of air and of water will be disproportionately great. For the spaces left by the heavenly bodies must be filled by some element. This cannot be fire, for then all the rest would have been dried up. Consequently, what fills it must be air and the water that surrounds the whole earth, vapor being water dissolved. After this exposition of the difficulties involved, let us go on to lay down the truth, with a view at once to what follows and to what has already been said. The upper region as far as the moon we affirm to consist of a body distinct both from fire and from air, but varying degree of purity and in kind, especially towards its limit on the side of the air, and of the world surrounding the earth. Now the circular motion of the first element and of the bodies it contains dissolves, and inflames by its motion, whatever part of the lower world is nearest to it, and so generates heat. From another point of view we may look at the motion as follows. The body that lies below the circular motion of the heavens is, in a sort, matter, and is potentially hot, cold, dry, moist, and possessed of whatever other qualities are derived from these. But it actually acquires or retains one of these in virtue of motion or rest, the cause and principle of which has already been explained. So at the center and round it we get earth and water, the heaviest and coldest elements, by themselves, round them and contiguous with them, air and what we commonly call fire. It is not really fire, for fire is an excess of heat and a sort of ebullition, but in reality, of what we call air, the part surrounding the earth is moist and warm, because it contains both vapor and a dry exhalation from the earth. But the next part, above that, is warm and dry. For vapor is naturally moist and cold, but the exhalation warm and dry, and vapor is potentially like water, the exhalation potentially like fire. So we must take the reason why clouds are not formed in the upper region to be this, that it is filled not with mere air but rather with a sort of fire. However, it may well be that the formation of clouds in that upper region is also prevented by the circular motion. For the air round the earth is necessarily all of it in motion, except that which is cut off inside the circumference which makes the earth a complete sphere. In the case of winds it is actually observable that they originate in marshy districts of the earth, and they do not seem to blow above the level of the highest mountains. It is the revolution of the heaven which carries the air with it and causes its circular motion, fire being continuous with the upper element and air with fire. Thus its motion is a second reason why that air is not condensed into water. But whenever a particle of air grows heavy, the warmth in it is squeezed out into the upper region and it sinks, and other particles in turn are carried up together with the fiery exhalation. Thus the one region is always full of air and the other of fire, and each of them is perpetually in a state of change. So much to explain why clouds are not formed and why the air is not condensed into water, and what account must be given of the space between the stars and the earth, and what is the body that fills it. As for the heat derived from the sun, the right place for a special and scientific account of it is in the treatise about sense, since heat is an affection of sense. But we may now explain how it can be produced by the heavenly bodies which are not themselves hot. We see that motion is able to dissolve and inflame the air. Indeed, moving bodies are often actually found to melt. Now the sun's motion alone is sufficient to account for the origin of terrestrial warmth and heat. For a motion that is to have this effect must be rapid and near, and that of the stars is rapid but distant, while that of the moon is near but slow, whereas the sun's motion combines both conditions in a sufficient degree. That most heat should be generated where the sun is present is easy to understand if we consider the analogy of terrestrial phenomena, for here, too, it is the air that is nearest to a thing in rapid motion which is heated most. This is just what we should expect, as it is the nearest air that is most dissolved by the motion of a solid body. This then is one reason why heat reaches our world. Another is that the fire surrounding the air is often scattered by the motion of the heavens and driven downwards in spite of itself. Shooting stars further suffix to prove that the celestial sphere is not hot or fiery, for they do not occur in that upper region but below, yet the more and the faster a thing moves, the more apartment it is to take fire. Besides, the sun, which most of all the stars is considered to be hot, is really white and not fiery in color. Having determined these principles, let us explain the cause of the appearance in the sky of burning flames and of shooting stars, and of torches, and goats, as some people call them. All these phenomena are one and the same thing, and are due to the same cause, the difference between them being one of degree. The explanation of these and many other phenomena is this. When the sun warms the earth, the evaporation which takes place is necessarily of two kinds, not of one only as some think. One kind is rather of the nature of vapor, the other of the nature of a windy exhalation. That which rises from the moisture contained in the earth and on its surface is vapor, while that rising from the earth itself, which is dry, is like smoke. Of these the windy exhalation, being warm, rises above the moisture vapor, which is heavy and sinks below the other. Hence the world surrounding the earth is ordered as follows. First, below the circular motion comes the warm and dry element, which we call fire, for there is no word fully adequate to every state of the humid evaporation. But we must use this terminology since this element is the most inflammable of all bodies. Below this comes air. We must think of what we just called fire as being spread round the terrestrial sphere on the outside like a kind of fuel, so that a little motion often makes it burst into flame just as smoke does, for flame is the ebullition of a dry exhalation. So whenever the circular motion stirs this stuff up in any way, it catches fire at the point at which it is most inflammable. The result differs according to the disposition and quantity of the combustible material. If this is broad and long, we often see a flame burning as in a field of stubble. If it burns lengthwise only, we see what are called torches and goats and shooting stars. Now when the inflammable material is longer than it is broad, sometimes it seems to throw off sparks as it burns. This happens because matter catches fire at the sides in small portions but continuously with the main body, then it is called a goat. When this does not happen, it is a torch. But if the whole length of the exhalation is scattered in small parts and in many directions and in breadth and depth alike, we get what are called shooting stars. The cause of these shooting stars is sometimes the motion which ignites the exhalation. At other times the air is condensed by cold and squeezes out and ejects the hot element, making their motion look more like that of a thing thrown than like a running fire. For the question might be raised whether the shooting of a star is the same thing as when you put an exhalation below a lamp and it lights the lower lamp from the flame above. For here too the flame passes wonderfully quickly and looks like a thing thrown, and not as if one thing after another caught fire. Or is a star when it shoots a single body that is thrown? Apparently both cases occur. Sometimes it is like the flame from the lamp and sometimes bodies are projected by being squeezed out, like fruit stones from one's fingers, and so are seen to fall into the sea and on the dry land, both by night and by day when the sky is clear. They are thrown downwards because the condensation which propels them inclines downwards. Thunderbolts fall downwards for the same reason. Their origin is never combustion but ejection under pressure, since naturally all heat tends upwards. When the phenomenon is formed in the upper region, it is due to the combustion of the exhalation. When it takes place at a lower level, it is due to the ejection of the exhalation by the condensing and cooling of the moisture evaporation. For this latter, as it condenses and inclines downward, contracts, and thrusts out the hot element and causes it to be thrown downwards. The motion is upwards or downwards or sideways according to the way in which the evaporation lies, and its disposition in respect of breadth and depth. In most cases the direction is sideways because two motions are involved, a compulsory motion downwards and a natural motion upwards, and under these circumstances an object always moves obliquely. Hence the motion of shooting stars is generally oblique. So the material cause of all these phenomena is the exhalation. The efficient cause sometimes the upper motion, sometimes the contraction and condensation of the air. Further, all these things happen below the moon. This is shown by their apparent speed, which is equal to that of things thrown by us, for it is because they are close to us, that these latter seem far to exceed in speed the stars, the sun, and the moon. Sometimes on a fine night we see a variety of appearances that form in the sky, chasms for instance, and trenches and blood-red colors. These, too, have the same cause. For we have seen that the upper air condenses into an inflammable condition, and that the combustion sometimes takes on the appearance of a burning flame, sometimes that of moving torches and stars. So it is not surprising that this same air when condensing should assume a variety of colors. For a weak light shining through a dense air, and the air when it acts as a mirror, will cause all kinds of colors to appear, but especially crimson and purple. For these colors generally appear when fire color and white are combined by superposition. Thus on a hot day, or through a smoky medium, the stars when they rise and set look crimson. The light will also create colors by reflection when a mirror is such as to reflect color only and not shape. These appearances do not persist long, because the condensation of the air is transient. Chasms get their appearance of depth from light breaking out of a dark blue or black mass of air. When the process of condensation goes further, in such a case we often find torches ejected. When the chasm contracts it presents the appearance of a trench. In general, white in contrast with black creates a variety of colors, like flame, for instance, through a medium of smoke. But by day the sun obscures them, and, with the exception of crimson, the colors are not seen at night because they are dark. These then must be taken to be the causes of shooting stars and the phenomena of combustion, and also of the other transient appearances of this kind. Let us go on to explain the nature of comets and the Milky Way, after a preliminary discussion of the views of others. Anaxagoras and Democritus declare that comets are a conjunction of the planets approaching one another and so appearing to touch one another. Some of the Italians called Pythagoreans say that the comet is one of the planets, but that it appears at great intervals of time and only rises a little above the horizon. This is the case with Mercury too, because it only rises a little above the horizon it often fails to be seen and consequently appears at great intervals of time. A view like theirs was also expressed by Hippocrates of Chios and his pupil Aeschylus. Only they say that the tail does not belong to the comet itself, but is occasionally assumed by it on its course in certain situations, when our sight is reflected to the sun from the moisture attracted by the comet. It appears at greater intervals than the other stars because it is slower to get clear of the sun and has been left behind by the sun to the extent of the whole of its circle before it reappears at the same point. It gets clear of the sun both towards the north and towards the south. In the space between the tropics it does not draw water to itself because that region is dried up by the sun on its course. When it moves towards the south it has no lack of the necessary moisture, but because the segment of its circle which is above the horizon is small, and that below it many times as large, it is impossible for the sun to be reflected to our sight, either when it approaches the southern tropic, or at the summer solstice. Hence in these regions it does not develop a tail at all. But when it is visible in the north it assumes a tail because the arc above the horizon is large and that below it small. For under these circumstances there is nothing to prevent our vision from being reflected to the sun. These views involve impossibilities, some of which are common to all of them, while others are peculiar to some only. This is the case, first, with those who say that the comet is one of the planets. For all the planets appear in the circle of the zodiac, whereas many comets have been seen outside that circle. Again, more comets than one have often appeared simultaneously. Besides, if their tail is due to reflection, as Aeschylus and Hippocrates say, this planet ought sometimes to be visible without a tail since, as it does not possess a tail in every place in which it appears. But, as a matter of fact, no planet has been observed besides the 5. And all them are often visible above the horizon together at the same time. Further, comets are often found to appear, as well when all the planets are visible as when some are not. but are obscured by the neighborhood of the sun. Moreover, the statement that a comet only appears in the north, with the sun at the summer solstice, is not true either. The great comet which appeared at the time of the earthquake in Achia when the tidal wave rose due west, and may have been known to appear in the south. Again, in the archonship of Eucles, son of Milon, at Athens there appeared a comet in the north in the month Gemelion, the sun being about the winter solstice. Yet they themselves admit that reflection over so great a space is an impossibility. An objection that tells equally against those who hold this theory and those who say that comets are a coalescence of the planets is, first, the fact that some of the fixed stars too get a tail. For this we must not only accept the authority of the Egyptians who assert it, but we have ourselves observed the fact. For a star in the thigh of the dog had a tail, though a faint one. If you fixed your sight on it, its light was dim, but if you just glanced at it, it appeared brighter. Besides, all the comets that have been seen in our day have vanished without setting, gradually fading away above the horizon, and they have not left behind them either one or more stars. For instance, the great comet we mentioned before appeared to the west in winter and frosty weather when the sky was clear, in the archonship of Astius. On the first day it set before the sun and was then not seen. On the next day it was seen, being ever so little behind the sun and immediately setting. But its light extended over a third part of the sky like a leap, so that people called it a path. This comet receded as far as Orion's belt and there dissolved. Democritus, however, insists upon the truth of his view and affirms that certain stars have been seen when comets dissolve. But on his theory this ought not to occur occasionally but always. Besides, the Egyptians affirm that conjunctions of the planets with one another, and with the fixed stars, take place, and we have ourselves observed Jupiter coinciding with one of the stars in the Twins and hiding it, and yet no comet was formed. Further, we can also give a rational proof of our point. It is true that some stars seem to be bigger than others, yet each one by itself looks indivisible. Consequently, just as, if they really had been indivisible, their conjunction could not have created any greater magnitude, so now that they are not in fact indivisible but look as if they were, their conjunction will not make them look any bigger. Enough has been said, without further argument, to show that the causes brought forward to explain comets are false. We consider a satisfactory explanation of phenomena inaccessible to observation to have been given when our account of them is free from impossibilities. The observations before us suggest the following account of the phenomena we are now considering. We know that the dry and warm exhalation is the outermost part of the terrestrial world which falls below the circular motion. It, and a great part of the air that is continuous with it below, is carried round the earth by the motion of the circular revolution. In the course of this motion it often ignites wherever it may happen to be of the right consistency, and this we maintain to be the cause of the shooting of scattered stars. We may say, then, that a comet is formed when the upper motion introduces into a gathering of this kind of fiery principle not of such excessive strength as to burn up much of the material quickly, nor so weak as soon to be extinguished, but stronger and capable of burning up much material, and when exhalation of the right consistency rises from below and meets it. The kind of comet varies according to the shape which the exhalation happens to take. If it is diffused equally on every side the star is said to be fringed, if it stretches out in one direction it is called bearded. We have seen that when a fiery principle of this kind moves we seem to have a shooting star, similarly when it stands still we seem to have a star standing still. We may compare these phenomena to a heap or mass of chaff into which a torch is thrust, or a spark thrown. That is what a shooting star is like. The fuel is so inflammable that the fire runs through it quickly in a line. Now if this fire were to persist instead of running through the fuel and perishing away, its course through the fuel would stop at the point where the latter was densest, and then the whole might begin to move. Such is a comet like a shooting star that contains its beginning and end in itself. When the matter begins to gather in the lower region independently the comet appears by itself. But when the exhalation is constituted by one of the fixed stars or the planets, owing to their motion, one of them becomes a comet. The fringe is not close to the stars themselves. Just as halos appear to follow the sun and the moon as they move, and encircle them, when the air is dense enough for them to form along under the sun's course, so too the fringe. It stands in the relation of a halo to the stars, except that the color of the halo is due to reflection, whereas in the case of comets the color is something that appears actually on them. Now when this matter gathers in relation to a star the comet necessarily appears to follow the same course as the star. But when the comet is formed independently it falls behind the motion of the universe, like the rest of the terrestrial world. It is this fact, that a comet often forms independently, indeed oftener than round one of the regular stars, that makes it impossible to maintain that a comet is a sort of reflection, Not indeed, as Hippocrates and his school say, to the sun, but to the very star it is alleged to accompany, in fact, a kind of halo in the pure fuel of fire. As for the halo, we shall explain its cause later. The fact that comets when frequent foreshadow wind and drought must be taken as an indication of their fiery constitution. For their origin is plainly due to the plentiful supply of that secretion. Hence the air is necessarily drier and the moist evaporation is so dissolved and dissipated by the quantity of the hot exhalation as not readily to condense into water. But this phenomenon too shall be explained more clearly later when the time comes to speak of the winds. So when there are many comets and they are dense, it is as we say, and the years are clearly dry and windy. When they are fewer and fainter, this effect does not appear in the same degree, though as a rule he is found to be excessive either in duration or strength. For instance, when the stone at Mesopotamia fell out of the air, it had been carried up by a wind and fell down in the daytime. Then too a comet happened to have appeared in the west. And at the time of the great comet the winter was dry and north winds prevailed, and the wave was due to an opposition of winds. For in the Gulf a north wind blew and outside it a violent south wind. Again in the archonship of Niomachus a comet appeared for a few days about the equinoctial circle. This one had not risen in the west, and simultaneously with it there happened the storm at Corinth. That there are few comets and that they appear rarely and outside the tropic circles more than within them is due to the motion of the sun and the stars. For this motion does not only cause the hot principle to be secreted but also dissolves it when it is gathering. But the chief reason is that most of this stuff collects in the region of the Milky Way. Let us now explain the origin, cause, and nature of the Milky Way. And here too let us begin by discussing the statements of others on the subject. 1. Of the so-called Pythagoreans, some say that this is the path of one of the stars that fell from heaven at the time of Phaethon's downfall. Others say that the sun used once to move in this circle and that this region was scorched or met with some other affection of this kind, because of the sun and its motion. But it is absurd not to see that if this were the reason, the circle of the zodiac ought to be affected in the same way, and indeed more so than that of the Milky Way, since not the sun only but all the planets move in it. We can see the whole of this circle, half of it being visible at any time of the night, but it shows no signs of any such affection except where a part of it touches the circle of the Milky Way. 2. Anaxagoras, Democritus, and their schools say that the Milky Way is the light of certain stars. 4. They say, when the sun passes below the earth some of the stars are hidden from it. Now the light of those on which the sun shines is invisible, being obscured by the other sun. But the Milky Way is the peculiar light of those stars which are shaded by the earth from the sun's rays. This, too, is obviously impossible. The Milky Way is always unchanged and among the same constellations, for it is clearly a greatest circle, whereas, since the sun does not remain in the same place, what is hidden from it differs at different times. Consequently, with the change of the sun's position the Milky Way ought to change its position too, but we find that this does not happen. Besides, if astronomical demonstrations are correct and the size of the sun is greater than that of the earth and the distance of the stars from the earth many times greater than that of the sun, just as the sun is further from the earth than the moon, then the cone made by the rays of the sun would terminate at no great distance from the earth, and the shadow of the earth, what we call night, would not reach the stars. On the contrary, the sun shines on all the stars and the earth screens none of them. 3. There is a third theory about the Milky Way. Some say that it is a reflection of our sight to the sun, just as they say that the comet is. But this too is impossible. For if the eye and the mirror and the whole of the object were severally at rest, then the same part of the image would appear at the same point in the mirror. But if the mirror and the object move, keeping the same distance from the eye which is at rest, but at different rates of speed and so not always at the same interval from one another, then it is impossible for the same image always to appear in the same part of the mirror. Now the constellations included in the circle of the Milky Way move, and so does the sun, the object to which our sight is reflected, but we stand still. And the distance of those two from us is constant and uniform, but their distance from one another varies. For the dolphin sometimes rises at midnight, sometimes in the morning. But in each case the same parts of the Milky Way are found near it. But if it were a reflection and not a genuine affection of these, this ought not to be the case. Again, we can see the Milky Way reflected at night in water and similar mirrors. But under these circumstances it is impossible for our sight to be reflected to the sun. These considerations show that the Milky Way is not the path of one of the planets, nor the light of imperceptible stars, nor a reflection. And those are the chief theories handed down by others hitherto. Let us recall our fundamental principle and then explain our views. We have already laid down that the outermost part of what is called the air is potentially fire, and that therefore when the air is dissolved by motion, there is separated off a kind of matter, and of this matter we assert that comets consist. We must suppose that what happens is the same as in the case of the comets when the matter does not form independently but is formed by one of the fixed stars or the planets. Then these stars appear to be fringed, because matter of this kind follows their course. In the same way, a certain kind of matter follows the sun, and we explain the halo as a reflection from it when the air is of the right constitution. Now we must assume that what happens in the case of the stars severally happens in the case of the whole of the heavens and all the upper motion. For it is natural to suppose that, if the motion of a single star excites a flame, that of all the stars should have a similar result, and especially in that region in which the stars are biggest and the most numerous and nearest to one another. Now the circle of the zodiac dissolves this kind of matter because of the motion of the sun and the planets, and for this reason most comets are found outside the tropic circles. Again, no fringe appears round the sun or moon, for they dissolve such matter too quickly to admit of its formation. But this circle in which the Milky Way appears to our sight is the greatest circle, and its position is such that it extends far outside the tropic circles. Besides, the region is full of the biggest and brightest constellations and also of what called scattered stars. You have only to look to see this clearly. So for these reasons all this matter is continually and ceaselessly collecting there. A proof of the theory is this: in the circle itself the light is stronger in that half where the Milky Way is divided, and in it the constellations are more numerous and closer to one another than in the other half, which shows that the cause of the light is the motion of the constellations and nothing else. For if it is found in the circle in which there are most constellations and at that point in the circle at which they are densest and contain the biggest and the most stars, it is natural to suppose that they are the true cause of the affection in question. The circle and the constellations in it may be seen in the diagram. The so-called scattered stars it is not possible to set down in the same way on the sphere because none of them have an evident permanent position, but if you look up to the sky the point is clear. For in this circle alone are the intervals full of these stars, in the other circles there are obvious gaps. Hence if we accept the cause assigned for the appearance of comets as plausible, we must assume that the same kind of thing holds good of the Milky Way. For the fringe which in the former case is an affection of a single star here forms in the same way in relation to a whole circle. So if we are to define the Milky Way we may call it a fringe attaching to the greatest circle, and due to the matter secreted. This, as we said before, explains why there are few comets and why they appear rarely. It is because at each revolution of the heavens this matter has always been and is always being separated off and gathered into this region. We have now explained the phenomena that occur in that part of the terrestrial world which is continuous with the motions of the heavens, namely, shooting stars and the burning flame, comets and the Milky Way, these being the chief affections that appear in that region. Let us go on to treat of the region which follows next in order after this and which immediately surrounds the earth. It is the region common to water and air, and the processes attending the formation of water above take place in it. We must consider the principles and causes of all these phenomena too as before. The efficient and chief and first cause is the circle in which the sun moves. For the sun as it approaches or recedes, obviously causes dissipation and condensation and so gives rise to generation and destruction. Now the earth remains but the moisture surrounding it is made to evaporate by the sun's rays and the other heat from above, and rises. But when the heat which was raising it leaves it, in part dispersing to the higher region, in part quenched through rising so far into the upper air, then the vapor cools because its heat is gone and because the place is cold, and condenses again and turns from air into water. And after the water was formed it falls down again to the earth. The exhalation of water is vapor, air condensing into water is cloud. Mist is what is left over when a cloud condenses into water, and is therefore rather a sign of fine weather than of rain, for mist might be called a barren cloud. So we get a circular process that follows the course of the sun. For according as the sun moves to this side or that, the moisture in this process rises or falls. We must think of it as a river flowing up and down in a circle and made up partly of air, partly of water. When the sun is near, the stream of vapor flows upwards, when it recedes, the stream of water flows down, and the order of sequence, at all events, in this process always remains the same. So if Oceanus had some secret meaning in early writers, perhaps they may have meant this river that flows in a circle about the earth. So the moisture is always raised by the heat and descends to the earth again when it gets cold. These processes and, in some cases, their varieties are distinguished by special names. When the water falls in small drops it is called a drizzle, when the drops are larger it is rain. Some of the vapor that is formed by day does not rise high because the ratio of the fire that is raising it to the water that is being raised is small. When this cools and descends at night it is called dew and hoar frost. When the vapor is frozen before it has condensed to water again, it is hoarfrost, and this appears in winter and is commoner in cold places. It is dew when the vapor has condensed into water and the heat is not so great as to dry up the moisture that has been raised, nor the cold sufficient, owing to the warmth of the climate or season, for the vapor itself to freeze. For dew is more commonly found when the season or the place is warm, whereas the opposite, as has been said, is the case with hoarfrost. For obviously vapor is warmer than water, having still the fire that raised it, consequently more cold is needed to freeze it. Both dew and hoarfrost are found when the sky is clear and there is no wind. For the vapor could not be raised unless the sky were clear, and if a wind were blowing it could not condense. The fact that hoarfrost is not found on mountains contributes to prove that these phenomena occur because the vapor does not rise high. One reason for this is that it rises from hollow and watery places, so that the heat that is raising it, bearing as it were too heavy a burden, cannot lift it to a great height but soon lets it fall again. A second reason is that the motion of the air is more pronounced at a height, and this dissolves a gathering of this kind. Everywhere, except in Pontus, dew is found with south winds and not with north winds. There the opposite is the case, and it is found with north winds and not with south. The reason is the same as that which explains why dew is found in warm weather and not in cold. For the south wind brings warm, and the north, wintry weather. For the north wind is cold and so quenches the heat of the evaporation. But in Pontus the south wind does not bring warmth enough to cause evaporation, whereas the coldness of the north wind concentrates the heat by a sort of recoil, so that there is more evaporation and not less. This is a thing which we can often observe in other places too. Wells, for instance, give off more vapor in a north than in a south wind. Only the north winds quench the heat before any considerable quantity of vapor has gathered, while in a south wind the evaporation is allowed to accumulate. Water, once formed, does not freeze on the surface of the earth, in the way that it does in the region of the clouds. From the latter there fall three bodies condensed by cold, namely rain, snow, hail. Two of these correspond to the phenomena on the lower level and are due to the same causes, differing from them only in degree and quantity. Snow and hoarfrost are one and the same thing, and so are rain and dew, only there is a great deal of the former and little of the latter. For rain is due to the cooling of a great amount of vapor, for the region from which and the time during which the vapor is collected are considerable. But of dew there is little, for the vapor collects for it in a single day and from a small area, as its quick formation and scanty quantity show. The relation of hoarfrost and snow is the same. When cloud freezes there is snow, when vapor freezes there is hoarfrost. Hence snow is a sign of a cold season or country. For a great deal of heat is still present, and unless the cold were overpowering it the cloud would not freeze. For there still survives in it a great deal of the heat which caused the moisture to rise as vapor from the earth. Hail on the other hand is found in the upper region, but the corresponding phenomenon in the vaporous region near the earth is lacking. For, as we said, to snow in the upper region corresponds hoarfrost in the lower, and to rain in the upper region, dew in the lower. But there is nothing here to correspond to hail in the upper region. Why this is so will be clear when we have explained the nature of hail. But we must go on to collect the facts bearing on the origin of it, both those which raise no difficulties and those which seem paradoxical. Hail is ice, and water freezes in winter, yet hailstorms occur chiefly in spring and autumn and less often in the late summer, but rarely in winter and then only when the cold is less intense. And in general hailstorms occur in warmer, and snowing colder places. Again, there is a difficulty about water freezing in the upper region. It cannot have frozen before becoming water, and water cannot remain suspended in the air for any space of time. Nor can we say that the case is like that of particles of moisture which are carried up owing to their small size and rest on the air. The water swimming on the air just as small particles of earth and gold often swim on water. In that case large drops are formed by the union of many small, and so fall down. This cannot take place in the case of hail, since solid bodies cannot coalesce like liquid ones. Clearly then drops of that size were suspended in the air, or else they could not have been so large when frozen. Some think that the cause and origin of hail is this. The cloud is thrust up into the upper atmosphere, which is colder because the reflection of the sun's rays from the earth ceases there, and upon its arrival there the water freezes. They think that this explains why hailstorms are commoner in summer and in warm countries. The heat is greater and it thrusts the clouds further up from the earth. But the fact is that hail does not occur at all at a great height, yet it ought to do so, on their theory, just as we see that snow falls most on high mountains. Again, clouds have often been observed moving with a great noise close to the earth, terrifying those who heard and saw them as portents or some catastrophe. Sometimes, too, When such clouds have been seen, without any noise, there follows a violent hailstorm, and the stones are of incredible size, and angular in shape. This shows that they have not been falling for long and that they were frozen near to the earth, and not as that theory would have it. Moreover, where the hailstones are large, the cause of their freezing must be present in the highest degree, for hail is ice as everyone can see. Now those hailstones are large which are angular in shape. And this shows that they froze close to the earth, for those that fall far are worn away by the length of their fall and become round and smaller in size. It clearly follows that the congelation does not take place because the cloud is thrust up into the cold upper region. Now we see that warm and cold react upon one another by recoil. Hence in warm weather the lower parts of the earth are cold and in a frost they are warm. The same thing, we must suppose, happens in the air, so that in the warmer seasons the cold is concentrated by the surrounding heat and causes the cloud to go over into water suddenly. For this reason raindrops are much larger on warm days than in winter, and showers more violent. A shower is said to be more violent in proportion as the water comes down in a body, and this happens when the condensation takes place quickly. Through this is just the opposite of what Anaxagoras says. He says that this happens when the cloud has risen into the cold air, whereas we say that it happens when the cloud has descended into the warm air, and that the more the further the cloud has descended. But when the cold has been concentrated within still more by the outer heat, it freezes the water it has formed and there is hail. We get hail when the process of freezing is quicker than the descent of the water. For if the water falls in a certain time and the cold is sufficient to freeze it in less, there is no difficulty about its having frozen in the air, provided that the freezing takes place in a shorter time than its fall. The nearer to the earth, and the more suddenly, this process takes place, the more violent is the rain that results and the larger the raindrops and the hailstones because of the shortness of their fall. For the same reason large raindrops do not fall thickly. Hail is rarer in summer than in spring and autumn, though commoner than in winter, because the air is drier in summer, whereas in spring it is still moist, and in autumn it is beginning to grow moist. It is for the same reason that hailstorms sometimes occur in the late summer, as we have said. The fact that the water has previously been warmed contributes to its freezing quickly, for so it cools sooner. Hence many people, when they want to cool hot water quickly, begin by putting it in the sun. So the inhabitants of Pontus, when they encamp on the ice to fish, they cut a hole in the ice and then fish, pour warm water round their reeds that it may freeze the quicker, for they use the ice like lead to fix the reeds. Now it is in hot countries and seasons that the water which forms soon grows warm. It is for the same reason that rain falls in summer and not in winter in Arabia and Ethiopia too, and that in torrents and repeatedly on the same day. For the concentration or recoil due to the extreme heat of the country cools the clouds quickly. So much for an account of the nature and causes of rain, dew, snow, hoar-frost, and hail. Let us explain the nature of winds, and all windy vapors, also of rivers and of the sea. But here, too, we must first discuss the difficulties involved, for, as in other matters, so in this no theory has been handed down to us that the most ordinary man could not have thought of. Some say that what is called air, when it is in motion and flows, is wind, and that this same air when it condenses again becomes cloud and water, implying that the nature of wind and water is the same. So they define wind as a motion of the air. Hence some, wishing to say a clever thing, assert that all the winds are one wind, because the air that moves is in fact all of it one and the same. They maintain that the winds appear to differ owing to the region from which the air may happen to flow on each occasion, but really do not differ at all. This is just like thinking that all rivers are one and the same river, and the ordinary and scientific view is better than a scientific theory like this. If all rivers flow from one source, and the same is true in the case of the winds, there might be some truth in this theory, but if it is no more true in the one case than in the other, this ingenious idea is plainly false. What requires investigation is this: the nature of wind and how it originates, its efficient cause and whence they derive their source, whether one ought to think of the wind as issuing from a sort of vessel and flowing until the vessel is empty, as if let out of a wineskin, or, as painters represent the winds, as drawing their source from themselves. We find analogous views about the origin of rivers. It is thought that the water is raised by the sun and descends in rain and gathers below the earth and so flows from a great reservoir, all the rivers from one, or each from a different one. No water at all is generated, but the volume of the rivers consists of the water that is gathered into such reservoirs in winter. Hence rivers are always fuller in winter than in summer, and some are perennial, others not. Rivers are perennial where the reservoir is large and so enough water has collected in it to last out and not be used up before the winter rain returns. Where the reservoirs are smaller there is less water in the rivers, and they are dried up and their vessel empty before the fresh rain comes on. But if anyone will picture to himself a reservoir adequate to the water that is continuously flowing day by day, and consider the amount of the water, it is obvious that a receptacle that is to contain all the water that flows in the year would be larger than the earth, or, at any rate, not much smaller. Though it is evident that many reservoirs of this kind do exist in many parts of the earth, yet it is unreasonable for anyone to refuse to admit that air becomes water in the earth for the same reason as it does above it. If the cold causes the vaporous air to condense into water above the earth, we must suppose the cold in the earth to produce this same effect, and recognize that there not only exists in it and flows out of it actually formed water, but that water is continually forming in it too. Again, even in the case of the water that is not being formed from day to day but exists as such, we must not suppose as some do that rivers have their source in definite subterranean lakes. On the contrary, just as above the earth small drops form and these join others, till finally the water descends in a body as rain, so too we must suppose that in the earth the water at first trickles together little by little, and that the sources of the rivers drip, as it were, out of the earth and then unite. This is proved by facts. When men construct an aqueduct they collect the water in pipes and trenches, as if the earth in the higher ground were sweating the water out. Hence, too, the headwaters of rivers are found to flow from mountains, and from the greatest mountains there flow the most numerous and greatest rivers. Again, most springs are in the neighborhood of mountains and of high ground, whereas if we accept rivers, water rarely appears in the plains. For mountains and high ground, suspended over the country like a saturated sponge, make the water ooze out and trickle together in minute quantities, but in many places they receive a great deal of water falling as rain, for it makes no difference whether a spongy receptacle is concave and turned up or convex and turned down, in either case it will contain the same volume of matter, and they also cool the vapor that rises and condense it back into water. Hence, as we said, we find that the greatest rivers flow from the greatest mountains. This can be seen by looking at itineraries. What is recorded in them consists either of things which the writer has seen himself or of such as he has compiled after inquiry from those who have seen them. In Asia we find that the most numerous and greatest rivers flow from the mountain called Parnassus, admittedly the greatest of all mountains towards the southeast. When you have crossed it you see the outer ocean, the further limit of which is unknown to the dwellers in our world. Besides other rivers there flow from it the Bactras, the Choasps, the Araxes. From the last a branch separates off and flows into Lake Meotis as the Danais. From it, too, flows the Indus, the volume of whose stream is greatest of all rivers. From the Caucasus flows the Phasis, and very many other great rivers besides. Now the Caucasus is the greatest of the mountains that lie to the northeast, both as regards its extent and its height. A proof of its height is the fact that it can be seen from the so-called deeps and from the entrance to the lake. Again, the sun shines on its peaks for a third part of the night before sunrise and again after sunset. Its extent is proved by the fact that thought contains many inhabitable regions which are occupied by many nations and in which there are said to be great lakes, yet they say that all these regions are visible up to the last peak. From Pyrene, this is a mountain towards the west in Celtis, there flow the Istris and the Tartessus. The latter flows outside the Pillars, while the Istris flows through all Europe into the Euxine. Most of the remaining rivers flow northwards from the Hercynian Mountains, which are the greatest in height and extent about that region. In the extreme north, beyond furthest Scythia, are the mountains called Rippi. The stories about their size are altogether too fabulous, however, they say that the most and, after the Istris, the greatest rivers flow from them. So, too, in Libya there flow from the Ethiopian mountains the Aegean and the Nices, and from the so-called Silver Mountain the two greatest of named rivers, the river called Creometes that flows into the outer ocean, and the main source of the Nile. Of the rivers in the Greek world, the Achelous flows from Pindus, the Anachus from the same mountain, the Strymon, the Nestus, and the Hebrus all three from Scambrus. Many rivers, too, flow from Rhodope. All other rivers would be found to flow in the same way, but we have mentioned these as examples. Even where rivers flow from marshes, the marshes in almost every case are found to lie below mountains or gradually rising ground. It is clear then that we must not suppose rivers to originate from definite reservoirs, for the whole earth, we might almost say, would not be sufficient, any more than the region of the clouds would be, if we were to suppose that they were fed by actually existing water only, and it were not the case that as some water passed out of existence some more came into existence. But rivers always drew their stream from an existing store. Secondly, the fact that rivers rise at the foot of mountains proves that a place transmits the water it contains by gradual percolation of many drops, little by little, and that this is how the sources of rivers originate. However, there is nothing impossible about the existence of such places containing a quantity of water like lakes, only they cannot be big enough to produce the supposed effect. To think that they are is just as absurd as if one were to suppose that rivers drew all their water from the sources we see, for most rivers do flow from springs. So it is no more reasonable to suppose those lakes to contain the whole volume of water than these springs. That there exist such chasms and cavities in the earth we are taught by the rivers that are swallowed up. They are found in many parts of the earth. In the Peloponnesus, for instance, there are many such rivers in Arcadia. The reason is that Arcadia is mountainous and there are no channels from its valleys to the sea. So these places get full of water, and this, having no outlet, under the pressure of the water that is added above, finds a way out for itself underground. In Greece this kind of thing happens on quite a small scale, but the lake at the foot of the Caucasus, which the inhabitants of these parts call a sea, is considerable. Many great rivers fall into it and it has no visible outlet but issues below the earth off the land of the Karak Sea about the so-called deeps of Pontus. This is a place of unfathomable depth in the sea, at any rate no one has yet been able to find bottom by sounding. At this spot, about 300 stadia from land, there comes up sweet water over a large area, not all it together but in 3 places. And in Liguria a river equal in size to the Redinus is swallowed up and appears again elsewhere, the Redinus being a navigable river. The same parts of the earth are not always moist or dry, but they change according as rivers come into existence and dry up. And so the relation of land to sea changes too, and a place does not always remain land or sea throughout all time. But where there was dry land there comes to be sea, and where there is now sea, there one day comes to be dry land. But we must suppose these changes to follow some order and cycle. The principle and cause of these changes is that the interior of the earth grows and decays, like the bodies of plants and animals. Only in the case of these latter the process does not go on by parts, but each of them necessarily grows or decays as a whole, whereas it does go on by parts in the case of the earth. Here the causes are cold and heat, which increase and diminish on account of the sun and its course. It is owing to them that the parts of the earth come to have a different character, that some parts remain moist for a certain time, and then dry up and grow old, while other parts in their turn are filled with life and moisture. Now when places become drier the springs necessarily give out. And when this happens the rivers first decrease in size and then finally become dry, and when rivers change and disappear in one part and come into existence correspondingly in another, the sea must needs be affected. If the sea was once pushed out by rivers and encroached upon the land anywhere, it necessarily leaves that place dry when it recedes. Again, if the dry land has encroached on the sea at all by a process of silting set up by the rivers when at their full, the time must come when this place will be flooded again. But the whole vital process of the earth takes place so gradually and in periods of time which are so immense compared with the length of our life, that these changes are not observed, and before their course can be recorded from beginning to end whole nations perish and are destroyed. Of such destructions the most utter and sudden are due to wars, but pestilence or famine cause them too. Famines, again, are either sudden and severe or else gradual. In the latter case the disappearance of a nation is not noticed because some leave the country while others remain, and this goes on until the land is unable to maintain any inhabitants at all. So a long period of time is likely to elapse from the first departure to the last, and no one remembers, and the lapse of time destroys all record even before the last inhabitants have disappeared. In the same way a nation must be supposed to lose account of the time when it first settled in a land that was changing from a marshy and watery state and becoming dry. Here, too, the change is gradual and lasts a long time, and men do not remember who came first, or when, or what the land was like when they came. This has been the case with Egypt. Here it is obvious that the land is continually getting drier and that the whole country is a deposit of the river Nile. But because the neighboring peoples settled in the land gradually as the marshes dried, the lapse of time has hidden the beginning of the process. However, all the mouths of the Nile, with the single exception of the Acanopus, are obviously artificial and not natural. And Egypt was nothing more than what is called Thebes, as Homer, too, shows, modern though he is in relation to such changes. For Thebes is the place that he mentions, which implies that Memphis did not yet exist, or at any rate was not as important as it is now. That this should be so is natural, since the lower land came to be inhabited later than that which lay higher. For the parts that lie nearer to the place where the river is depositing the silt are necessarily marshy for a longer time, since the water always lies most in the newly formed land. But in time this land changes its character, and in its turn enjoys a period of prosperity. for these places dry up and come to be in good condition, while the places that were formerly well-tempered someday grow excessively dry and deteriorate. This happened to the land of Argos and Mycenae in Greece. In the time of the Trojan Wars, the Argive land was marshy and could only support a small population, whereas the land of Mycenae was in good condition, and for this reason Mycenae was the superior. But now the opposite is the case. For the reason we have mentioned, the land of Mycenae has become completely dry and barren, while the Argive land that was formerly barren owing to the water has now become fruitful. Now the same process that has taken place in this small district must be supposed to be going on over whole countries and on a large scale. Men whose outlook is narrow suppose the cause of such events to be change in the universe, in the sense of a coming to be of the world as a whole. Hence they say that the sea being dried up and is growing less, because this is observed to have happened in more places now than formerly. But this is only partially true. It is true that many places are now dry, that formerly were covered with water. But the opposite is true too, for if they look they will find that there are many places where the sea has invaded the land. But we must not suppose that the cause of this is that the world is in process of becoming. For it is absurd to make the universe to be in process because of small and trifling changes, when the bulk and size of the earth is surely as nothing in comparison with the whole world. Rather we must take the cause of all these changes to be that, just as winter occurs in the seasons of the year, so in determined periods there comes a great winter of a great year and with it excess of rain. But this excess does not always occur in the same place. The deluge in the time of Deucalion, for instance, took place chiefly in the Greek world and in it especially about ancient Hellas, the country about Dodona and the Achelous, a river which has often changed its course. Here the Selli dwelt and those who were formerly called Greci and now Hellenes. When, therefore, such an excess of rain occurs we must suppose that it suffices for a long time. We have seen that some say that the size of the subterranean cavities is what makes some rivers perennial and others not, whereas we maintain that the size of the mountains is the cause, and their density and coldness, for great, dense, and cold mountains catch and keep and create most water, whereas if the mountains that overhang the sources of rivers are small or porous and stony and clayey, these rivers run dry earlier. We must recognize the same kind of thing in this case too. Where such abundance of rain falls in the great winter it tends to make the moisture of those places almost everlasting. But as time goes on places of the latter type dry up more, while those of the former, moist type, do so less, until at last the beginning of the same cycle returns. Since there is necessarily some change in the whole world, but not in the way of coming into existence or perishing. For the universe is permanent, it must be, as we say, that the same places are not forever moist through the presence of sea and rivers, nor forever dry. And the facts prove this. The whole land of the Egyptians, whom we take to be the most ancient of men, has evidently gradually come into existence and been produced by the river. This is clear from an observation of the country, and the facts about the Red Sea suffice to prove it too. One of their kings tried to make a canal to it, for it would have been of no little advantages to them for the whole region to have become navigable. Sesostris is said to have been the first of the ancient kings to try, but he found that the sea was higher than the land. So he first, and Darius afterwards, stopped making the canal, lest the sea should mix with the river water and spoil it. So it is clear that all this part was once unbroken sea. For the same reason Libya, the country of Ammon, is, strangely enough, lower and hollower than the land to the seaward of it. For it is clear that a barrier of silt was formed and after it lakes and dry land, but in course of time the water that was left behind in the lakes dried up and is now all gone. Again the silting up of the Lake Maeotis by the rivers has advanced so much that the limit to the size of the ships which can now sail into it to trade is much lower than it was 60 years ago. Hence it is easy to infer that it, too, like most lakes, was originally produced by the rivers and that it must end by drying up entirely. Again, this process of silting up causes a continuous current through the Bosporus, and in this case we can directly observe the nature of the process. Whenever the current from the Asiatic shore threw up a sandbank, there first formed a small lake behind it. Later it dried up and a second sandbank formed in front of the first and a second lake. This process went on uniformly and without interruption. Now when this has been repeated often enough, in the course of time the strait must become like a river, and in the end the river itself must dry up. So it is clear, since there will be no end to time and the world is eternal, that neither the Tanais nor the Nile has always been flowing, but that the region whence they flow was once dry, for their effect may be fulfilled, but time cannot. And this will be equally true of all other rivers. But if rivers come into existence and perish and the same parts of the earth were not always moist, the sea must needs change correspondingly. and if the sea is always advancing in one place and receding in another, it is clear that the same parts of a whole earth are not always either sea or land, but that all this changes in course of time. So we have explained that the same parts of the earth are not always land or sea, and why that is so, and also why some rivers are perennial and others not. Meteorology, Book 2. Translated by E.W. Webster. Let us explain the nature of the sea and the reason why such a large mass of water is salt and the way in which it originally came to be. The old writers who invented theogonies say that the sea has springs, for they want earth and sea to have foundations and roots of their own. Presumably they thought that this view was grander and more impressive, as implying that our earth was an important part of the universe. For they believed that the whole world had been built up round our earth and for its sake, and that the earth was the most important and primary part of it. Others, wiser in human knowledge, give an account of its origin. At first, they say, the earth was surrounded by moisture. Then the sun began to dry it up, part of it evaporated and is the cause of winds and the turnings back of the sun and the moon, while the remainder forms the sea. So the sea is being dried up and is growing less, and will end by being someday entirely dried up. Others say that the sea is a kind of sweat exuded by the earth when the sun heats it, and that this explains its saltness, for all sweat is salt. Others say that the saltness is due to the earth. Just as water strained through ashes becomes salt, so the sea owes its saltness to the admixture of earth with similar properties. We must now consider the facts which prove that the sea cannot possibly have springs. The waters we find on the earth either flow or are stationary. All flowing water has springs. By a spring, as we have explained above, we must not understand a source from which waters are ladled as it were from a vessel, but a first point at which the water which is continually forming and percolating gathers. Stationary water is either that which has collected and has been left standing, marshy pools, for instance, and lakes, which differ merely in size, or else it comes from springs. In this case it is always artificial, I mean as in the case of wells, otherwise the spring would have to be above the outlet. Hence the water from fountains and rivers flows of itself, whereas wells need to be worked artificially. All the waters that exist belong to one or other of these classes. On the basis of this division we can second that the sea cannot have springs. For it falls under neither of the two classes, it does not flow and it is not artificial, whereas all water from springs must belong to one or other of them. Natural standing water from springs is never found on such a large scale. Again, there are several seas that have no communication with one another at all. The Red Sea, for instance, communicates but slightly with the ocean outside the straits, and the Hyrcanian and Caspian seas are distinct from this ocean and people dwell all round them. Hence, if these seas had had any springs anywhere they must have been discovered. It is true that in straits, where the land on either side contracts an open sea into a small space, the sea appears to flow. But this is because it is swinging to and fro. In the open sea this motion is not observed, but where the land narrows and contracts the sea, the motion that was imperceptible in the open necessarily strikes the attention. The whole of the Mediterranean does actually flow. The direction of this flow is determined by the depth of the basins and by the number of rivers. Maeotis flows into Pontus and Pontus into the Aegean. After that the flow of the remaining seas is not so easy to observe. The current of Maeotis and Pontus is due to the number of rivers. More rivers flow into the Euxine and Maeotis than into the whole Mediterranean with its much larger basin, and to their own shallowness. For we find the sea getting deeper and deeper. Pontus is deeper than Maeotis, the Aegean than Pontus, the Sicilian Sea than the Aegean, the Sardinian and Tyrrhenic being the deepest of all. Outside the Pillars of Heracles the sea is shallow owing to the mud, but calm, for it lies in a hollow. We see, then, that just as single rivers flow from mountains, so it is with the earth as a whole. The greatest volume of water flows from the higher regions in the north. Their alluvium makes the northern seas shallow, while the outer seas are deeper. Some further evidence of the height of the northern regions of the earth is afforded by the view of many of the ancient meteorologists. They believed that the sun did not pass below the earth, but round its northern part, and that it was the height of this which obscured the sun and caused night. So much to prove that there cannot be sources of the sea and to explain its observed flow. We must now discuss the origin of the sea, if it has an origin, and the cause of its salt and bitter taste. What made earlier writers consider the sea to be the original and main body of water is this. It seems reasonable to suppose that to be the case on the analogy of the other elements. Each of them has a main bulk which by reason of its mass is the origin of that element, and any parts which change and mix with the other elements come from it. Thus the main body of fire is in the upper region, that of air occupies the place next inside the region of fire, while the mass of the earth is that round which the rest of the elements are seen to lie. So we must clearly look for something analogous in the case of water. But here we can find no such single mass, as in the case of the other elements, except the sea. River water is not a unity, nor is it stable, but is seen to be in a continuous process of becoming from day to day. It was this difficulty which made people regard the sea as the origin and source of moisture and of all water. And so we find it maintained that rivers not only flow into the sea but originate from it, the salt water becoming sweet by filtration. But this view involves another difficulty. If this body of water is the origin and source of all water, why is it salt and not sweet? The reason for this, besides answering this question, will ensure our having a right first conception of the nature of the sea. The earth is surrounded by water, just as that is by the sphere of air, and that again by the sphere called that of fire, which is the outermost both on a common view and on ours. Now the sun, moving as it does, sets up processes of change and becoming and decay, and by its agency the finest and sweetest water is every day carried up and is dissolved into vapor and rises to the upper region, where it is condensed again by the cold and so returns to the earth. This, as we have said before, is the regular course of nature. Hence all my predecessors who supposed that the sun was nourished by moisture are absurdly mistaken. Some go on to say that the solstices are due to this, the reason being that the same places cannot always supply the sun with nourishment and that without it he must perish. For the fire we are familiar with lives as long as it is fed, and the only food for fire is moisture. As if the moisture that is raised could reach the sun. Or this ascent were really like that performed by flame as it comes into being, and to which they suppose the case of the sun to be analogous. Really there is no similarity. A flame is a process of becoming, involving a constant interchange of moist and dry. It cannot be said to be nourished since it scarcely persists as one and the same for a moment. This cannot be true of the sun, for if it were nourished like that, as they say it is, we should obviously not only have a new sun every day, as Heraclitus says, but a new sun every moment. Again, when the sun causes the moisture to rise, this is like fire heating water. So, as the fire is not fed by the water above it, it is absurd to suppose that the sun feeds on that moisture, even if its heat made all the water in the world evaporate. Again, it is absurd, considering the number and size of the stars, that these thinkers should consider the sun only and overlook the question how the rest of the heavenly bodies subsist. Again, they are met by the same difficulty as those who say that at first the earth itself was moist and the world round the earth was warmed by the sun, and so air was generated and the whole firmament grew, and the air caused winds and solstices. The objection is that we always plainly see the water that has been carried up coming down again. Even if the same amount does not come back in a year or in a given country, yet in a certain period all that has been carried up is returned. This implies that the celestial bodies do not feed on it, and that we cannot distinguish between some air which preserves its character once it is generated and some other which is generated but becomes water again and so perishes. On the contrary, all the moisture alike is dissolved and all that condensed back into water. The drinkable, sweet water, then, is light and is all of it drawn up, the salt water is heavy and remains behind, but not in its natural place. For this is a question which has been sufficiently discussed, I mean about the natural place that water, like the other elements, must in reason have, and the answer is this. The place which we see the sea filling is not its natural place but that of water. It seems to belong to the sea because the weight of the salt water makes it remain there, while the sweet, drinkable water which is light is carried up. The same thing happens in animal bodies. Here, too, the food when it enters the body is sweet, yet the residue and dregs of liquid food are found to be bitter and salt. This is because the sweet and drinkable part of it has been drawn away by the natural animal heat and has passed into the flesh and the other parts of the body according to their several natures. Now just as here it would be wrong for anyone to refuse to call the belly the place of liquid food because that disappears from it soon, and to call it the place of the residue because this is seen to remain, so in the case of our present subject. This place, we say, is the place of water. Hence all rivers and all the water that is generated flow into it, for water flows into the deepest place, and the deepest part of the earth is filled by the sea. Only all the light and sweet part of it is quickly carried off by the sun, while the rest remains for the reason we have explained. It is quite natural that some people should have been puzzled by the old question why such a mass of water leaves no trace anywhere, for the sea does not increase though innumerable and vast rivers are flowing into it every day, but if one considers the matter the solution is easy. The same amount of water does not take as long to dry up when it is spread out as when it is gathered in a body, and indeed the difference is so great that in the one case it might persist the whole day long while in the other it might all disappear in a moment, as for instance if one were to spread out a cup of water over a large table. This is the case with the rivers. All the time they are flowing their water forms a compact mass, but when it arrives at a vast wide place it quickly and imperceptibly evaporates. But the theory of the Phaedo about rivers and the sea is impossible. There it is said that the earth is pierced by intercommunicating channels and that the original head and source of all waters is what is called Tartarus, a mass of water about the center, from which all waters, flowing and standing, are derived. This primary and original water is always surging to and fro, and so it causes the rivers to flow on this side of the earth's center and on that, for it has no fixed seat but is always oscillating about the center. Its motion up and down is what fills rivers. Many of these form lakes in various places. Our sea is an instance of one of these, but all of them come round again in a circle to the original source of their flow, many at the same point, but some at a point opposite to that from which they issued. For instance, if they started from the other side of the earth's center, they might return from this side of it. They descend only as far as the center, for after that all motion is upwards. Water gets its tastes and colors from the kind of earth the rivers happen to flow through. But on this theory rivers do not always flow in the same sense. For since they flow to the center from which they issue forth they will not be flowing down any more than up, but in whatever direction the surging of Tartarus inclines to. But at this rate we shall get the proverbial rivers flowing upwards, which is impossible. Again, where is the water that is generated and what goes up again as vapor to come from? For this must all of it simply be ignored, since the quantity of water is always the same and all the water that flows out from the original source flows back to it again. This itself is not true, since all rivers are seen to end in the sea except where one flows into another. Not one of them ends in the earth, but even when one is swallowed up it comes to the surface again. And those rivers are large which flow for a long distance through a low-lying country, for by their situation and length they cut off the course of many others and swallow them up. This is why the Istris and the Nile are the greatest of the rivers which flow into our sea. Indeed, so many rivers fall into them that there is disagreement as to the sources of them both. All of which is plainly impossible on the theory, and the more so as it derives the sea from Tartarus. Enough has been said to prove that this is the natural place of water and not of the sea, and to explain why sweet water is only found in rivers, while salt water is stationary, and to show that the sea is the end rather than the source of water, analogous to the residual matter of all food, and especially liquid food, in animal bodies. We must now explain why the sea is salt, and ask whether it eternally exists as identically the same body, or whether it did not exist at all once and some day will exist no longer, but will dry up as some people think. Everyone admits this, that if the whole world originated the sea did too, for they make them come into being at the same time. It follows that if the universe is eternal the same must be true of the sea. Anyone who thinks like Democritus that the sea is diminishing and will disappear in the end reminds us of Aesop's tales. His story was that Charybdis had twice sucked in the sea, the first time she made the mountains visible, the second time the islands. And when she sucks it in for the last time she will dry it up entirely. Such a tale is appropriate enough to Aesop in a rage with a ferryman, but not to serious inquirers. Whatever made the sea remain at first, whether it was its weight, as some even of those who hold these views say, for it is easy to see the cause here, or some other reason, clearly the same thing must make it persist forever. They must either deny that the water raised by the sun will return at all, or, if it does, they must admit that the sea persists forever or as long as this process goes on, and again, that for the same period of time that sweet water must have been carried up beforehand. So the sea will never dry up, for before that can happen the water that has gone up beforehand will return to it, for if you say that this happens once you must admit its recurrence. If you stop the sun's course there is no drying agency. If you let it go on it will draw up the sweet water as we have said whenever it approaches, and let it descend again when it recedes. This notion about the sea is derived from the fact that many places are found to be drier now than they once were. Why this is so we have explained. The phenomenon is due to temporary excess of rain and not to any process of becoming in which the universe or its parts are involved. Some day the opposite will take place and after that the earth will grow dry once again. We must recognize that this process always goes on thus in a cycle, for that is more satisfactory than to suppose a change in the whole world in order to explain these facts. But we have dwelt longer on this point than it deserves. To return to the saltness of the sea, those who create the sea once for all, or indeed generate it at all, cannot account for its saltness. It makes no difference whether the sea is the residue of all the moisture that is about the earth and has been drawn up by the sun, or whether all the flavor existing in the whole mass of sweet water is due to the admixture of a certain kind of earth. Since the total volume of the sea is the same once the water that evaporated has returned, it follows that it must either have been salt at first too, or, if not at first, then not now either. If it was salt from the very beginning, then we want to know why that was so, and why, if salt water was drawn up then, that is not the case now. Again, if it is maintained that an admixture of earth makes the sea salt, for they say that earth has many flavors and is washed down by the rivers and so makes the sea salt by its admixture, it is strange that rivers should not be salt too. How can the admixture of this earth have such a striking effect in a great quantity of water and not in each river singly? For the sea, differing in nothing from rivers but in being salt, is evidently simply the totality of river water, and the rivers are the vehicle in which that earth is carried to their common destination. It is equally absurd to suppose that anything has been explained by calling the sea the sweat of the earth, like Empedocles. Metaphors are poetical and so that expression of his may satisfy the requirements of a poem, but as a scientific theory it is unsatisfactory. Even in the case of the body it is a question how the sweet liquid drunk becomes salt sweat, whether it is merely by the departure of some element in it which is sweetest, or by the admixture of something, as when water is strained through ashes. Actually the saltness seems to be due to the same cause as in the case of the residual liquid that gathers in the bladder. That, too, becomes bitter and salt though the liquid we drink and that contained in our food is sweet. If then the bitterness is due in these cases, as with the water strained through lye, to the presence of a certain sort of stuff that is carried along by the urine, as indeed we actually find a salt deposit settling in chamber pots, and is secreted from the flesh in sweat, as if the departing moisture were washing the stuff out of the body, then no doubt the admixture of something earthy with the water is what makes the sea salt. Now in the body stuff of this kind, viz. the sediment of food, is due to failure to digest, but how there came to be any such thing in the earth requires explanation. Besides, how can the drying and warming of the earth cause the secretion such a great quantity of water, especially as it must be a mere fragment of what is left in the earth? Again, waiving the question of quantity, why does not the earth sweat now when it happens to be in process of drying? If it did so then, it ought to do so now. But it does not, on the contrary, when it is dry it grows moist, but when it is moist it does not secrete anything at all. How then was it possible for the earth at the beginning when it was moist to sweat as it grew dry? Indeed, the theory that maintains that most of the moisture departed and was drawn up by the sun and that what was left over is the sea is more reasonable. But for the earth to sweat when it is moist is impossible. Since all the attempts to account for the saltness of the sea seem unsuccessful, let us explain it by the help of the principle we have used already. Since we recognize two kinds of evaporation, one moist, the other dry, it is clear that the latter must be recognized as the source of phenomena like those we are concerned with. But there is a question which we must discuss first. Does the sea always remain numerically one and consisting of the same parts, or is it, too, one in form and volume while its parts are in continual change, like air and sweet water and fire? All of these are in a constant state of change, but the form and the quantity of each of them are fixed, just as they are in the case of a flowing river or a burning flame. The answer is clear, and there is no doubt that the same account holds good of all these things alike. They differ in that some of them change more rapidly or more slowly than others, and they all are involved in a process of perishing and becoming which yet affects them all in a regular course. This being so, we must go on to try to explain why the sea is salt. There are many facts which make it clear that this taste is due to the admixture of something. First, in animal bodies what is least digested, the residue of liquid food, is salt and bitter, as we said before. All animal excreta are undigested, but especially that which gathers in the bladder. Its extreme lightness proves this, for everything that is digested is condensed, and also sweat, in these then is excreted, along with other matter, an identical substance to which this flavor is due. The case of things burnt is analogous. What heat fails to assimilate becomes the excrementary residue in animal bodies, and, in things burnt, ashes. That is why some people say that it was burnt earth that made the sea salt. To say that it was burnt earth is absurd, but to say that it was something like burnt earth is true. We must suppose that just as in the cases we have described, so in the world as a whole, everything that grows and is naturally generated always leaves an undigested residue, like that of things burnt, consisting of this sort of earth. All the earthy stuff in the dry exhalation is of this nature, and it is the dry exhalation which accounts for its great quantity. Now since, as we have said, the moist and the dry evaporations are mixed, some quantity of this stuff must always be included in the clouds and the water that are formed by condensation, and must redescend to the earth in rain. This process must always go on with such regularity as the sublunary world admits of. And it is the answer to the question how the sea comes to be salt. It also explains why rain that comes from the south, and the first rains of autumn, are brackish. The south is the warmest of winds and it blows from dry and hot regions. Hence it carries little moist vapor and that is why it is hot. It makes no difference even if this is not its true character and it is originally a cold wind, for it becomes warm on its way by incorporating with itself a great quantity of dry evaporation from the places it passes over. The north wind, on the other hand, coming from moist regions, is full of vapor and therefore cold. It is dry in our part of the world because it drives the clouds away before it, but in the south it is rainy, just as the south is a dry wind in Libya. So the south wind charges the rain that falls with a great quantity of this stuff. Autumn rain is brackish because the heaviest water must fall first, so that that which contains the greatest quantity of this kind of earth descends quickest. This, too, is why the sea is warm. Everything that has been exposed to fire contains heat potentially, as we see in the case of lye and ashes and the dry and liquid excreta of animals. Indeed those animals which are hottest in the belly have the hottest excreta. The action of this cause is continually making the sea more salt, but some part of its saltness is always being drawn up with the sweet water. This is less than the sweet water in the same ratio in which the salt and brackish element in rain is less than the sweet, and so the saltness of the sea remains constant on the whole. Salt water when it turns into vapor becomes sweet, and the vapor does not form salt water when it condenses again. This I know by experiment. The same thing is true in every case of the kind. Wine and all fluids that evaporate and condense back into a liquid state become water. They all are water modified by a certain admixture, the nature of which determines their flavor. But this subject must be considered on another more suitable occasion. For the present let us say this. The sea is there and some of it is continually being drawn up and becoming sweet. This returns from above with the rain. But it is now different from what it was when it was drawn up, and its weight makes it sink below the sweet water. This process prevents the sea, as it does rivers, from drying up except from local causes. This must happen to sea and rivers alike. On the other hand the parts neither of the earth nor of the sea remain constant but only their whole bulk. For the same thing is true of the earth as of the sea, some of it is carried up and some comes down with the rain, and both that which remains on the surface and that which comes down again change their situations. There is more evidence to prove that saltness is due to the admixture of some substance, besides that which we have adduced. Make a vessel of wax and put it in the sea, fastening its mouth in such a way as to prevent any water getting in. Then the water that percolates through the wax sides of the vessel is sweet, the earthy stuff, the admixture of which makes the water salt, being separated off as it were by a filter. It is this stuff which makes salt water heavy, it weighs more than fresh water, and thick. The difference in consistency is such that ships with the same cargo very nearly sink in a river when they are quite fit to navigate in the sea. This circumstance has before now caused loss to shippers freighting their ships in a river. That the thicker consistency is due to an admixture of something is proved by the fact that if you make strong brine by the admixture of salt, eggs, even when they are full, float in it. It almost becomes like mud, such a quantity of earthy matter is there in the sea. The same thing is done in salting fish. Again if, as is fabled, there is a lake in Palestine, such that if you bind a man or beast and throw it in it floats and does not sink, this would bear out what we have said. They say that this lake is so bitter and salt that no fish live in it and that if you soak clothes in it and shake them it cleans them. The following facts all of them support our theory that it is some earthy stuff in the water which makes it salt. In Konya there is a spring of brackish water that flows into a neighboring river which is sweet but contains no fish. The local story is that when Heracles came from Erytha driving the oxen and gave the inhabitants the choice, they chose salt in preference to fish. They get the salt from the spring. They boil off some of the water and let the rest stand. When it has cooled and the heat and moisture have evaporated together it gives them salt, not in lumps but loose and light like snow. It is weaker than ordinary salt and added freely gives a sweet taste, and it is not as white as salt generally is. Another instance of this is found in Umbria. There is a place where reeds and rushes grow. They burn some of these, put the ashes into water and boil it off. When a little water is left and has cooled it gives a quantity of salt. Most salt rivers and springs must once have been hot. Then the original fire in them was extinguished but the earth through which they percolate preserves the character of lye or ashes. Springs and rivers with all kinds of flavors are found in many places. These flavors must in every case be due to the fire that is always in them, for if you expose earth to different degrees of heat it assumes various kinds and shades of flavor. It becomes full of almond lye and other things of the kind, and the fresh water percolates through these and changes its character. Sometimes it becomes acid as in Sicania, a part of Sicily. There they get a salt and acid water which they use as vinegar to season some of their dishes. In the neighborhood of Lyncus, too, there is a spring of acid water, and in Scythia a bitter spring. The water from this makes the whole of the river into which it flows bitter. These differences are explained by a knowledge of the particular mixtures that determine different savors. But these have been explained in another treatise. We have now given an account of waters and the sea, why they persist, how they change, what their nature is, and have explained most of their natural operations and affections. Let us proceed to the theory of winds. Its basis is a distinction we have already made. We recognize two kinds of evaporation, one moist, the other dry. The former is called vapor, for the other there is no general name but we must call it a sort of smoke, applying to the whole of it a word that is proper to one of its forms. The moist cannot exist without the dry nor the dry without the moist. Whenever we speak of either we mean that it predominates. Now when the sun in its circular course approaches, it draws up by its heat the moist evaporation. When it recedes the cold makes the vapor that had been raised condense back into water which falls and is distributed through the earth. This explains why there is more rain in winter and more by night than by day, though the fact is not recognized because rain by night is more apartment to escape observation than by day, but there is a great quantity of fire and heat in the earth, and the sun not only draws up the moisture that lies on the surface of it, but warms and dries the earth itself. Consequently, since there are two kinds of evaporation, as we have said, one like vapor, the other like smoke, both of them are necessarily generated. That in which moisture predominates is the source of rain, as we explained before, while the dry evaporation is the source and substance of all winds. That things must necessarily take this course is clear from the resulting phenomena themselves, for the evaporation that is to produce them must necessarily differ, and the sun and the warmth in the earth not only can but must produce these evaporations. Since the two evaporations are specifically distinct, wind and rain obviously differ and their substance is not the same, as those say who maintain that one and the same air when in motion is wind, but when it condenses again is water. Air, as we have explained in an earlier book, is made up of these as constituents. Vapor is moist and cold, for its fluidity is due to its moistness, and because it derives from water it is naturally cold, like water that has not been warmed, whereas the smoky evaporation is hot and dry. Hence each contributes a part, and air is moist and hot. It is absurd that this air that surrounds us should become wind when in motion, whatever be the source of its motion. On the contrary, the case of winds is like that of rivers. We do not call water that flows anyhow a river, even if there is a great quantity of it, but only if the flow comes from a spring. So too with the winds, a great quantity of air might be moved by the fall of some large object without flowing from any source or spring. The facts bear out our theory. It is because the evaporation takes place uninterruptedly but differs in degree and quantity that clouds and winds appear in their natural proportion according to the season, and it is because there is now a great excess of the vaporous, now of the dry and smoky exhalation, that some years are rainy and wet, others windy and dry. Sometimes there is much drought or rain, and it prevails over a great and continuous stretch of country. At other times it is local, the surrounding country often getting seasonable or even excessive rains while there is drought in a certain part, or, contrariwise, all the surrounding country gets little or even no rain while a certain part gets rain in abundance. The reason for all this is that while the same affection is generally apartment to prevail over a considerable district because adjacent places, unless there is something special to differentiate them, stand in the same relation to the sun, yet on occasion the dry evaporation will prevail in one part and the moist in another, or conversely. Again, the reason for this latter is that each evaporation goes over to that of the neighboring district. For instance, the dry evaporation circulates in its own place while the moist migrates to the next district or is even driven by winds to some distant place, or else the moist evaporation remains and the dry moves away. Just as in the case of the body, when the stomach is dry the lower belly is often in the contrary state, and when it is dry the stomach is moist and cold, so it often happens that the evaporations reciprocally take one another's place and interchange. Further, after rain wind generally rises in those places where the rain fell, and when rain has come on the wind ceases. These are necessary effects of the principles we have explained. After rain the earth is being dried by its own heat and that from above and gives off the evaporation which we saw to be the material cause of wind. Again, suppose this secretion is present and wind prevails, the heat is continually being thrown off, rising to the upper region, and so the wind ceases. Then the fall in temperature makes vapor form and condense into water. Water also forms and cools the dry evaporation when the clouds are driven together and the cold concentrated in them. These are the causes that make wind cease on the advent of rain, and rainfall on the cessation of wind. The cause of the predominance of winds from the north and from the south is the same. Most winds, as a matter of fact, are north winds or south winds. These are the only regions which the sun does not visit. It approaches them and recedes from them, but its course is always over the west and the east. Hence clouds collect on either side, and when the sun approaches it provokes the moist evaporation, and when it recedes to the opposite side there are storms and rain. So summer and winter are due to the sun's motion to and from the solstices, and water ascends and falls again for the same reason. Now since most rain falls in those regions towards which and from which the sun turns, and these are the north and the south, and since most evaporation must take place where there is the greatest rainfall, just as green wood gives most smoke, and since this evaporation is wind, it is natural that the most important winds should come from these quarters. The winds from the north are called boreae, those from the south notae. The course of winds is oblique, for though the evaporation rises straight up from the earth, they blow round it because all the surrounding air follows the motion of the heavens. Hence the question might be asked whether winds originate from above or from below. The motion comes from above, before we feel the wind blowing the air, but raise its presence if there are clouds or a mist, for their motion shows that the wind has begun to blow before it has actually reached us, and this implies that the source of winds is above. But since wind is defined as a quantity of dry evaporation from the earth moving round the earth, it is clear that while the origin of the motion is from above, the matter and the generation of wind come from below. The oblique movement of the rising evaporation is caused from above, for the motion of the heavens determines the processes that are at a distance from the earth, and the motion from below is vertical, and every cause is more active where it is nearest to the effect, but in its generation and origin wind plainly derives from the earth. The facts bear out the view that winds are formed by the gradual union of many evaporations, just as rivers derive their sources from the water that oozes from the earth. Every wind is weakest in the spot from which it blows. As they proceed and leave their source at a distance they gather strength. Thus the winter in the north is windless and calm, that is, in the north itself, but the breeze that blows from there so gently as to escape observation becomes a great wind as it passes on. We have explained the nature and origin of wind, the occurrence of drought and rains, the reason why rain stops wind and wind rises after rain, the prevalence of north and south winds, and also why wind moves in the way it does. The sun both checks the formation of winds and stimulates it. When the evaporation is small in amount and faint, the sun wastes it and dissipates by its greater heat the lesser heat contained in the evaporation. It also dries up the earth, the source of the evaporation, before the latter has appeared in bulk, just as, when you throw a little fuel into a great fire, it is often burnt up before giving off any smoke. In these ways the sun checks winds and prevents them from rising at all. It checks them by wasting the evaporation, and prevents their rising by drying up the earth quickly. Hence calm is very apparent to prevail about the rising of Orion and lasts until the coming of the Itzi and their forerunners. Calm is due to two causes. Either cold quenches the evaporation, for instance a sharp frost, or excessive heat wastes it. In the intermediate periods, too, the causes are generally either that the evaporation has not had time to develop or that it has passed away and there is none as yet to replace it. Both the setting and the rising of Orion are considered to be treacherous and stormy, because they place at a change of season, namely of summer or winter, and because the size of the constellation makes its rise last over many days, and a state of change is always indefinite and therefore liable to disturbance. The Itzi blow after the summer solstice and the rising of the Dog Star, not at the time when the sun is closest nor when it is distant, and they blow by day and cease at night. The reason is that when the sun is near it dries up the earth before evaporation has taken place, but when it has receded a little its heat and the evaporation are present in the right proportion. So the ice melts and the earth, dried by its own heat and that of the sun, smokes and vapors. They abate at night because the cold pf the nights checks the melting of the ice. What is frozen gives off no evaporation, nor does that which contains no dryness at all. It is only where something dry contains moisture that it gives off evaporation under the influence of heat. The question is sometimes asked, why do the north winds which we call the Itzi blow continuously after the summer solstice, when there are no corresponding south winds after the winter solstice? The facts are reasonable enough, for the so-called white south winds do blow at the corresponding season, though they are not equally continuous and so escape observation and give rise to this inquiry. The reason for this is that the north wind are from the Arctic regions which are full of water and snow. The sun thaws them and so the Etsiel blow, after rather than at the summer solstice. For the greatest heat is developed not when the sun is nearest to the north, but when its heat has been felt for a considerable period and it has not yet receded far. The bird winds blow in the same way after the winter solstice. They, too, are weak Etsiel, but they blow less and later than the Etsiel. They begin to blow only on the 70th day because the sun is distant and therefore weaker. They do not blow so continuously because only things on the surface of the earth and offering little resistance evaporate then, the thoroughly frozen parts requiring greater heat to melt them. So they blow intermittently till the true Etsiel come on again at the summer solstice, for from that time onwards the wind tends to blow continuously, but the south wind blows from the Tropic of Cancer and not from the Antarctic region. There are two inhabitable sections of the earth, one near our upper, or northern pole, the other near the other or southern pole, and their shape is like that of a tambourine. If you draw lines from the center of the earth they cut out a drum-shaped figure. The lines form two cones, the base of the one is the tropic, of the other the ever-visible circle, their vertex is at the center of the earth. Two other cones towards the south pole give corresponding segments of the earth. These sections alone are habitable. Beyond the tropics no one can live, for the shade would not fall to the north, whereas the earth is known to be uninhabitable before the sun is in the zenith or the shade is thrown to the south, and the regions below the bear are uninhabitable because of the cold. The crown, too, moves over this region, for it is in the zenith when it is on our meridian. So we see that the way in which they now describe the geography of the earth is ridiculous. They depict the inhabited earth as round, but both ascertained facts and general considerations show this to be impossible. If we reflect we see that the inhabited region is limited in breadth, while the climate admits of its extending all round the earth. For we meet with no excessive heat or cold in the direction of its length but only in that of its breadth, so that there is nothing to prevent our traveling round the earth unless the extent of the sea presents an obstacle anywhere. The records of journeys by sea and land bear this out. They make the length far greater than the breadth. If we compute these voyages and journeys the distance from the Pillars of Heracles to India exceeds that from Ethiopia to Maeotis and the northernmost Scythians by a ratio of more than 5-3, as far as such matters admit of accurate statement. Yet we know the whole breadth of the region we dwell in up to the uninhabited parts. In one direction no one lives because of the cold, in the other because of the heat. But it is the sea which divides as it seems the parts beyond India from those beyond the Pillars of Heracles and prevents the earth from being inhabited all round. Now since there must be a region bearing the same relation to the southern pole as the place we live in bears to a pole, it will clearly correspond in the ordering of its winds as well as in other things. So just as we have a north wind here, they must have a corresponding wind from the Antarctic. This wind cannot reach us since our own north wind is like land breeze and does not even reach the limits of the region we live in. The prevalence of north winds here is due to our lying near the north. Yet even here they give out and fail to penetrate far. In the southern sea beyond Libya east and west winds are always blowing alternately, like north and south winds with us. So it is clear that the south wind is not the wind that blows from the south pole. It is neither that nor the wind from the winter tropic. For symmetry would require another wind blowing from the summer tropic, which there is not, since we know that only one wind blows from that quarter. So the south wind clearly blows from the torrid region. Now the sun is so near to that region that it has no water, or snow which might melt and cause its heat. But because that place is far more extensive and open the south wind is greater and stronger and warmer than the north and penetrates farther to the north than the north wind does to the south. The origin of these winds and their relation to one another has now been explained. Let us now explain the position of the winds, their oppositions, which can blow simultaneously with which, and which cannot, their names and number, and any other of their affections that have not been treated in the particular questions. What we say about their position must be followed with the help of the figure. For clearness' sake we have drawn the circle of the horizon, which is round, but it represents the zone in which we live, for that can be divided in the same way. Let us also begin by laying down that those things are locally contrary which are locally most distant from one another, just as things specifically most remote from one another are specific contraries. Now things that face one another from opposite ends of a diameter are locally most distant from one another. See diagram. Let A be the point where the sun sets at the equinox and B, the point opposite, the place where it rises at the equinox. Let there be another diameter cutting this at right angles, and let the point H on it be the north and its diametrical opposite to the south. Let Z be the rising of the sun at the summer solstice and E its setting at the summer solstice, D its rising at the winter solstice, and G its setting at the winter solstice. Draw a diameter from Z to G from D to E. Then since those things are locally contrary which are most distant from one another in space, and points diametrically opposite are most distant from one another, those winds must necessarily be contrary to one another that blow from opposite ends of a diameter. The names of the winds according to their position are these. Zephyrus is the wind that blows from A, this being the point where the sun sets at the equinox. Its contrary is Aphelios blowing from B, the point where the sun rises at the equinox. The wind blowing from H, the north, is the true north wind, called Eparxias, while Notus blowing from O is its contrary, for this point is the south and O is contrary to H, being diametrically opposite to it. Cassius blows from Z, where the sun rises at the summer solstice. Its contrary is not the wind blowing from E but Lips blowing from G. For Lips blows from the point where the sun sets at the winter solstice and is diametrically opposite to Cassius, so it is its contrary. Urus blows from D, coming from the point where the sun rises at the winter solstice. It borders on Notus, and so we often find that people speak of Euronoti. Its contrary is not Lips blowing from G but the wind that blows from E, which some call Argists, some Olympias, and some Siron. This blows from the point where the sun sets at the summer solstice, and is the only wind that is diametrically opposite to Urus. These are the winds that are diametrically opposite to one another and their contraries. There are other winds which have no contraries. The wind they call Thraces, which lies between Argists and Eparxias, blows from I, and the wind called Messes, which lies between Cassius and Eparxias, from K. The line nearly coincides with the ever-visible circle, but not quite. These winds have no contraries. Messes has not, or else there would be a wind blowing from the point M which is diametrically opposite. Thraces corresponding to the point I has not, for then there would be a wind blowing from N, the point which is diametrically opposite. But perhaps a local wind which the inhabitants of those parts call Phoenicias blows from that point. These are the most important and definite winds and these their places. There are more winds from the north than from the south. The reason for this is that the region in which we live lies nearer to the north. Also, much more water and snow is pushed aside into this quarter because the other lies under the sun and its course. When this thaws and soaks into the earth and is exposed to the heat of the sun in the earth, it necessarily causes evaporation to rise in greater quantities and over a greater space. Of the winds we have described, Eparxias is the north wind in the strict sense. Thraces and the Messes are north winds too. Cassius is half north and half east. South are that which blows from due south and Lips. East, the wind from the rising of the sun at the equinox and Urus. Phoenicias is half south and half east. West, the wind from the true west and that called Argists. More generally these winds are classified as northerly or southerly. The west winds are counted as northerly, for they blow from the place of sunset and are therefore colder. The east winds are southerly, for they are warmer because they blow from the place of sunrise. So the distinction of cold and hot or warm is the basis for the division of the winds into northerly and southerly. East winds are warmer than west winds because the sun shines on the east longer, whereas it leaves the west sooner and reaches it later. Since this is the distribution of the winds, it is clear that contrary winds cannot blow simultaneously. They are diametrically opposite to one another and one of the two must be overpowered and cease. Winds that are not diametrically opposite to one another may blow simultaneously, for instance the winds from Z and from D. Hence it sometimes happens that both of them, though different winds and blowing from different quarters, are favorable to sailors making for the same point. Contrary winds commonly blow at opposite seasons. Thus Cassius and in general the winds north of the summer solstice blow about the time of the spring equinox, but about the autumn equinox Lips, and Zephyrus about the summer solstice, but about the winter solstice Urus. Eparxias, Thraces, and Argists are the winds that fall on others most and stop them. Their source is so close to us that they are greater and stronger than other winds. They bring fair weather most of all winds for the same reason, for, blowing as they do, from close at hand, they overpower the other winds and stop them. They also blow away the clouds that are forming and leave a clear sky unless they happen to be very cold. Then they do not bring fair weather, but being colder than they are strong they condense the clouds before driving them away. Cassius does not bring fair weather because it returns upon itself. Hence the saying, bringing it on himself as Cassius does clouds. When they cease, winds are succeeded by their neighbors in the direction of the movement of the sun. For an effect is most apartment to be produced in the neighborhood of its cause, and the cause of winds moves with the sun. Contrary winds have either the same or contrary effects. Thus Lips and Cassius, sometimes called Hellespontias, are both rainy jests and Urus are dry, the latter being dry at first and rainy afterwards. Messes and Eparxias are coldest and bring most snow. Eparxias, Thraces, and Argists bring hail. Notice, Zephyrus, and Eris are hot. Keshes covers the sky with heavy clouds, Lips with lighter ones. Keshes does this because it returns upon itself and combines the qualities of Boreas and Eris. By being cold it condenses and gathers the vaporous air, and because it is easterly it carries with it and drives before it a great quantity of such matter. Apakshias, Thrasers, and Argists bring fair weather for the reason we have explained before. These winds and messes are most commonly accompanied by lightning. They are cold because they blow from the north, and lightning is due to cold, being ejected when the clouds contract. Some of these same bring hail with them for the same reason, namely, that they cause a sudden condensation. Hurricanes are commonest in autumn, and next in spring. Apakshias, Thrasers, and Argists give rise to them most. This is because hurricanes are generally formed when some winds are blowing and others fall on them, and these are the winds which are most apartment to fall on others that are blowing, the reason for which, too, we have explained before. The Itziafi around, they begin from the north, and become for dwellers in the west Thrasi, Argisti, and Zephyrus, for Zephyrus belongs to the north. For dwellers in the east they veer round as far as Apeliots. So much for the winds, their origin and nature and the properties common to them all or peculiar to each. We must go on to discuss earthquakes next, for their cause is akin to our last subject. The theories that have been put forward up to the present date are three, and their authors three men, Anaxagoras of Clazomene, and before him Anaximenes of Miletus, and later Democritus of Abdera. Anaxagoras says that the ether, which naturally moves upwards, is caught in hollows below the earth and so shakes it, for though the earth is really all of it equally porous, its surface is clogged up by rain. This implies that part of the whole sphere is above and part below, above being the part on which we live, below the other. This theory is perhaps too primitive to require refutation. It is absurd to think of up and down otherwise than as meaning that heavy bodies move to the earth from every quarter, and light ones, such as fire, away from it, especially as we see that, as far as our knowledge of the earth goes, the horizon always changes with a change in our position, which proves that the earth is convex and spherical. It is absurd, too, to maintain that the earth rests on the air because of its size, and then to say that impact upwards from below shakes it right through. Besides, he gives no account of the circumstances attendant on earthquakes, for not every country or every season is subject to them. Democritus says that the earth is full of water and that when a quantity of rainwater is added to this an earthquake is the result. The hollows in the earth being unable to admit the excess of water it forces its way in and so causes an earthquake. Or again, the earth as it dries draws the water from the fuller to the emptier parts, and the inrush of the water as it changes its place causes the earthquake. Anaximenes says that the earth breaks up when it grows wet or dry, and earthquakes are due to the fall of these masses as they break away. Hence earthquakes take place in times of drought and again of heavy rain, since, as we have explained, the earth grows dry in time of drought and breaks up, whereas the rain makes it sodden and destroys its cohesion. But if this were the case the earth ought to be found to be sinking in many places. Again, why do earthquakes frequently occur in places which are not excessively subject to drought or rain, as they ought to be on the theory? Besides, on this view, earthquakes ought always to be getting fewer, and should come to an end entirely someday. The notion of contraction by packing together implies this. So this is impossible. The theory must be impossible too. We have already shown that wet and dry must both give rise to an evaporation. Earthquakes are a necessary consequence of this fact. The earth is essentially dry, but rain fills it with moisture. Then the sun and its own fire warm it and give rise to a quantity of wind both outside and inside it. This wind sometimes flows outwards in a single body, sometimes inwards, and sometimes it is divided. All these are necessary laws. Next we must find out what body has the greatest motive force. This will certainly be the body that naturally moves farthest and is most violent. Now that which has the most rapid motion is necessarily the most violent, for its swiftness gives its impact the greatest force. Again, the rarest body, that which can most readily pass through every other body, is that which naturally moves farthest. Wind satisfies these conditions in the highest degree. Fire only becomes flame and moves rapidly when wind accompanies it, so that not water nor earth is the cause of earthquakes but wind, that is, the inrush of the external evaporation into the earth. Hence, since the evaporation generally follows in a continuous body in the direction in which it first started, and either all of it flows inwards or all outwards, most earthquakes and the greatest are accompanied by calm. It is true that some take place when a wind is blowing, but this presents no difficulty. We sometimes find several winds blowing simultaneously. If one of these enters the earth we get an earthquake attended by wind. only these earthquakes are less severe because their source and cause is divided. Again, most earthquakes and the severest occur at night or, if by day, about noon, that being generally the calmest part of the day. For when the sun exerts its full power, as it does about noon, it shuts the evaporation into the earth. Night, too, is calmer than day. The absence of the sun makes the evaporation return into the earth like a sort of ebb tide, corresponding to the outward flow, especially towards dawn, for the winds, as a rule, begin to blow then, and if their source changes about like the Euripus and flows inwards, the quantity of wind in the earth is greater and a more violent earthquake results. The severest earthquakes take place where the sea is full of currents or the earth spongy and cavernous, so they occur near the Hellespont and in Achaia and Sicily, and those parts of Euboea which correspond to our description where the sea is supposed to flow in channels below the earth. The hot springs, too, near Edepsus are due to a cause of this kind. It is the confined character of these places that makes them so liable to earthquakes. A great and therefore violent wind is developed, which would naturally blow away from the earth, but the onrush of the sea in a great mass thrusts it back into the earth. The countries that are spongy below the surface are exposed to earthquakes because they have room for so much wind. For the same reason earthquakes usually take place in spring and autumn and in times of wet and of drought because these are the windiest seasons. Summer with its heat and winter with its frost cause calm. Winter is too cold, summer too dry for winds to form. In time of drought the air is full of wind. Drought is just the predominance of the dry over the moist evaporation. Again, excessive rain causes more of the evaporation to form in the earth. Then this secretion is shut up in a narrow compass and forced into a smaller space by the water that fills the cavities. Thus a great wind is compressed into a smaller space and so gets the upper hand, and then breaks out and beats against the earth and shakes it violently. We must suppose the action of the wind in the earth to be analogous to the tremors and throbbings caused in us by the force of the wind contained in our bodies. Thus some earthquakes are a sort of tremor, others a sort of throbbing. Again, we must think of an earthquake as something like the tremor that often runs through the body after passing water as the wind returns inwards from without in one volume. The force wind can have may be gathered not only from what happens in the air, where one might suppose that it owed its power to produce such effects to its volume, but also from what is observed in animal bodies. Tetanus and spasms are motions of wind, and their force is such that the united efforts of many men do not succeed in overcoming the movements of the patients. We must suppose, then, to compare great things with small, that what happens in the earth is just like that. Our theory has been verified by actual observation in many places. It has been known to happen that an earthquake has continued until the wind that caused it burst through the earth into the air and appeared visibly like a hurricane. This happened lately near Heraclea in Pontus and some time past at the island Hyiera, one of the group called the Aeolian Islands. Here a portion of the earth swelled up and a lump like a mound rose with a noise. Finally it burst, and a great wind came out of it and threw up live cinders and ashes which buried the neighboring town of Lipara and reached some of the towns in Italy. The spot where this eruption occurred is still to be seen. Indeed, this must be recognized as the cause of the fire that is generated in the earth. The air is first broken up in small particles and then the wind is beaten about and so catches fire. A phenomenon in these islands affords further evidence of the fact that winds move below the surface of the earth. When a south wind is going to blow there is a premonitory indication. A sound is heard in the places from which the eruptions issue. This is because the sea is being pushed on from a distance and its advance thrusts back into the earth the wind that was issuing from it. The reason why there is a noise and no earthquake is that the underground spaces are so extensive in proportion to the quantity of the air that is being driven on that the wind slips away into the void beyond. Again, our theory is supported by the facts that the sun appears hazy and is darkened in the absence of clouds, and that there is sometimes calm and sharp frost before earthquakes at sunrise. The sun is necessarily obscured and darkened when the evaporation which dissolves and rarefies the air begins to withdraw into the earth. The calm, too, and the cold towards sunrise and dawn follow from the theory. The calm we have already explained. There must as a rule be calm because the wind flows back into the earth. Again, it must be most marked before the more violent earthquakes, for when the wind is not part outside earth, part inside, but moves in a single body, its strength must be greater. The cold comes because the evaporation which is naturally and essentially hot enters the earth. Wind is not recognized to be hot, because it sets the air in motion, and that is full of a quantity of cold vapor. It is the same with the breath we blow from our mouth. Close by it is warm, as it is when we breathe out through the mouth. But there is so little of it that it is scarcely noticed, whereas at a distance it is cold for the same reason as wind. Well, When this evaporation disappears into the earth, the vaporous exhalation concentrates and causes cold in any place in which this disappearance occurs. A sign which sometimes precedes earthquakes can be explained in the same way. Either by day or a little after sunset, in fine weather, a little, light, long-drawn cloud is seen, like a long very straight line. This is because the wind is leaving the air and dying down. Something analogous to this happens on the seashore. When the sea breaks in great waves, the marks left on the sand are very thick and crooked, but when the sea is calm they are slight and straight, because the secretion is small. As the sea is to the shore, so the wind is to the cloudy air, so, when the wind drops, this very straight and thin cloud is left, a sort of wave mark in the air. An earthquake sometimes coincides with an eclipse of the moon for the same reason. When the earth is on the point of being interposed, but the light and heat of the sun has not quite vanished from the air but is dying away, the wind which causes the earthquake before the eclipse, turns off into the earth, and calm ensues. For there often are winds before eclipses, at nightfall if the eclipse is at midnight, and at midnight if the eclipse is at dawn. They are caused by the lessening of the warmth from the moon when its sphere approaches the point at which the eclipse is going to take place. So the influence which restrained and quieted the air weakens and the air moves again and a wind rises, and does so later. The later the eclipse. A severe earthquake does not stop at once or after a single shock, but first the shocks go on, often for about 40 days, after that, for 1 or even 2 years it gives premonitory indications in the same place. The severity of the earthquake is determined by the quantity of wind and the shape of the passages through which it flows. Where it is beaten back and cannot easily find its way out, the shocks are most violent, and there it must remain in a cramped space like water that cannot escape. Any throbbing in the body does not cease suddenly or quickly, but by degrees according as the affection passes off. So here the agency which created the evaporation and gave it an impulse to motion clearly does not at once exhaust the whole of the material from which it forms the wind which we call an earthquake. So until the rest of this is exhausted the shocks must continue, though more gently, and they must go on until there is too little of the evaporation left to have any perceptible effect on the earth at all. Subterranean noises, too, are due to the wind. Sometimes they portend earthquakes, but sometimes they have been heard without any earthquake following. Just as the air gives off various sounds when it is struck, so it does when it strikes other things, for striking involves being struck, and so the two cases are the same. The sound precedes the shock because sound is thinner and passes through things more readily than wind. But when the wind is too weak by reason of thinness to cause an earthquake, the absence of a shock is due to its filtering through readily, though by striking hard and hollow masses of different shapes it makes various noises, so that the earth sometimes seems to bellow, as the portent-mongers say. Water has been known to burst out during an earthquake. But that does not make water the cause of the earthquake. The wind is the efficient cause, whether it drives the water along the surface or up from below, just as winds are the causes of waves and not waves of winds. Else we might as well say that earth was the cause, for it is upset in an earthquake, just like water, for a fusion is a form of upsetting. No, earth and water are material causes, being patients, not agents. The true cause is the wind. The combination of a tidal wave with an earthquake is due to the presence of contrary winds. It occurs when the wind which is shaking the earth does not entirely succeed in driving off the sea which another wind is bringing on, but pushes it back and heaps it up in a great mass in one place. Given this situation, it follows that when this wind gives way, the whole body of the sea, driven on by the other wind, will burst out and overwhelm the land. This is what happened in Achia. There a south wind was blowing, but outside a north wind. Then there was a calm and the wind entered the earth, and then the tidal wave came on and simultaneously there was an earthquake. This was the more violent as the sea allowed no exit to the wind that had entered the earth, but shut it in. So in their struggle with one another the wind caused the earthquake, and the wave by its settling down the inundation. Earthquakes are local and often affect a small district only, whereas winds are not local. Such phenomena are local when the evaporations at a given place are joined by those from the next and unite. This, as we explained, is what happens when there is drought or excessive rain locally. Now earthquakes do come about in this way, but winds do not. For earthquakes, rains, and droughts have their source and origin inside the earth, so that the sun is not equally able to direct all the evaporations in one direction. But on the evaporations in the air the sun has more influence, so that, when once they have been given an impulse by its motion, which is determined by its various positions, they flow in one direction. When the wind is present in sufficient quantity there is an earthquake. The shocks are horizontal like a tremor, except occasionally, in a few places, where they act vertically, upwards from below, like a throbbing. It is the vertical direction which makes this kind of earthquake so rare. The motive force does not easily accumulate in great quantity in the position required, since the surface of the earth secretes far more of the evaporation than its depths. Wherever an earthquake of this kind does occur, a quantity of stones comes to the surface of the earth, as when you throw up things in a winnowing fan, as we see from Sipylus and the Phlegraean plain and the district in Liguria, which were devastated by this kind of earthquake. Islands in the middle of the sea are less exposed to earthquakes than those near land. First, the volume of the sea cools the evaporations and overpowers them by its weight and so crushes them. Then, currents and not shocks are produced in the sea by the action of the winds. Again, it is so extensive that evaporations do not collect in it but issue from it, and these draw the evaporations from the earth after them. Islands near the continent really form part of it. The intervening sea is not enough to make any difference, but those in the open sea can only be shaken if the whole of the sea that surrounds them is shaken too. We have now explained earthquakes, their nature and cause, and the most important of the circumstances attendant on their appearance. Let us go on to explain lightning and thunder, and further whirlwind, firewind, and thunderbolts, for the cause of them all is the same. As we have said, there are two kinds of exhalation, moist and dry, and the atmosphere contains them both potentially. It, as we have said before, condenses into cloud, and the density of the clouds is highest at their upper limit. For they must be denser and colder on the side where the heat escapes to the upper region and leaves them. This explains why hurricanes and thunderbolts and all analogous phenomena move downwards in spite of the fact that everything hot has a natural tendency upwards. Just as the pips that we squeeze between our fingers are heavy but often jump upwards, so these things are necessarily squeezed out away from the densest part of the cloud. Now the heat that escapes disperses to the upper region. But if any of the dry exhalation is caught in the process as the air cools, it is squeezed out as the clouds contract, and collides in its rapid course with the neighboring clouds, and the sound of this collision is what we call thunder. This collision is analogous, to compare small with great, to the sound we hear in a flame which men call the laughter or the threat of Hephaestus or of Hestia. This occurs when the wood dries and cracks and the exhalation rushes on the flame in a body. So in the clouds, the exhalation is projected and its impact on dense clouds causes thunder. The variety of the sound is due to the irregularity of the clouds and the hollows that intervene where their density is interrupted. This then, is thunder, and this its cause. It usually happens that the exhalation that is ejected is inflamed and burns with a thin and faint fire. This is what we call lightning, where we see as it were the exhalation colored in the act of its ejection. It comes into existence after the collision and the thunder, though we see it earlier because sight is quicker than hearing. The rowing of triremes illustrates this. The oars are going back again before the sound of their striking the water reaches us. However, there are some who maintain that there is actually fire in the clouds. Empedocles says that it consists or some of the sun's rays which are intercepted, and Anaxagoras that it is part of the upper ether, which he calls fire, which has descended from above. Lightning, then, is the gleam of this fire, and thunder the hissing noise of its extinction in the cloud. But this involves the view that lightning actually is prior to thunder and does not merely appear to be so. Again, this intercepting of the fire is impossible on either theory, but especially it is said to be drawn down from the upper ether. Some reason ought to be given why that which naturally ascends should descend, and why it should not always do so, but only when it is cloudy. When the sky is clear there is no lightning. To say that there is altogether wanton. The view that the heat of the sun's rays intercepted in the clouds is the cause of these phenomena is equally unattractive. This, too, is a most careless explanation. Thunder, lightning, and the rest must have a separate and determinate cause assigned to them on which they ensue. But this theory does nothing of the sort. It is like supposing that water, snow, and hail existed all along and were produced when the time came and not generated at all, as if the atmosphere brought each to hand out of its stock from time to time. They are concretions in the same way as thunder and lightning are discretions, so that if it is true of either that they are not generated but pre-exist, the same must be true of the other. Again, how can any distinction be made about the intercepting between this case and that of interception in denser substances such as water? Water, too, is heated by the sun and by fire, yet when it contracts again and grows cold and freezes no such ejection as they describe occurs, though it ought on there to take place on a proportionate scale. Boiling is due to the exhalation generated by fire, but it is impossible for it to exist in the water beforehand, and besides they call the noise hissing, not boiling. But hissing is really boiling on a small scale, for when that which is brought into contact with moisture and is in process of being extinguished gets the better of it, then it boils and makes the noise in question. Some, Clademus is one of them, say that lightning is nothing objective but merely an appearance. They compare it to what happens when you strike the sea with a rod by night and the water is seen to shine. They say that the moisture in the cloud is beaten about in the same way, and that lightning is the appearance of brightness that ensues. This theory is due to ignorance of the theory of reflection, which is the real cause of that phenomenon. The water appears to shine when struck because our sight is reflected from it to some bright object, hence the phenomenon occurs mainly by night. The appearance is not seen by day because the daylight is too intense and obscures it. These are the theories of others about thunder and lightning, some maintaining that lightning is a reflection, the others that lightning is fire shining through the cloud and thunder its extinction. The fire not being generated in each case but existing beforehand. We say that the same stuff is wind on the earth, and earthquake under it, and in the clouds, thunder. The essential constituent of all these phenomena is the same, namely, the dry exhalation. If it flows in one direction it is wind, in another it causes earthquakes. In the clouds, when they are in a process of change and contract and condense into water, it is ejected and causes thunder and lightning and the other phenomena of the same nature. So much for thunder and lightning. Meteorology, Book 3, translated by E.W. Webster. Let us explain the remaining operations of this secretion in the same way as we have treated the rest. When this exhalation is secreted in small and scattered quantities and frequently, and is transitory, and its constitution rare, it gives rise to thunder and lightning. But if it is secreted in a body and is denser, that is, less rare, we get a hurricane. The fact that it issues in body explains its violence. It is due to the rapidity of the secretion. Now when this secretion issues in a great and continuous current, the result corresponds to what we get when the opposite development takes place and rain and a quantity of water are produced. As far as the matter from which they are developed goes, both sets of phenomena are the same. As soon as a stimulus to the development of either potentiality appears, that of which there is the greater quantity present in the cloud is at once secreted from it, and there results either rain, or, if the other exhalation prevails, a hurricane. Sometimes the exhalation in the cloud, when it is being secreted, collides with another under circumstances like those found when a wind is forced from an open into a narrow space in a gateway or a road. It often happens in such cases that the first part of the moving body is deflected because of the resistance due either to the narrowness or to a contrary current, and so the wind forms a circle and eddy. It is prevented from advancing in a straight line, at the same time it is pushed on from behind, so it is compelled to move sideways in the direction of least resistance. The same thing happens to the next part, and the next, and so on, till the series becomes one, that is, till a circle is formed, for if a figure is described by a single motion that figure must itself be one. This is how eddies are generated on the earth, and the case is the same in the clouds as far as the beginning of them goes. Only here, as in the case of the hurricane which shakes off the cloud without cessation and becomes a continuous wind, the cloud follows the exhalation unbroken, and the exhalation, failing to break away from the cloud because of its density, first moves in a circle for the reason given and then descends, because clouds are always densest on the side where the heat escapes. This phenomenon is called a whirlwind when it is colorless, and it is a sort of undigested hurricane. There is never a whirlwind when the weather is northerly, nor a hurricane when there is snow. The reason is that all these phenomena are wind, and wind is a dry and warm evaporation. Now frost and cold prevail over this principle and quench it at its birth. That they do prevail is clear, or there could be no snow or northerly rain, since these occur when the cold does prevail. So the whirlwind originates in the failure of an incipient hurricane to escape from its cloud. It is due to the resistance which generates the eddy, and it consists in the spiral which descends to the earth and drags with it the cloud which it cannot shake off. It moves things by its wind in the direction in which it is blowing in a straight line, and whirls round by its circular motion and forcibly snatches up whatever it meets. When the cloud burns as it is drawn downwards, that is, when the exhalation becomes rarer, it is called a fire wind, for its fire colors the neighboring air and inflames it. When there is a great quantity of exhalation and it is rare and is squeezed out in the cloud itself, we get a thunderbolt. If the exhalation is exceedingly rare, this rareness prevents the thunderbolt from scorching and the poets call it bright. If the rareness is less, it does scorch and they call it smoky. The former moves rapidly because of its rareness, and because of its rapidity passes through an object before setting fire to it or dwelling on it so as to blacken it. The slower one does blacken the object, but passes through it before it can actually burn it. Further, resisting substances are affected, unresisting ones are not. For instance, it has happened that the bronze of a shield has been melted while the woodwork remained intact because its texture was so loose that the exhalation filtered through without affecting it. So it has passed through clothes, too, without burning them, and has merely reduced them to shreds. Such evidence is enough by itself to show that the exhalation is at work in all these cases, but we sometimes get direct evidence as well, as in the case of the conflagration of the temple at Ephesus which we lately witnessed. The independent sheets of flame left the main fire and were carried bodily in many directions. Now that smoke is exhalation and that smoke burns is certain, and has been stated in another place before, but when the flame moves bodily, then we have ocular proof that smoke is exhalation. On this occasion what is seen in small fires appeared on a much larger scale because of the quantity of matter that was burning. The beams which were the source of the exhalation split, and a quantity of it rushed in a body from the place from which it issued forth and went up in a blaze, so that the flame was actually seen moving through the air away and falling on the houses. For we must recognize that exhalation accompanies and precedes thunderbolts though it is colorless and so invisible. Hence, where the thunderbolt is going to strike, the object moves before it is struck, showing that the exhalation leads the way and falls on the object first. Thunder, too, splits things not by its noise but because the exhalation that strikes the object and that which makes the noise are ejected simultaneously. This exhalation splits the thing it strikes but does not scorch it at all. We have now explained thunder and lightning and hurricane, and further fire winds, whirlwinds, and thunderbolts, and shown that they are all of them forms of the same thing and wherein they all differ. Let us now explain the nature and cause of halo, rainbow, mock suns, and rods. Since the same account applies to them all, we must first describe the phenomena and the circumstances in which each of them occurs. The halo often appears as a complete circle. It is seen round the sun and the moon and bright stars, by night as well as by day, and at midday or in the afternoon, more rarely about sunrise or sunset. The rainbow never forms a full circle, nor any segment greater than a semicircle. At sunset and sunrise the circle is smallest and the segment largest. As the sun rises higher the circle is larger and the segment smaller. After the autumn equinox in the shorter days it is seen at every hour of the day, in the summer not about midday. There are never more than 2 rainbows at one time. Each of them is 3-colored, the colors are the same in both and their number is the same, but in the outer rainbow they are fainter and their position is reversed. In the inner rainbow the first and largest band is red, in the outer rainbow the band that is nearest to this one and smallest is of the same color. The other bands correspond on the same principle. These are almost the only colors which painters cannot manufacture, for there are colors which they create by mixing, but no mixing will give red, green, or purple. These are the colors of the rainbow, though between the red and the green an orange color is often seen. Mock suns and rods are always seen by the side of the sun, not above or below it nor in the opposite quarter of the sky. They are not seen at night but always in the neighborhood of the sun, either as it is rising or setting but more commonly towards sunset. They have scarcely ever appeared when the sun was on the meridian, though this once happened in Bosporus where 2 mock suns rose with the sun and followed it all through the day till sunset. These are the facts about each of these phenomena. The cause of them all is the same, for they are all reflections. But they are different varieties, and are distinguished by the surface from which and the way in which the reflection to the sun or some other bright object takes place. The rainbow is seen by day, and it was formerly thought that it never appeared by night as a moon rainbow. This opinion was due to the rarity of the occurrence. It was not observed, for though it does happen it does so rarely. The reason is that the colors are not so easy to see in the dark and that many other conditions must coincide, and all that in a single day in the month. For if there is to be one it must be at full moon, and then as the moon is either rising or setting. So we have only met with 2 instances of a moon rainbow in more than 50 years. We must accept from the theory of optics the fact that sight is reflected from air and any object with a smooth surface just as it is from water, also that in some mirrors the forms of things are reflected, in others only their colors. Of the latter kind are those mirrors which are so small as to be indivisible for sense. It is impossible that the figure of a thing should be reflected in them, for if it is the mirror will be sensibly divisible since divisibility is involved in the notion of figure. But since something must be reflected in them and figure cannot be, it remains that color alone should be reflected. The color of a bright object sometimes appears bright in the reflection, but it sometimes, either owing to the admixture of the color at the mirror or to weakness of sight, gives rise to the appearance of another color. However, we must accept the account we have given of these things in the theory of sensation, and take some things for granted while we explain others. Let us begin by explaining the shape of the halo, why it is a circle and why it appears round the sun or the moon or one of the other stars. The explanation being in all these cases the same. Sight is reflected in this way when air and vapor are condensed into a cloud and the condensed matter is uniform and consists of small parts. Hence in itself it is a sign of rain, but if it fades away, of fine weather; if it is broken up, of wind. For if it does not fade away and is not broken up but is allowed to attain its normal state, it is naturally a sign of rain, since it shows that a process of condensation is proceeding which must, when it is carried to an end, result in rain. For the same reason these halos are the darkest. It is a sign of wind when it is broken up, because its breaking up is due to a wind which exists there but has not reached us. This view finds support in the fact that the wind blows from the quarter in which the main division appears in the halo. Its fading away is a sign of fine weather, because if the air is not yet in a state to get the better of the heat it contains and proceed to condense into water, this shows that the moist vapor has not yet separated from the dry and fire-like exhalation, and this is the cause of fine weather. So much for the atmospheric conditions under which the reflection takes place. The reflection is from the mist that forms round the sun or the moon, and that is why the halo is not seen opposite the sun like the rainbow. Since the reflection takes place in the same way from every point, the result is necessarily a circle or a segment of a circle, for if the lines start from the same point and end at the same point and are equal, the points where they form an angle will always lie on a circle. Let AGB and AZB and ADB be lines, each of which goes from the point A to the point B and forms an angle. Let the lines AG, AS, ADB equal and those at B, GB, ZB, DB equal to. See diagram. Draw the line AB. Then the triangles are equal, for their base AB is equal. Draw perpendiculars to AB from the angles, Ch from G, S from Z, D from D. Then these perpendiculars are equal, being in equal triangles. And they are all in one plane, being all at right angles to AB and meeting at a single point E. So if you draw the line it will be a circle and E its center. Now B is the sun, A the eye, and the circumference passing through the points GZD the cloud from which the line of sight is reflected to the sun. The mirrors must be thought of as contiguous. Each of them is too small to be visible, but their contiguity makes the whole made up of them all to seem one. The bright band is the sun, which is seen as a circle, appearing successively in each of the mirrors as a point indivisible to sense. The band of cloud next to it is black, its color being intensified by contrast with the brightness of the halo. The halo is formed rather near the earth because that is calmer, for where there is wind it is clear that no halo can maintain its position. Halos are common around the moon because the greater heat of the sun dissolves the condensations of the air more rapidly. Halos are formed round stars for the same reasons, but they are not prognostic in the same way because the condensation they imply is so insignificant as to be barren. We have already stated that the rainbow is a reflection. We have now to explain what sort of reflection it is, to describe its various concomitants, and to assign their causes. Sight is reflected from all smooth surfaces, such as air and water among others. Air must be condensed if it is to act as a mirror, though it often gives a reflection even uncondensed when the sight is weak. Such was the case of a man whose sight was faint and indistinct. He always saw an image in front of him and facing him as he walked. This was because his sight was reflected back to him. Its morbid condition made it so weak and delicate that the air close by acted as a mirror, just as distant and condensed air normally does, and his sight could not push it back. So promontories in the sea loom when there is a southeast wind, and everything seems bigger, and in a mist, too, things seem bigger. So, too, the sun and the stars seem bigger when rising and setting than on the meridian. But things are best reflected from water, and even in process of formation it is a better mirror than air, for each of the particles, the union of which constitutes a raindrop, is necessarily a better mirror than mist. Now it is obvious and has already been stated that a mirror of this kind renders the color of an object only, but not its shape. Hence it follows that when it is on the point of raining and the air in the clouds is in process of forming into raindrops but the rain is not yet actually there, if the sun is opposite, or any other object bright enough to make the cloud a mirror and cause the sight to be reflected to the object, then the reflection must render the color of the object without its shape. Since each of the mirrors is so small as to be invisible and what we see is the continuous magnitude made up of them all, the reflection necessarily gives us a continuous magnitude made up of one color, each of the mirrors contributing the same color to the whole. We may deduce that since these conditions are realizable there will be an appearance due to reflection whenever the sun and the cloud are related in the way described and we are between them. But these are just the conditions under which the rainbow appears. So it is clear that the rainbow is a reflection of sight to the sun. So the rainbow always appears opposite the sun whereas the halo is round it. They are both reflections, but the rainbow is distinguished by the variety of its colors. The reflection in the one case is from water which is darkened from a distance, in the other from air which is nearer and lighter in color. White light through a dark medium or on a dark surface, it makes no difference, looks red. We know how red the flame of green wood is. This is because so much smoke is mixed with the bright white firelight, so, too, the sun appears red through smoke and mist. That is why in the rainbow reflection the outer circumference is red, the reflection being from small particles of water, but not in the case of the halo. The other colors shall be explained later. Again, a condensation of this kind cannot persist in the neighborhood of the sun, it must either turn to rain or be dissolved. But opposite to the sun there is an interval during which the water is formed. If there were not this distinction, halos would be colored like the rainbow. Actually no complete or circular halo presents this color, only small and fragmentary appearances called rods. But if a haze due to water or any other dark substance formed, we should have had, as we maintain, a complete rainbow like that which we defined lamps. A rainbow appears round these in winter, generally with southerly winds. Persons whose eyes are moist see it most clearly because their sight is weak and easily reflected. It is due to the moistness of the air and the soot which the flame gives off and which mixes with the air and makes it a mirror, and to the blackness which the mirror derives from the smoky nature of the soot. The light of the lamp appears as a circle which is not white but purple. It shows the colors of the rainbow, but because the sight that is reflected is too weak and the mirror too dark, red is absent. The rainbow that is seen when oars are raised out of the sea involves the same relative positions as that in the sky, but its color is more like that round the lamps, being purple rather than red. The reflection is from very small particles continuous with one another, and in this case the particles are fully formed water. We get a rainbow, too, if a man sprinkles fine drops in a room turned to the sun so that the sun is shining in part of the room and throwing a shadow in the rest. Then if one man sprinkles in the room, another, standing outside, sees a rainbow where the sun's rays cease and make the shadow. Its nature and color is like that from the oars, and its cause is the same, for the sprinkling hand corresponds to the oar. That the colors of the rainbow are those we described and how the other colors come to appear in it will be clear from the following considerations. We must recognize, as we have said, and lay down, first, that white color on a black surface or seen through a black medium gives red, second, that sight when strained to a distance becomes weaker and less, third, that black is in a sort the negation of sight. An object is black because sight fails, so everything at a distance looks blacker, because sight does not reach it. The theory of these matters belongs to the account of the senses, which are the proper subjects of such an inquiry. We need only state about them what is necessary for us. At all events, that is the reason why distant objects and objects seen in a mirror look darker and smaller and smoother, why the reflection of clouds in water is darker than the clouds themselves. This latter is clearly the case, the reflection diminishes the sight that reaches them. It makes no difference whether the change is in the object seen or in the sight, the result being in either case the same. The following fact further is worth noticing. When there is a cloud near the sun and we look at it, does not look colored at all but white, but when we look at the same cloud in water it shows a trace of rainbow coloring. Clearly, then, when sight is reflected it is weakened and, as it makes dark look darker, so it makes white look less white, changing it and bringing it nearer to black. When the sight is relatively strong the change is to red. The next stage is green, and a further degree of weakness gives violet. No further change is visible, but 3 completes the series of colors, as we find 3 does in most other things, and the change into the rest is imperceptible to sense. Hence also the rainbow appears with 3 colors. This is true of each of the 2, but in a contrary way. The outer band of the primary rainbow is red, for the largest band reflects most sight to the sun, and the outer band is largest. The middle band and the third go on the same principle. So if the principles we laid down about the appearance of colors are true, the rainbow necessarily has 3 colors, and these 3 and no others. The appearance of yellow is due to contrast, for the red is whitened by its juxtaposition with green. We can see this from the fact that the rainbow is purest when the cloud is blackest, and then the red shows most yellow. Yellow in the rainbow comes between red and green, so the whole of the red shows white by contrast with the blackness of the cloud around, for it is white compared to the cloud and the green. Again, when the rainbow is fading away and the red is dissolving, the white cloud is brought into contact with the green and becomes yellow. But the moon rainbow affords the best instance of this color contrast. It looks quite white. This is because it appears on the dark cloud and at night. So, just as fire is intensified by added fire, black beside black makes that which is in some degree white look quite white. Bright dyes too show the effect of contrast. In woven and embroidered stuffs the appearance of colors is profoundly affected by their juxtaposition with one another. Purple, for instance, appears different on white and on black wool, and also by differences of illumination. Thus embroiderers say that they often make mistakes in their colors when they work by lamplight, and use the wrong ones. We have now shown why the rainbow has 3 colors and that these are its only colors. The same cause explains the double rainbow and the faintness of the colors in the outer one and their inverted order. When sight is strained to a great distance the appearance of the distant object is affected in a certain way, and the same thing holds good here. So the reflection from the outer rainbow is weaker because it takes place from a greater distance and less of it reaches the sun, and so the colors seen are fainter. Their order is reversed because more reflection reaches the sun from the smaller, inner band. For that reflection is nearer to our sight which is reflected from the band which is nearest to the primary rainbow. Now the smallest band in the outer rainbow is that which is nearest, and so it will be red, and the second and the third will follow the same principle. Let B be the outer rainbow, the inner one, let R stand for the red color, G for green, V for violet, yellow appears at the point Y. 3 rainbows or more are not found because even the second is fainter, so that the third reflection can have no strength whatever and cannot reach the sun at all. See diagram. The rainbow can never be a circle nor a segment of a circle greater than a semicircle. The consideration of the diagram will prove this and the other properties of the rainbow. See diagram. Let A be a hemisphere resting on the circle of the horizon, let its center be K and let H be another point appearing on the horizon. Then, if the lines that fall in a cone from K have HK as their axis, and K and M being joined, the lines KM are reflected from the hemisphere to H over the greater angle, the lines from K will fall on the circumference of a circle. If the reflection takes place when the luminous body is rising or setting, the segment of the circle above the earth which is cut off by the horizon will be a semicircle. If the luminous body is above the horizon it will always be less than a semicircle, and it will be smallest when the luminous body culminates. First let the luminous body be appearing on the horizon at the point H, and let Km be reflected to H, and let the plane in which A is, determined by the triangle HKM, be produced. Then the section of the sphere will be a great circle. Let it be A, for it makes no difference which of the planes passing through the line HK and determined by the triangle KMH is produced. Now the lines drawn from H and K to a point on the semicircle A are in a certain ratio to one another, and no lines drawn from the same points to another point on that semicircle can have the same ratio. For since both the points H and K and the line KH are given, the line MH will be given too. Consequently the ratio of the line MH to the line MK will be given too. So M will touch a given circumference. Let this be an M. Then the intersection of the circumferences is given, and the same ratio cannot hold between lines in the same plane drawn from the same points to any other circumference but Mn. Draw a line DB outside of the figure and divide it so that DB equals MH/MK. But MH is greater than MK since the reflection of the cone is over the greater angle, for it subtends the greater angle of the triangle KMH. Therefore D is greater than B. Then add to B a line Z such that B plus ZD equals DB. Then make another line having the same ratio to B as KH has to Z, and join me. Then I is the pole of the circle on which the lines from K fall. For the ratio of D to M is the same as that of Z to KH and of B to K. If not, let D be in the same ratio to a line indifferently lesser or greater than M, and let this line be IP. Then HK and KR and IP will have the same ratios to one another as Z, B, and D. But the ratios between Z, B, and D were such that Z plus BD equals D, B. Therefore IP equals IP. Now, if the points K, H be joined with a point P by the lines HP, KP, these lines will be to one another as I is to IP, for the sides of the triangle's hip, KP are about the angle I are homologous. Therefore, HP2 will be to KP as high as to IP. But this is also the ratio of MH to MK, for the ratio both of height to IP and of MH to MK is the same as that of D to B. Therefore, from the points H, K there will have been drawn lines with the same ratio to one another, not only to the circumference Mn but to another point as well, which is impossible. Since then D cannot bear that ratio to any line either lesser or greater than M. The proof being in either case the same, it follows that it must stand in that ratio to me itself. Therefore as me is to X so it will be to me and finally MH to MK. If, then, a circle be described with I as pole at the distance me it will touch all the angles which the lines from H and K make by their reflection. If not, it can be shown, as before, that that lines drawn to different points in the semicircle will have the same ratio to one another, which was impossible. If, then, the semicircle AB revolved about the diameter HKI, the lines reflected from the points H, K at the point M will have the same ratio, and will make the angle KMH equal, in every plane. Further, the angle which M and M make with high will always be the same. So there are a number of triangles on high and K equal to the triangles HMI and KMI. Their perpendiculars will fall on high at the same point and will be equal. Let O be the point on which they fall. Then O is the center of the circle, half of which, MN, is cut off by the horizon. See diagram. Next let the horizon be ABG but let H have risen above the horizon. Let the axis now be high. The proof will be the same for the rest as before, but the poli of the circle will be below the horizon AG since the point H has risen above the horizon. But the pole, and the center of the circle, and the center of that circle, namely high, which now determines the position of the sun are on the same line. But since KH lies above the diameter AG, the center will be at O on the line K below the plane of the circle AG determined the position of the sun before. So the segment which is above the horizon will be less than a semicircle. For YXM was a semicircle and it has now been cut off by the horizon AG. So part of it, M, will be invisible when the sun has risen above the horizon, and the segment visible will be smallest when the sun is on the meridian, for the higher H is the lower the pole and the center of the circle will be. In the shorter days after the autumn equinox there may be a rainbow at any time of the day, but in the longer days from the spring to the autumn equinox there cannot be a rainbow about midday. The reason for this is that when the sun is north of the equator the visible arcs of its course are all greater than a semicircle, and go on increasing, while the invisible arc is small, but when the sun is south of the equator the visible arc is small and the invisible arc great, and the farther the sun moves south of the equator the greater is the invisible arc. Consequently, in the days near the summer solstice, the size of the visible arc is such that before the point H reaches the middle of that arc, that is its point of culmination, the point is well below the horizon, the reason for this being the great size of the visible arc, and the consequent distance of the point of culmination from the earth. But in the days near the winter solstice the visible arcs are small, and the contrary is necessarily the case, for the sun is on the meridian before the point H has risen far. Mock suns, and rods too, are due to the causes we have described. A mock sun is caused by the reflection of sight to the sun. Rods are seen when sight reaches the sun under circumstances like those which we described, when there are clouds near the sun and sight is reflected from some liquid surface to the cloud. Here the clouds themselves are colorless when you look at them directly, but in the water they are full of rods. The only difference is that in this latter case the color of the cloud seems to reside in the water, but in the case of rods on the cloud itself. Rods appear when the composition of the cloud is uneven, dense in part rare, and more and less watery in different parts. Then the sight is reflected to the sun, the mirrors are too small for the shape of the sun to appear, but, the bright white light of the sun, to which the sight is reflected, being seen on the uneven mirror, its color appears partly red, partly green or yellow. It makes no difference whether sight passes through or is reflected from a medium of that kind. The color is the same in both cases. If it is red in the first case it must be the same in the other. Rods then are occasioned by the unevenness of the mirror as regards color, not form. The mock sun, on the contrary, appears when the air is very uniform, and of the same density throughout. This is why it is white. The uniform character of the mirror gives the reflection in it a single color, while the fact that the sight is reflected in a body and is thrown on the sun altogether by the mist, which is dense and watery though not yet quite water, causes the sun's true color to appear just as it does when the reflection is from the dense, smooth surface of copper. So the sun's color being white, the mock sun is white too. This, too, is the reason why the mock sun is a surer sign of rain than the rods. It indicates, more than they do, that the air is ripe for the production of water. Further, a mock sun to the south is a surer sign of rain than one to the north, for the air in the south is readier to turn into water than that in the north. Mock suns and rods are found, as we stated, about sunset and sunrise, not above the sun nor below it, but beside it. They are not found very close to the sun, nor very far from it, for the sun dissolves the cloud if it is near, but if it is far off the reflection cannot take place, since sight weakens when it is reflected from a small mirror to a very distant object. This is why a halo is never found opposite to the sun. If the cloud is above the sun and close to it the sun will dissolve it. If it is above the sun but at a distance the sight is too weak for the reflection to take place, and so it will not reach the sun. But at the side of the sun, it is possible for the mirror to be at such an interval that the sun does not dissolve the cloud, and yet sight reaches it undiminished because it moves close to the earth and is not dissipated in the immensity of space. It cannot subsist below the sun because close to the earth the sun's rays would dissolve it, but if it were high up and the sun in the middle of the heavens, sight would be dissipated. Indeed, even by the side of the sun, it is not found when the sun is in the middle of the sky, for then the line of vision is not close to the earth, and so but little sight reaches the mirror and the reflection from it is altogether feeble. Some account has now been given of the effects of the secretion above the surface of the earth. We must go on to describe its operations below, when it is shut up in the parts of the earth. Just as its twofold nature gives rise to various effects in the upper region, so here it causes two varieties of bodies. We maintain that there are two exhalations, one vaporous the other smoky, and there correspond two kinds of bodies that originate in the earth, fossils and metals. The heat of the dry exhalation is the cause of all fossils. Such are the kinds of stones that cannot be melted, and ralga, and ochre, and ruddle, and sulfur, and the other things of that kind, most fossils being either colored lye or, like cinnabar, a stone compounded of it. The vaporous exhalation is the cause of all metals, those bodies which are either fusible or malleable such as iron, copper, gold. All these originate from the imprisonment of the vaporous exhalation in the earth, and especially in stones. Their dryness compresses it, and it congeals just as dew or hoarfrost does when it has been separated off, though in the present case the metals are generated before that segregation occurs. Hence, they are water in a sense, and in a sense not. Their matter was that which might have become water, but it can no longer do so, nor are they, like savors, due to a qualitative change in actual water. Copper and gold are not formed like that, but in every case the evaporation congealed before water was formed. Hence, they all, except gold, are affected by fire, and they possess an admixture of earth, for they still contain the dry exhalation. This is the general theory of all these bodies. But we must take up each kind of them and discuss it separately. Meteorology, Book 4. Translated by E. W. Webster. We have explained that the qualities that constitute the elements are four, and that their combinations determine the number of the elements to be four. Two of the qualities, the hot and the cold, are active. Two, the dry and the moist, passive. We can satisfy ourselves of this by looking at instances. In every case heat and cold determine, conjoin, and change things of the same kind and things of different kinds, moistening, drying, hardening, and softening them. Things dry and moist, on the other hand, both in isolation and when present together in the same body are the subjects of that determination and of the other affections enumerated. The account we give of the qualities when we define their character shows this too. Hot and cold we describe as active, for congregating is essentially a species of being active, moist and dry are passive, for it is in virtue of its being acted upon in a certain way that a thing is said to be easy to determine or difficult to determine. So it is clear that some of the qualities are active and some passive. Next we must describe the operations of the active qualities and the forms taken by the passive. First of all, true becoming, that is, natural change, is always the work of these powers, and so is the corresponding natural destruction, and this becoming and this destruction are found in plants and animals and their parts. True natural becoming is a change introduced by these powers into the matter underlying a given thing when they are in a certain ratio to that matter, which is the passive qualities we have mentioned. When the hot and the cold are masters of the matter, they generate a thing. If they are not, and the failure is partial, the object is imperfectly boiled or otherwise unconcocted. But the strictest general opposite of true becoming is putrefaction. All natural destruction is on the way to it, as are, for instance, growing old or growing dry. Putrescence is the end of all these things, that is of all natural objects, except such as are destroyed by violence. You can burn, for instance, flesh, bone, or anything else, but the natural course of their destruction ends in putrefaction. Hence things that putrefy begin by being moist and end by being dry. For the moist and the dry were their matter, and the operation of the active qualities cause the dry to be determined by the moist. Destruction supervenes when the determined gets the better of the determining by the help of the environment, though in a special sense the word putrefaction is applied to partial destruction, when a thing's nature is perverted. Hence everything, except fire, is liable to putrefy, for earth, water, and air putrefy, being all of them matter relatively to fire. The definition of putrefaction is the destruction of the peculiar and natural heat in any moist subject by external heat, that is, by the heat of the environment. So since lack of heat is the ground of this affection and everything in as far as it lacks heat is cold, both heat and cold will be the causes of putrefaction, which will be due indifferently to cold in the putrefying subject or to heat in the environment. This explains why everything that putrefies grows drier and ends by becoming earth or dung. The subject's own heat departs and causes the natural moisture to evaporate with it, and then there is nothing left to draw in moisture, for it is a thing's peculiar heat that attracts moisture and draws it in. Again, putrefaction takes place less in cold than in hot seasons, for in winter the surrounding air and water contain but little heat and it has no power, but in summer there is more. Again, what is frozen does not putrefy, for its cold is greater than the heat of the air and so is not mastered, whereas what affects a thing does master it. Nor does that which is boiling or hot putrefy, for the heat in the air being less than that in the object does not prevail over it or set up any change. So too anything that is flowing or in motion is less apartment to putrefy than a thing at rest, for the motion set up by the heat in the air is weaker than that pre-existing in the object, and so it causes no change. For the same reason a great quantity of a thing putrefies less readily than a little, for the greater quantity contains too much proper fire and cold for the corresponding qualities in the environment to get the better of. Hence, the sea putrefies quickly when broken up into parts, but not as a whole, and all other waters likewise. Animals too are generated in putrefying bodies, because the heat that has been secreted, being natural, organizes the particles secreted with it. So much for the nature of becoming and of destruction. We must now describe the next kinds of processes which the qualities already mentioned set up in actually existing natural objects as matter. Of these concoction is due to heat, its species are ripening, boiling, broiling. Inconcoction is due to cold and its species are rawness, imperfect boiling, imperfect broiling. We must recognize that the things are not properly denoted by these words. The various classes of similar objects have no names universally applicable to them. Consequently we must think of the species enumerated as being not what those words denote but something like it. Let us say what each of them is. Concoction is a process in which the natural and proper heat of an object perfects the corresponding passive qualities, which are the proper matter of any given object. For when concoction has taken place we say that a thing has been perfected and has come to be itself. It is the proper heat of a thing that sets up this perfecting, though external influences may contribute in some degrees to its fulfillment. Baths, for instance, and other things of the kind contribute to the digestion of food, but the primary cause is the proper heat of the body. In some cases of concoction the end of the process is the nature of the thing, nature, that is, in the sense of the formal cause and essence. In other cases it leads to some presupposed state which is attained when the moisture has acquired certain properties or a certain magnitude in the process of being broiled or of putrefying, or however else it is being heated. This state is the end, for when it has been reached the thing has some use and we say that concoction has taken place. Must is an instance of this, and the matter in boils when it becomes purulent, and tears when they become room, and so with the rest. Concoction ensues whenever the matter, the moisture, is mastered. For the matter is what is determined by the heat connatural to the object, and as long as the ratio between them exists in it a thing maintains its nature. Hence things like the liquid and solid excreta and ejecta in general are signs of health, and concoction is said to have taken place in them, for they show that the proper heat has got the better of the indeterminate matter. Things that undergo a process of concoction necessarily become thicker and hotter, for the action of heat is to make things more compact, thicker, and drier. This then is the nature of concoction. But inconcoction is an imperfect state due to lack of proper heat, that is, to cold. That of which the imperfect state is the corresponding passive qualities which are the natural matter of anything. So much for the definition of concoction and inconcoction. Ripening is a sort of concoction, for we call it ripening when there is a concoction of the nutriment in fruit. And since concoction is a sort of perfecting, the process of ripening is perfect when the seeds in fruit are able to reproduce the fruit in which they are found, for in all other cases as well this is what we mean by perfect. This is what ripening means when the word is applied to fruit. However, many other things that have undergone concoction are said to be ripe, the general character of the process being the same, though the word is applied by an extension of meaning. The reason for this extension is, as we explained before, that the various modes in which natural heat and cold perfect the matter they determine have not special names appropriated to them. In the case of boils and phlegm, and the like, the process of ripening is the concoction of the moisture in them by their natural heat, for only that which gets the better of matter can determine it. So everything that ripens is condensed from a spirituous into a watery state, and from a watery into an earthy state, and in general from being rare becomes dense. In this process the nature of the thing that is ripening incorporates some of the matter in itself, and some it rejects. So much for the definition of ripening. Rawness is its opposite and is therefore an imperfect concoction of the nutriment in the fruit, namely, of the undetermined moisture. Consequently a raw thing is either spirituous or watery or contains both spirit and water. Ripening being a kind of perfecting, rawness will be an imperfect state, and this state is due to a lack of natural heat and its disproportion to the moisture that is undergoing the process of ripening. Nothing moist ripens without the admixture of some dry matter. Water alone of liquids does not thicken. This disproportion may be due either to defect of heat or to excess of the matter to be determined. Hence the juice of raw things is thin, cold rather than hot, and unfit for food or drink. Rawness, like ripening, is used to denote a variety of states. Thus the liquid and solid excreta and catars are called raw for the same reason, for in every case the word is applied to things because their heat has not got a mastery in them and compacted them. If we go further, brick is called raw and so is milk and many other things too when they are such as to admit of being changed and compacted by heat but have remained unaffected. Hence, while we speak of boiled water, we cannot speak of raw water, since it does not thicken. We have now defined ripening and rawness and assigned their causes. Boiling is, in general, a concoction by moist heat of the indeterminate matter contained in the moisture of the thing boiled, and the word is strictly applicable only to things boiled in the way of cooking. The indeterminate matter, as we said, will be either spirituous or watery. The cause of the concoction is the fire contained in the moisture, for what is cooked in a frying pan is broiled. It is the heat outside that affects it and, as for the moisture in which it is contained, it dries this up and draws it into itself. But a thing that is being boiled behaves in the opposite way. The moisture contained in it is drawn out of it by the heat in the liquid outside. Hence boiled meats are drier than broiled, for, in boiling, things do not draw the moisture into themselves, since the external heat gets the better of the internal. If the internal heat had got the better it would have drawn the moisture to itself. Not everybody admits of the process of boiling. If there is no moisture in it, it does not, for instance, stones, nor does it if there is moisture in it but the density of the body is too great for it to be mastered, as in the case of wood. But only those bodies can be boiled that contain moisture which can be acted on by the heat contained in the liquid outside. It is true that gold and wood and many other things are said to be boiled, but this is a stretch of the meaning of the word, though the kind of thing intended is the same, the reason for the usage being that the various cases have no names appropriated to them. Liquids too, like milk and must, are said to undergo a process of boiling when the external fire that surrounds and heats them changes the savor in the liquid into a given form, the process being thus in a way like what we have called boiling. The end of the things that undergo boiling, or indeed any form of concoction, is not always the same. Some are meant to be eaten, some drunk, and some are intended for other uses. For instance, dyes, too, are said to be boiled. All those things then admit of boiling which can grow denser, smaller, or heavier, also those which do that with a part of themselves and with a part do the opposite, dividing in such a way that one portion thickens while the other grows thinner, like milk when it divides into whey and curd. Oil by itself is affected in none of these ways, and therefore cannot be said to admit of boiling. Such then is the phase of concoction known as boiling, and the process is the same in an artificial and in a natural instrument, for the cause will be the same in every case. Imperfect boiling is the form of inconcoction opposed to boiling. Now the opposite of boiling properly so called is an inconcoction of the undetermined matter in a body due to lack of heat in the surrounding liquid. Lack of heat implies, as we have pointed out, the presence of cold. The motion which causes imperfect boiling is different from that which causes boiling, for the heat which operates the concoction is driven out. The lack of heat is due either to the amount of cold in the liquid or to the quantity of moisture in the object undergoing the process of boiling. Where either of these conditions is realized, the heat in the surrounding liquid is too great to have no effect at all, but too small to carry out the process of concocting uniformly and thoroughly. Hence things are harder when they are imperfectly boiled than when they are boiled, and the moisture in them more distinct from the solid parts. So much for the definition and causes of boiling and imperfect boiling. Broiling is concoction by dry foreign heat. Hence if a man were to boil a thing but the change and concoction in it were due, not to the heat of the liquid but to that of the fire, the thing will have been broiled and not boiled when the process has been carried to completion. If the process has gone too far we use the word scorched to describe it. If the process leaves the thing dry at the end the agent has been dry heat. Hence the outside is drier than the inside, the opposite being true of things boiled. Where the process is artificial, broiling is more difficult than boiling, for it is difficult to heat the inside and the outside uniformly, since the parts nearer to the fire are the first to get dry and consequently get more intensely dry. In this way the outer pores contract and the moisture in the thing cannot be secreted but is shut in by the closing of the pores. Now broiling and boiling are artificial processes, but the same general kind of thing, as we said, is found in nature too. The affections produced are similar though they lack a name, for art imitates nature. For instance, the concoction of food in the body is like boiling, for it takes place in a hot and moist medium and the agent is the heat of the body. So, too, certain forms of indigestion are like imperfect boiling. And it is not true that animals are generated in the concoction of food, as some say. Really they are generated in the excretion which putrefies in the lower belly, and they are sent afterwards. The concoction goes on in the upper belly but the excretion putrefies in the lower. The reason for this has been explained elsewhere. We have seen that the opposite of boiling is imperfect boiling. Now there is something correspondingly opposed to the species of concoction called broiling, but it is more difficult to find a name for it. It would be the kind of thing that would happen if there were imperfect broiling instead of broiling proper through lack of heat due to deficiency in the external fire or to the quantity of water in the thing undergoing the process. For then we should get too much heat for no effect to be produced, but too little for concoction to take place. We have now explained concoction and inconcoction, ripening and rawness, boiling and broiling, and their opposites. We must now describe the forms taken by the passive qualities, the moist and the dry. The elements of bodies, that is, the passive ones, are the moist and the dry. The bodies themselves are compounded of them and whichever predominates determines the nature of the body. Thus some bodies partake more of the dry, others of the moist. All the forms to be described will exist either actually, or potentially and in their opposite. For instance, there is actual melting and on the other hand that which admits of being melted. Since the moist is easily determined and the dry determined with difficulty, their relation to one another is like that of a dish and its condiments. The moist is what makes the dry determinable, and each serves as a sort of glue to the other, as Empedocles said in his poem on nature, gluing meal together by means of water. Thus the determined body involves them both. Of the elements earth is especially representative of the dry, water of the moist, and therefore all determinate bodies in our world involve earth and water. Every body shows the quality of that element which predominates in it. It is because earth and water are the material elements of all bodies that animals live in them alone and not in air or fire. Of the qualities of bodies, hardness and softness are those which must primarily belong to a determined thing, for anything made up of the dry and the moist is necessarily either hard or soft. Hard is that the surface of which does not yield into itself, soft that which does yield but not by interchange of place. Water, for instance, is not soft, for its surface does not yield to pressure or sink in but there is an interchange of place. Those things are absolutely hard and soft which satisfy the definition absolutely, and those things relatively so which do so compared with another thing. Now relatively to one another hard and soft are indefinable, because it is a matter of degree. But since all the objects of sense are determined by reference to the faculty of sense, it is clearly the relation to touch which determines that which is hard and soft absolutely, and touch is that which we use as a standard or mean. So we call that which exceeds it hard and that which falls short of it soft. A body determined by its own boundary must be either hard or soft, for it either yields or does not. It must also be concrete, or it could not be so determined. So since everything that is determined and solid is either hard or soft and these qualities are due to concretion, all composite and determined bodies must involve concretion. Concretion therefore must be discussed. Now there are two causes besides matter: the agent and the quality brought about. The agent being the efficient cause, the quality the formal cause. Hence concretion and disaggregation, drying and moistening, must have these two causes. But since concretion is a form of drying, let us speak of the latter first. As we have explained, the agent operates by means of two qualities and the patient is acted on in virtue of two qualities. Action takes place by means of heat or cold, and the quality is produced either by the presence or by the absence of heat or cold, but that which is acted upon is moist or dry or a compound of both. Water is the element characterized by the moist, earth that characterized by the dry, for these among the elements that admit the qualities moist and dry are passive. Therefore cold, too, being found in water and earth, both of which we recognize to be cold, must be reckoned rather as a passive quality. It is active only as contributing to destruction or incidentally in the manner described before, for cold is sometimes actually said to burn and to warm, but not in the same way as heat does, but by collecting and concentrating heat. The subjects of drying are water and the various watery fluids and those bodies which contain water either foreign or connatural. By foreign I mean like the water in wool, by connatural, like that in milk. The watery fluids are wine, urine, whey, and in general those fluids which have no sediment or only a little, except where this absence of sediment is due to viscosity. For in some cases, in oil and pitch for instance, it is the viscosity which prevents any sediment from appearing. It is always a process of heating or cooling that dries things, but the agent in both cases is heat, either internal or external. For even when things are dried by cooling, like a garment, where the moisture exists separately, it is the internal heat that dries them. It carries off the moisture in the shape of vapor, if there is not too much of it, being itself driven out by the surrounding cold. So everything is dried, as we have said, by a process either of heating or cooling, but the agent is always heat, either internal or external, carrying off the moisture in vapor. By external heat I mean as where things are boiled, by internal where the heat breathes out and takes away and uses up its moisture. So much for drying. Liquefaction is, first, condensation into water, second, the melting of a solidified body. The first, condensation, is due to the cooling of vapor. What melting is will appear from the account of solidification. Whatever solidifies is either water or a mixture of earth and water, and the agent is either dry heat or cold. Hence those of the bodies solidified by heat or cold which are soluble at all are dissolved by their opposites. Bodies solidified by the dry hot are dissolved by water, which is the moist cold, while bodies solidified by cold are dissolved by fire, which is hot. Some things seem to be solidified by water, for example boiled honey, but really it is not the water but the cold in the water which effects the solidification. Aqueous bodies are not solidified by fire, for it is fire that dissolves them, and the same cause in the same relation cannot have opposite effects upon the same thing. Again, water solidifies owing to the departure of heat, so it will clearly be dissolved by the entry into it of heat. Cold, therefore, must be the agent in solidifying it. Hence aqueous bodies do not thicken when they solidify, for thickening occurs when the moisture goes off and the dry matter comes together, but water is the only liquid that does not thicken. Those bodies that are made up of both earth and water are solidified both by fire and by cold, and in either case are thickened. The operation of the two is in a way the same and in a way different. Heat acts by drawing off the moisture, and as the moisture goes off in vapor the dry matter thickens and collects. Cold acts by driving out the heat, which is accompanied by the moisture as this goes off in vapor with it. Bodies that are soft but not liquid do not thicken but solidify when the moisture leaves them, for example potter's clay in process of baking, but those mixed bodies that are liquid thicken besides solidifying, like milk. Those bodies which have first been thickened or hardened by cold often begin by becoming moist, thus potter's clay at first in the process of baking steams and grows softer, and is liable to distortion in the ovens for that reason. Now of the bodies solidified by cold which are made up both of earth and water but in which the earth preponderates, those which solidify by the departure of heat melt by heat when it enters into them again. This is the case with frozen mud. But those which solidify by refrigeration, where all the moisture has gone off in vapor with the heat, like iron and horn, cannot be dissolved except by excessive heat, but they can be softened though manufactured iron does melt, to the point of becoming fluid and then solidifying again. This is how steel is made. The dross sinks to the bottom and is purged away, when this has been done often and the metal is pure of steel. The process is not repeated often because the purification of the metal involves great waste and loss of weight. But the iron that has less dross is the better iron. The stone pyromachus, too, melts and forms into drops and becomes fluid. After having been in a fluid state it solidifies and becomes hard again. Millstones, too, melt and become fluid. When the fluid mass begins to solidify it is black but its consistency comes to be like that of lime. And earth, too. Of the bodies which are solidified by dry heat some are insoluble, others are dissolved by liquid. Pottery and some kinds of stone that are formed out of earth burnt up by fire, such as millstones, cannot be dissolved. Natron and salt are soluble by liquid, but not all liquid but only such as is cold. Hence water and any of its varieties melt them, but oil does not. For the opposite of the dry hot is the cold moist, and what the one solidified the other will dissolve, and so opposites will have opposite effects. If a body contains more water than earth, fire only thickens it. If it contains more earth, fire solidifies it. Hence natron in salt and stone and potter's clay must contain more earth. The nature of oil presents the greatest problem. If water preponderated in it, cold ought to solidify it. If earth preponderated, then fire ought to do so. Actually neither solidifies, but both thicken it. The reason is that it is full of air, hence it floats on the top of water, since air tends to rise. Cold thickens it by turning the air in it into water, for any mixture of oil and water is thicker than either. Fire and the lapse of time thicken and whiten it. The whitening follows on the evaporation of any water that may have been in it. The is due to the change of the air into water as the heat in the oil is dissipated. The effect in both cases is the same and the cause is the same, but the manner of its operation is different. Both heat and cold thicken it, but neither dries it. Neither the sun nor cold dries oil, not only because it is glutinous but because it contains air. Its glutinous nature prevents it from giving off vapor, and so fire does not dry it or boil it off. Those bodies which are made up of earth and water may be classified according to the preponderance of either. There is a kind of wine, for instance, which both solidifies and thickens by boiling, must. All bodies of this kind lose their water as they that it is their water may be seen from the fact that the vapor from them condenses into water when collected. So wherever some sediment is left, this is of the nature of earth. Some of these bodies, as we have said, are also thickened and dried by cold. For cold not only solidifies but also dries water, and thickens things by turning air into water. Solidifying, as we have said, is a form of drying. Now those things that are not thickened by cold, but solidified, belong rather to water, for example, wine, urine, vinegar, lye, whey. But those things that are thickened, not by evaporation due to fire, are made up either of earth or of water and air. Honey of earth, while oil contains air. Milk and blood, too, are made up of both water and earth, though earth generally predominates in them. So, too, are the liquids out of which natron and salt are formed, and stones are also formed from some mixtures of this kind. Hence, if the whey has not been separated, it burns away if you boil it over a fire. But the earthy element in milk can also be coagulated by the help of fig juice, if you boil it in a certain way as doctors do when they treat it with fig juice, and this is how the whey and the cheese are commonly separated. Whey, once separated, does not thicken, as the milk did, but boils away like water. Sometimes, however, there is little or no cheese in milk, and such milk is not nutritive and is more like water. The case of blood is similar. Cold dries and so solidifies it. Those kinds of blood that do not solidify, like that of a stag, belong rather to water and are very cold. Hence they contain no fibers, for the fibers are of earth and solid, and blood from which they have been removed does not solidify. This is because it cannot dry, for what remains is water, just as what remains of milk when cheese has been removed is water. The fact that diseased blood will not solidify is evidence of the same thing, for such blood is of the nature of serum and that is phlegm and water, the nature of the animal having failed to get the better of it and digest it. Some of these bodies are soluble, for example natron, some insoluble, for example pottery, of the latter, some, like horn, can be softened by heat, others, like pottery and stone, cannot. The reason is that opposite causes have opposite effects. Consequently, if solidification is due to two causes, the cold and the dry, solution must be due to the hot and the moist, that is, to fire and to water, these being opposites, water dissolving what was solidified by fire alone, fire what was solidified by cold alone. Consequently, if any things happen to be solidified by the action of both, these are least department to be soluble. Such a case we find where things have been heated and are then solidified by cold. When the heat in leaving them has caused most of the moisture to evaporate, the cold so compacts these bodies together again as to leave no entrance even for moisture. Therefore heat does not dissolve them, for it only dissolves those bodies that are solidified by cold alone, nor does water, for it does not dissolve what cold solidifies, but only what is solidified by dry heat. But iron is melted by heat and solidified by cold. Wood consists of earth and air and is therefore combustible but cannot be melted or softened by heat. For the same reason it floats in water all except ebony. This does not, for other kinds of wood contain a preponderance of air, but in black ebony the air has escaped and so earth preponderates in it. Pottery consists of earth alone because it solidified gradually in the process of drying. Water cannot get into it, for the pores were only large enough to admit of vapor escaping, and seeing that fire solidified it, that cannot dissolve it either, so solidification and melting, their causes, and the kinds of subjects in which they occur have been described. All this makes it clear that bodies are formed by heat and cold and that these agents operate by thickening and solidifying. It is because these qualities fashion bodies that we find heat in all of them, and in some cold in so far as heat is absent. These qualities, then, are present as active, and the moist and the dry as passive, and consequently all four are found in mixed bodies. So water and earth are the constituents of homogeneous bodies both in plants and in animals and of metals such as gold, silver, and the rest water and earth and their respective exhalations shut up in the compound bodies, as we have explained elsewhere. All these mixed bodies are distinguished from one another, firstly by the qualities special to the various senses, that is, by their capacities of action. For a thing is white, fragrant, sonant, sweet, hot, cold in virtue of a power of acting on sense. Secondly by other more characteristic affections which express their aptitude to be affected, I mean, for instance, the aptitude to melt or solidify or bend and so forth, all these qualities, like moist and dry, being passive. These are the qualities that differentiate bone, flesh, sinew, wood, bark, stone and all other homogeneous natural bodies. Let us begin by enumerating these qualities expressing the aptitude or inaptitude of a thing to be affected in a certain way. They are as follows: to be apartment or inapt to solidify, melt, be softened by heat, be softened by water, bend, break, be comminuted, impressed, molded, squeezed. To be tractile or non-tractile, malleable or non-malleable, to be fissile or non-fissile, apartment or inapt to be cut, to be viscous or friable, compressible or incompressible, combustible or incombustible, to be apartment or inapt to give off fumes. These affections differentiate most bodies from one another. Let us go on to explain the nature of each of them. We have already given a general account of that which is apartment or inapt to solidify or to melt, but let us return to them again now. Of all the bodies that admit of solidification and hardening, some are brought into this state by heat, others by cold. Heat does this by drying up their moisture, cold by driving out their heat. Consequently some bodies are affected in this way by defect of moisture, some by defect of heat, watery bodies by defect of heat, earthy bodies of moisture. Now those bodies that are so affected by defect of moisture are dissolved by water, unless like pottery they have so contracted that their pores are too small for the particles of water to enter. All those bodies in which this is not the case are dissolved by water, for example natron, salt, dry mud. Those bodies that solidified through defect of heat are melted by heat, for example ice, lead, copper. So much for the bodies that admit of solidification and of melting, and those that do not admit of melting. The bodies which do not admit of solidification are those which contain no aqueous moisture and are not watery, but in which heat and earth preponderate, like honey and must, for these are in a sort of state of effervescence, and those which do possess some water but have a preponderance of air, like oil and quicksilver, and all viscous substances such as pitch and birdlime. Those bodies admit of softening which are not, like ice, made up of water, but in which earth predominates. All their moisture must not have left them, as in the case of natron and salt, nor must the relation of dry to moist in them be incongruous, as in the case of pottery. They must be tractile, without admitting water, or malleable, without consisting of water, and the agent in softening them is fire. Such are iron and horn, both of bodies that can melt and of bodies that cannot, some do and some do not admit of softening in water. Copper, for instance, which can be melted, cannot be softened in water, whereas wool and earth can be softened in water, for they can be soaked. It is true that though copper can be melted the agent in its case is not water, but some of the bodies that can be melted by water too such as natron and salt cannot be softened in water, for nothing is said to be so affected unless the water soaks into it and makes it softer. Some things, on the other hand, such as wool and grain, can be softened by water though they cannot be melted. Any body that is to be softened by water must be of earth and must have its pores larger than the particles of water, and the pores themselves must be able to resist the action of water, whereas bodies that can be melted by water must have pores throughout. Why is it that earth is both melted and softened by moisture, while natron is melted but not softened? Because natron is pervaded throughout by pores so that the parts are immediately divided by the water. But earth has also pores which do not connect and is therefore differently affected according as the water enters by one or the other set of pores. Some bodies can be bent or straightened, like the reed or the withy, some cannot, like pottery and stone. Those bodies are apartment to be bent and straightened which can change from being curved to being straight and from being straight to being curved, and bending and straightening consist in the change or motion to the straight or to a curve, for a thing is said to be in process of being bent whether it is being made to assume a convex or a concave shape. So bending is defined as motion to the convex or the concave without a change of length. For if we added or to the straight, we should have a thing bent and straight at once, and it is impossible for that which is straight to be bent. And if all bending is a bending back or a bending down, the former being a change to the convex, the latter to the concave, a motion that leads to the straight cannot be called bending, but bending and straightening are two different things. These, then, are the things that can, and those that cannot be bent, and be straightened. Some things can be both broken and comminuted, others admit only one or the other. Wood, for instance, can be broken but not comminuted. Ice and stone can be comminuted but not broken, while pottery may either be comminuted or broken. The distinction is this: breaking is a division and separation into large parts, comminution into parts of any size, but there must be more of them than two. Now those solids that have many pores not communicating with one another are comminuable, for the limit to their subdivision is set by the pores, but those whose pores stretch continuously for a long way are breakable, while those which have pores of both kinds are both comminuable and breakable. Some things, for example copper and wax, are impressible, others, for example pottery and water, are not. The process of being impressed is the sinking of a part of the surface of a thing in response to pressure or a blow, in general to contact. Such bodies are either soft, like wax, where part of the surface is depressed while the rest remains, or hard, like copper. Non-impressible bodies are either hard, like pottery, its surface does not give way and sink in, or liquid, like water, for though water does give way it is not in a part of it, for there is a reciprocal change of place of all its parts. Those impressibles that retain the shape impressed on them and are easily molded by the hand are called plastic. Those that are not easily molded, such as stone or wood, or are easily molded but do not retain the shape impressed, like wool or a sponge, are not plastic. The last group are said to be squeezable. Things are squeezable when they can contract into themselves under pressure, their surface sinking in without being broken and without the parts interchanging position, as happens in the case of water. We speak of pressure when there is movement and the motor remains in contact with the thing moved, of impact when the movement is due to the local movement of the motor. Those bodies are subject to squeezing which have empty pores, empty, that is, of the stuff of which the body itself consists and that can sink upon the void spaces within them, or rather upon their pores. For sometimes the pores upon which a body sinks in are not empty. A wet sponge, for instance, has its pores full. But the pores, if full, must be full of something softer than the body itself which is to contract. Examples of things squeezable are the sponge, wax, flesh. Those things are not squeezable which cannot be made to contract upon their own pores by pressure, either because they have no pores or because their pores are full of something too hard. Thus iron, stone, water and all liquids are incapable of being squeezed. Things are tractile when their surface can be made to elongate, for being drawn out is a movement of the surface, remaining unbroken, in the direction of the mover. Some things are tractile, for example hair, thongs, sinew, dough, birdlime, and some are not, for example water, stone. Some things are both tractile and squeezable, for example wool. In other cases the two qualities do not coincide. Phlegm, for instance, is tractile but not squeezable, and a sponge squeezable but not tractile. Some things are malleable, like copper. Some are not, like stone and wood. Things are malleable when their surface can be made to move, but only in part, both downwards and sideways with one and the same blow. When this is not possible a body is not malleable. All malleable bodies are impressible, but not all impressible bodies are malleable. For example wood, though on the whole the two go together. Of squeezable things some are malleable and some not. Wax and mud are malleable, wool is not. Some things are fissile, for example wood, some are not, for example potter's clay. A thing is fissile when it is a partment to divide in advance of the instrument dividing it, for a body is said to split when it divides to a further point than that to which the dividing instrument divides it and the act of division advances, which is not the case with cutting. Those bodies which cannot behave like this are non-fissile. Nothing soft is fissile. By soft I mean absolutely soft and not relatively, for iron itself may be relatively soft, nor are all hard things fissile, but only such as are neither liquid nor impressible nor comminuable. Such are the bodies that have the pores along which they cohere lengthwise and not crosswise. Those hard or soft solids are a partment to be cut which do not necessarily either split in advance of the instrument or break into minute fragments when they are being divided. Those that necessarily do so and liquids cannot be cut. Some things can be both split and cut, like wood, though generally it is lengthwise that a thing can be split and crosswise that it can be cut. 4. A body being divided into many parts fin so far as its unity is made up of many lengths it is a partment to be split, in so far as it is made up of many breadths it is a partment to be cut. A thing is viscous when, being moist or soft, it is tractile. Bodies owe this property to the interlocking of their parts when they are composed like chains, for then they can be drawn out to a great length and contracted again. Bodies that are not like this are friable. Bodies are compressible when they are squeezable and retain the shape they have been squeezed into, incompressible when they are either inapt to be squeezed at all or do not retain the shape they have been squeezed into. Some bodies are combustible and some are not. Wood, wool, bone are combustible, stone, ice are not. Bodies are combustible when their pores are such as to admit fire and their longitudinal pores contain moisture weaker than fire. If they have no moisture, or if, as in ice or very green wood, the moisture is stronger than fire, they are not combustible. Those bodies give off fumes which contain moisture, but in such a form that it does not go off separately in vapor when they are exposed to fire. For vapor is a moist secretion tending to the nature of air produced from a liquid by the agency of burning heat. Bodies that give off fumes give off secretions of the nature of air by the lapse of time. As they perish away they dry up or become earth. But the kind of secretion we are concerned with now differs from others in that it is not moist nor does it become wind, which is a continuous flow of air in a given direction. Fumes are common secretion of dry and moist together caused by the agency of burning heat. Hence they do not moisten things but rather color them. The fumes of a woody body are called smoke. I mean to include bones and hair and everything of this kind in the same class. For there is no name common to all the objects that I mean, but, for all that, these things are all in the same class by analogy. Compare what Empedocles says, they are one and the same, hair and leaves and the thick wings of birds and scales that grow on stout limbs. The fumes of fat are a sooty smoke and those of oily substances a greasy steam. Oil does not boil away or thicken by evaporation because it does not give off vapor but fumes. Water on the other hand does not give off fumes, but vapor. Sweet wine does give off fumes, for it contains fat and behaves like oil. It does not solidify under the influence of cold and it is a parchment to burn. Really it is not wine at all in spite of its name, for it does not taste like wine and consequently does not inebriate as ordinary wine does. It contains but little fumigable stuff and consequently is inflammable. All bodies are combustible that dissolve into ashes, and all bodies do this that solidify under the influence either of heat or of both heat and cold, for we find that all these bodies are mastered by fire. Of stones the precious stone called carbuncle is least amenable to fire. Of combustible bodies some are inflammable and some are not, and some of the former are reduced to coals. Those are called inflammable which produce flame and those which do not are called non-inflammable. Those fumigable bodies that are not liquid are inflammable, but pitch, oil, wax are inflammable in conjunction with other bodies rather than by themselves. Most inflammable are those bodies that give off smoke. Of bodies of this kind those that contain more earth than smoke are apartment to be reduced to coals. Some bodies that can be melted are not inflammable, for example copper, and some bodies that cannot be melted are inflammable, for example wood, and some bodies can be melted and are also inflammable, for example frankincense. The reason is that wood has its moisture altogether and this is continuous throughout and so it burns up, whereas copper has it in each part but not continuous, and insufficient in quantity to give rise to flame. In frankincense it is disposed in both of these ways. Fumigable bodies are inflammable when earth predominates in them and they are consequently such as to be unable to melt. These are inflammable because they are dry like fire. When this dry comes to be hot there is fire. This is why flame is burning smoke or dry exhalation. The fumes of wood are smoke, those of wax and frankincense and such like, and pitch and whatever contains pitch or such like are sooty smoke, while the fumes of oil and oily substances are a greasy steam, so are those of all substances which are not at all combustible by themselves because there is too little of the dry in them, the dry being the means by which the transition to fire is effected, but burn very readily in conjunction with something else. For the fat is just the conjunction of the oily with the dry, so those bodies that give off fumes, like oil and pitch, belong rather to the moist, but those that burn to the dry, homogeneous bodies differ to touch by these affections and differences, as we have said. They also differ in respect of their smell, taste, and color. By homogeneous bodies I mean, for instance, metals, gold, copper, silver, tin, iron, stone, and everything else of this kind and the bodies that are extracted from them, also the substances found in animals and plants, for instance, flesh, bones, sinew, skin, viscera, hair, fibers, veins. These are the elements of which the non-homogeneous bodies like the face, a hand, a foot, and everything of that kind are made up, and in plants, wood, bark, leaves, roots, and the rest like them. The homogeneous bodies, it is true, are constituted by a different cause, but the matter of which they are composed is the dry and the moist, that is, water and earth, for these bodies exhibit those qualities most clearly. The agents are the hot and the cold, for they constitute and make concrete the homogeneous bodies out of earth and water as matter. Let us consider, then, which of the homogeneous bodies are made of earth and which of water, and which of both. Of organized bodies some are liquid, some soft, some hard. The soft and the hard are constituted by a process of solidification, as we have already explained. Those liquids that go off in vapor are made of water, those that do not are either of the nature of earth, or a mixture either of earth and water, like milk, or of earth and air, like wood, or of water and air, like oil. Those liquids which are thickened by heat are a mixture. Wine is a liquid which raises a difficulty, for it is both liable to evaporation and it also thickens, for instance new wine does. The reason is that the word wine is unambiguous and different wines behave in different ways. New wine is more earthy than old, and for this reason it is more apartment to be thickened by heat and less apartment to be congealed by cold. For it contains much heat and a great proportion of earth, as in Arcadia, where it is so dried up in its skins by the smoke that you scrape it to drink. If all wine has some sediment in it, then it will belong to earth or to water according to the quantity of the sediment it possesses. The liquids that are thickened by cold are of the nature of earth. Those that are thickened either by heat or by cold consist of more than one element, like oil and honey, and sweet wine. Of solid bodies those that have been solidified by cold are of water, for example ice, snow, hail, or frost. Those solidified by heat are of earth, for example pottery, cheese, natron, salt. Some bodies are solidified by both heat and cold. Of this kind are those solidified by refrigeration, that is by the privation both of heat and of the moisture which departs with the heat. For salt and the bodies that are purely of earth solidify by the privation of moisture only, ice by that of heat only, these bodies by that of both. So both the active qualities and both kinds of matter were involved in the process. Of these bodies those from which all the moisture has gone are all of them of earth, like pottery or amber. For amber, also, and the bodies called tears are formed by refrigeration, like myrrh, frankincense, gum. Amber, too, appears to belong to this class of things. The animals enclosed in it show that it is formed by solidification. The heat is driven out of it by the cold of the river and causes the moisture to evaporate with it, as in the case of honey when it has been heated and is immersed in water. Some of these bodies cannot be melted or softened, for instance, amber and certain stones, for example the stalactites in caves. For these stalactites, too, are formed in the same way. The agent is not fire, but cold which drives out the heat, which, as it leaves the body, draws out the moisture with it. In the other class of bodies the agent is external fire. In those from which the moisture has not wholly gone earth still preponderates, but they admit of softening by heat, for example iron and horn. Now since we must include among meltables those bodies which are melted by fire, these contain some water, indeed some of them, like wax, are common to earth and water alike. But those that are melted by water are of earth. Those that are not melted either by fire or water are of earth, or of earth and water, since, then, all bodies are either liquid or solid, and since the things that display the affections we have enumerated belong to these two classes and there is nothing intermediate, it follows that we have given a complete account of the criteria for distinguishing whether a body consists of earth or of water or of more elements than one, and whether fire was the agent in its formation, or cold, or both. Gold, then, and silver and copper and tin and lead and glass and many nameless stone are of water, for they are all melted by heat. Of water, too, are some wines and urine and vinegar and lion whey and serum, for they are all congealed by cold. In iron, horn, nails, bones, sinews, wood, hair, leaves, bark, earth preponderates. So, too, in amber, myrrh, frankincense, and all the substances called tears, and stalactites, and fruits, such as leguminous plants and corn. For things of this kind are, to a greater or less degree, of earth. For of all these bodies some admit of softening by heat, the rest give off fumes and are formed by refrigeration. So again in natron, salt, and those kinds of stones that are not formed by refrigeration and cannot be melted. Blood, on the other hand, and semen, are made up of earth and water and air. If the blood contains fibers, earth preponderates in it, consequently it solidifies by refrigeration and is melted by liquids. If not, it is of water and therefore does not solidify. Semen solidifies by refrigeration, its moisture leaving it together with its heat. We must investigate in the light of the results we have arrived at what solid or liquid bodies are hot and what cold. Bodies consisting of water are commonly cold, unless, like lye, urine, wine, they contain foreign heat. Bodies consisting of earth, on the other hand, are commonly hot because heat was active in forming them, for instance lime and ashes. We must recognize that cold is in a sense the matter of bodies. For the dry and the moist are matter, being passive, and earth and water are the elements that primarily embody them, and they are characterized by cold. Consequently cold must predominate in every body that consists of one or other of the elements simply, unless such a body contains foreign heat as water does when it boils or when it has been strained through ashes. This latter, too, has acquired heat from the ashes, for everything that has been burnt contains more or less heat. This explains the generation of animals in putrefying bodies. The putrefying body contains the heat which destroyed its proper heat. Bodies made up of earth and water are hot, for most of them derive their existence from concoction and heat, though some, like the waste products of the body, are products or putrefaction. Thus blood, semen, marrow, fig juice, and all things of the kinds are hot as long as they are in their natural state, but when they perish and fall away from that state they are so no longer. For what is left of them is their matter, and that is earth and water. Hence both views are held about them, some people maintaining them to be cold and others to be warm, for they are observed to be hot when they are in their natural state, but to solidify when they have fallen away from it. That, then, is the case of mixed bodies. However, the distinction we laid down holds good. If its matter is predominantly water, a body is cold, water being the complete opposite of fire, but if earth or air it tends to be warm. It sometimes happens that the coldest bodies can be raised to the highest temperature by foreign heat, for the most solid and the hardest bodies are coldest when deprived of heat and most burning after exposure to fire. Thus water is more burning than smoke and stone than water. Having explained all this, we must describe the nature of flesh, bone, and the other homogeneous bodies severally. Our account of the formation of the homogeneous bodies has given us the elements out of which they are compounded and the classes into which they fall, and has made it clear to which class each of those bodies belongs. The homogeneous bodies are made up of the elements, and all the works of nature in turn of the homogeneous bodies as matter. All the homogeneous bodies consist of the elements described as matter, but their essential nature is determined by their definition. This fact is always clearer in the case of the later products of those, in fact, that are instruments, as it were, and have an end. It is clearer, for instance, that a dead man is a man only in name. And so the hand of a dead man, too, will in the same way be a hand in name only, just as stone flutes might still be called flutes, for these members, too, are instruments of a kind. But in the case of flesh and bone the fact is not so clear to see, and in that of fire and water even less. For the end is least obvious there where matter predominates most. If you take the extremes, matter is pure matter and the essence is pure definition, but the bodies intermediate between the two are matter or definition in proportion as they are near to either. For each of those elements has an end and is not water or fire in any and every condition of itself, just as flesh is not flesh nor viscera, and the same is true in a higher degree with face and hand. What a thing is always determined by its function. A thing really is itself when it can perform its function, an eye, for instance, when it can see. When a thing cannot do so it is the thing only in name, like a dead eye or one made of stone, just as a wooden saw is no more a saw than one in a picture. The same, then, is true of flesh, except that its function is less clear than that of the tongue. So, too, with fire, but its function is perhaps even harder to specify by physical inquiry than that of flesh. The parts of plants, and inanimate bodies like copper and silver, are in the same case. They all are what they are in virtue of a certain power of action or passion, just like flesh and sinew. But we cannot state their form accurately, and so it is not easy to tell when they are really there and when they are not unless the body is thoroughly corrupted and its shape only remains. So ancient corpses suddenly become ashes in the grave, and very old fruit preserves its shape only but not its taste. So, too, with the solids that form from milk. Now heat and cold and the motions they set up as the bodies are solidified by the hot and the cold are sufficient to form all such parts as are the homogeneous bodies, flesh, bone, hair, sinew, and the rest. For they are all of them differentiated by the various qualities enumerated above, tension, tractility, comminuability, hardness, softness, and the rest of them, all of which are derived from the hot and the cold and the mixture of their motions. But no one would go as far as to consider them sufficient in the case of the non-homogeneous parts, like the head, the hand, or the foot, which these homogeneous parts go to make up. Cold and heat and their motion would be admitted to account for the formation of copper or silver, but not for that of a saw, a bowl, or a box. So here, save that in the examples given the cause is art, but in the non-homogeneous bodies nature or some other cause. Since, then, we know to what element each of the homogeneous bodies belongs, we must now find the definition of each of them. The answer, that is, to the question, what is flesh, semen, and the rest? For we know the cause of a thing and its definition when we know the material or the formal or, better, both the material and the formal conditions of its generation and destruction, and the efficient cause of it. After the homogeneous bodies have been explained, we must consider the non-homogeneous too, and lastly the bodies made up of these, such as man, plants, and the rest.